Bob Ziroll is one of the most popular React instructors in the world, and he's back again with this completely updated React for Beginners course. This course is the perfect starting place for anyone learning React. You'll learn the basics of modern React and build a bunch of fun projects.
Hey free code campers, and welcome to this Introduction to React course. My name is Bob Ziroll, and I am super excited to be here guiding you through the wonderful world of learning React. I have been working for the last 6 months to make this the most interactive React course out there. In fact, throughout this course, you are going to be working on over 170 challenges and building 6 larger projects. Now, there are a lot of React video courses out there, but this one is the only one that has been worked on and developed hand in hand with the folks over at MDN Web Docs to make sure that it meets their standards. I am just so excited to be teaching this React course. I've been teaching React and web development now for over a decade and have helped usher thousands of people into their new careers in web development. So trust me when I say you're in good hands. Let me tell you for just a second about what you can expect from this course. This React course and all of the courses that we make over at Scrimba are super interactive. Instead of just teaching topic after topic, we focus our curriculum on projects and challenges, and we use those to drive forward the curriculum and introduce new topics along the way. This makes it so that all of our content is very hands-on. As I mentioned, you're going to be completing over 170 challenges and building 6 projects. Let's look at those 6 projects right now. The first 2 projects focus on building static web pages in React, allowing us to dip our toes into the syntax of React, and then starting to transition into using reusable components, which is one of the fundamental things that we learn in React. In sections 3 and 4 of the course, we're going to be transitioning away from just static web pages into web applications that are much more interactive with the user. And to do that, we'll be building 2 really awesome web applications. One is called Chef Claude, where the user can input a list of ingredients, send that off to an artificial intelligence engine to give you a recipe that you can use with those ingredients. And a meme generator, where you can input the top text, bottom text, and change the meme image if you want. At that point, we have not 1, but 2 capstone projects that we'll be working on. The first one is a dice game called Tensies, and the second one is called Assembly Endgame. It's basically a hangman-style game where the user tries to guess a secret word. So I've mentioned how interactive the course is going to be. You might be asking, what's the best way to follow along? Well, you really have 2 options. You could stay here on YouTube and continue to follow the course here while doing the challenges and projects in your own editor on your own machine, or you can hop over to Scrimba and do the challenges over there. Either one is completely fine with me as long as you're doing those challenges and building the projects. Because the course was originally recorded on Scrimba, there will be times where I talk about clicking a link in the slides or clicking into the editor and typing down your answer. Obviously, neither of which will work here in YouTube. So I'll do my very best to make sure all of the links from those slides are down in the video description in this video. Now, indulge me a little bit here. I'm going to step up on a soapbox and give you a little bit of a spiel that I give to all of my students. My main goal for this course is that you can finish the course, open up a blank text editor, and start building a React project of your choice. Far too many courses out there will just present information at you, not requiring you to actually do any work, and then leave you alone and underprepared to try and build a project. The reason this happens is a phenomenon often referred to as tutorial hell, where you watch tutorial after tutorial after tutorial, feeling like you're learning something new, but never being required to actually type down any code or practice what you're learning. What this ends up doing is making you feel like you're learning something along the way, but then you get to the end, you open up an editor, and your mind goes completely blank. In fact, it's kind of funny to try and imagine learning some other kind of skill in the same way. Imagine watching all of Wimbledon and feeling like you're somehow becoming a better tennis player. That's not how it works in sports, or language, or music, and certainly not in software engineering. So I found that there's actually 2 things that need to happen for you to avoid tutorial hell altogether. The first one actually has to do more with me as your teacher. It's my responsibility to make sure that I prepare this course and teach this course in a way that follows scientifically proven methods for you to retain the information I'm trying to teach to you. So that's not something you're going to have to worry about. That's something I had to worry about when I was creating the course. The second one, though, is something that relies entirely on you, and that is that you actually do the work. Every challenge, every quiz, every project that I throw your way, I need you to actually do those challenges and quizzes and projects. Something I like to tell all of my students is that the easiest way to learn something new is to actually do it the hard way. This means that instead of just coasting on by, hoping that you're retaining the information, you actually put in the work and the time and the effort that it takes to learn that new thing. Practice, practice, practice is extremely important. And I'm going to be up on this soapbox reminding you about this many times throughout the course. I think that the best way to do this is to have a bit of a paradigm shift and remember that you are not being graded on this course. Be curious. It doesn't matter if you make mistakes. You can always undo the changes that you've made and try again. Okay, I'm going to get down off that soapbox now. But if you have any feedback about the course, or if you simply want to connect with me, the place I'm most active these days is on X @BobZiroll. So feel free to give me a follow there. You can shoot me a DM. I'm happy to respond as much as I can. Okay, I can't wait anymore. Without any further delay, let's jump in and start learning React.
In this first section, we are going to be learning everything we need to know in order to build static pages in React. And I know what you're probably thinking, but Bob, I already know how to make static pages. I understand that building purely static pages is not the reason that you're hoping to learn React, but I have found over my many years of teaching people React that it's important to first learn how to think in React. Writing good React code requires a bit of a paradigm shift from how you might be used to building web applications in the vanilla technologies of HTML, CSS, and JavaScript. And so in my experience, it's important to first get a solid foundation of how to think about React and think in React before we jump straight into the more fun and productive parts of React that really make it a magnificent framework for user interactions and web apps in general. In order to give some structure to the curriculum and in true Scrimba fashion, we are going to be building a project throughout this section called ReactFacts. And although it may look like a simple static page, it's really going to help us get the solid foundation that we need in React to continue on to maybe some of the more exciting projects that we have in this course. Throughout this section, we are going to be learning why you should even care about React. Chances are you found this course because you were told that learning React is an important step if you're hoping to get a job as a web developer or level up your skills in the web development arena. And so I think it's crucial to understand why people are telling you to learn React. Naturally, we'll be learning how to set up a new React project, and this bullet point actually encompasses both creating a new React project in the code, which you'll be doing directly here in Scrimba, or for those of you that happen to not be following along in Scrimba, we will be covering how to set up a new project on your local machine, which of course will be helpful for anybody when it comes time to building your own projects outside of the Scrimba environment. Then we'll be learning about the fundamental pieces of React, which are React elements and a syntax that the React team has created to make it easier called JSX. Then we'll take those React elements that we learn how to create and build our own custom components, which are reusable, composable pieces of code. And then just so our stuff doesn't look too ugly, we'll learn how to style those custom components, and we'll be using tons of hands-on challenges along the way while we're learning these topics. So without further ado, let's jump in and start learning how we can build static pages in React. Before we dive into the nitty-gritty of how you set React up locally on your machine, I want you to get your hands on React as soon as possible. If you're taking this course on Scrimba, then you'll be able to just click into the same editor that I'm using and type along, do the challenges, and so forth. If you're watching this on another platform like YouTube, very shortly we're going to cover how you can set up your React app on your local machine so that you can follow along with these challenges. In the meantime, I would recommend coming over to Scrimba.com just to try this first challenge out so you can get your hands on the keyboard and practice your very first React app. Assuming you have some experience writing HTML and CSS and some associated JavaScript, you should be very familiar with the idea that if you want something to show up on the browser, this is our mini browser over here, then we need to include it as markup in our HTML file. So I would just add something like an H1 that says hello world. I hit save, and sure enough, hello world shows up in our markup. With React, we take a bit of a different approach. Instead of adding anything manually to our markup, React will be in charge of taking our JavaScript and adding the associated markup to our HTML document for us. In order for this to work, I need some kind of placeholder. We're going to add a div here, which gives a place to React where it can insert all of the markup that we generate using React in our JavaScript files. I'm going to give this div an ID of root, and we'll see why in just a second. And before we move over to our index file, you might have noticed that the file extension here is .jsx. We're going to cover why that is in just a minute, but for now, let's just treat this like a regular JavaScript file. Here in the Scrimba interface, the implementation of React is sort of hidden behind the scenes. You can see in my dependencies, I'm using React version 19. Actually, at the time of recording this, the release candidate is all that's available right now. React 19 is on the cusp of being officially released. But because I have these dependencies installed and Scrimba is taking care of all of the bundling details and everything behind the scenes, if you have no idea what that means, that's okay. We're going to talk about it in just a few scrims. Now, before we move on, let me hit save. We'll get rid of this hello world that was showing up there because we removed that from our markup. And now to get the very most basic React app set up, I need to do two things. The first thing is I need to create a root. And don't worry about the terminology. We are going to be talking about this in just a second. And the second thing is I need to render some markup to the root. In order to create a root, I'm going to import, believe it or not, a method called createRoot. And this is going to come from the React DOM library, but from a specific submodule called client. So I need to import createRoot from React DOM/client. We can use this method to create a root. We'll go ahead and call it a variable root, and we'll call createRoot. And here we are. Why is it called a root? Well, since in React, we are going to be rendering all of our markup using React inside of JavaScript files, we need one central location where React can insert all of that content. And as we mentioned, this div with the ID of root that we set up is going to be like the root of our application. It's the one place where React will insert everything. So what I need to pass to the createRoot method is this DOM node, and I can get it by doing any regular DOM node selection. I can say document.getElementById, for example, and pass in the ID of root. And now that I have a so-called root, I can call a method on that root called render. Again, I know we're moving quickly. I'm just doing this so that we can get your hands on the keyboard, and then we'll come back and practice this and revisit it, so don't be too concerned about that. Okay, so what do I pass to the render method? Well, this is going to be a little bit weird, but I'm going to pass what looks an awful lot like HTML inside of my JavaScript. To distinguish this from what we had before, we'll say hello React. And here's the moment of truth. We'll go ahead and hit save. And look at that, we get our first text showing up on our screen. Now, I know we've done a couple strange things. We're moving kind of quickly. So now I want to just pause for a second. I want you to look over this code and try to memorize it as best as you can. The beautiful thing about Scrimba is I can give you a challenge now to rewrite this code, which is exactly what I'm going to be doing. So take a minute now to try and memorize this code. If you want, you can type it right down here below to get a little bit of muscle memory. Go ahead and do that now. And then it's your time for a challenge. Okay, your challenge is to rewrite those first lines of React code that we just had on the page. You can render anything that you want to the screen. It doesn't have to be an H1 like we had before. If I hit save, we'll see that disappears now. I'll put us on a new line here, and now it's your turn to work on this challenge. Okay, so we need to, I'll just get rid of this challenge text. We need to import createRoot from React-DOM/client. Then we're going to create a root by calling createRoot. And what we pass to createRoot will be a way to select the DOM node that we want to put all of our JavaScript code or all of our markup from JavaScript into. Before I did that with document.getElementById, but just so we can see another way, I could use query selector and specify the hash mark root. This works in exactly the same way. And then I can use that root to render something, again, that looks an awful lot like HTML. Maybe this time I'll opt for just a simple paragraph tag. And we'll say, hello from the world of React. Hit save, and there's our paragraph showing up. Awesome. As you might have guessed, you don't necessarily have to do this in two separate lines. Instead of creating a separate variable, I could simply chain these methods together. Also, in true programming fashion, there's usually many ways to do the same thing. So you might sometimes see this importing the entire React DOM library and calling React DOM.createRoot. Honestly, at this point, it really doesn't matter, but I just wanted to show you a couple different ways in case you ran into it in the wild. We'll go ahead and leave it like this for now. All right, one last thing before we talk about how to set this up locally on your own machine. I'm going to give you a challenge, and spoiler, it's essentially going to be doing the exact same thing we just did, but without the help of seeing the code ahead of time. So if you want, take some time to memorize what's here, and in the next scrim, we will redo this challenge with a little bit of a twist. Okay, it's challenge time. I want you to set up a React app again from scratch. And this time, I want you to try rendering an unordered list with 2 or 3 list items inside that enumerate why you're excited to be learning React. At this point, I'll give another plug for the benefits of using Scrimba. I really want you to try this challenge to the best of your abilities before you just simply click the button and move on. You'll hear me say it a million times, but you really will just be shorting your own education and your own practice if you decide to take the easy way out. And there's absolutely nothing wrong with going back to the previous lesson to remind yourself of how it's done so that you can come back here and accomplish it, or even to go to Google or ChatGPT and ask questions there. Doing that discovery process is going to be much better for your long-term memory and your skill building in writing React code than it will be to just skip this challenge and move forward. Okay, enough talking, Bob. Let's start this challenge. All right, we'll get rid of this challenge text. Again, we're going to import create root from react-dom/client, and then we'll call create root. We'll pass to it a DOM node. I'll go back to using getElementById. We'll give it the DOM node with the ID of root, and then we'll just go ahead and chain on our render this time. However, because I do have some nested elements, I'm going to go ahead and put these on their own lines. We'll create an unordered list, and at this point it should feel pretty familiar because we are just going to be writing what essentially looks like HTML. I'll go ahead and create a list item, and let's see, why am I excited about React? Well, it's a super popular JavaScript framework. Or I guess you could say library. There's a little bit of contention about that. Let's go ahead and call it a library. And let's see, it will help me be even more employable. Learning React is going to help you think in a new way that most JavaScript libraries and frameworks are adhering to these days. Anyway, we're going to talk more about that. And I don't know, maybe let's do something a little more silly. React has a pretty cool logo. Sure, why not? Okay, let's go ahead and hit save. And look at that, we get a little bit of strange styling, but that's just from our CSS, but we have our list items on the page. This is great, and we're starting to see one of the benefits of using React is we can lean on a familiar syntax in HTML with a couple tweaks here and there that we'll be discovering as we go through this course. Hopefully that challenge went okay for you. Again, if you struggled through it, this would be a perfect time to go back and to try it again. Now that we've talked through it, it might stick even better in your mind if you go through it again. And nothing's ever stopping you from doing it as many times as you want. Get that muscle memory in, get the repetitions in, and remember to take breaks along the way throughout this course. Now that we've had a chance to get our hands on React, let's go back and talk a little bit more about how we can set React up locally, especially for those of you that are not following along in Scrimba. I mentioned how Scrimba has some magic happening in the background so that React just kind of works in the Scrimba environment. However, if you're coming from just learning HTML, CSS, and JavaScript, probably being used to just being able to double-click an HTML file and have it run locally on your machine, things are not quite as simple as that with the modern front-end ecosystem that exists today. Now, I do want your focus to be learning the syntax and the philosophy behind React before you start worrying about all of the tooling and how to deploy and what it means to build a project and all that extra stuff that is important to learn but kind of distracts a little bit from learning React itself. So if you're taking this course here on Scrimba, I recommend you just continue to do the exercises directly here in the Scrimba interface. That said, there will obviously come a point at which you want to build your own projects, and although Scrimba is more and more capable of doing that, when you go off to your developer job, maybe writing React, you probably aren't going to be building your production code inside of Scrimba. So I want to walk through how you can get a React project set up locally. We're going to be using the recommended build tool called Vite. And yes, it is pronounced Vite. That's French for quick or fast. And to get started, you're welcome to click the screenshot here, which will take you directly to vitejs.dev if you want to read a little bit more about Vite. But I also, in this scrim, will be walking you through how to get everything set up. In order to use Vite on your machine, you need to have Node and NPM installed already on your machine. If you open up a terminal, you can type node space -v. That's to check the version of Node that you have installed. If it gives you any kind of version that's 18 and above, then you're golden and you'll likely be able to skip the next few slides that I'm about to show you. We also want to check if NPM is installed, although as far as I know, once you install Node, you automatically get NPM. Don't quote me on that for sure. But go ahead and use npm space -v to check what your NPM version is. If your terminal essentially says, I have no idea what you're talking about when you type this in, that means you need to install Node and NPM. And I'm not necessarily going to walk us through how to install Node because there's a million YouTube videos that can help you out. In fact, if you click the screenshot here, it will take you directly to the query on YouTube, specifically installing Node.js with a package called NVM, which is short for Node Version Manager. I have found personally that Node Version Manager is the least complicated way to not only install Node, but also to update it as new versions of Node are released. Now, just for reference, I've included screenshots here, which you can click either one to take you either to the NVM repository, which is the Node Version Manager you would use if you're on a Mac or a Linux machine. And over here on the right is a link to a similar repository for NVM-Windows, which, as I'm sure you have figured out, is specifically for Windows platform. Now, at the time of recording, it does look like the NVM-Windows team is working on a new package called Runtime, which it says is the successor to NVM for Windows. But since that is not yet released, you'll just have to click on the screenshot and see if Runtime is the new way to do this. Now, I know I said I'm not going to walk through this whole thing. I'm not going to go through every single step. But once you do have NVM installed, you'll simply run nvm install --lts for the long-term supported version. And that will just get you the most updated stable version of Node. Once you've done that, you can check again for your Node version and your NPM version. And once those are showing real numbers, you are golden and ready to move on. And of course, as with all version numbers you see here, when you do this, it's probably not going to be these exact versions of Node and NPM because the ecosystem is evolving pretty quickly. And building your first project with Vite couldn't be easier. In your terminal, you're simply going to type npm create Vite at latest. And this will jump you into kind of a wizard that helps you create your project. It'll ask you to name your project. So you'll put in something like first-react and hit enter. Then it'll ask you to select a framework. As you can see, there are other frameworks that are supported by Vite. We're going to go down to React. And for this, you just use your arrow keys and hit return to submit. Once you do that, it's going to ask you which variant you want to use. We're just going to keep it as simple as possible for now and just use the regular JavaScript version. Hit return to submit that again, and everything will get scaffolded and ready for you to run. And helpfully enough, it tells you exactly what to do. We're going to first cd into our project, then we're going to run npm install, which will only take a few seconds to finish. And at this point, once we're finished, I personally prefer to run the development server inside of the integrated terminal in VS Code. And so I'm just going to use code space dot. That's the shortcut for opening the current folder inside of VS Code. And once I'm in VS Code, I can run npm run dev. This will spin up a development server on port 5173, and I can just go to localhost :5173 to see the default project that is created with Vite. At this point, you can interact with the different files and the code that you see. If this truly is your first time interacting with React, it might seem a little bit overwhelming. You would go directly here into the src or source folder and find a couple files there. Essentially, you can delete most of the content of those files, but it's always good to kind of play around in a new, I guess you could call it, code base, just to get a lay of the land. And with that, you should be completely set up to run a React app locally with Vite. Again, because I'm going to be giving you a number of challenges, many of which include some starter code, I still recommend being here on Scrimba to do those challenges with as few barriers as possible. The more you can get your hands on the code, the better you're going to learn React. Before we jump into some of the more theoretical reasons as to why people have really adopted React so heavily, I want to sort of jump in a time machine and go back to see how it is React looked in the very, very early days of React. We'll get a chance to get our hands on the keyboard and really dive into some code before taking another break and learning a bit more about the history of why we enjoy React. Let's spend just a minute talking about JavaScript libraries and JavaScript frameworks. At this point in your learning journey, you may have heard these terms before and wondered what they were. So I think we should go through them. First, let's talk a little bit about the difference between what a library is and what a framework is. Generally speaking, a library is something that is just a collection of reusable code. When you're programming, sometimes you'll find yourself having to rewrite some logic over and over and over again, maybe even across different code bases. And this is kind of where libraries step in. The point of libraries usually is to reduce the need to write some repetitive or complex things from scratch over and over. Because it's just a collection of reusable code, it's really up to you how it's going to be used, when it's going to be used. There really aren't any boundaries that you're expected to stay within. Its main purpose is just to simplify the task that you were already going to be doing. A framework, on the other hand, is a bit more structured. It usually has some kind of predetermined architecture and expects you to follow a specified pattern of development. Oftentimes, it's pretty important that you're very familiar with the documentation for frameworks because they do expect you to follow their patterns. Instead of essentially having no boundaries like a library often has, you are expected to work within the boundaries that are set by the framework. Maybe put a little simpler, there's kind of like a right way and a wrong way to use the framework itself. So the question often comes up, is React a library or is it a framework? Well, if you go to the React homepage, it specifically calls itself a library. It says it's the library for web and native user interfaces. Honestly, React has been built out as a whole ecosystem these days to a point where one of the most common ways to use React is to do it using a framework like Next.js. We're going to be talking about that in a second. I think it could be really interesting for us to take a quick overview of the history of some very popular libraries and frameworks in JavaScript. Way back in 2006, there was a really popular library that was introduced called jQuery. And chances are you have heard of jQuery. Even if you're pretty new to web development, I would not be surprised if you've heard of jQuery. One of the main purposes of jQuery was to bridge the gap between different browsers and how they interpreted JavaScript to interact with the document object model, or the DOM. jQuery made it a lot easier to achieve that cross-browser compatibility, whereas before, with regular JavaScript, it was kind of a question. You might write some JavaScript that worked well in Chrome but didn't work in Firefox or Safari. jQuery definitely falls into the realm of a library. Its syntax essentially accomplishes the same thing that regular DOM JavaScript can accomplish, but with a syntax that's a lot more terse and some would say more familiar or easier to deal with. Then around 2010, there was a bit of a surge in JavaScript frameworks when AngularJS, Ember, and Backbone came out. There were definitely others at the time as well, but these were a little bit more closely aligned to a framework. They expected you to do things a specific way, and they started introducing the concepts of components on the web. AngularJS actually has kind of a funny history. It was created by engineers at Google. Its original name was simply Angular. And then later, around 2013, when React, the new Angular, and Vue.js came out, Angular, the original Angular 1, I guess you could say, rebranded as AngularJS so that the new version of Angular could simply be called Angular. Around the same time, we also saw React, and I think just a little bit later, Vue.js came out. And these three libraries/frameworks sort of represented the next wave of how to build web apps in JavaScript. Things definitely did not start slowing down at 2013. They only got more intense. In 2016, we saw the release of Svelte and Next.js, which is a full stack framework that uses React as its UI library. And from 2020 on, we saw a lot more showing up in Remix, Solid, Astro, Quick, Redwood, Alpine. There's so many others that have shown up since then. Each one of these has its own unique approach to web development, both front-end and full-stack web development, and it definitely can be pretty overwhelming to consider the realm of possibilities that exists out there. So of all the different choices that you have to learn, why choose React? For many of you taking this course, you are probably looking at React because it has the highest job demand. If you're considering getting into web development or you're trying to level up your skills as a web developer, I'm sure you have noticed that React has probably more job demand than any of the other libraries or frameworks out there. This is why we at Scrimba have chosen React to be the front-end library of choice in our front-end developer career path. Maybe as a quick aside, it's also important to note that oftentimes people hiring web developers, they're not going to be turned off by somebody who doesn't know their specific stack. They know that they're going to have to train somebody in their own stack, and they're really just looking for somebody who has the capability of learning and building cool things. That said, it definitely doesn't hurt to choose a library like React that already has the highest job demand. Another thing that makes React a great choice is that it has a huge ecosystem and community that supports it. Between the React.Flex Discord server, the React.js subreddit, and the wealth of NPM packages that were specifically written for React code, you are definitely surrounded by a great ecosystem with React. Another thing that some people report they really like about React is that it has less magic that's happening behind the scenes. Don't get me wrong, React is doing a lot of magical things behind the scenes, but you as the developer are often expected to simply rely on regular JavaScript methods to accomplish certain tasks in React. Whereas some other frameworks expect you to learn their framework-specific way of doing something. As we go through this course, I think you'll see a few examples of that. This next one isn't specific to React, but it's very composable and declarative. This is a great reason to use React as opposed to just not using a library at all. And lastly, React is being very actively developed. The team at Meta were the original ones to create React back in 2013, and it's been actively developed ever since. Now, a question that I very often see in our Scrimba forums and subreddits where people are learning programming is asking, do I really need to learn JavaScript before I learn React? And my personal, unhesitating, emphatic answer is yes, you absolutely have to know JavaScript before you jump into learning React. If you tried to learn the two at the same time, it would become very easy to conflate what is JavaScript and what is React, and I think doing so would be a huge step backwards in your education in web development. So that's why in the introduction to the course, I specifically say it's important to already be familiar with HTML, CSS, and JavaScript before trying to learn React. Now, libraries and frameworks, they're not for everyone. So let's talk about when you might not want a framework. If you were just working on a simple static landing page for a business or your own personal website, it might be fine with such a small project to just stick to the core technologies of HTML, CSS, and JavaScript. Remember that frameworks or libraries like React are a big codebase of their own, and they will have to be pulled down to the user's machine anytime they want to run your project. On modern fast networks, that's not usually that much of a problem, but if it's just a simple small project, or if you do have network load concerns, maybe you need your app to correctly run on slow 3G networks in different parts of the world, then those would both be good reasons to just skip using a library or framework altogether, or at the very least, to use a very lightweight one. These UI libraries and frameworks also come with quite a hefty learning curve compared to just the core technologies. So that's something you might need to take into account when you're deciding whether it's the right time to use a framework. Also, where the core technologies of HTML, CSS, and JavaScript are not evolving or changing that often, frameworks do tend to be improved and upgraded, so you may find yourself spending a fair amount of time doing maintenance to your application, upgrading to the newest version, whatever it might be, and it's possible that's not something that you want to spend your time doing. And lastly, if you are already embedded in a codebase, it's possible that the framework of your choice may not be super compatible, or at least not easily compatible with your existing codebase. In the decisions you make in all of web development, you'll find that there's always trade-offs. And so these are just some of the concerns you might want to keep in mind when it comes to choosing your library or framework. Okay, let's get back to talking about some of these reasons to use React by talking about this specific point here, how React is composable and declarative. When we first wrote this code, I mentioned that it can seem a little bit strange for us to have what looks like HTML directly here inside of our JavaScript. And that's true. In fact, when React was first introduced, there was a short amount of time when this syntax didn't exist at all. Instead, React exported a function that was called createElement. Now, this is not to be confused with the document.createElement, although the concept is pretty similar. You see, within React, we can call this createElement function, and it takes 3 parameters. The first parameter is what type of element you want to create, very similar to document.createElement. The second parameter is something that's called props. We're going to spend a lot of time in props a little bit later. For now, because I'm creating an H1, I'm just going to pass null here because I'm more interested in showing what gets returned from this than anything else. The third parameter is what children we want our H1 to have. In our case, this is an H1 that's just going to have some text. So I'm just going to put some text in here and we'll say this is hello from createElement. Okay, I'll hit save. We see we get essentially the same thing that we had before. The syntax is maybe not as familiar and a little bit more verbose, especially, by the way, once you start to nest these inside of each other, but I'm not really planning to go deep down that rabbit hole. Instead, what I want to do is take the return value from this function and save it in a variable. Let's go ahead and call this ReactElement. I'll set it equal to this createElement call, and we'll go ahead and still render our React element. But now that I've done that, I can console log ReactElement. And let's open up the console and see what we get. Okay, look at that. So what createElement returns is an object that has some information about the DOM node that is going to get inserted by React into our actual DOM. Notice this object is just a regular JavaScript object. It needs to be structured in this way so that React can understand what it is, but it's just a JavaScript object. Remember this because it will be key for us down the road when we start talking about JSX. So long story short, in the very early days of React, they created this function called createElement. It still exists today, as we can see. We're in version 19 and we can still use it. And createElement returns a regular JavaScript object with a specific structure that makes sense to React. Now, I don't have firsthand experience with this, but I suspect that the React team realized that this wasn't going to be a long-term solution, and so they created JSX, which is that HTML-looking thing that we saw in the beginning of the scrim. Let's take just a minute to look really quickly at JSX, and then we'll pull up some more slides and we'll talk about some of the main reasons why we care about React so much. As you can probably tell, using createElement is not the greatest developer experience. We didn't really go into it, but if you wanted to nest elements together, like if you had an H1 that had, I don't know, maybe a span inside with some text, well, you would have to take your createElement, and then instead of the children being just a text node like this, it would be another React element, which you would have to get by calling createElement. And so then you would have your span, it would have, let's just say, no props, and then it would have its own children. I'm inside the span, and so forth. Definitely a far cry from how we're used to adding elements to the DOM with HTML. And so pretty shortly after React was initially released, the same team that created React also created the syntax for JSX, which allows developers to write what they're already very familiar with in writing HTML. If you want to add a span in here, just like in HTML, you would simply add a span. And under the hood, React is going to take this set of JSX elements that are nested together, and it's going to turn them into those createElement calls that we saw before. Let's clean some of this up. This one's just sitting outside here, and we no longer need createElement. Let me go ahead and change this H1 to just be a regular H1 that says hello from JSX. And notice what the console still says. This is from before we made this change, and it still says hello from createElement as the children. We go ahead and hit save, and we get an object with the exact same structure. So the main point I want to get across is that JSX is simply what we call syntactic sugar on top of the createElement call, and under the hood, React is taking this JSX syntax and turning it into calls to createElement. Now there is a bit more to the object that we see here. For example, I can't just copy the object I see in the console and paste it in place of ReactElement or try to type this out manually. There is a little bit more happening behind the scenes, but that's not really that relevant for you in this stage of your React journey. Next, we're going to pull up a few slides and learn a little bit more about some of the reasons that we love React, but I don't want you to forget the syntax you see here because I will be giving you an exercise requiring you to write it all again from scratch. We're going to be covering a bunch of different reasons why React is a great choice for libraries to be learning at this point in your learning journey, but there's two main reasons I want to talk about why it's best that we graduate from just using the vanilla technologies of HTML, CSS, and JavaScript. So what makes React so great? Well, the first major reason we're going to talk about is that React is something called composable. All this means is that we have the tools available to us that allow us to easily create reusable and interchangeable pieces of the web that can be combined in a lot of different ways to create complex systems. Now, I'll admit this next analogy is not the absolute perfect analogy, but let's talk for a second about what is arguably the most famous statue in the world. This is Michelangelo's statue of David, and I've had the privilege of seeing this in person in Italy, and if you've never seen it in person, you might not understand just how large this statue is. It is a 14-foot tall, solid marble statue. When this was created, Michelangelo had a block of marble, and he carved away chunks of that until what was left was the statue that you see here. My point in showing this is that the statue of David and all sculptures that were carved as a single solid block of stone or whatever material, what you have left is a single unit, and it can't be reused or repurposed in any way, which for artwork makes a lot of sense. Now, the reason this might not be the absolute best analogy is because this next picture is not nearly as beautiful as the original statue of David. If we are to set aesthetics aside, you can see that someone has replicated the statue of David with Lego bricks. Again, not nearly as beautiful, but I think it encapsulates the principle of composability really well. If you've ever played with Lego bricks, you know that they usually come in a big jumbled pile, and you can use those Lego bricks to create whatever your mind can conjure up. Each one of those little Lego bricks can be reused and repurposed in a lot of different ways, some of which are really rudimentary and simple, and some of which are pretty complex, like replicating the statue of David. In artwork, obviously this is more beautiful, but in web development, it's a very powerful tool for us to be able to take little pieces and combine them together in complex ways. Let's take a look at a small piece of code here. What you see here is a snippet from the Bootstrap website. If you have been in web development for a while, you might be familiar with what Bootstrap is. It's just a pre-built CSS library, and I took this directly from their website where it showed a bunch of different examples of navigation bars. This is over 30 lines of code that represent a single navigation bar. That by itself is not that remarkable. Navigation bars can oftentimes end up being this long or much longer. But if you were around in the early days of the web, you might have seen a series of HTML files, each of which was a different page on your website. And anytime you wanted this navigation bar to be at the top of that web page, you had to copy and paste this code to a separate HTML file. This meant that the first 30-something or more lines of code were dedicated to a navigation bar, and the only thing that really changed would require you to scroll way down the HTML page to find. Not only that, but if you wanted to make a change to this navigation bar, you might have to make it in a lot of different places. Now we can contrast that with what we get with React, which is custom components. You can even hear the similarity in the name there. These represent components that are more composable. I've given these kind of silly names here to really highlight the fact that these are custom. They're things that I have created. They're obviously not native HTML elements, but instead a custom component that represents all of the code that we saw here. This My Awesome Navbar encapsulates all of this code, and then anytime in my document that I want to include a navbar, I can simply render a copy of My Awesome Navbar, and I will get everything that comes with the code that we see here. And if I want to make a change, I can make that change in one place, and it will reflect everywhere My Awesome Navbar is used. Now, we're not fully ready to jump directly into the syntax of React, but I wanted to give you a chance to get your hands on this and really just kind of figure things out as you go. Interacting with code that is unfamiliar to you is a great way to obviously become familiar with it and to really create those links in your mind that will help you understand this in the end. You can see in our mini browser that I have that Bootstrap navigation bar showing up here, and in root.render I have this My Awesome Navbar custom component. If I scroll up, we can see the code for that custom component, and that starts right here on line 4. One thing you'll notice is that throughout the code I am using class name instead of just class. That's not a mistake. It's something that we do have to do in React. We're going to touch on that later. But for now, what I'd like to do is give you a challenge that will require you to deduce what I have done here and try to create your very own custom component in React. Let's scroll down here and I will add a challenge here. Okay, your challenge is to create your very first custom React component using the My Awesome Navbar component above as your template. You'll call your new component main content and just have it return a simple h1 element that says something like React is great. After you create that new component, make sure that you are rendering it inside of root.render just like we are with My Awesome Navbar. Just render it right here below that. Okay, I'll hand it over to you. Time to work on this challenge. Okay, well, we can look above to the example of My Awesome Navbar and see that to create a new component, we just have to create a new function. And that function will return some JSX. In this example, the JSX is much more complex than what we're going to do, but that's okay. So down here, let's go ahead and create a new function called main content, and we'll have it return some JSX. We'll just have it return an h1. Notice that in the case above, we're returning everything collected together in parentheses. This is just a way for us to be able to start our markup on the next line. We're going to talk more about that later, but I don't necessarily have to do that if in this case I'm just returning a simple h1. Let's go ahead and say React is great. Okay, I can hit save and notice that our h1 is not showing up. Well, we've created this function, but we're not, you could say, calling it or rendering an instance of main content. We can do that by surrounding the name of our function in what looks like HTML tags. Let's go ahead and hit save, and there we have our React is great main content component is rendering to our mini browser. This is awesome. A quick note, I do have to put this slash towards the end. If I don't include it, then I get some kind of Scrimba errors showing up here. So it's important that for self-closing components, which is mostly what we'll be dealing with in this course, I do have to make sure I include that slash at the end. And that covers the concept of composability in React. As we progress through the course, we are going to go a lot deeper into the concept of composability. We'll see a bunch of different ways that we can make our components much more composable than they are just as we see here. But I think this has been a good start and a great way for us to get our hands on the keyboard. Next, we're going to talk about another major reason why people love React and front-end libraries like React in general, and that is that it's declarative. So that's what we'll be talking about next. Another reason that we love React is because it is something that we call declarative. Declarative simply means that we can lean on the library of React to handle all of the manual, tedious tasks that we otherwise would have to worry about ourselves. And I think understanding declarative is most helpful if we look at its opposite, which is imperative. So with something declarative, we can tell the program what should be done, and we can think of it like the computer saying, just tell me what needs to happen and I'm going to worry about how to actually do it. Whereas with the opposite of imperative, we need to describe how things should be done. This is like the computer saying, I need you to describe to me every single step along the way on how to do something, and then I'll execute the steps that you tell me to execute. Let's see an example of this in code. So we have here just about as basic of a React app as you can possibly have, which is all we've really worked on so far. But I want you to get your hands on the keyboard and try out a challenge. Okay, your challenge is to recreate this above line of code, which is actually still showing in our mini browser because I haven't hit refresh yet. But by recreating it in vanilla JavaScript, by creating the h1 using the createElement method on the document, giving it some text content, just using the text content property of the new element you created, then giving that new element a class name of header, and then using append child to append this new element that you created to the div with the ID of root. And by the way, just so that we really drive this point home, I don't want you to use inner HTML to accomplish any of this. Using inner HTML is a little bit shady anyway. There's some situations where you can get in trouble by using it anyway. If it has been a while since you've done this kind of manual DOM manipulation, it's okay to search on Google to figure out how to do this. Use ChatGPT to help you out. Just don't let ChatGPT write all the code for you and then copy and paste it. Okay, it's your turn. Work on this challenge. Okay, so we can get our new h1. Let's say this is going to be, we'll just call it h1. And we'll use document.createElement. We'll create a new h1 element. We can add some text content to it by accessing the text content property. And maybe we'll just say this is manual imperative coding. Okay, I can give my h1 a class name by setting its class name equal to header. And then I can grab the div with the ID of root by using getElementById. We'll grab the root, and then I can say append child, and we'll append the new h1 there. Now, I don't think I've actually set up a class of header, but that's okay. Let's hit save, and sure enough, that worked just fine. This is imperative coding, though, as the header says, and it's because we've had to manually tell it every single step of the way. First, create a new element, then manually add this text content to it, then add a class name to it, and each one of these has to be on its own line of code. Then take this new h1 child that we have slowly built up over time, append it, grab the element with the ID of root, append the new h1 to it, And as this says, this is really imperative. We have to tell it every single step of the way what to do. The way that we have just seen how we do it in React is, of course, quite a bit more declarative. Here, we can simply say, hey, React, I'm going to let you figure out how you should really turn this into a text node inside of an h1 element. We, of course, would say the class name is equal to header in order to be consistent with what we have down below. And React is going to figure out how to do this. A really good analogy that I have heard of to illustrate the difference between declarative and imperative is if you were to go to a restaurant and tell the host, I'd like you to lead me down the hallway by 50 steps and then turn right, we'll walk another 35 steps, and I'd like you to then seat us at the booth on the left. In that case, we have had to direct the host on every single step of the way how to set us down at a table at a restaurant. The equivalent declarative way is to trust that the host will know exactly how to do their job, and all we would have to say is something like, we would like a table for 4. The host might then walk us to the exact same booth that we otherwise manually directed them to sit us at, but we've been able to offload those specific instructions to a person, or in the case of React, a library, that we can simply trust to do its job. Now, of course, with something as simple as putting a single h1 on the page, well, first of all, we likely would just do something like that directly into our HTML. But with React, where most of the content on our page is going to be created in JavaScript, this example already demonstrates how much nicer it is to do it in a more declarative way. And especially if you think of all the steps that would be required to create even something as simple as this little section project that we're going to work on, it's just going to be so much easier to do it in React, where every element can be structured and look just like HTML without us having to do all of the imperative, manual, tedious task of creating these text nodes and appending them to text elements and appending those text elements to their parents and so forth. Speaking of the ReactFacts project that you see here, it's time for us to jump in and start creating this from scratch. Before we jump right into our Section 1 project of ReactFacts, there's just a little bit of, I guess you could call it housekeeping, that I want to take care of, just so that we are set up to have success in working on this project. And in my regular style, I want to start us off with a challenge. I know you just did this exact same thing, but we're getting those repetitions in so that you can build the muscle memory in your fingers. I want you to set up a new React app from scratch. I've given you a couple hints here that should help you along the way. And in the end, I just want you to render a simple h1 element just like we did before. Okay, I'll hand it over to you. Work on this challenge. All right, let's clean up this text, and we need to import the createRoot method from react-dom/client. With that, we can create a root, and we do it, of course, by calling createRoot. Then we need to pass to createRoot a DOM node where all of our markup will be stuffed inside of, and React is going to handle all that for us, so we just need to grab that DOM node by calling something like document.getElementById or query selector. We'll go ahead and use getElementById to get the element with the ID of root. Once again, that's in our HTML. It's our actual markup right here, and React will be in charge of putting all of our markup that we eventually create in React right inside of this div. So this tells React where to eventually render the markup, and we need to then call the render method on the root, so root.render, and this is where we tell it what to render. We'll go ahead and put in our JSX, and we'll just say this is React. I don't know, I'm not getting very creative here. Okay, hitting save should make this show up. It should say this is React. Perfect. Okay, great job. Let's tackle the housekeeping I want to handle first. I mentioned in the very beginning that you might have noticed we're using this .jsx extension instead of a regular .js extension. I'm actually fairly certain this would work. If I were to rename this to just index.js and hit save, we're still working. However, under the hood, we're using Vite, which we did see a lesson on how to set that up locally. And in the documentation of Vite, they recommend that if you ever have a JavaScript file in React that is using JSX in any capacity, then you should use a .jsx extension instead of a regular .js extension. We won't necessarily go into why Vite expects you to do that. Just know that it really helps Vite in its ability to bundle your code performantly and just make things work smoothly in the end. So it's now .jsx. I need to come make sure that I'm referencing the .jsx file. And keep in mind, before I wrote this line, I really wouldn't have needed to do that. And if we were using that old API using createElement and doing all of this manually without JSX, then we wouldn't have to rename this to a JSX file. But because we are using this H1 right here with JSX, we need to make sure that it is a JSX file. Okay, that was one of the things I wanted to cover. The other little point of housekeeping I wanted to handle at this point was to talk something about images. In the ReactFacts project, we do have two logos. We've got the React logo up here in the header of this little project, and then we also have the logo floating around down here on the right side. With static images that aren't going to be changing or aren't coming from some kind of CDN or database, there is a kind of unique way that you have to deal with them that's different than what you might be familiar with when using vanilla HTML, CSS, and JavaScript. Let me go ahead and take the project that you just built here, and first of all, we'll go ahead and put this on its own line so we can just deal with this single line here by itself, and I'm going to change it to be an image element. When you're writing static HTML, you are probably pretty familiar with saying that your source is going to equal a string, and then that is going to be a relative path to where your image is living. I've put the React logo PNG file on the same level as my index.jsx file, and so I should be able to simply say react-logo.png. This is going to be a strange proportion, but when I hit save, you'll see that the React logo is showing up correctly. And the truth is, even at this point, if you were to download this project as a zip file and run it locally, install the dependencies, it would be using Vite in the background, this would still continue to work. However, if you aren't really following along here in Scrimba and you set up a new Vite project, there's a chance that putting a relative path in your image source like this wouldn't work correctly. So I wanted to address that now. If anybody who isn't following along here in Scrimba finds that when I talk about putting your image path in the same way that I have here, where it's just a path that's relative to the current file that you're writing in, and you find that it's not working, the quickest solution for now is to just make it an absolute path from your project root. For example, if all of your code is in an src folder, you might put /src and then keep working your way down to where this actual PNG file is. Maybe you have like an assets folder like that. And when you do that, this will start to work again. Now, my point of housekeeping here is to let you know there is a better way to deal with static images in React, but we're not quite yet set up to learn about that. That's actually going to happen in the next section. But again, I just wanted to get ahead of it a little bit at this point so that there isn't too much confusion happening from those of you not following along here in Scrimba. And there is one final point of housekeeping I want to take care of now, and that is to talk about what you do when you want to render multiple elements inside of your render. It's really common for us to have components in React that render more than just one HTML element. However, you'll notice if, for example, I have an image and then I also try to render, let's say underneath it, an H1 that says this is another element, I'm getting this warning here, and if you hover over it, it says JSX expressions must have one parent element. And it's true, when I'm trying to render something, I cannot render two elements side by side in the way that I'm attempting to here. Remember when we learned about how JSX compiles down to that call to create element, and this is a create element from React, so I'll just go ahead to make sure that's clear. We'll import create element from React. Well, trying to render two JSX elements side by side like this would kind of be like trying to do this. Create element, create element. Of course, I have a problem here, and I don't think this is exactly what it's trying to do, but I find it helpful to think of it as a problem in terms of trying to call two functions back to back like this on the same line. Let me get rid of this syntax error so that we can deal with this other one. And of course, I'm not limited to only ever rendering one thing at a time. I just need to make sure that it's wrapped together in a parent. So in React, this simply means that if I want to have two elements, I need to wrap them into a single parent element that can house both of those elements together. This is kind of akin to how we saw we can have create element. In this case, it would be similar to saying we have a div, we're not going to worry about props, and then the children would be calling another instance of create element. And this is okay to do. Now, for accessibility reasons, div should probably be the last resort of what you reach to. There are a lot of other semantically correct HTML elements that we could use in its place. For example, maybe a main element would make a little bit more sense here. Or if it's a section, it could be a section or an article. It can be really helpful to go over to MDN and learn about these semantically correct containers and choose the one that makes the most sense. Okay, we've covered a lot of ground in this random housekeeping lesson. As a quick recap, if you're ever going to have any amount of JSX inside of your file, make sure that you rename your file extension to be .jsx instead of .js. Secondly, when it comes to images, actually, let me fix the path here because hopefully that didn't cause too many problems. We can see that this is working. If I scroll down, we have our H1 there. When it comes to images, for now, I'm just going to be using a relative path, and there's a chance that doing so inside of a freshly created Vite project would cause problems. So I showed you how to use the absolute path from your project root in order to make this work for now, and we'll be seeing a kind of more accepted way to do this later. And last of all, you can only ever render a single JSX element at a time, and that element can have as many children as you want, but there does need to be one parent element that encapsulates all of the other elements you want to show up on the page. With that, we are now poised to start working on our ReactFacts page, and we're just going to take it one little step at a time. All right, I'm excited to get started on our section project. As a reminder, this is what we're aiming for, and in this particular challenge, we're aiming for this point. There's some really rudimentary styles that I've included in our index.css just so that this didn't look quite so much like an eyesore. But notice for now, I'm just styling the core elements, and you won't have to worry too much about this at this point. You are starting from scratch again. I'm sorry if that feels a bit obnoxious. I do want to have your memory working so that you're not just cruising along through this course without putting in the effort. Some hints here, if you're doing this here in Scrimba, for the image source, you can just set it equal to react-logo.png. I've included that here in the project on the same root folder as everything else. But as I mentioned in a previous scrim, if you're following along locally with a Vite project that you set up manually, then you might for now have to put an absolute path to this logo. We're soon going to be learning about another way we can pull in images when they're static images, but for now we're not quite there yet. Also, since we haven't officially learned about how to tie class names into our JSX or do inline styles, when you render this image, it's going to be quite a bit larger than what you see here, but you can just use the width property just like you can in HTML. In my example down there, I just have it set equal to 40 pixels in width. Okay, enough talking. I'll hand it over to you to get started on this challenge. Okay, we can go ahead and import create root from react-dom/client. We'll create a root with create root. Remember, when we're doing this, we pass to it where we want React to put everything. So we'll grab the DOM node where we want everything to get put inside of, and that will be with the div that has the ID of root in our HTML right here. And then when we call render, we're telling React what we want to put inside of that div. As a reminder, I can't render an image followed by a sibling h1 followed by my unordered list, but instead, I need to make sure that I'm only ever rendering a single parent element that surrounds everything. I could choose a div if I wanted to. I usually tend to do that as a last resort. For now, I'm just going to call it a main because that feels a little bit more semantically correct. Okay, let's surround these with the main like that, and I'll go ahead and stub out my unordered list with my 5 list items. Let's start with the image, and I'm going to add the source equal to React logo.png, and we'll see when I save, we get quite a large image here. This is where I think normally I would resort to adding some CSS to style this, but for now, we can see that we can just add width like we would in HTML and set this equal to 40 pixels. Okay, quite a bit more manageable. Let me go ahead and fill in the rest of the text, and I'll just cut to a finish point for that so you don't have to sit and watch me do that. And there we have it. All of our text is added in. One last thing I need to make sure I do is to add some alt text to my image. So I'll just say this is the React logo, and awesome. Now, of course, the project that we're working on here is very small in scope compared to a full website or web app that you would normally see. And right now we're just kind of stuffing everything right here inside of root.render. And I'm sure, as you have probably figured out or can imagine, this isn't going to be the long-term way that we do this. So next what we'll be doing is learning about how to make custom components, which will allow us a lot more flexibility and certainly a greater sense of organization than just trying to stuff everything inside of root.render. So that's what we'll be doing next. But before we jump into that, I have a little quiz that I want us to take just to reinforce the concepts that we've learned so far. Let's do a quick quiz before we move on and start learning about custom components in React. And what I'm going to do is mark this as a challenge in Scrimba, which will pause the playback and give you an opportunity to actually click here into the editor and type your answers down. And I would recommend actually typing the answers down because there's something about having to verbalize or write down your concise answer that requires you to think through it a little bit more rather than just kind of thinking within yourself, I kind of get the answer to that question. So when it pauses, actually click in here, read through the questions, answer them, and then we'll go through it together. Okay, where does React put all of the elements I create in JSX when I call root.render? Remember, there's two parts to creating this root and using this root. The first part is creating the root and telling it where you want to put all of the elements that get rendered, and then the second part is what you want to render in that spot. So when React renders all of this, it puts it all inside of this div with the ID of root, because that's the one we selected when we created this root. And you can actually verify that even here in Scrimba. If you open your developer tools and you select one of the elements in the mini browser here, if you dig deep enough, you'll eventually find this HTML document nested inside of the HTML document of the Scrimba window. And you can find the div with the ID of root, and you can expand it, and you'll see this main element, and it'll have an image and an H1 and unordered list and everything. So let me actually type down an answer here. Okay, it'll put all of those elements inside of the div with the ID of root, or of course you could choose a different element when you're calling create root and it'll put it inside of that element instead. Okay, number 2, what would show up in my console if I were to run this line of code, console log h1 with the text hello world? I intended this to be a little bit more of a generic answer, not necessarily giving me the exact structure, but the answer is an object. This object is just a plain JavaScript object. It does have its prototype chain set up in a specific way that React can recognize and use it, but it's just a plain JavaScript object. If we were to create a new element or create a new text node or something like that in plain JavaScript and console log that, it wouldn't be just a regular JavaScript object, it would be an instance of whatever it was that we were creating, like a new HTML element, for example. So let me fill out this answer a little more. And I just wrote out essentially what we just talked about. Okay, number 3, what is wrong with this code? Hopefully it was clear that I wasn't expecting you to say, well, it needed to import the create root method or anything like that. But instead, the point is that we can't have two sibling elements being rendered together like we show here. Instead, there has to be some kind of wrapper component, or element rather. So we might have a div, or let's say a section, just for kicks. So this would be the correct way, and now nothing is wrong with this code. Let me type that answer down. Again, you can only render one parent element at a time, and as a reminder, that parent element can have as many children elements as you want to put in there. Okay, let's scroll down a little bit. Number 4, what does it mean for something to be declarative instead of imperative? Imperative means you need to tell the computer exactly how to do its job. Step by step, you give it very specific instructions for it to accomplish the task. Whereas declarative, we can lean on the library or framework or whatever it is that we're using to do the heavy lifting for us. And we can write our code in a lot more of a descriptive way and let the tool, like React, handle the heavy lifting for us. You might have participated in or seen one of those challenges where you're supposed to describe to somebody how to make a peanut butter and jelly sandwich. And when the person takes the instructions very, very literally, it usually ends up as a big mess. That's more like giving imperative commands to doing a regular task, whereas the declarative way would be to say, please make a peanut butter and jelly sandwich, and you would just trust that the other person knows how to handle all of the steps along the way. I think another helpful way to think of the term declarative is to use this word describe. Declarative means we can write our code to simply describe what should show up on the page and allow the tool like React to handle the details on how to put those things on the page. HTML, for example, is a very declarative language because you simply describe the contents of a page and we expect the browser to know how to handle displaying that. In vanilla JavaScript, when you're trying to create a bunch of elements on the page, it's very imperative because without something like JSX, you can't simply type out the structure of your page. You need to create the nodes individually and append text to them and add click handlers and all sorts of things like that. I think I'm belaboring the point a little bit. Let's move on to number 5. What does it mean for something to be composable? All composable means for us in web development is that we can take larger sections of what we're trying to build and break it down into smaller pieces. We can make those pieces flexible enough to handle multiple different scenarios so that they can be reused in multiple different ways, which allows us to, in the end, write a little less code, which leads to fewer bugs and allows us to make something greater than if we just tried to, I guess metaphorically, carve the final product out of one single giant block of stone. So as an answer, that might look something like this. When something is composable, it means that we have small pieces that we can put together to make something larger or greater than what the individual pieces themselves could possibly make. Great job on this quiz. Hopefully all of this was pretty straightforward at this point. This is a great chance to do some self-reflection and see if you think you might be falling behind, then this is not the time to just keep pushing forward. Remember, nobody's giving you a grade for this course. You're not going to receive some kind of award by going through it quicker. In fact, in the end, you're less likely to get the outcomes that you want if you plow ahead without understanding what we're learning. Keep up the great work, and next we're going to look into making custom components in React. When we first started talking about components, we saw this example where we can encapsulate a bunch of logic inside of our own custom components, almost like our own custom HTML elements, which gives us a lot of flexibility to reuse those elements whenever we need to, make changes in one place and have it reflect that change everywhere, and ultimately provide us a lot of composability with the way that we write our user interfaces. So far, we have not really been doing that at all. We've been stuffing everything inside of root.render, which has served us really well as we're learning the basic syntax, but it's time for us to jump into creating our own custom component. Now, it's not actually the first time that you've done it, because you got your hands on super early in the course where you were able to create your own main content component. And what we saw back then was that we used the concept of a function to give us the power of reusability. And I'm sure this is a familiar concept because functions are used in every programming language that I know of, and its purpose is to encapsulate reusable pieces of code, allow you some flexibility with things like adding parameters to it, and then to call that function whenever you need to accomplish that task. And that's exactly what we do when we're creating custom components. Let's see an example of how we might intuit creating custom components, and then we'll see just some really slight tweaks to make it sort of the more accepted React way. Let's say I wanted to take everything here that I am currently rendering inside of root.render and put it inside of its own custom component. Well, just like any other function, let's go ahead and try this. We'll say I want to return this markup. And notice that here I'm starting with the main element right here on the same line as my return. This is viable. As long as I start on the same line with my JSX, all of the other JSX will kind of follow as part of the return. However, it's much prettier to put this inside of parentheses. I can just wrap everything inside of parentheses, and that allows me to keep my JSX markup on its own lines. Let's give this function a name. Maybe we'll just call it maybe temporary name for now. Clearly, we're going to be changing this, and I probably should spell temporary correctly. Okay, well, what would happen if inside of root.render, instead of having all of my JSX there, I just called temporary name? Let's make this a little bit larger, and let's save it and see what happens. And look at that, it's working just fine. And this makes sense because we're returning those JavaScript objects that get created with JSX code from our temporary name. So it's essentially the same thing as if we just cut this out and pasted it in this temporary name function calls place. However, when we're dealing with React, as you have seen, this isn't really how we render these components. The first thing to know is that with custom components in React, we have to use something called Pascal case. It's essentially the same thing as camel case, where normally you would have a space, you remove the space and put a capital letter. The only difference is we need to start with a capital letter as well. So we would have temporary name with a capital T at the beginning. So let me go ahead and change this up here. And then the only other difference is instead of calling it like a regular function with the parentheses, we would surround it in angle brackets in very much the same way we would a self-closing HTML element. Okay, let's hit save. And awesome, things are working exactly like they were. Not only that, but now we're following the regular React convention. Okay, guess what time it is? It's time for a challenge. And guess what? I'm not going to make you write it all from scratch again, at least not right now. Okay, the first part of your challenge is to create a new page component. That page component should return an ordered list of the reasons why you're excited to be here learning React. Don't worry too much about this list, just throw something in there and make it fun. Then after you've created the definition for that custom component, make sure that you render it to the page so it actually shows up in the mini browser. Okay, good luck. Work on this challenge. Okay, well, to create a new custom component, we create a new function. We'll call it page with a capital P, and we can have it return some JSX. I'm going to surround it in parentheses so I can put it on its own lines, and we'll have it be, actually it's supposed to be an ordered list. And we'll just put in a couple list items here. Maybe for one, we'll say React is a popular library, so I will be able to fit in with all the coolest devs out there. Awesome. And I don't know, for the other one, let's say that I am more likely to get a job as a front-end developer if I know React. And I think there's some truth to that. React is the most popular UI library out there. Knowing React doesn't hurt by any means when applying to jobs. Let's clean up this challenge text, and let's see what happens at this point if I hit save. Notice that our page is still blank. Well, that's because we've defined our component, but we are not creating an instance of it. We're not rendering it at all. Again, I technically could call it like it were a function, and we see that that kind of works. However, the, of course, much stronger convention is for us to render it as if it were an HTML element by surrounding it in those angle brackets. While we're looking at this, I think it's important to note that while throughout this course, we're mostly going to be dealing with self-closing components like we see here, any component that you create can also have its own separate closing tag like we see here, and you can see if I hit save, it's going to be working exactly the same. In my advanced course here on Scrimba, I do talk a lot more about this way of using components. This is another example of how components are very composable, opening up quite a bit of power to developers when it comes time to placing some elements inside. Don't worry too much about this because, as I mentioned, we're not really going to be doing a whole lot of this throughout this course, so we'll just be sticking mostly to the self-closing syntax that we see here. Okay, nice work on part 1 of this challenge. In part 2, we're going to be adding a little bit more to the page that we see here. This would be a perfect time to, again, do a self-assessment to see if you are ready to move on. One thing you could do, and I'll mention this a few times, is you could just delete everything and see if you can build the whole thing again from scratch without any help. So I'll bring all this back, but that is an exercise that you are more than welcome to impose upon yourself at any point throughout this course. When you're ready, let's move on, and we'll start on part 2 of the challenge. All right, let's get started on part 2 of this challenge. And actually at the end of this challenge, our little silly page that we're making here is going to look an awful lot like the ReactFacts section project that we're going to be building as well. I've broken the steps down into 3 bullet points. Each one represents another section of our page. So the first thing I want you to do is to add a header element. That will be the first thing that we're returning from our page component, and that will just have an image element inside. Make sure to read the text for any of the details here about setting the source, the width, or the alt text. After that, I want you to add an H1 to our main page that has something like reasons I'm excited to learn React. Put it above the ordered list and then wrap both the H1 and the ordered list in a main element. Again, this is allowing us to maintain some semantic structuring inside of our little page here. Then at the bottom, you'll add a footer that just has some text like this. Okay, I'll turn it over to you. Go ahead and work on this challenge. I think the biggest trick in this challenge is that as soon as you add a header, you're now trying to render 2 sibling elements at once. If you hover your mouse over here on the closing parenthesis where the red squiggly is, it very helpfully tells us JSX expressions must have 1 parent element. For now, what I'm going to do is just add a div to surround these, but very soon we're going to talk about another way that we can accomplish this. A div will work just great for us for now. Inside our header, we'll add an image element, and we'll just go ahead and add those 3 attributes. We have our source, our width, and of course, width is not a required attribute by any means. Very shortly, we're going to learn more about how to use real CSS to do this sort of thing. And as always, we should make sure we include our alt text. Okay, for our second bullet point here, I'm actually going to work a little bit backwards. I'm going to first surround everything in a main element. Okay, and then I'll add my h1 here at the top. I think my spacing is a little bit funny here because of the way I had it formatted. Let me fix this. Okay, it's been a minute since we hit save. Let's go ahead and see how we're doing. Okay, things are looking pretty good. We have one final thing, and that is to add our footer. And this wasn't really part of the challenge. I think I'm going to put this in a small tag like this, just to provide it a little less emphasis. And let's just go ahead and copy what we see here. And at the time of recording, we are in 2024. And my last name is Ziroll. So we'll just put that in there. And awesome. Let me hit save. Good. Now we're protected from people trying to steal our really important code here. Let's go ahead and clean up the challenge text. And awesome. Hopefully that wasn't too big of a challenge. If it was, that's completely okay. And again, that's a perfect sign that tells you that it's time to keep practicing this before pushing ahead. Now, some of you seeing this might be wondering why we're just shoving everything together into this one large page component. This doesn't really teach us about composability and how we can make our own smaller custom components that each do one little piece at a time. And you would be right. We are going to be doing this very soon, and that should improve the composability and the readability of our code. Before we do that, I have another quick quiz that I want to give, and then we'll jump right into making multiple different custom components and talking about the relationship between parent and child components. Okay, let's do another really quick quiz. You know the deal. I'll mark this as a challenge. It'll pause the stream, and I actually want you to click in and type your answers down under each one of these questions. Then we'll go over everything together. Okay, number one, what is a React component? Simply put, a React component is a function that returns React elements. Okay, so what exactly is a React element? Well, a React element is a React version of what we see in the DOM. You can think of it kind of like the React version of an HTML element, and because JSX looks so similar to HTML elements, we call them React elements. However, the main difference is when we're returning React elements like our div and our header and everything else that you see here. Well, first is turning the JSX syntax into calls to React.createElement, and then the createElement function is turning them into JavaScript objects that React then is able to interpret and turn into real DOM nodes under the hood. So in answer to this question, we say that a React component is simply a function that returns React elements, and I think the pluralization here is key. Sometimes you'll hear people talk about how this is UI that the React component is returning. This is just short for user interface. It essentially means the same thing we just talked about. Okay, number two, what is wrong with the code that we see here? Well, it is a pretty small change, but we need to make sure that when we're defining our components in React, we need to use what's called Pascal case, and that is where the first letter is capitalized. The rest of it follows the regular rules of camel casing. All right, and then number three, what is wrong with the code that you see here? The component itself is perfectly fine. However, when it comes time to render that component, and render in this case just means to create an instance of this component and let React put it on our actual page, we don't call it like a regular function as you see here. Instead, we surround it in the angle brackets similar to regular HTML syntax. This is a way to signify to React that we want to create an instance of this header component, which under the hood essentially calls our component, returns the header element with the image inside, these React elements, as we talked about in question number one, which then eventually get compiled down to those JavaScript objects, which React then interprets as real elements in the DOM. I know when I list out that many different steps, it makes it seem a little bit inefficient, but trust me, React is very fast at doing all of this. Okay, short and sweet. Hopefully you were able to follow along. Next, we're going to be learning more about how we can compose our components together. I mentioned that there would be an alternative to surrounding everything that we see here in a div like I did here to avoid that issue with multiple different JSX elements trying to be rendered all at once. And this workaround is something that React has actually created itself. We're going to import something called F fragment, and that comes directly from the React library. This is a so-called built-in component from React that we can use, and we can render it right here as if it were a regular HTML element. We'll put the closing fragment down here at the bottom. Need to make sure I close this correctly. And I can indent everything, and we see that that error has gone away. I can hit save, and my page is going to display the same way it was before. There's a slight difference, though, in the resulting HTML. When I had a div here, remember that I'm rendering that div and all of its contents directly here inside of my HTML. And so what I end up getting is another nested div whose purpose doesn't really exist. And then all of the other markup that I have here. If I were to just copy and paste this into my HTML, this is essentially what React would be creating. When I use a fragment, React will not actually insert another nested level of an element here. It's a workaround that allows us to combine multiple different elements together, but without creating another DOM node that it has to worry about. So by using a fragment, I essentially end up with this. It's a little bit cleaner. It doesn't insert unnecessary elements into the DOM as much. It also can have a couple other random side effects, like when you're dealing with Flexbox or grid containers and child elements. Most of that is a bit beyond the scope of what we're concerned about right now. Let me clean up my HTML here, since React is going to be doing that work for us. And one final thing I want to talk about is this is a little bit cumbersome to have to import the capital F fragment like this. And so React has actually implemented a simpler way where instead of typing out fragment, I can put an empty angle bracket set just like this, and then I don't need to import anything. So when you're looking at my code or other React code, you might see these empty angle brackets just like you see here, and under the hood, that's just creating a fragment, which essentially allows us to bypass that issue about rendering multiple sibling React elements together. No real challenge with this one, just wanted to make sure I covered that base. As we've talked about, it's really not ideal that we have a single page component and we're just stuffing all of our markup into that page component. Don't get me wrong, in real React apps, this is still a very, very small component. These components can sometimes become hundreds of lines long, and there's legitimate reasons to do it that way. But that wouldn't be a great learning experience for us as we're trying to learn more about composing our components together. To help illustrate this, I'm going to provide a quick mini challenge for you. Okay, in this challenge, I want you to take the header element that we're currently rendering inside of the page component and move it into its own component called header. Then in its place, I want you to render an instance of that new header component so that when you hit save, well, everything will pretty much look exactly the same way you see it now. Okay, go ahead and give this your best shot. All right, well, if we want to create another component, we won't want to do that inside of our page component here, but instead outside of it. So I'm going to create a new header function. It will return the code right here, these elements, this header element, and that does the first part of the challenge. Next, all we need to do is create an instance of that header component, and we'll do it in the exact same way that we've seen before and that we see down here with the page component. We'll surround the name of our function in these angle brackets just like that. I'll hit save, and my header is still up here at the top. Now, of course, when we're dealing with such a small application like we see here, this is probably overkill. I think I'm probably prematurely optimizing to create separate components like this. But I hope the idea is coming across. When you're working on a larger application, your header is very unlikely to be 3 lines of code. It might include a lot more dealing with user interaction, pulling in data from a database, and all sorts of more complex things like that. In those cases, I think it becomes much more apparent that it's really, really helpful to move that kind of logic into its own separate component, thus compartmentalizing it and making it not only reusable, but a lot easier to deal with as a developer. Okay, let's continue on with this challenge. Just to get a little extra repetition in, the continuation of this challenge is to move both the main element into its own component that you call main content and the footer element into its own component called footer. Then make sure that you remove that from the page component and render main content and footer in its place. Go ahead and work on this challenge. Okay, let's go ahead and create a new function called main content. And before I work on that, I'll go ahead and create my footer component as well. Let's add a return to each of these. Okay, we'll come down here and copy or rather cut out the main element here and put it inside of our main content. And we'll do the same thing with our footer. Again, if I hit save at this point, we'll see that I'm only showing my header because my page is only rendering my header component. So we'll go ahead and render our main content and our footer. Hit save, and we're back where we started. Again, I know this might seem a little bit tedious. Hopefully getting the repetition in like that is a good thing. As a React developer, you are going to write hundreds and thousands of components, so this is really just starting you out on that journey. Also, again, this is pretty clear that it's prematurely optimizing to create these 3 separate components. If you were to know that this was the extent of the page you were trying to create, then you probably wouldn't do this. However, in most scenarios, it really does make a lot more sense to have a separate header component, maybe a separate footer component, and then probably quite a bit more than just a single main content component that contains the main portions of your site. Let me go ahead and clean up the challenge text. And before we move on, I just want to talk about the terminology of parent and child components. What we've done here is set up a bit of a hierarchy where we have a page component, and that page component, which we're rendering right here, will on its own render a header component and the other 2 components. And typically in a larger React app, this will continue on down the tree where, for example, the main content component might be rendering other custom components, and those ones will probably be rendering other custom components, creating this tree hierarchy, which results in what we call parent components and child components. And you can take that analogy as far down the line as you want, calling grandchild components and grandparent components, which in the end allows us to really create a masterpiece of composed custom React components together, which, similar to that statue of David made out of Lego bricks, allows us to create the website or web application that we want to create. All right, nice job on that challenge. At this point, I think it's well overdue for us to learn more about how we can style our components, because right now we're not doing a whole lot of styling here. We're doing some inline styling with the width attribute, and I have some CSS that's just selecting entire elements. And so let's go ahead and see what it takes for us to add some CSS to our components. Let's get started first by completing another challenge. Inside of our header, right here where I've left a space for you, I want you to add a nav element. Inside that nav element, you should add an unordered list, which should contain 3 list items. And those list items should say pricing, about, and contact. Don't worry at this point about any kind of styling. It's not going to look very pretty. Go ahead and work on this challenge. Okay, so let's add a nav element like this. Inside that nav, we'll add an unordered list, and we'll have 3 list items. Those will say pricing, about, and contact. Okay, let's see what we've gotten ourselves into. We'll hit save, and it's beautiful. Done, ship it. No, let's learn about some styling so that we can make this look actually like a navigation bar instead of this weird 1990s website. Fortunately, styling something in React is not that different than you are already familiar with using vanilla HTML and CSS. Let me clean up this challenge text and head over to our HTML file. Notice that we are linking our style sheet here inside of our HTML file, which means just like in regular vanilla HTML and CSS, we can just add any classes that we want to our JSX over here in React, and then access those classes in our CSS file in order to style them. However, as we've briefly touched on, there is one minor difference, and that is whenever we're styling something in JSX, we won't use class equals, but instead we'll use class name with a capital N. And there's actually a good reason for this. I think a common misconception is that people think, well, we're inside of a JavaScript file and the word class is a reserved keyword in JavaScript when you're creating a new class of something. But that's actually not the reason that we use class name in React. Remember that React is going to take these JSX elements and eventually turn them into native DOM elements. And when we're creating a DOM element, like if I were to say we're creating a new unordered list, I would use document.createElement, unordered list. And then in JavaScript, if I wanted to add a class name to that, I would say ul.className equals, and then set it equal to the class name that I want it to have. Of course, in vanilla DOM JavaScript, there's also things like class list where you can add properties and so forth, but that's not what we're concerned with at this point. Under the hood, I'm accessing the native DOM properties of this unordered list that I'm creating in JSX. And so something you'll just have to become used to in React, whenever you want to add a class to your JSX, you'll use the property class name instead. So with our unordered list, maybe we'll give this the class name of, I don't know, nav-list maybe? Obviously, in such a small setup, it might be easier just to select the nav and then the unordered list inside of nav, but that kind of defeats the purpose of learning about CSS with classes. So with our unordered list with the class name of navlist, we can go over to our CSS and let's select navlist just like we are used to doing with a dot at the beginning because it's a class name. And maybe the first thing we should do is take off those bullet points by saying list style none. And sure enough, there it goes. Our bullet points are gone. Okay, and with that under our belts, that brings us to the next part of our challenge. The next part of the challenge is to use Flexbox and line our list items up horizontally so that they're in line with the React logo, which should in the end look something more like this. I think in this example I did bump up the font size, but you don't have to worry about that if you don't want to. As I've written in the note here, just for practice's sake, I don't want you selecting any bare elements like selecting the entire nav or the entire unordered list, but make sure that you add a class anywhere that you're wanting to do some styling. All right, it's your turn to work on this challenge. I think the trickiest part with this challenge is having to create a couple different Flexbox containers. So let's just start right here with our unordered list, which we already have a class name for. So I should be able to say display flex. And okay, the items are lining up. That's great. I'm going to worry about the spacing in just a minute, but for now, let's get it so that the logo and the unordered list are in a line. If we look at our markup again, we have our logo right here, and our nav is the next item that needs to be aligned, which means that the parent of these two, the header, is what needs to become a flex container. I could just select the header. I think if I were doing this for real, I probably would just select the header in this case, but I'm going to give it a class name of header just so we can get a little extra typing practice in there. And then in our CSS, we will, actually I'm going to put this above the nav list, we'll say .header is display flex, and oh, I need to hit save here so that applies. Okay, cool, those are now in a line. Of course, it looks like things got a little bit squeezed with our logo, which is just kind of what happens when you make something a flex container with an image in it. It will stretch it to be the full height. In order to fix that, I can say align, let's see, items to the center, and yeah, that set my logo back to the same proportions that it was before. Because I just have the two items, the image element and the nav element, I think I can just say justify content space between, and sure enough, that pushed the nav over here to the right. And then I think I'm going to have to style each one of these list items, and only because I'm a man of my word, I'm going to add a class name to each one of them. In the real world, I would just select the li children of the navlist element. We'll go ahead and call this navlist item. Okay, in our, well, let's hit save. I have to remember to hit save on Scrimba there. And then we'll select the .navlist item. And my goal is to get some spacing here. I think if I put a margin, let's try margin right of 10 pixels. And wow, actually that looks pretty good. I think I might bump up the font size to just something like 1.1 rem just to see. Yep, I think that's pretty good. I actually think my margin right is putting a space over here on the right. Let's try margin left, and I think that might be a little better. I think my nav and the rest of my page is going to line up a little bit nicer that way. Now my image is looking a little bit smaller than I think I would like it to. And so now that we know how to add styles with classes, let's go ahead and do a third part of our challenge. All right, the last challenge in this scrim is to move the width style off of the JSX on the image here and over into the CSS using a dedicated class name on the image element. Then make sure to change that width to 55 pixels instead of the 40 pixels that we currently have. Let's pause now to work on this challenge. All right, let's give this a dedicated class name. Maybe we'll just call this nav-logo. and I'll hit save. We'll go over to the CSS and access the nav-logo, give it a width of 55 pixels. And well, look at that. It automatically applied immediately. As soon as I finish that, we can go over to the element again and remove that 40 pixel width. And okay, that's looking pretty good. Now, before we move on, I want to encourage you to take some time to put some additional effort into styling the page that we have here. Obviously, what we have is just about as basic as it could possibly get. I did this myself, and I put maybe 5 minutes of styling into this, and I think it shows. It's definitely not going to win any design awards or anything like that, but give it your own little flair. You don't even have to use this dark theme that we've been using. You can switch it to something completely different and fun. I want this to be not only an opportunity to practice playing in the code, which is probably why you're here on Scrimba in the first place, but also to give you an opportunity to interact with the Scrimba community, especially the Scrimba community over on Discord. There's a dedicated I Built This channel in our Scrimba Discord server, and that would be a great place to put your own design tweak on this, post it over there in the I Built This channel, and really feel proud about what you've done so far in this course. Once you've had a chance to put some flair on this and post something in the Discord server, then come back here to the course and we'll keep moving forward. We've spent some time separating each of the parts of our main app into different components, but these components are still kind of cluttering up our index.jsx file. Especially as these components were to get larger and larger as we built our site out, we would find this not to be a tenable solution, as I'm sure you can imagine. Fortunately, moving these components into their own files is a really simple task. Here in the Project Explorer, I'm going to create a new file and we'll call it header.jsx. Remember, because the header component has JSX in it, whenever we have a file that will contain JSX, we need to make sure we use the .jsx extension so that Vite does a more thorough job when it comes to compiling our code down. So like I said, this process is going to be pretty straightforward. I'm going to cut the header component out from the index file and go over to my header file and paste it in here. Now, if I save this, I'm going to get errors because I'm missing the header component that I'm trying to render in my index file. It's trying to render header, but it doesn't know anything about header. So I'm going to place a challenge pause here just to give you a chance to think through what the steps are that need to happen in order for this to start working again. You're welcome to actually do those steps if you want, but it's not necessarily what I'm expecting at this point. We'll do that in just a second with the other components. I think there's just 2 small changes we need to make in order for our page to start working again, so take a second to see if you can figure out what those are. Well, currently our header is kind of trapped inside of our header file. And so I need to make sure that I export this component. There's a lot of different ways to do this. One of the most common ways I see is just using export default in front of your function. Of course, technically, because this is a default export, we don't necessarily have to give it a name, but I think for debugging purposes, this actually ends up being pretty beneficial for us. Okay, so now we have a way to send our header component out of the header file. Let's go over to our index, and all we need to do is to import it. And because I exported default, I can just say import header. I don't have to surround it in curly braces because I'm exporting it as a default, and I will import that from ./H header. If this is your first time dealing with exports and imports in JavaScript, as a really quick high-level overview, when you default export something, all you have to do is say import, and then you can call it whatever you want at this point. I could have said whatever component. And then as long as I called it whatever component down here, whatever component, it should just work. I'll go ahead and hit save and we'll see that we're up and running again. Naturally, I like to just keep everything consistently named, so of course I'm going to rename this to header. Also, as a quick recap for imports and exports, here because I'm beginning this with a ./, that's a way to indicate that I'm importing this from my own file and not from a third-party package that lives in my node modules folder. It also has a default of .js for the extension, and in this case it also tends to work with .jsx, so I don't have to include that part, but I think some teams decide they do want to do that. A lot of things just end up being conventions that you have to learn from whatever project or team you're on. It's most important to stick with the conventions of your project and just to stay consistent. Okay, I renamed that. Let's hit save. We can see that we're up and running. All right, it's your turn. Let me type out a challenge. Okay, not too shocking, but your challenge is to move the main content component and the footer components into their own separate files, probably just called maincontent.jsx and footer.jsx. And then, of course, you'll need to do whatever else needs to happen in order for our app to continue working. Go ahead and get started on this challenge. All right, let's create a couple new files, maincontent.jsx and footer.jsx. It's probably helpful to note right now, I'm just kind of stuffing everything here at the project root because we don't have that much. Oftentimes you'll find people creating a folder that's called components and putting all of their designated component files into that folder. And of course, as your project gets larger and larger, you'll have to come up with more intense ways to organize things so that it's not too overwhelming. Every project tends to be different, so don't take what I'm doing here as gospel and be willing to be flexible. As long as you understand the principles, it should all be pretty straightforward. Okay, let's take our main content component and we will put it into our main content here. I'm going to just type out export default and then paste in the rest of the component. We'll go ahead and do the same thing for our footer. We'll take that out, put it in our footer, export default. And we need to remember to import those things, so I'll go ahead and do that. Because I chose the same names as what we had before, I won't need to make any changes there. Our index file now looks really clean, and everything is still working. As always, feel free to play around with this code if you want to move things into their own components folder and change your imports just to play around with things. That would be a great way to get your hands on the code even more. Then, whenever you're ready, let's keep moving forward. When I'm starting out on a new project, one thing that I really like to do is try to solidify a mental model of how I'm going to build a certain app or page. At this point in the process, I'm not trying to write out exactly what I'm trying to create. I'm simply making sure I understand what needs to show up on the page and how I might go about creating that. This is a great time to tackle any tricky areas of a specific design that I think I might run into and start thinking about that earlier rather than later. So I'm going to mark a challenge here. I want you to take just a minute or two and see if you can figure out how you would separate each part of this page, what kinds of elements you might use, any specific CSS you might decide to use, and stuff like that. So go ahead and take a minute to think about that. In web development, there's always a lot of different ways to approach a specific problem, so the way that I'm thinking about this may not be the same that you did, and that's okay. When I see this page, I see two main parent components. One would be this header, which fortunately doesn't have a whole lot in there for us, and then sort of a main content section. This one, unlike the practice one that we were doing, doesn't have a footer. Inside the header, I might just have a single logo that contains both the icon and the text. A lot of brands will make sure that their text is actually part of the image to make sure it's the same. For no particular reason, we're going to actually use this as a text element, so we'll have two elements. We'll have the logo image itself and then some text. To me, I can just see right now, because I will have these inline, I could either use an image and a span, both of which are inline elements, and I probably won't face too many issues with that. Of course, if I do run into anything, I usually just tend to resort directly to Flexbox, and that's a great way for me to get things all aligned nice and neatly. And then I just have maybe an H1 sitting here in the main content of our page and our unordered list. And then of course in the background we have sort of a partial background image. We're going to see how we might tackle that. Once I've started creating this mental model, I can start thinking of those portions of the page in terms of actual elements that I want to create. Oftentimes I will put everything inside of some sort of container. In this case, I just have it as a div with a class name of container. And then we have our two main sections, our header section and our main section. So those would be our header element and our main element in HTML. And although we don't really have other navigation elements like we had in our practice app with the pricing, about, and contact, very typically clicking the logo or the logo text, I guess in our case, would send you back to the home page of a website. So that would be considered part of the navigation. We're not going to bother with anchor tags in this case, but it still would make sense for us to set it up correctly and put it inside of a nav element. That's where we'll have an image and a span perhaps, and we'll make sure to apply some styles to those. Then in our main section, as we said, we just have a simple H1 and then an unordered list with some list items, and everything should be pretty peachy from there. It seems like it's going to be a pretty straightforward project. By way of organization, I probably will do a very similar setup as I had before, where I might have some sort of app component, which will be in charge of rendering essentially everything. And then that app component will render a header component, which will contain the markup in our header section up here, and maybe a main or a main content component, just like we had in our practice, that renders everything on the main element. Hopefully that can be a helpful practice for you. Feel free to adapt it to whatever makes the most sense for you, but I do find that it tends to be one of the best ways when I'm preparing for a new project to make sure that I get started off on the right foot. With this quick mental outline of the project behind us, let's jump into a series of challenges where you will have a chance to build each piece of this section project. Let's get the very bare bones of this project set up. And as a little gift, I'm not going to require you to write any more create root code. Hopefully you've had enough repetition now that if you needed to, you could do that again. So let me walk through the steps and then I'll hand it over to you to work on this first part of the project. First, I want you to create a separate app.jsx file. It will be a sibling to this current index.jsx file. And you're going to create a new app component. It's just going to be called app. This is a really common way to set up a React app where you'll have index.jsx, which is involved in setting up things like the root and doing other more project configuration style things, and then having a separate file like app.jsx, which will export a component called app or something along those lines, whose job it is to aggregate all of the other parts of your app that you want. It acts as sort of a parent component to everything that will get displayed on your page. After that, I want you to create a separate components folder, and you're going to create two different component files inside, a navbar.jsx and a main.jsx. For now, in those components, all you'll need to do is render something like an h1 that says like navbar goes here or main component goes here. Make sure to export those, and inside of the app component that you just created before this, you'll import and render the navbar and main components. Then, inside of this file, index.jsx, you'll import and render the app component right here in root.render. As a final step, and this one might require a little bit of extra research if you haven't done this before, I want you to go over to Google Fonts and get the Inter font with the weights of 400, 600, and 700. Then just add the links to those Google Fonts here in the index.html file. And make sure to do it above this link element here so it'll go up here. Okay, that's all the steps for this challenge. It's quite a bit to do, but I think you should be able to do it relatively quickly. So I'll hand it over to you to work on this challenge. All right, let's start by creating some files. I'll create a new app.jsx with a capital A in app. And here we will just get set up. We'll export default our app function. And you know what, let's take it one little step at a time. I'll first render an h1 here that says app component here. Let's go over to index.jsx and import it. We'll import app from ./app. And down here, let's just get it rendered. This is kind of a nice intermediate way for us to just make sure that everything is working correctly. Okay, cool. App component here. Now let's create our components folder. And inside components, I'll go ahead and create a navbar.jsx and a main.jsx. And I'll just copy and paste. This is kind of the cheater way, but it'll save a little bit of time. We'll call this main, and we'll say that's the main component. And we'll do the same thing for navbar. Okay, and then over in app.jsx, we don't want this to be rendering its own markup per se, at least not right now, but instead we want to import our main component, and that's going to be from ./components, because we're inside the components folder, /main, and we'll import navbar from ./components/navbar. And then we will just render the, let's see, we'll do the navbar first. And then because we have two siblings that we're trying to render, we need to wrap them in some kind of parent. We'll just use a fragment at this time. And we hit save, and awesome, looks like that's working great. Okay, then we need to bring in, I think as a final step, a little bit separate from everything else, some Google fonts. We're going to bring in the Inter font with the weights 400, 600, and 700. And actually, it looks like at the time of recording this, Google Fonts has introduced something called variable fonts, which allow me to bring in the font and then set a specific style to change the font kind of however I want with the weights. So we'll just go ahead and bring in the variable font. It's totally okay if you didn't do it that way during the challenge, but I can just bring in those links. And we're not ready to use these quite yet, but I'll go over to index.jsx and just clean up our challenge text. And cool, we're in a great starting place. In the next part of our section project challenge, we will be working on the navigation bar styling at the top. I wanted to give some fair warning about the next few challenges that we are about to do. There will be a few points throughout this entire course where we're working on our section project, and it does kind of turn into mostly CSS work. I'm going to leave it up to you to decide if you want the refresher on CSS or you want the challenge of working on the CSS. Of course, doing the CSS and styling is likely to be a large part of any front-end job that you have. And so personally, I think it's good experience, but if you are coming to this course with quite a bit of experience in CSS and styling in general, following a design and getting your project to look the way it's supposed to look, then you have my kind of hesitant permission to skip the CSS portions of the upcoming lessons. That said, if you've never tried to mimic a design from a design program like Figma, or it's been a while since you've done any CSS, then I highly, highly recommend that you do complete the CSS portions of these challenges that we're about to do. In this lesson, we're just going to be focusing on the navigation bar at the top. If you click the screenshot here, that will take you to the Figma design where you can see things like the font, the sizing, the colors, and so forth. I'm also going to leave this Google slide in the lower corner if you need to reference the Figma design again in one of the future lessons that we do during this project. So let's get started on the nav bar. Your challenge is to complete the nav bar so that it looks like the design. I have a couple hints here for semantic HTML purposes. The nav bar should render a header as its top level component, and it should have a nav element nested inside. Then we can put the image and the text of ReactFacts, which in our case will be two separate elements. They can both be rendered inside of the nav as children. And semantically, it makes sense because typically in a navigation bar, your site's logo in the nav bar on the upper left will also include some kind of anchor that navigates the user to the homepage usually. And then as a hint, I've already mentioned this, but make sure you reference the Figma design so you can get the most accurate information about the colors and sizes and so forth. All right, it's your turn. Give this nav bar your best shot. All right, so instead of an H1, let's go ahead and render our header element. Inside the header, we will add a nav element. And our nav is going to have an image, and we'll fill this out in just a second. And then the text, let's just go ahead and add this as a span. I can type in ReactFacts right now. I think we can get rid of the challenge text. We kind of have an idea of what we're doing. Let's hit save. And okay, all we see is ReactFacts. That's probably what we'd expect. Let's fill out the image, and then we'll have a bunch of styling to do. So first, we need to make sure we have a source. And remember, image sources here in Scrimba might end up being a little bit different than the way that you're doing them locally. If you're using, for example, a Vite project, I think it will work if I type in a relative path. I'm here inside of my components folder, so I need to make sure to go back a directory. And then I have my react-logo.png right there. Let's see if that works. Okay, that does work. I think if I do an absolute path from the project root, it should also work. Yeah, our image is showing up. I'm just going to leave it like this because I think this will work a majority of the computers. And very soon we'll be learning about another way we can bring in this logo that will work across whatever platform you're using. Okay, in our image, we want to make sure we always include an alt text. So we'll say this is the React logo. And from there, we are just going to have some styling to do. I think that's pretty much all that's left for this challenge. So I could go through and add class names to everything. More power to you if that's how you decided to do this challenge. It's great to get practice with class name. However, because I know that this site is just going to have one header, one nav, and that nav is only going to have one image and one span inside, I'm going to shortcut that a little bit and just access these elements. So this is the point at which we'll mostly be working in CSS. And again, if you already feel very, very comfortable with CSS, it's okay. You have my permission to skip this part. Otherwise, please stick around and watch this process. I've chosen to include this because I think it could be a helpful reminder and helpful practice for a lot of people taking this course. So let's move over to our CSS file. And this image is driving me a little bit crazy. Let's access the image inside of our nav and say that the width is, let's give it 30 pixels. And boy, 30 just looks a little bit small. I think the design says 30, but I don't know. I think I like 40 a little better. We might even bump that up a little more later. Okay, so by default, ReactFacts is not aligned to the center. Vertical aligning like this, I personally believe, is best done with Flexbox. So I'm going to access the parent and make it a Flex container. So that's the nav element. Let me just make sure. And yeah, so our nav will be the Flex parent or the Flex container, and the image and the span will become the Flex items inside of it. So this will be display Flex. And then we can align the items to the center, and perfect, that looks pretty good. If I look at the design, the entire header shows that it is about 90 pixels. So I'm going to style the header and give it a height of 90 pixels. And I think that makes it so the nav is not taking up all that space. You know what, before we do anything else, I'm going to give it a background color and just bring in the, say, the background color from the design on Figma, which is this color. And yeah, we can see that that's not the correct height. So now that the header has a height, let's just make sure that the nav has a height of 100% so that it fills the entire parent container. And cool, now that's centered. It's pushed pretty close up there to the left, and that's because I had added this margin of 0 to the body. I kind of need that, because if I don't, then we can see we get that gap around our header. So let's leave this at 0, but then we can just add some padding inside of, honestly, I don't think it would matter if it's the header or the nav. Let's go ahead and put it inside the header, and let's give it maybe 30 pixels on the top and bottom and 25 pixels on the left and right. I think that looks pretty good. Okay, now I think the biggest eyesore is the text of ReactFacts, which is barely visible right now. Let's separate it from the image by about the 7 pixels that the design shows. So we'll give the image itself a margin right of 7 pixels. I guess we could also give the span a margin left of 7 pixels. I don't think it would matter too much either way. And let's go ahead and select that text. So this is going to be the nav with the child of a span. And again, I just as easily could have gone here and given class names to everything. Maybe just so I'm covering my bases, just as a reminder, we don't say class equals, but we say class name with a capital N equals, and then everything else is exactly the same as you're used to with regular classes. In this case, I am going to take the shortcut. Okay, the color is driving me crazy. Let's switch it to the blue color from the design, and let's bump up the font size a bit. And the design does say that it's 22.25 pixels. If we take that and divide it by 16, we can get the rem size, which is a better practice to use for our font size anyway. I'm going to round a little bit and say that it's about 1.3 rem. And actually, I think it more closely rounds to 1.4. So let's just bump that up again. Okay, that's looking pretty good. The font is not quite right though. And that's where our inter font comes into play. I'm just going to style the entire body to have that. So we'll say the font family is going to be inter. Let me make sure that is, yeah, that's working. Okay, great. And maybe we'll just give a sans serif backup for that. If we look at the design, that ReactFacts text has a font weight of 700, and that is looking pretty darn good. All right, that's really taking shape. Great job working on this challenge. Next, we'll naturally be styling the main content section. All right, I'm going to have the same caveat for this lesson. We are mostly doing CSS in this challenge, so do with that what you will. If you could use practice in CSS, then we would love to have you do this challenge. Either way, I do want you to at least add all of the markup that needs to happen here. So let's take a look at the challenge itself. Just like the navbar challenge, we're going to be building out the main content section so that it matches what we see in the Figma design. There are two aspects of the Figma design that I want you to skip for now because we'll be doing those as separate challenges. One is having the bullets on the side be a different color, and I believe a different size. And the second is this side React logo over here. Don't worry about those two aspects, but do worry about everything else that you see and try to match the design as closely as possible. Go ahead and get started on this challenge. Okay, let's do the markup here. I'm going to surround everything in a main element since that's semantically correct for the main content on our page. And we will have the fun facts about React be an H1 here, so I'll go ahead and type that in. And then simply enough, we have an unordered list. This should feel pretty familiar because our challenges earlier on in the course were essentially doing this exact same thing. And with that, we'll just have 5 list items. And I'll go ahead on a Mac and hit Option-Shift down, and that will let me copy this line. And I won't make you sit and watch me type out all of the text here, so I'll go ahead and copy and paste that in. All right, let's hit save, and awesome, that's a great start. Let me make this a little bit bigger so we have a little more space to see these items. And we are just going to jump over to the CSS now and get started working on that. First, let's get the background and the text in the right color. I think I'm just going to set a background color on the body. If instead I were to style the main element, which I'm sure we could make work, but we'll see, let me comment this one out and put it here on main. Yeah, we'll see that we have actually a couple issues that are highlighted here. First of all, we get some collapsing margin happening with our H1. The default margin on the top of the H1 is actually pushing our entire main section down, and so we get that white stripe there. And secondly, we're not taking up the full height of our page. We might address that in just a minute, but I think it makes a ton of sense to put the background color just on the body, so we don't have to worry about that, so that's what we'll do for now. I am currently pushed all the way up to the left here because the body has a margin of 0, and again, I don't want to add margin to the body because that's going to kind of mess up our header up there. So that's a perfect thing for us to do on the main element. We'll go ahead and give this some padding, and it looks like it's about 60 pixels on the top and about 30 pixels on the left. We'll just let that go top and bottom and left and right. And that's looking pretty far down. I do think that's because of that H1 margin. So I'll go ahead and select the H1 inside of my main and set the margin to 0. And yeah, that looks a lot closer. Because I set a dark background on the body, I think I also am going to use the body selector to select the color and just change it to white. That way, if I did create a footer or something and wanted that text to also be white because it's a dark background, then I wouldn't have to repeat that style. But I don't know, we're venturing into realms where it really doesn't matter how you do it at that point. All right, let's set the font size here while we're at it. And the design currently shows that it's 39 pixels. That translates to about 2.4 rem. So that's what we'll set that at. Let me make this a little wider again. Okay, let's start working on our list. The lines look like they're pretty tight together, and the design shows that there's about 20 pixels of space between them. At this point, I suppose I could say main and then child selector of unordered list. But at this point, because I might have multiple unordered lists, I'm just going to kind of do my own personal best practice. And in my main section, I'll go ahead and give this a class name. And let's say it's the facts list. Okay, then over in our CSS, I can just select .facts list. And it looks like it's about 46 pixels pushed away from the header. So let's give this a margin top of 46 pixels. Make this a little taller here. And I think actually if I make this wider, we can see this one starts to get a little bit wide. In this case, it's not so bad. But if we were to add more facts, for example, that had a lot more words, we would end up with a full width list item there. And so maybe what I'll do is give this a max width. And let's just say something like 400 pixels. That way, when this gets really wide, we are still limiting ourselves to the width of this list. I don't know, that's a design decision that might not make a big difference right now. Okay, let's add some space above and below each of the list items. I'll just go ahead and select the facts list and get all the list items inside of there. And I can add a margin to both the top and the bottom by using margin block. So that will allow me to say 10 pixels on the top and 10 pixels on the bottom of each item. And that gives us a little bit of extra space there. That's nice. And in the design, if we look really closely, each of these also has a line height set, and it says 19 pixels. Let's see if that really makes much of a difference. And boy, there's barely any difference there, but it does make a little bit of a difference, especially when it starts to wrap. So we'll just leave it in there. And one other thing I actually just realized is my items are not spaced as much as I thought they would be. The design shows them as 20 pixels apart, but I just realized that when I'm doing margin block, the bottom margin for one item and the top margin for the other are collapsing together into a single 10 pixel margin. So I can either set this to margin block of 20 pixels, and that actually looks a little bit more correctly spaced, or I think I can do padding block of 10 pixels, and padding does not collapse in the same way. I think I'm going to leave it just here at padding blocks so I don't have to worry about thinking about collapsing margins in the future. But either way should work just fine. And okay, this is in a pretty good place. The only other two things we have on this project, like I mentioned, is to color the bullets here and then to add the little React logo on the right. Those do have a little bit of a gotcha to them, so we're just going to do them separately in their own challenges. I'll remove this challenge text, and we will go ahead and start tackling those challenges next. I was going to have coloring the bullets so that they were a little bit larger and blue be a challenge that I gave you. And of course, if you want to try and do it on your own, you're more than welcome to do that. A really common way to customize bullets like this are to completely remove the bullets from the unordered list and then to use a before pseudo element and create your own little CSS shape that is in the shape of a bullet. But at that point, it felt a little too, I guess, nitty-gritty to be really diving into doing that with CSS in the middle of the React course. I know I said it's good to practice CSS, but I think that might have been a little bit overkill. Instead, we're going to stray just a tiny bit from the design, and we're going to use a special pseudo selector called marker. So I can grab my list items here, and I can use : marker. And this is a pseudo selector that's very specifically intended to add styles to your bullet points in list items. I can grab the color of, let's see, our span right here. And actually I can just grab this whole style, I think. Let's go ahead and set the color. And just like that, our bullets are now the same blue color as ReactFacts. I am allowed to style any font properties like font size. And I did find that 1.5 rems is about as large as I can go before these start getting misaligned. We can see if I were to make this something really large, like 4 rems, that the alignment ends up being a little bit messed up. And I tried for quite a while to get these to align and couldn't really do that. If you know of a good way to do this, then please reach out to me on the Scrimba Discord server. I would love to know how you did it. But that said, don't waste a bunch of time on it. I'm just going to set it to 1.5 where they look like they're still pretty well aligned, and we'll just leave it at that. It does stray a little bit from the design because I think these bullets are a little bit bigger than what we see there. They're probably more like 2 rem, but I just couldn't deal with the misalignment. It was bugging me just a little too much. Okay, you get that one for free. Didn't make you do any work there. The last little design thing we'll add is the logo over here, and that will pretty much wrap up the ReactFacts section project for us. We just have one more tiny thing that we're going to add, and that is the React logo that's floating here in the background. Because this isn't an element that is really a semantically important part of our markup, I'm just going to have you add it as a background image instead of trying to add it as an image element. For example, I don't need a screen reader to read that there's an image element here or have it be accessible via the keyboard or anything like that, so I think it's okay for it to just be a background image on the main element. The challenges that we've done up until now at least had a little bit of markup that you had to write React code or JSX code for. This one is going to be purely CSS, so I do give you permission. If you feel completely solid with your CSS skills, I give you permission to skip this one. That said, I think CSS can be fun, so even if you are, you're welcome to stick around and do this challenge. I've given some hints about how you should use the background image with the URL, and one thing I did add is the React logo half.png file here. It is only the actual half of the logo, like it looks like here. It's not just bleeding off the side of the page. That just has more to do with how I exported it from Figma, but honestly, it makes the job a little bit easier to match the design that we see here. One thing I'm going to do really quick, just because it's bugging me, is I'm going to create an images folder, and I'm going to move my logos into that images folder, and that means I need to come over to my navbar and just fix my reference here. We're going to start with /images. Hitting save, and okay, everything is working great. Read the challenge text here, and I'll pass it on to you to start working on the challenge. Okay, on our main element, I'm going to add a background image, and we'll set that to a URL. I think in CSS I don't have to have my quotation marks, so I'm just going to say /images /React logo half.png. Awesome, there we go. By default, it is repeating, so I'm going to add the background repeat property and just set that to the value of no repeat. Okay, and that's making it float by default in the upper left, so that's where the background position comes from. And background position is actually a combination of two different properties. So there's background position X and background position Y. In fact, let's just use those to start and then we'll make it short. So X would be the left and right, or the horizontal positioning. And one option I have here is to put it all the way to the right. That looks pretty good. That's halfway there. And then I would add background position Y, and right doesn't make sense there because we're talking about up and down. So I could say top, which I think is the default in this case. I could say bottom, and that pushes it a little bit too far to the bottom. I can say center, and that puts it directly in the center, although it looks a little bit high compared to the design. The design looks like it's not exactly in the center. So what I can do is provide a percentage of where it should sit in that direction. So I think if I were to put it at something like 65%, that seems about right. So maybe we'll just stick with 65%. Now I can combine these though and make these a little bit more straightforward. So we'll say background position right, space, 65%, and then I can get rid of my specific background position X and Y properties. And now I'm just being picky, but I think this might be just a hair lower. We'll go ahead and say, yeah, let's stick it at 70%. Keep in mind, we're not really doing any mobile first or desktop first designs. If I start to make this really large, then things, I don't know, they don't look great. They're breaking down a little bit. But for now, this is going to work okay for us. Again, CSS isn't really the point of this course. Again, if you feel pretty comfortable with the background shorthand property, then you actually can combine these three together and just say background is this value, space, this value, space, this value. Myself, I always forget what order these need to be in, so I either have to look it up or I just choose to do this three separate properties like we have here. Okay, let me clean up the challenge text here, and let's just navigate over to our index page so we can actually be looking at some React code again. Hopefully for some of you that was helpful to spend some time on the CSS. We will be going back and forth to CSS a little bit as the course progresses, but I'm excited, as I'm sure you are, to get back to learning more about React. We've just barely started scratching the surface of what React is capable of doing. Now we have a few administrative details to help set us up for success through this course, and then we'll be doing a recap of the actual React things that we've learned so far. So buckle up, we're just getting started and it gets more and more exciting from here. Hey yo, you did it. You built your first React project. I know it might not seem like much, but it's really exciting. These first few steps of building a static page are really crucial in your journey to learning React. As a quick recap, the things that we've learned, we talked about why we should even care about React in the first place. We talked about how the composability paradigm that it introduces is super helpful in how you can structure your applications going forward, and how its declarative nature just really improves the developer experience. We practiced time and time again, probably too many times in your eyes, how to set up a new React project, but we also talked about how you can set things up locally on your own machine using Vite. Scrimba is a great environment to play around with your code and to learn very interactively like we're doing here, but eventually you'll be wanting to build your own projects on your local machine, so we made sure to cover that. We talked about JSX and how it's a so-called syntactic sugar on top of React.createElement, and how in the end, all it's doing is returning JavaScript objects. Those objects then describe what React should be placing on the page, and it gives us React developers a really nice, familiar syntax that we can use to describe what should end up in our web app. We built our own custom components, which is the crux of having composability in React. And truth be told, we have yet only scratched the surface of the ways in which building custom components gives you the flexibility that composition gives. And just so we're not left with something terrible to look at, we talked about styling and spent a fair amount of time actually building the styles for our app. If you haven't yet done so, this would be an ideal time to head over to the Scrimba Discord community and post a message about the accomplishment of finishing section 1 of the React course. You can click on the screenshot you see here for an invite to the Discord community and a link directly to the Today I Did channel. This might be a good time to take a quick break from learning React if you have found yourself binging this course. It's important for your brain to rest and relax so that it can actually digest the information you've already consumed and make some space for what is to come. And we do have some really exciting things to come. So once you're ready, let's go ahead and jump into the next section. With the basic concepts and syntax of building static pages in React under our belt, we are now poised to progress forward and start learning about how we can write data-driven React apps. You see, in our previous project, everything that was displaying on the page, we had hard-coded directly into our markup. And there certainly is still a place for hard-coded text on a page. Anything that is considered static or unchanging is going to be written directly into the code. However, we are soon going to learn about how the power of React comes not only from its composability and declarative nature, but from its ability to receive information in the form of data and use that to produce reusable components on the page. The project we'll be building in this section is going to be a travel journal. And the primary thing that will make it different from the static page that we made in the previous section is that all of the information that we see on the page is actually going to be contained in a regular JavaScript file in the form of regular objects and arrays. This is the completed project over here, and you can see that we have this data.js file where all of the information lives, and then the React code that we write will take this array, iterate over it, and produce React components with that information inserted in the correct place. Feel free to peruse around this code to see if you can get a cursory level understanding of what's going on. And as always, you can click on the screenshot you see here to take you to the Figma design, so you can be prepared to start building this project based on the real colors and spacing that are defined in the Figma file. In this section, we are going to be learning first, of course, why reusability is important, and we'll recognize that it's actually something that you are exposed to in just about every website you visit. Then we'll dive into the syntax for the primary vehicle for doing reusability and data-driven React components, which is something called props. Then, with an understanding of how props works, we will create components from an array of data, just like we were talking about earlier. And of course, this wouldn't be a real Scrimba course if we didn't include a ton of hands-on challenges along the way. So warm up those fingers, get ready to complete all of the challenges in this section, which is what we'll be diving into right away. We'll start working on this section project of the travel journal by having kind of a softball challenge. This will mostly be review of the things that we've learned previously. Our task is simply to make this header section for the travel journal. The first thing you should do is click on the screenshot here. That's going to open this design in Figma so you can see the details for this design. And I've tried to set you up for success with this project by including a fairly detailed description of the task at hand. A couple things that I have done already for you. If we look in our index.html, I've pulled in the Google font of Inter, which is the font that you'll see is used here in the design. And then I've also pulled in this little globe image just right here as globe.png. And so you'll be able to use that as your image source. Feel free to style this however you want. You can use class names, or because this is a relatively small app, I'm okay if you want to use some element selectors, assuming you're using some good semantic HTML for the app. If it's been a minute since you finished section 1, this will be a great way to brush off the rest. So I'll hand it over to you to work on this challenge. All right, so let's create an app component in a separate file. So I'll just create a new file called app.jsx. And before I jump back and forth, I'll go ahead and import it, even though it's not really exporting yet. We'll get that in just a second. So we'll import app from the app file, and then I'll just go ahead and render my app right here. All right, I think I'll probably error if I hit save, so I'm not going to do that quite yet. We'll go over to app.jsx, and I will export default my function app. And just as a sanity check, just to make sure things are working, I like to just render something like an h1 that says I'm the app component. Okay, let's hit save. Okay, good. No mistakes so far. We're importing the app and rendering it correctly. Let's go check out our challenge text. Okay, so that's this first part done. Next, we need to create a components folder and a header component, which I guess I wasn't explicit about that being inside the components folder, but hopefully you figured that out. It's not a big deal if you didn't. Something probably important to point out is that our app is going to end up being really small. There's not a whole lot to this page, as you can see. And so creating a separate components folder is maybe a little bit of overkill, or maybe you like doing it. File organization really does end up being pretty subjective. And so just make sure you're following the conventions of whatever project you're in, or if it's your own project, you can make up whatever conventions you want. Just to see it done a little bit differently than we have been, I'm going to create this components folder, And inside, I'll create a header.jsx file. And let's see, what did the challenge tell us to do? Create a components folder, header component, render the header inside the app component. Okay, that was a little bit vague, but that's what I was trying to do. So we'll export default function header, and we'll have it also just return an h1 for now. I'm the header component. We're exporting it here. Now let's go over to app, and inside our app, we're going to import header from, and now our path has to start with ./components/H header. Okay, instead of our h1, let's go ahead and render our header, and I'm the header component. Perfect. All right, let's see what else we have. That is done now. Let's go back to our header, and instead of returning an h1, I'm going to return a semantic HTML header element. Inside the header, I'll go ahead and put my image. This is the little globe image, so my source is going to be, now let's see, I'm inside my header, which is inside the components folder, and I need to be outside the components folder, so I need to go /globe.png. And then we'll go ahead and I guess we can call our text for the My Travel Journal. We'll just call that an h1, and we'll say that's My Travel Journal. Let's hit save. And the globe is impossible to see because it's white on a white background. Let's see, if we give the header a background of red. Okay, awesome. There's our globe, and we have our text. Let's go back to our challenge, and I guess we can mark the second one off. And the third one is basically all design. At this point, we've done all of the React-specific stuff we're going to do with this challenge. If you already feel really comfortable with your CSS skills, then I do give you permission to skip the rest of this as we're just going to be doing CSS. However, even if a little bit you want to get some extra practice with CSS or watch how somebody else writes their CSS, then please, by all means, stick around. We'll get through this pretty quickly. Because my page is so small and I only have one header, I'm going to select the elements from the header just directly. So we have our header, and instead of a background of red, if I go and look over at the design, I can see that the color is actually this color. And let's go ahead and get the layout correct. I'm going to use display of flex just to get everything lined up. And it's pretty huge right now, but I'll go ahead and justify content to the center. The text is actually white, so we'll change the color to white. I can see from the design that the height is 55 pixels. Oh, okay, and we need to also align our items to the center. And I think that should be everything for this section itself. Now let's go ahead and style the image. So I'll select the image that's inside the header. Again, if you were to ever consider putting more than one image in here, you might want to give this some kind of class name like, I don't know, .globe or something. I trust that you understand the concept of class name in React and selecting with classes in general in CSS, so I'm just going to keep it simple for now. It looks like the width of this little globe is 24 pixels. And if I look closely, it has a margin right of 7 pixels. And then let's go ahead and select my H1. We'll change the font size back down to 1 rem. And actually the design shows that it's a little bit smaller than 16 pixels. So maybe I don't know, just kind of estimate at this point, 0.9 rem, we'll say. I think the font weight is a little bit lower, so we'll go ahead and say the font weight is 500, and that looks a little more accurate to the design. And the font family is different too. The font family is Inter. And let's see, is that making a difference? Yes, it is. Perfect. One last thing that I just realized we didn't do, we always have to put our alt text on our images. So I'll say maybe globe icon. Okay, let's go see, and yep, we were able to do that one. And so let's go ahead and check that off. And I guess now that we've done that and scratched that itch, let's go ahead and clean up this challenge text. And awesome, great work. Everything we've done so far should represent things that you have already learned by this point in the course. If maybe you're picking up this course again after a little bit of a break and some of this feels unfamiliar, this is the best time to go back and review what you might be a little bit rusty on. And I say that because we're now ready to move forward on our section project and start learning about how we can make the rest of this page here. Once you feel good and ready, let's keep moving forward. Let's jump right in and start building an instance of our journal entry component. The main purpose of this exercise is to highlight the fact that we're not quite ready to finish off the app as we currently have it, at least not in a reasonable way that starts to use the potential of React. So your challenge is to build out the entry component, and there's a couple things that I've done for you since we last saw this code. First of all, I created the entry.jsx file already for you, so you don't have to worry about that. I also pulled in the little marker icon that's just sitting right here next to the country name or the location name. And that's just right here inside of a new images folder that I created, and it's called marker.png. I also pulled the globe.png in there just because that made sense and fixed the reference to it in the header. Now, since your task is going to be creating an instance of this component and filling out the data, it will require you to hardcode that data for now. And in an effort to try and make that a little bit less tedious, I've included this japan.md file. We're going to delete this pretty soon, but this just has the text here so you can copy and paste it, at least without having to go back and forth between the designs so much. All right, let's go back to our challenge text. Some notes I included. I only want you to render one instance of this entry component. And I guess I wasn't explicit about this, but you will want to render that inside of the app, just right underneath header. You might already recognize that's going to include its own little challenge, but I'm not going to say anything more about that. As I've mentioned, I pulled in marker.png, so make sure you use that. And then a reminder that the main purpose of this challenge is to show you where some of our limitations in our understanding of React currently are. So don't worry about the fact that you're hard coding all of this data into the component. Some of you may not have been worried about that in the first place. Okay, I think I've set you up with everything you need. So I'll pass it over to you to work on this challenge. Okay, let's go ahead and we're going to export default a new function called entry. This is called entry because it's like a journal entry in our travel journal. And when I look at the design, I see everything in this entry as a surrounding div, or I think if I were to be a bit more semantically correct, this might work out as an HTML article element. Planning out the CSS ahead, I might put this as two separate elements and use a flexbox going this way, and then the elements that are in here might end up just naturally flowing top to bottom if they're all block elements, although this view on Google Maps, I might have to do a little bit something with that. And that's okay, we'll figure it out as we go. So I want to, from each of my entries, we'll go ahead and return a parent article element. And you know what, I'm going to build out the structure first, and then I'll come back and do some styling, which means it's going to look pretty terrible for a little bit. Let's just throw everything on the page. So I have my main image, and I just realized I didn't put the URL to the image in my japan.md, so hopefully that didn't cause too many issues with anybody. But the URL is very clearly listed in the design, and you should have been over in the design anyway. So we'll go ahead and give it this URL there, and we always need to include our alt. Let's go ahead and say Mount Fuji. Okay, kind of reading this left to right, we next would run into our little image of the marker there, and then the location name, and the view on Google Maps link. So I'm going to surround all three of these items in its own div just so I can give it some flexbox styling. We'll go ahead and create a div, and we'll fill out those images. So we have an image source of... We're inside of our components folder, so I need to go out and then into images and then to marker.png. We'll include our alt that says a marker icon. Maybe call it a map marker icon. All right, the next thing we had the name of the country that we were visiting, and I don't know, for now I think I'm just going to use a span because that's also an inline element. Let's just go ahead and do that. We'll say this was Japan. And then we had a link, so that's my anchor, and I'll need an href that goes to the link for Google Maps. Go ahead and just grab this, and we'll put that in there. Oh, and this is not self-closing. We need some text on it, so we'll say view on Google Maps. Now I'm flying blind a little bit here because I haven't created an instance of my entry component. Let's go ahead and hit save. No errors, that's always good. Let's go over to our app.js, and let's import our entry. I'll just copy this one. All right, so here is where there's kind of a little gotcha. If you remember, we can't put two sibling components side by side like this. Now, I don't think I have a reason yet to wrap everything. If I need to add some styles, I might have to change this to a container div of some sort. But because I don't want to add a bunch of extra stuff to it, I'm just going to use these fragments, and that solves that problem there. Let's go ahead and hit save. And my image is ginormous. Let's go ahead and start styling that part up. So over in my entry, I'm going to buy myself a little bit of room by cleaning up this challenge text. I'm going to start off by making my article into a Flex container. I think that will be an okay way to do it. This is coding. We might change things along the way. Oh, and I do want to give my article a class name. And let's call it, let's say it's a journal entry, just so it's really clear what we're doing here. Okay, let's go to our CSS and create a journal entry. Sometimes I like to put the name of the element here just so that it's really clear what we're doing. I think it makes it a little bit easier to find. And let's give it a display of flex. Okay, so I should be able to scroll over to the right and see that. And now let's go ahead and style up this image. It's not the only image, and I don't really want to just select the direct children, so let's go ahead and give this a class name as well. And we'll say this is, I don't know, maybe this is the main image. Yeah, that's good enough. All right, back to our CSS. Let's style our main image. And in the design, we can see that the width is set to 125 pixels. And I bet this was a little bit tricky because the URLs that we're using, they have a different aspect ratio than what our design shows. Our design shows a portrait where it's taller than it is wide, and the actual image itself is wider than it is tall. The fix for this is for me to use the object fit CSS rule, but it does mean that I need a container for it. So over here, I'll go ahead and just create a little container. And I can surround my image in that container. We'll give this a class name of, let's go main image container. All right, now that I've done that in my CSS, we can select our main image container, give it the height and width that we want. So this is actually what we want here. And we can specify the height, which in the design shows 168 pixels, very specific. And we need an overflow of hidden. Then we can tell the image we want it to have a height of 100% the container, a width of 100% the container, and object fit of, let's use cover. And actually that's looking pretty good. We do need rounded corners though, so let's give this a border radius of 5 pixels. Just a little subtle rounded corner there. We'll worry about our spacing in a little bit. I'm going to make this a little bit wider for us. Okay, making good progress so far. Let's deal with getting the rest of the content on the page, and then we'll do some final touches, or I might just do the final touches for you. Let's go ahead and call each one of these an H2. That seems logical. So in our entry, let's see, where are we? We have this div. H2s are block level, so that should put it onto the next line for us. And oh, well, let's see, that needs to be inside this div if we want it to do that. Okay. And let's see, this says Mount Fuji. Let's just see where it is. Oh, okay, that's better than I thought it would be. It's a good start. Then we'll give another block element. I guess we could call the date an H3. Well, no, it doesn't feel like a header. Let's go ahead and just call it a paragraph, and we'll style it up to be a little more bold. Let's go grab our dates, and we'll do another paragraph here. All right, let's see how we did. Oh, well, because we're using a display of flex, our item here shrunk in order to fit all of the long text here. We can counteract that by, in our CSS, let's see, in our image container, we need to say flex shrink of 0. And at this point, I'm just going to use the magic of editing. And just like that, with the snap of a finger, all of the design for our entry component is done. If only it were that easy in real life, right? I think I'll probably increase the size of this just a little bit so we can see all of our text. And awesome. It might not be 100% perfect, but that's okay. It's good enough for us to move on. Hopefully, as you were doing this exercise, you could see that there's a pretty significant limitation to the way that we're hard coding all of the data here in our entry component. As it stands, if we wanted to create a second entry, we would likely have to create another entry component, and that doesn't really make sense when it comes to using reusable components because, well, obviously we're not taking advantage of the reusability aspect of a component in React. Feel free to look at some of the changes that I made in the markup or the CSS. Although they're not crucial to your understanding of React, it can sometimes be overwhelming to be tossed into a big change like what we just saw with the design. Then once you're ready, let's move forward and start talking about how we can make this entry component more reusable. As we've already discussed, the way that we have our entry component set up is not reusable at all. If we were to go to our app.jsx and create another instance of our entry component, we're constrained to having another trip to Mount Fuji. And that's because the way that we set it up is by hard coding all of the information directly here into the component. So obviously this isn't going to be our ultimate solution because we want our travel journal to have more than one destination in it. The idea of reusable components can be found all over the internet. If you go to Amazon.com, for example, you can see we have this list of new releases in cell phones and accessories. And although the information in each one of these products is different, the structure of it appears to be exactly the same. We have a little badge icon, an image, a product name, a rating, and a price. And you will see this all over the web. Let's take IMDb, for example. When it comes time for a new movie to be entered as a fan favorite, you can imagine there isn't a developer who's jumping in and typing the HTML code down furiously to try and get this new movie entered into the fan favorites list. Instead, what's displayed here is data-driven, which means all someone has to do at IMDb is add a new movie to the database, and the site will automatically update to display the repeated elements of that new movie here in this list, which consist of a cover image, a rating, a title, and so forth. And as you can imagine, React has a solution for structuring our code in a way that is more similar to this, where it can be data-driven. We're going to talk about the data-driven aspect of React a little bit later, but for now we can see that our component is so hard-coded that there's no meaningful way for us to have it represent different kinds of data. And in React, this is where the concept of props comes into play. In my years of teaching React, I have found that props tends to be one of the first hurdles for people that are just getting into learning React. And so my plan is to take the topic of props and to spread it out a little bit thin. We'll take one little step at a time, and in typical Scrimba fashion, you'll get your hands on the keyboard. And I think by the end, you'll have a really solid understanding of how props works in React. So without further ado, let's jump in and start learning one of the most impactful and exciting aspects of React. Let's start by understanding the basic concept of props in React. What you see here is just a plain index.html file. We haven't introduced anything dealing with React in this. I want you to take a close look at the elements that you see here and see if you can figure out what's wrong with them. Let's start with the anchor tag. An A tag, an anchor tag, is intended to link you to another place. But currently we don't have an attribute like the href specified. Without an href, this link is essentially useless. We need the href property in order for us to send someone to another page, maybe like google.com. Similarly, the image element is basically useless without any kind of source property. We need to add this source attribute or property in order to specify exactly what image will be here. We could put the path to a local file, or we could put the address of a file that's hosted somewhere on the internet. Input is interesting because I think on its own, it actually will put an input box that we could type into if we wanted to. However, there are attributes or properties that we can add to the input that will make it a lot more, let's say, beefed up or capable. For example, I can add a placeholder that says something like first name, and that suddenly makes the first name text appear inside of my element on the page. Or there's ones that have even more consequence to them, like the type property. If I change the type of this input to something totally different like submit, now it changes from an input text box to a button. Similarly, I could change it to radio and it completely changes the visual look of this input. These are concepts that I'm sure you're already very familiar with. Let's look at a similar parallel example in JavaScript. Here I've written a function that's called add two numbers together, and it just hard returns 1 and 2. Think for a second, what is wrong with this function? It's syntactically correct, but what's wrong with a function like this? Well, it's very, very limited in its capabilities. Right now, if I call add two numbers together, it will always return 3. Essentially, it's a useless function. Now, you might already see where I'm going with this. If I add some parameters, like let's say A and B, to this function, now I can dynamically add and return the result, or rather the sum, of the two numbers that I pass in. And with the small addition of these two parameters that I've added, I now have sort of beefed up this function in a way that it's capable of adding whatever two numbers I want, not just the hard-coded 1 and 2 that used to be there. Again, these concepts should be familiar to you by now, but this is just a primer for us to understand the concept of props in React. In both of these instances, in JavaScript and HTML, we can see that passing additional information to our maybe elements, or in this case, functions, allows us to reuse these elements or functions in multiple different ways. So with that primer under our belts, let's look at another conceptual parallel that is a little more visual. Let's take a second to understand props in a little bit more of a visual way. Here we have a screenshot, albeit kind of an older screenshot from YouTube. And as we look around the site, and honestly, as you look around pretty much any web app, you're going to find this repeated nature of different components on the page. For example, here in this top playlist, we have a number of different videos, each of which has a very similar structure. We have an image on the top half. In some bold text right below that, we have the title of the video. And there's other aspects too, like the viewership count. Each video also has a little timestamp in the lower right, and the other visual aspects that you see here. Obviously, you can imagine that whenever a new video gets uploaded to YouTube, there isn't a developer that's going in and manually recreating any of this content, but instead, the data of that new video, like the cover image, the title, the number of views, and so forth, is being stored in a database. And this flexible, reusable component is able to receive the information about that specific video in order to display it as a unique video on YouTube. And as you become more familiar with this concept, you'll start to see how these reusable components can be nested together. For example, not only do we have individual, let's call them video tile components, but we have repeated lists of those video tile components, which maybe we would call it something like a video tile list or a video list component. Inside of those video list components are a nested list of video tile components. And kind of as we saw on the Apple website, there's this section over here on the left, which, albeit pretty small, is probably a repeated component. Each one of these just has an icon and a title. Okay, I think I've beat this concept into the ground. I think you're probably starting to understand it. Now let's go back to some React code and see how we can actually implement this in the code. There's one more quick thing we need to cover before we can start using props in React, which is the way that we will be able to make our components more reusable. We've learned about JSX and how this syntax that looks very much like HTML is able to be interpreted as a way to create new elements on the page, and whatever we put in between our opening tag and our closing tag, just like in HTML, is what will actually get rendered as, in this case, text, or in some cases, other nested elements on our website. However, one of the most common things you'll find yourself doing is having some sort of variable or value that you need to have displaying on your page. For example, let's say in the process of creating our component, we came up with a first name, which let's set it equal to Joe, and a last name, which we'll set to Schmo. And instead of saying hello world, we wanted to say hello Joe Schmo. When you're first learning React, it might be tempting to try and just stick first name in here and then a space and then last name. Or maybe as we're used to doing it in vanilla JavaScript, we might do some string concatenations. We might try to say first name plus a blank space and then plus the last name. Now, I'm not going to hit save yet, but I want you to think about what it is that will happen when I refresh this page. Some of you probably figured out that it's just going to literally display the text that I put between my opening and closing h1 element. Fortunately, React has made it really easy for us to interpret JavaScript values in the middle of our JSX as opposed to literally displaying this text as if it were what I wanted displaying on the screen. And the way I can do that is by simply surrounding any JavaScript values with a single set of curly braces. So we'll see, I'll be able to hit save, and now Joe is correctly coming through. So that brings us to the first challenge that I'm going to give you. Simply enough, your challenge is to finish off this h1 below so that it says, hello, Joe Schmo. There shouldn't be any of these characters or the variable name, last name, or anything like that. Go ahead and work on this challenge. All right, simply enough, all we need to do is get rid of those characters and then surround last name in a set of curly braces. Now let's talk for a second about what's going on with this line. When React is being transpiled or compiled to regular JavaScript, this less than symbol followed by the name of the element followed by the greater than symbol, it's able to interpret that as the beginning of being in JSX. I kind of like to think of it as entering into JSX land, let's call it. Once we're in JSX land, the code that we have that follows will be interpreted literally on the screen like we see with this word hello. However, once we run into this opening curly brace, React says, okay, we're no longer in JSX. What follows should be interpreted as regular JavaScript. And thus we enter what you, I guess, could call JavaScript land. And here in JavaScript land, we have this variable first name, which has been declared earlier, just like we would in normal JavaScript. And so it gets interpreted, or rather the actual value that first name represents gets put into the place of this curly brace variable expression that we see here. Then with the closing curly brace, we're now back in JSX land, and we have a literal space here that gets interpreted as a space. I guess I should probably hit save so we see that this is working. So there's our space right there in the code or on the display. And then with the opening curly brace, we enter back into JavaScript land and we get a JavaScript expression, in this case, a variable that's set to the string shmo. And the transpiler will take everything here, replace it with what its value actually is, and that's what gets displayed on the screen. Let's clean up this challenge text. And at this point, it's important for our understanding to realize that the JavaScript that we put in here, as long as some value is getting returned from that JavaScript, we can run whatever JavaScript code we want inside of the curly braces that we put, even though we're inside of JSX. For example, let's say we wanted to, instead of saying hello Joe Schmo, let's go ahead and clean some of this up. What if we wanted to have it say it is currently, and then whatever time it currently is? Well, because I can run whatever JavaScript I want inside of a set of curly braces, again, as long as a value is being returned from that expression, I can run code like, okay, let's create a new date, and then I'm going to call get hours on that date, and then, well, let's just see what this shows up as. Okay, it is currently 15. If you're from a place that uses 24-hour clock, that certainly makes sense. We also might do a modulo 12 if we want to have that display in 12-hour time. And there it goes. It says it is currently 3. Maybe we say it is currently about 3. And that makes sense because for me right now, it is 3:23 p.m. Now, I would say with great power comes great responsibility, and having a bunch of logic stuffed into the middle of our JSX here isn't my personal favorite. And so my personal preference would still be to put my logic happening up here. Let's say maybe const hours equals, and then we'll paste in that expression, and then simply enough, I would just say hours goes here, and we get the same result. And we can take this as far down this rabbit hole as we want. For example, let's say we wanted it to display either good morning, good afternoon, good evening, or good night, depending on what time of day it was. All we'd have to do is simply write out our logic for determining what this particular word should be. And again, I would prefer myself to do this up here before the return in our component. And then we would simply display the text that resulted from our calculations right here in the code. Because this is more of a simple algorithmic challenge, I'm just going to write out my solution, and then I'll give you a really simple challenge for displaying the correct text down here inside of our H1. Okay, I just hit refresh so we can see our hard-coded goodnight right here, and I've written out the following logic. It's pretty straightforward. I got rid of the modulo 12, so we could go all the way up to, I think it ends at 23 hours. I created this let variable called time of day, and then all I did after that was create some conditionals that said if it's before 12 o'clock, then we'll say this time of day text is morning. If it's between 12 and 5 p.m., then it's afternoon. If it's before 9 p.m., then we'll say it's evening, and otherwise we'll say it's night. I don't know, maybe these aren't the perfect hours. But now it's your turn, we'll have a really simple challenge. Simply enough, your challenge is to change this hard-coded word night to display the text that we determined from the logic above. Go ahead and work on this challenge. All right, all we have to do is get our time of day variable. We'll put it in right here, and then of course, if we were just to hit refresh now, it would say good time of day, and that's not exactly what we want. If we, however, surround it in curly braces, now this will be interpreted as the JavaScript value of time of day, which was determined up here in our logic, and we get good afternoon, because again, it's about 3 o'clock my time. And we can see that this is working if right now it's about 15 for me. So if I were to change this, this wouldn't make any sense, but let's go ahead and say between the hours of 12 and 2, it's considered afternoon. I'll go ahead and hit save. And sure enough, even though it's 3:30 my time, we're getting a good evening. Let's go ahead and change that back because that's pretty weird. Okay, now that we've gone through how to put JavaScript inside of our JSX, we are primed to look more into the actual syntax of props and see how we can make the components that we're creating more reusable. In order for us to learn the syntax of using props in React, we're going to use this little contact book that I made as an example. As you can see, everything right now is just hard-coded here inside of apps. So we have these article elements. These articles represent each one of these contact cards. And just like we saw before, everything is hard-coded, which again, for a tiny app like this might be okay. But if you had any dreams to scale this to a bigger amount than just having 4 different contacts in your contact book, then this clearly won't be the way to go. So to familiarize ourselves with the code, I'm going to give you a fairly straightforward challenge, and then over the course of the next 2 scrims, we'll be talking more about the syntax for props in React. So your challenge is to first create a new contact component in another file. In this list below, choose one of them to move over to that new contact component that you create. Then back here in our app component, I want you to import that new contact component and create 4 instances of it. In the meantime, you can just delete all of the articles that are here once you've moved one of them over into that contact component. And don't be too worried about the data that's in these because we'll get it back in the next scrims. While you're on this last step of the challenge where you import and render 4 instances of the contact card, I want you to be thinking ahead of time what the problem is going to be when we do it that way. There shouldn't be a syntax error or anything like that, but there will be an obvious bug that shows up on our page. Okay, I'll turn it over to you. Go ahead and start working on this challenge. All right, so first we're just going to create a contact.jsx file, and I'll export default my contact component function. We'll just have it return one of these articles. Okay, paste that in. I think that should be everything from this side. Let's go back to app.jsx and we will import contact from ./contact. And let's go ahead and just delete the 4 articles that we have here. And we'll render 4 of these contact components. Okay, now if you didn't take a second to think about what's going to show up, before I hit save, I want you to think now, what are we going to see when we hit refresh? Let's hit save, and we have 4 Mr. Whiskersons. As much as we love Mr. Whiskerson, we really want all of our contacts to be in our contact book. And naturally, the reason that 4 Mr. Whiskersons are showing up is because we took the hard-coded data and we set that as what's being returned from our contact component. This is not terribly unlike having a function that's called add2numbers and then just hard-coding having it return 1 + 2. This function can only literally do one thing, and it has no flexibility to work with other numbers that we might want to add together. As we've mentioned, the way that I can make this function more flexible is by taking in parameters, and then instead of hard-coding the data in here, allowing the person who's using the add2numbers function to provide numbers A and B, and then simply return the added sum of those 2. Okay, I think we've become pretty familiar with this little contact example that we have. In the next scrim, we're going to focus on how we can pass our information into the contact component as we see it from this side of the equation. Then in the scrim that follows, we'll go over to our contact card and we'll see how we can consume or receive the information that's being passed into the contact component when it's being rendered from this side. If you need a little more time with this code, that's fine. Feel free to play around. And when you're ready, let's see how we can pass information into our contact component. We need a way to pass data into our contact component. Otherwise, we'll have to hard code everything into that component, and it basically ruins the whole purpose of having reusable components. Fortunately, React has chosen a way to do this that makes a lot of sense for anyone who has done any kind of HTML in the past. Just like in HTML, when I have a reusable element like a link, I can pass in different attributes in HTML to alter the behavior of that link element. I also can pass information into that link like an href so that the link can act a little differently from other links that have different values for their href. Now in HTML, I can't simply come to my link and add whatever I want here and set it equal to something because, well, this whatever I want attribute is not something that's defined in the HTML spec for the link element. That said, the way that we pass data into a React component is going to look very, very similar to how we do it in HTML. However, because a contact component is a custom component, it's something that I created, I can in fact pass in whatever I want as what looks like an attribute in HTML, but in React is called a property, or more commonly, a prop. And because it's custom, I can create a prop that's called whatever I want, and I can set it equal to whatever value I want it to have. So take a second to think, if I'm passing data into my contact component, what kind of data would I want to be passing in? The answer to this question is whatever information we need to pass in so that the contact component can finish its job. It can display what it needs to display. Remember, the goal is to take out any hard-coded data, more specifically the image source, the name of our contact, the actual phone number of our contact, and the email of our contact. Those 4 pieces of information don't belong here in the contact card unless, for whatever reason, we don't want to reuse this component. Let's go ahead and start with the image. Over in our app component, let's get rid of this whatever I want, and let's choose to pass in a prop called img. I can set this equal to, and let's go over to our contact. We'll just take the path to our file, and we'll set it equal to the path to that file. Now remember, we haven't yet started working on how we can consume the props that we're passing into our component. So in this scrim, we're just going to be doing some work here on this side of the equation, and in the next scrim, we'll finally get to a place where we can see our contacts working the way that they're supposed to be working. Now, I do have a challenge coming up that you might hate me a little bit for giving to you, but just try to trust that I have your best interest in mind. Just like in HTML, we're not limited to having a single attribute on our HTML elements, we're not limited to having a single prop on our React components. I'll go ahead and put these on their own lines because I know I'm going to have a few of them, and this is perfectly syntactically correct. I'm going to go ahead and do one more of these props, and then the challenge that I know you're going to hate me for is you are going to be in charge of adding all of the rest of the props for these contacts. I guess we can just work from top down, so we already handled the image. Next, we're going to be passing in the name. And the name for this first one will be Mr. Whiskerson. And now the time has come, let me type down what your challenge is. I usually don't love giving out busy work, but this is an example of a time when getting your hands on the keyboard and getting as much repetition as you can is going to be your best friend. Passing props into a React component is one of the most common things that you'll do in any React application. So let's start off strong, a little bit of a trial by fire. Your task is to add all of the rest of the data to the contact card instances. And what I've done is I've pasted in the article elements that we had in the old version when we were hard coding everything. Keep in mind, each one of these contacts should have an image, a name, a phone number, and an email. And that's all the setup you need. Warm up those fingers and get started on this challenge. Okay, let's go ahead and do this. So I'm going to pass in a phone. Because I get to choose the names of these, I could choose phone number like this, although I think it's fairly clear what it means when I say phone. So I'm just going to pass in phone, and let's go ahead and grab the phone number and pass that in as data. Keep in mind what we're passing in right now is a string. Everything is a string. In HTML, you kind of have to do it that way. You pass everything in as a string. In React, we're going to see that there's a way to pass in any data type to our components. But for now, everything we're displaying is a string, so this will work great. And lastly, we have an email for Mr. Whiskerson, and here it is right here. Pass that in, and that should be all the information we need for our contact card to work when, again, eventually we come to the contact side and consume the data that we're passing in. I'll do one more of these by hand, and then I'll speed up through the rest of it so you don't have to tediously watch me do this. We add our props right here after the name of the contact and before the closing angle bracket. Make sure we leave a space there. I'm going to pass in an image prop, and I'll set this equal to the path of the image for Fluffykins. It's right there. We'll pass that in. Awesome. Notice that I can do these in line as we're seeing here, or if there's a lot of props, I can put each one on their own line. Either way is completely syntactically right and correct. I'm a little worried that you're not going to be able to see the stuff I'm typing behind the mini browser over here, so I am going to put these on their own lines. Okay, the name, let's just copy it to make sure we don't get it wrong. Fluffykins goes right there. Phone, this one right here. And email is this guy right here. Maybe just so I don't have to scroll as far, I'll go ahead and delete these two articles now that I'm done with them. And as I mentioned, I'm just going to speed up through the rest of this so you don't have to tediously watch me do this. Hopefully you already put in your time, so we'll try to get through this quick. Okay, let's all be honest, that wasn't really that bad. Let's go ahead and clean out our challenge text here. Now, hopefully one thing you notice is just how much nicer the organization of this is. We've been able to have more of a data focus here where the data is most important, and we've been able to have more of a layout and design focus here in the individual contact card. And if we want to make a change to how the contact card is laid out or add some new classes or anything like that, we can do it from one place here in the contact component. And out here in the app component, it doesn't really care about that. We're able to just pass in data and have the contact card handle everything else. Of course, if we decide we want to add additional data as we're passing this in, then we would need to make modifications to both the contact card and to the props that we're passing into the contact component. But that's kind of true of the way that we were doing it before anyway. Okay, is it time for the big reveal? Let's go ahead and hit save. And of course, we still have 4 Mr. Whiskersons. Don't worry, your effort was not in vain. In the next scrim, we're going to be learning about how we can consume the information that we're passing in as props to our contact component. So that's what we'll be doing next. In the last lesson, we learned how we can pass our own custom data into the components that we're creating using properties, more commonly referred to as props, in a way that's very similar to how we can pass data or information into an HTML element using the HTML element's attributes. We also talked about how there's a difference where in an HTML element, I can't choose to create whatever attributes I want on those HTML elements. They have to be attributes that are recognized according to the HTML spec. But with React, as we're passing in data, we can pass in whatever props we want. We got to choose the names here. We just happened to choose names that were really logical and easy to understand. Always a good way to approach your variable naming. So how do we receive these on the contact side so we can finally get rid of all of the hard-coded data that we have in here? Well, just like a function that receives a parameter, my React components will receive something in the function's parameter, which will be an object that represents all of the properties that we passed in. Really commonly, I might call this something like props. But just like any function parameter name, I can call this whatever I want. In fact, let's see what happens when I console log whatever, since that's the name we chose. Let me make this a little bit smaller here and open up our console. We'll hit save. And we can see that we have a JavaScript object that was console logged 4 different times. Now I want you to think for a second, why did it console log 4 times if we only wrote 1 console log? Well, it's because we have 4 instances of our contact component. And remember, although the syntax looks an awful lot like HTML, really what's happening under the hood is this function is getting called. This contact function component is being executed. And because it's happening 4 times, it's being executed 4 times, and we have 1 console log that's being run 4 times. Let me actually copy one of these from the console so we can talk a little bit more about it. And I'll just paste it down here. And I'll go ahead and clean this up so it's a little easier to see what's going on. Okay, so this was the first one that got console logged, and I think this should probably be looking pretty familiar. What we received as the parameter to our contact component, or in other words, what we're receiving as props, I'll go ahead and change this to props because that's much more common, is an object, a regular JavaScript object, where it's got properties that map to the values that we passed in our app component right here. Keep in mind, we got to choose the names of these props. So if I were to, for example, change img to something like the full word of image, we can hit save. And now we can see that the first instance in our console doesn't have an img prop, but instead has an image prop, or an image property to the props object that we're receiving. Now, I don't want to go too far down that rabbit hole, so we'll clean that up. Let's go over to our contact. We'll clean up what we have here as well. And now it's going to be time for a challenge. Let me go ahead and type that out. Now that we're receiving an object that has all of the data that the instance of the contact component needs in order to correctly display our contacts up here, we should be primed now to update our contact component so that we can use that data instead of the hard-coded data that it currently has. So your challenge is to fix the code below to use the props object and the values that it holds to replace the hard-coded values that we have below. As a quick note, there's going to be a small bug in the code, so I want you to do your best to squash it. Just don't be disheartened when you hit save and you see a little bit of an inconsistency in the contacts. This challenge does require you now to synthesize some of the information that you've learned previously with the information that we've just been learning. It's okay if that's a bit of a challenge for you, but I do want to encourage you again to give it your absolute best shot. Don't just run into the first sign of trouble and decide to hit play and watch me do it. Instead, turn to an AI assistant, turn to the Scrimba Discord community, ask a friend or Google it, or go back and rewatch some of the previous lessons if that might help jog your memory. All of those are, yes, more time consuming, but they will be a much better learning experience for you. Remember, you're here to learn React, and the only way to do that is to work through it the more difficult way. All right, enough of a soapbox speech. I'll pass it over to you to work on this challenge. I'll go ahead and clean up the challenge text here. And let's actually start right here in the H3. At first, we might decide just to try and type in props.name. Props is an object and it has a name property, so I should be able to do that. Well, don't feel bad if you fell into this trap. I happen to fall into this trap all the time. I'll hit save, and we have literally props.name showing up for every contact here. Of course, when we're inside of JSX and we need to evaluate a JavaScript value, we need to surround it in a single set of curly braces. Simple enough. Now when I hit save, awesome. Even though the pictures and everything else is the same, the names are coming through. Our contacts are becoming unique. Let's go ahead and do the same thing for our source. Now, our source is a string, but we're going to pull that string off of the props object, which is in JavaScript. So I'm going to get rid of my quotation marks and put a set of curly braces, and then we'll say props.img. Now, this is where that little bug comes into play. We'll hit save, and look at that. We have Fluffykins, Felix, and Pumpkin working, but Mr. Whiskerson is not working. Why is that? Well, it's a bug that we introduced when I was talking about how we get to choose whatever name we want for these properties. And in doing so, I changed this one to the full text of image. So let's go ahead and change this back to img. It's always going to be important that the names of our properties that we pass into our components are consistent across every instance of that component. Now we hit save and we've squashed that bug. Coming back to contact, we can do the same thing now with the phone. We'll go ahead and delete the hard-coded phone, set of curly braces, props.phone, and for the email, curly braces, props.email. Hit save, and awesome, we're back to a working state for our contact book. Now, hopefully I'm not belaboring the point, but over the years of teaching props, I have found it to be a sticking point for people in their learning journey, and I don't want that to be the case for you. So we're taking it one little bite at a time, and we've basically come to the conclusion here. We've been able to define what information via properties or props that we're passing into our custom components. In the code of our custom components, we're receiving that as an object that we're deciding to call props. Let's get rid of this console log. And then we're accessing the data on that props object with regular JavaScript using props.img, props.name, and so forth. If you feel like you've been able to follow along up until this point, give yourself a big high five or a pat on the back. That's a pretty big accomplishment. I know we've put quite a bit of work into what now appears to be a fairly simple concept, but writing props in React is going to be an everyday part of your React life. So hopefully you can appreciate the extra time and attention we're taking on it. Before we move back to our travel journal, I want to show you a cool little trick that we can do when it comes to the props that we pass in. So that's what we'll be working on in the next scrim. Okay, it's time to give you a prop quiz. Sorry, I couldn't help myself. Like before, your task is to read through each of these questions, to actually click into the editor and type down your answers. Don't forget, in Scrimba, if you have any changes that you make to the code, you can always save it as a note. so that you have access to it later. You can even record your own voice talking over the top of the note if you wanted to keep an audio note. And all of those are saved here in your account on Scrimba. So pause now, answer the questions through this quiz, and then you can hit play and we'll go through the quiz together. Number 1, what do props help us accomplish? Well, just like parameters being passed into a function, props being passed into a component help us make that component more reusable. As you become more and more experienced in React, you'll realize that there are times when it makes a lot of sense to pass props into a component so that it's reusable, and other times when it might be possible to pass props into a component, but it's just not always necessary. I can't tell you how much time I have spent trying to create a component that's very reusable and then ended up only using it 1, maybe 2 times. That's just one of those things that will come with experience as you write more and more React code. Remember, when we pass props into a component, it could be data that actually gets displayed as a part of that component, or it could sort of be like metadata that you're passing into the component that in a way configures it to act a certain way. Either way, it helps us make any component that we create more reusable so that we can keep our code as dry as possible. Okay, so number 2, how do you pass a prop into a component? In the same way that you pass attributes to HTML elements, like a source attribute for an image, you essentially do the same thing when you're passing props to a component. So if I have my own component like, let's say, my awesome header, I'm using a strange name just to make it very clear that this is a custom one. You can pass a prop of your own choosing, like maybe title, into that component. That brings us to number 3. Can I pass a custom prop, like, for example, blah, 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 to a native DOM element? So, for example, a div with a lowercase d. Well, the answer is no. So we come to the next part, why not? And that's because under the hood, when React sees a regular HTML element that we're trying to render, we express that element through the JSX syntax, and that JSX syntax actually returns an object, and the object describes the actual DOM node that should be created. When we add an attribute to a regular DOM element like a lowercase d div, the object that this JSX creates is expecting to be able to add this property to the DOM element. And since DOM elements don't have an attribute called blah, 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 I can't just choose the props that I want to add to native DOM elements like this div. So let me try typing out a summary of that. So the answer is no, because the JSX that we use to describe those native DOM elements we want React to create will eventually be turned into real DOM elements, and real DOM elements don't have whatever properties, let's say properties, or attributes specified in the HTML specification, which, as we all know, doesn't include properties like blah, blah, blah. Okay, I think we understand that concept. How do I receive props in a component? Simply enough, the parameters to that component function will receive a value called props, which of course we could name whatever we want, but by very strong convention will be props. And that leads us to the last question, which is what data type is props in the component when I receive it? This parameter, which we're calling props, is an object, which means if I want to access the properties of that object, I use dot syntax. So props dot whatever the prop was that I passed in. Let's use blah, 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 because that's what we said before. Okay, awesome job on that quiz. If you struggled with any of these questions, of course, don't hesitate to go back and review the things that we've recently learned. And when you're ready, let's move on. By this point in the course, you should already be familiar with the concept of object destructuring. But just in case, we're going to do a quick recap right now. Let's say we have this variable const person, and it's equal to an object with an image, name, phone, and email properties. As we've already seen, I can go ahead and access any of those properties by calling person, the name of the object, dot, and then the name of the property in that object, like name. And of course, this works as we would expect, with Mr. Whiskerson showing up because that's the name of my person object. However, in certain circumstances, it can be kind of nice to destructure some of the variables out of our objects and use them directly. I can do that by saying const and then using a set of curly braces, specifying the names of the properties that I want to pull out of my object, like image and name, and then setting that equal to my person object. What this does is it declares two new variables in one go, img and name, and it sets their values equal to the value of the property that has the same name inside of this object. So if I go ahead and now just console log name, not person.name, but just name, we'll hit save and we get the same thing, Mr. Whiskerson. I can do the same for img and we get the path that was inside of this object but is now outside in a global variable. It's important to note at this point that I don't get to decide what I'm calling these. For example, I couldn't just decide, well, I actually want this to be image, the full word spelled out, because we'll see if I try to get that from the object, it's going to be undefined because there is no image property on this object. Now, JavaScript doesn't just leave us high and dry. There is some trickery I can do. In case you weren't familiar, I can say I want to grab the information from the img property, but I want to rename it, and I can put this little colon here. I want to rename it image. And now when I do that, I do correctly get the information from this img property, but renaming it to image. This isn't terribly important right now. I just wanted to qualify what I said when I said we have to use the same names as the properties in the object. Let's back this part off to a working state here, and I'll just leave this down here in case you want to play with it. But let's bring this concept into React by seeing how we can apply object destructuring to the props that we're bringing in. Remember, props is an object. Even if you were to only pass a single property in your React component, it would still come in as a props object with a single property on it. And because it's an object, I can choose to just destructure it right here in line. I happen to know that it's going to have an img property, a name, a phone, and an email. Of course, now that I've gotten rid of my props object and instead have defined these four new variables and pulled their values from the props object, my code below is no longer going to work. So that leads us to a quick challenge. Okay, your challenge is to fix the bug that we've just introduced now that we are destructuring the props object right here in line in the definition of our contact component. Go ahead and get started on this challenge. Okay, it should have been a pretty straightforward one. Remembering that we are no longer bringing in the props object, all we really need to do is take all of the instances where we're saying props.image or name or phone or email and get rid of the props.dot part. We can hit save, and sure enough, our contacts are back. The main reason I'm taking time to show this is because it will be a really common thing as you're seeing React code out in the wild to see props being destructured in line the way that we've done it right here. As far as I know, there's no functional difference between destructuring them in line like this or having the props object like this. It really would just depend on your own personal preference, or more importantly, the preference of the maintainers of whatever repository of code you're working in. It's more important above everything else to be consistent with how you're writing it. I personally oscillate between the two, and I don't know that I have that strong of an opinion one way or the other. However, for the remainder of this course, I will likely just be using the props object for a pretty simple reason. When we get to a point where we're declaring other variables inside of our component code, I find it does become a little bit easier to keep track of which variables are coming from outside, from props, and which variables are coming inside, being defined inside the body of our component, by signifying that something is coming from the outside with that props.object syntax before it. So I'll go ahead and change this back to props. We've already changed this back to props. And although it does provide a little bit of extra visual clutter, I do find there being a benefit in knowing very easily when something is coming down through props and when something is being defined in another way. Let's clean up our code a little bit here. And although there certainly will be more for us to learn about props going forward, it's time for us to get our hands on the keyboard and practice these props a little bit more. All right, I'm not going to make you spin up an entirely new React app completely from scratch, but we are going to be starting pretty close to the beginning. In my index.jsx, I am importing and rendering this app component, and the app component I've just barely scaffolded for you. This challenge is going to require a little bit more than I have in the past, but you should be plenty well equipped to complete this challenge. We're going to create a little page where you display some of your favorite jokes. And so first you'll need to create a joke component that will be in its own file. And then here inside of our app, I want you to import and render maybe 4 or 5 instances of that joke component. Each one of those joke components should receive 2 props, a setup prop and a punchline prop, and then render those inside of your joke component really however you want. We just want to display the text of the joke on the page. Take some time to look up some of your favorite 2-part jokes that have a little setup and a punchline, or maybe you already know some offhand. Or if you need a little bit of inspiration, you can go over to jokes.md where I've included some of my favorites. I do have a little extra credit here. I'll let you read through this and decide if you want to do it or not. It does touch on something that we haven't yet taught, so it will likely include some outside research in order to complete. All right, the time is yours. Start working on this challenge. Okay, I think I'm going to work a little bit backwards here. So first we'll go ahead and you know what? I kind of know what the challenge says, so I'm going to buy myself some room here. We'll import a joke component, which we haven't yet created, so we'll have to create that in just a second. And inside here, we'll go ahead, let's turn this into maybe a main element, and we'll render 5 instances of our joke component. 1, 2, 3, 4, 5. All right, let's go over, before I hit save and kind of crash everything, let's create our joke.jsx, and over there, we'll get started with our export default function joke. And let's do a little bit of a sanity check here. I'm just going to render an h1 that says inside the joke component. Okay, hitting save, I should see 5 times, yep, inside the joke component. Perfect. And this scrolls down a little bit for the 5th one. Okay, so I need to pass the data for my jokes into my joke components. So for each one of these, I'm going to add a new prop called setup, and we'll set that equal to a string. I'm just going to go over to my jokes.md and copy each one of these jokes. Okay, I've copied those, and then over in my app.js, we'll go ahead and paste those in. And I can already tell this is going to be a little bit too horizontally wide for the setup that I'm recording on. So I'm going to go ahead and put each one of these on their own lines. All right, so I'm passing in a setup. Let's go ahead and also add a punchline prop. And I'll just do the same thing where I copy the punchlines from over here in my jokes file. And we'll go back and paste those in right there. These are great jokes, by the way. I don't know if you've actually taken the time to think through them, but they were some of my favorites. Okay, job done, right? What do you think will happen when I hit save? I don't think I fooled too many of you. You're too smart for that. So if I hit save, we'll see I'm still seeing inside the joke component 5 times. I'm passing my props into my joke component, but my joke component is not making use of them. So we'll go ahead here and accept our props. And let's just go ahead and console log our props just to take a look at that. Okay, cool. We're getting 5 different objects, again, because I'm rendering 5 instances of the joke component. And the props that it's receiving is an object with a setup property and a punchline property. Perfect. Let's go ahead and scaffold out the rest of this component. So maybe I'll just create a div. Actually, I might just create a fragment here. We'll probably need to turn that into a div later if we want to style it, but for now this will be okay. And let's just put a paragraph for the setup, a paragraph for the punchline, and maybe we'll have a little separator with a little horizontal rule. This will be a little bit rough for now, but that's okay. All right, if I hit save, we'll just have a bunch of horizontal rules showing up because my paragraphs are empty. Let's go ahead and say that I want to first display props.setup, and then I want to display props.punchline. Again, remember, we need the curly braces. Otherwise, we would just be literally putting in the text props.setup, and that's all that would show up 5 times. Okay, moment of truth. Awesome. We're getting our jokes displaying on the page. I think I'm going to take just a second to add a little bit of style here. All right, all I did was add a little bit of margin to the body, and then I gave a class name of setup and bolded the text. I also gave this one a class name of punchline, but I haven't actually done anything with that yet. Just trying to keep it simple for now. And just like that, we've been able to pass information from the outer component of our app, or in other words, the parent component, that then renders, well, first renders this main element, and then inside of that, it has these children components of our custom joke component. And we pass the data in through props, a setup prop and a punchline prop. Now, I did have a little extra credit, and I figured I would go through this at this point, although what we're about to talk about isn't necessarily something that we've learned yet. For example, let's say we have a joke that really only has a punchline. It's just a one-liner joke, and it doesn't have a setup. My personal favorite that I included in the example is this one that says that it's hard to explain puns to kleptomaniacs because they take things literally. Well, in this case, I'm not going to be providing a setup. There's no reason to have a setup there. However, if I hit save, we'll see that we just have this sentence that's kind of floating in here. I guess it's not as apparent there, but let's imagine in our joke we decided instead of just having the joke text there, we were to say something like setup, colon, and punchline, colon. And then if I go ahead and hit save, we see we just have this setup that's floating here without any text there. Again, this isn't something that we have learned yet. We will be learning this in the future, but if you took the time to do the extra credit, you might have come across a concept called conditional rendering. With conditional rendering, I can tell React that I only want to include this paragraph element if a certain condition exists. One way I can do that, there's a number of different ways, but one way is I can surround the entire paragraph element in a set of curly braces. And then at the beginning, before I render the paragraph, I can say if there's a props.setup, or in other words, if that is a truthy value, then I want you to render or return this paragraph element. One kind of shortcut way I can do that is to use a double ampersand. Essentially, this says if props.setup is truthy, it's an existing value, it's not an empty string or undefined, then I want you to return this in the place of this little expression that we have here. It's maybe not a huge improvement, but I can go ahead and hit save, and we just show our punchline here. We don't have the floating setup that we had before. The really nice thing about React is that it uses just plain JavaScript under the hood, which means I could accomplish essentially the same thing in another way. Let's say instead of just removing this completely from the DOM if props.setup doesn't exist, I instead wanted to maybe add, well, let's say a style prop. I can say the style is going to be display of none, but only if, and let me move this down for just a second, only if props.setup does not exist. One way I could accomplish this is by using something like a ternary, a regular JavaScript expression of a ternary. So I would say display is going to be, well, first, is props.setup a thing? If so, then maybe we say that it will be a display of block, but otherwise it will be a display of none. We can hit save and see we essentially accomplished the same task, although this way does appear to be quite a bit more complicated than what we had before. I'll go ahead and reverse that back to the conditional rendering, which is also something you'll see very commonly. The point is, React is using JavaScript under the hood, and there's a lot of native JavaScript APIs and techniques we are going to be learning about that help us display things on our page in the way that we want to. I hope that this was a helpful exercise. I'm really looking forward to seeing people's different jokes that they have. And we have one more little thing that we need to learn about props before we're able to move forward and continue with working on our section project of the travel journal. We have just one more thing we need to cover regarding passing data through props before we can finally continue back on with our travel journal project. Up until now, we have only passed this string data type through our props, and that's what we're most familiar with. We've talked about how props are a very similar concept to passing attributes in HTML, and in HTML, we have to pass a string. There isn't really another alternative. In certain circumstances, we can pass something that looks like it's not a string, like a function, for example, but in reality, we still have to surround them in these quotation marks, so they're a string. With React, however, because we're working in JavaScript, we're not limited to just using a string. And I actually wanted to make this into a challenge that will help you think a little bit more critically. So your challenge is to think how you might go about passing in a prop that isn't of a string data type. Let's say, for example, we wanted to pass to each one of our joke components an upvotes and downvotes prop that is a number instead of a string, as well as maybe a prop that is an array of comment objects and a boolean of whether or not the joke is a pun. With this challenge, you don't necessarily have to go through and actually do this. If you'd like, then you're absolutely more than welcome to, but I'm going to pause the scrim now and give you a chance to think through how you might do this, and if you'd like, play around with the code. While we're here inside of our JSX, as we've learned, we can switch over into a sort of JavaScript mode by using a set of curly braces. And I can do the exact same thing when it comes to passing props. Let's say I wanted to add an upvotes count. I can create the upvotes prop, and then instead of putting quotation marks, because that signifies that I'm about to pass in a string, since my upvotes may be something that I want to do some kind of math on, like if I were to add a little thumbs up or heart icon that when a user clicks it, it would add 1 to the existing upvotes, then instead of using a string, I'm going to pass in a set of curly braces and then put in whatever number I want to pass as my data type down to my joke component. Let's go over to our joke component and just console log our props again, just so we can see what's coming in now. And I'll open up the console here, and awesome, we can see that with the first one, I'm gonna move this up a little bit. With the first one, we have just a punchline. That's one we didn't pass a setup to. But at the end of our object, we have an upvotes that says 10, and it's the number 10, it's not a string 10. And because props.upvotes is a number, if I needed to, I could do some math on it. So for example, I could console log props.upvotes plus 1, and I think I'll probably get some not a numbers or undefines here because I only put it in one of my components on this first joke. But we can see for the first one in the console, we get 11 because it originally was 10 and then we added 1. Let me bring this back to just props. Let's go back to our app here. And if we wanted to do something like a Boolean for this isPun property, let's go ahead and say this one is pun. And, is this one a pun? That's a little strange. It's about puns, and I think it is a pun too. It's kind of a double entendre. It's a great joke. So we'll say this is a pun. It's a true as a pun. Again, not a string, but the actual Boolean value of true. Let me go through and add the isPun property to the rest of these. And geez, most of these are puns. I guess this one isn't really a pun. We'll go ahead and call that one false. Let's go ahead and hit save to see what we get for the consoles. And sure enough, we have a new prop called isPun, and it's either the Boolean value true, or in the case of this last one, it's the Boolean value false. Again, because it's a Boolean, I could do an operator on it like the not operator, or flip it from its value with just the single not. Of course, because it's a Boolean value, I could do something like console log not props.isPun and flip it with this not operator. We can see that we get the opposite of what we had before. Whereas if I had passed this in as a string, it wouldn't really do what we were hoping that it would do. And this goes just as well for things that are a bit more complex. Like if we wanted to pass in maybe an array of comments, I can set a new prop called comments, do one set of curly braces. This can be a little bit confusing because it looks like the syntax for a JavaScript object, but remember, this is just getting me into a JavaScript expression. Inside of that expression, I can do my square brackets in order to start a new array, and that new array might be an array of objects. This is looking a little bit crazy. It sometimes can help to put these on their own lines like this, and these comments can be as complex as we need them to be. Maybe each one of them has an author that is some sort of author ID, like a user ID. It might have a body, which is the text of the actual comment, or maybe this would just say text. It could have a title if for some reason your comment is allowed to have a title. And of course, because it's an array, we would probably have multiples of these. We can come put our console log back. I'll just log all of props since not all of them have comments. And actually, just to make it a little easier to see, we'll go ahead and just console log props.comments. We'll get some undefines, but there we see we have an array of 2 comment objects in the first joke that we put those properties in. Just for the sake of completeness, I think it's helpful to know that technically it's totally fine to take your strings and also surround them in curly braces because a string is also a valid data type in JavaScript. But I think because we're already so familiar with writing strings as our attribute values in HTML, it's also completely valid just to leave the curly braces off and pass a string directly to your prop like this. However, I couldn't do the same if I wanted to pass in any other data type than a string like the value true. This is going to be a syntax error, and I would have to surround this in a set of curly braces. Okay, I think you probably get the point here. Now we should be finally primed to get back to our travel journal and take the next few steps that we need to take. I want to interrupt our regularly scheduled programming here and talk about how we can handle static assets outside of Scrimba. Naturally, I always recommend people follow along this course on Scrimba.com, But if you do happen to be working in an environment outside of Scrimba on your local machine or wherever it might be, you might find that the way that we're referencing static assets like these images may not work in your environment. Using a build tool like Vite is going to essentially rearrange where these images are being held, and so referencing them with a relative path may lead to broken links. Think of it this way, when you're using a system like Vite, it's going to rearrange your code under the hood to make things a bit more performant, and especially when you run a final build that gets deployed online, it's going to essentially compress all of this code into single files, like a single giant JavaScript file that includes all of the React library as well as all of your code, a single HTML file and a single CSS file, and more likely than not, a place for all of your images to live. But the structure of your folders will be different at that time. And so that's why these relative paths are likely not going to work. To solve this problem, what you can do is import your images from their relative path so that JavaScript is aware of where they were before all of this restructuring happened, and the build tool, in the process of building itself, can fix the relative paths that you used when you were importing those assets. If all of what I just said makes absolutely no sense, really don't worry too much about it. I just wanted to make sure I address it because I know in past versions of this course it has been a bit of a confusing point. And handling static assets the way that Vite does works here in Scrimba because we're using Vite as our bundler under the hood, at least for these React projects. All this means is that when I have something like this image that is a hard-coded string leading to the relative path of the mrwhiskerson.png file, if you're working locally on your machine, what you can do instead is say, I'm going to import, let's call it Mr. Whiskerson from, and then I'm going to use that relative path. Now I have a variable that I can use to replace this hard-coded string. I'll put a set of curly braces and just say this is Mr. Whiskerson. So I'll go ahead and do this for all four of them, and we'll see that everything is still working just fine. Okay, I've imported each one of these static images, and now I'll go through and replace the image text that we have here. Okay, we can hit save, and sure enough, all of the images are working just fine. Now, throughout the rest of this course, you may or may not see me doing this kind of import of static assets, so I just want to warn you ahead of time. If you are following along in an environment outside of Scrimba, you may have to take just one extra step to import whatever static asset I'm referring to, whereas in Scrimba, I can just use the relative path as it is. Okay, let's get back to our regular lessons. All right, we're finally back here at the travel journal, but we have learned so much about props in React. In fact, so much that it might look strange that if we look back at our entry component, we still have everything hard-coded. Let's go ahead and fix that. Over in our app.jsx, we have our challenge text. Your challenge is to pass props to our entry component right here so that it can display its data. I've put all the data that you need over here in data.md so that you can find each prop name and its value. One thing that's a little tricky about data.md is this image prop, img prop. It's going to be an object, so make sure that you pass it in correctly, and that object will have both an src property and an alt or alt property. Then when you go over to the entry component, just make sure that you remember that img is not going to be a text data type, it's going to be an object, so you'll have to deal with that accordingly. Then, of course, after you pass in all of the props that entry needs to display its data, make sure, as I mentioned, go over to entry.jsx, receive those props, and replace any of the hard-coded data in that component to use the incoming props instead. This is one of those refactors that when you hit refresh, it's going to look like nothing changed. But that's just a normal part of web development. All right, it's your turn. Start working on this challenge. All right, I already know I'm going to be passing enough props here that I want to put them each on their own lines. And let's go to data.md. Okay, we'll start off with our img, which will be an object with a source and an alt. All right, so img prop is going to be equal to, and this is where things might have been a little bit tricky. Remember, if we're going to use a data type other than a string, we need to start our set of curly braces in order to get into a JavaScript expression. And then my object is also going to have a set of curly braces. Hopefully that didn't throw too many people off. If it did, that's okay. It's something that will just take a little bit of time to get used to. Our image is going to have a source property, which I'll just leave empty for now, and an alt property. which I'll leave empty. Let's go grab that data from right here. Okay, I'll put these on their own lines just to help so that when I paste it in, it will work correctly. All right, let's hit paste, and perfect. Okay, that's passing in correctly. Let's get to the next prop. Let's see, we have title and country. I think I can remember those well enough. So we'll pass in a title. This is a title for our entry, and it's going to say Mount Fuji. And oh, it looks like I have an extra comma over there. Let's get rid of that. And oh, I've got my curly braces messed up. Okay, let's go back to data.md, and let's see. Our next two are title and country. So I think I can remember both of those. Our next prop will start here on the next line. We'll start with title, and that's going to be equal to Mount Fuji. And then our country, this is for the little name next to the map marker there, is equal to Japan. Okay, let's see what else we have. Google Maps link. I'll go ahead and copy both of these. And we will put in a new prop, Google Maps link, and we'll set it equal to the link that we just copied. And I think we're almost done. I think we just have the dates and the text there. So yep, dates and text, and we'll just add those in. All right, it can be a little deceiving if I hit save now. It'll look like everything's the same, but that's not because we succeeded in our challenge, which I can remember, so I'll get rid of the text, but because we haven't changed our entry component at all. Looks like we're already receiving props, so I guess I did a little bit of that work for you. Just to make sure things are coming in correctly, let's go ahead and console log our props. Okay, cool. Our image is an object that has a source and an alt. We have a title, a country, Google Maps link, which is rather long, our dates, and our text. At this point, the rest of this is just replacing any of the hard-coded data we had with the new incoming data. Let me minimize this just to buy some room here on the image, and we'll go ahead and change some of these. So for the image source, I need to put a set of curly braces because I need to evaluate the JavaScript expression that's coming in through props, and we had .img.src. I think this is probably the trickiest part of this, but shouldn't have been too bad. We'll go props.img.alt, and I guess before we go too far down the rabbit hole, let's go ahead and hit save. And awesome, our image is coming through, and I can only assume that our image alt text is coming through as well. All right, let's do the rest of this. So right here we have hard-coded Japan. We're going to instead put props.country. For my Google Maps link, I'm going to leave the text as hard-coded because every one of mine will say the same thing, but this href is what can get replaced. So I'll put a set of curly braces, and we'll do props.Google Maps link, I think is what it was. Let me just double check that. Google Maps link, yes. Okay, here we have our entry title. Let's go ahead, props.title. The dates will become props.dates, and the text will become props.text. Is it text? Yeah, text, perfect. Okay, the boring moment of truth. We'll hit save, and everything looks the same, but of course we know, as the developer of this component, that the data is no longer hard-coded, but instead being pulled in from the outside. Although this particular update might seem a little boring, it does mean that we now have the power to reuse our entry component to create more instances, which aren't just duplicates of Mount Fuji. This is a huge step in our journey in React. Learning props is one of the more difficult things, as I've mentioned, for beginners to grasp. Hopefully this exercise has been helpful. If you were able to get through this exercise without too much additional help, then giant kudos to you. That's a big step. If not, that's completely okay. Remember, you're not here to get a grade or to set any kind of speed record through this course. Go back, practice what you need to practice, take the time you need to take. Because we do have a lot more to learn, but the new things that we'll be learning will be hinging upon the knowledge that you've learned thus far. Once you've done a little happy dance and congratulated yourself, then we'll keep moving forward. This lesson is basically a spoiler alert for what we're about to learn, because we are going to see how we can use the array.map method to take regular JavaScript data and turn it into JSX elements that can be displayed on the screen. And so this felt like a really natural time to do a quick review of the .map method. If it's been a while or you're feeling a bit hazy about the .map method, you can click the screenshot here. That will take you to the MDN docs on the map method. And I would just recommend going through, reading everything they have, playing with the interactive demos they have and everything like that to help bring you up to speed on .map. So what we'll be doing is a series of challenges. I've got 3 challenges here, but instead of just going through everything in one go, I'm going to have you do challenge 1 first, then we'll go through it together, then challenge 2, go through it together, then challenge 3. Remember, the goal is to look at our input data and try to turn it into some output data using the .map method. So pause now and start working on challenge 1. Okay, so the first thing we'll do is run nums.map. .map takes a callback function, and I'm going to use a function declaration just for now to better understand exactly what's going on here. And this callback function is going to run for every item in my array that I'm running .map on. And then whatever I return from this function, so I'm going to add a return inside here, whatever I return from this function will get placed at the same index as the original item with whatever kind of modification we make to it. And then in the end, .map returns a brand new array that will be the exact same length as the original array. And so we should probably be saving that. Let's say const, and these are squares, so we'll say squares is equal to the array that comes back from calling nums.map. And then this function will be taking a look at every item, or probably better is to say it's going to look at each number, or num, inside of the original array, and then we will have it return num times num. That'll give us the square of that number. Now if I console log squares, we should get our output of 1, 4, 9, 16, and 25 in an array, and sure enough, there it is. Okay, let's move on to challenge 2. I'm going to comment out this console log. This time, given an array of strings, return an array where the first letter of each string is capitalized. At this point, you might be recognizing we're essentially just doing some JavaScript algorithm challenges here. Obviously, do a quick search on Google if you need to. So now it's your time again. Pause and work on challenge number 2. Well, let's set everything up. We'll say maybe capitalized. It's not really capitalized, but I think you get the idea. We'll run names.map. And this time I think I will use an arrow function. Whether or not you're really familiar with arrow functions, I think by now it's probably time that you become versed in arrow functions. So I'm going to use that syntax, and over time I think you'll just get used to it the more you see it. I'll start out by opening up the body of this function and using a return, but then we'll use some of the benefits of an arrow function by removing some of these extra characters that we don't need. Now, this function is going to be looking at each of the names inside of the names array, so we'll call it name. And like I mentioned, now we're essentially just doing a JavaScript algorithm challenge. So I'll say we want to return, and we can actually index into strings as if they were an array. So I'm going to say, get me the first character of this name, and we'll call .to uppercase. And then I bet many of you came across the .slice method. So I'm going to use name.slice starting at index 1. Now, if I don't provide a second parameter, it means just start at index of 1, or in other words, the second character of the string, and get me everything from that point until the end. Honestly, I'm winging it a little bit, so we'll see if this is working. I'm going to console log capitalized, and let's run it and see how we did. Okay, that looks awesome. Great, now that brings us to challenge number 3, and this is the one that's really intended to prepare us to understand how we can use the .map method alongside JSX in React to turn regular JavaScript data into something that gets displayed on the screen by React. This time you have another array of strings. We have a few different Pokemon names here, and your job is to use the .map method to return a new array of strings. This time the strings are kind of like HTML strings where they're surrounded with these paragraph tags, opening and closing tags. Keep in mind, we are not doing anything React specific. There's nothing special about putting the paragraph elements or the paragraph tags around the text that you want. But this will be very similar to what we do when it comes time to do this in React. So pause now and work on challenge number 3. All right, hopefully you found that was maybe even easier than challenge number 2. Let's start off by creating a new variable. Maybe let's call it paragraphs. And we'll set that equal to the array that comes back from calling Pokemon.map. And this time let's use an arrow function again. I'm going to look at every single, well, let's see. I think Pokemon is both the singular and the plural form of Pokemon. So maybe we'll just call this Mon for individual monsters. And let's start out by opening the body of this function like we did before. And then I think we'll go through and clean up some of our arrow function extra characters that we have. So I'm going to return, and essentially all I'm doing is taking the string of my individual monster, Mon, and surrounding it with the paragraph opening and closing tags. So I'll use a template string here, and we'll put in our paragraph tags like this, but then in the middle, I will just inject the individual string of the Pokemon. And now if we console log paragraphs, okay. We get an array of, well, they're still just strings, but they look kind of like paragraph elements. Awesome work. Now, if I wanted to clean up my arrow functions, I only have one parameter, so I don't need those parentheses surrounding there. And then I could take advantage of my implicit return by moving up the return value here and getting rid of my curly braces. And sure enough, that's much more concise. I can do the same thing up here. Now this return value is a little bit longer, so you can decide whether or not you actually want to do this, but I can put that up on the next line. Or if you want to use the next line, you can surround your return value in parentheses and then start that on the next line, and that should work just fine too. Let's just double check that. Okay, looking great. In fact, I suspect that these aren't actually necessary in the first place. Yeah, I guess the parentheses really aren't that necessary. I think I like them there just for maybe my own sake in keeping things balanced, but you can do it however you want. Okay, now that we've reviewed array.map, we should be perfectly primed to jump right into the next lesson. We just did a review on how we can create arrays from other arrays. Now the next thing we need to understand is that React knows how to render arrays. Let's say, for example, I had an array. Let's say this is the Ninja Turtles. And for now, I'll just set this up as an array of strings. And this is an example of a time when it can be kind of helpful just to see what happens. Scrimba is a great environment to do this in, so let's see what happens if I want to render this array of Ninja Turtles. As I said, it's just an array of strings, but of course, if I were to just type Ninja Turtles, like the variable name, then I would just get the literal text Ninja Turtles. So let's go ahead and surround this in a set of curly braces and see what happens. Okay, look at that. React was able to render it. Of course, it just mashed everything together because it's trying to render these strings, and it looks like it just concatenated them and stuffed them on the page as bare text. Of course, there's no difference if we wanted to, instead of setting this as a variable ahead of time, we just wanted to hard code an array directly in here. I can comment this out and see that we get the exact same result. Let me put this back so we're using our Ninja Turtles variable. And although for our example we're using an array of strings, it could be an array of any data type. Well, that's not actually entirely true. If I were to change this into just a regular object, let's say first name Bob, and I don't even need to go more in depth than that. I wish I were a Ninja Turtle, but I'm just a regular person. Let's see what happens when we try to render an array with objects in it. Okay, we do get an error, and that says that objects are not valid as a React child. So that is an error that you will likely see often. In fact, this has nothing to do with arrays. React simply can't render objects unless that object is of a very specific type. Remember, way back in the beginning of this course, we learned that JSX simply returns an object. So if I were to say h1 and let's go ahead and put Donatello's name in here, and then console log JSX, let me get rid of this for now. We can remember that JSX is an object. So although React isn't able to render the objects that we create, or maybe that we pull down as data from an API somewhere, it is able to render a specific kind of object, and that is an object that was created with the JSX syntax, or if you remember under the hood, the object that gets created with a call to React.createElement. So let me pull this back to when we had our array of Ninja Turtles, and I'm going to give you a little challenge. Okay, this is bordering on the realm of busy work. But for this challenge, I want you to manually turn this array of strings into an array of JSX elements, so you'll actually get rid of the quotation marks, by surrounding each one of the Ninja Turtle names with, I put an H2 element, but you can choose and play around with whatever element you want. Then before you hit save, try to think what's going to render to the page and see if you can make sense of what it's doing. Go ahead and get started on this challenge. Okay, I'll go through this pretty quickly just so you don't have to sit and watch me type out some JSX code. Okay, let's clean this up to buy some room here. So in this case, all we've done is we've taken an array and we've filled it with JSX elements. Or in other words, we filled it with those special React objects that get created when we use JSX. And if we go ahead and hit save, we can see that we actually get our H2s displaying on the page. So React was able to take an array of JSX elements and render them exactly how we might expect it to. In the end, this would be really no different than if I were to take this list and to just paste it directly in here. Of course, I'd have to get rid of my commas for that to work, but we can see hitting save gives me the same results. Let's back this off to using the array again, and I'll hit save. You might have noticed that there is a little warning that says each child in a list should have a unique key prop. We're going to cover that a bit later, so don't be too concerned about that now. All right, so combining what we just learned about how React can render arrays of JSX elements specifically is what we're most interested in, and what we were just reminded of previously with the capabilities of using array.map, we can take those two topics and we can apply them to our React apps so that instead of taking this data and hard coding a new instance of a joke component and putting in the punchline and the setup, we can instead pull in all of the jokes data from an outside source, which is what might happen if we were pulling this data down from an API, for example, as an array of data, and turn that array of data into an array of joke component instances where we pass the specific data down to those joke components through props. That might have been a little bit hard to follow just from me talking. So let's get our hands on the keyboard. We're going to do some challenges in the next scrim. Let me walk you through a couple quick changes that I made before we take what we've just learned and apply it to React. First of all, as you probably already noticed, I took all of our hard-coded instances of our joke components and just moved them outside here and commented them out. Then, where we used to have jokes.md, I created a jokesdata.js file. We're not quite ready to learn how to pull data down from an API and use that data in our React apps. We are going to be doing that in the next section. So for now, we're just going to kind of mimic that. I'm exporting an array of joke objects from this file. This would be kind of similar to the data that we're pulling down from an API. Then all I'm going to do in my app component is import jokes data from that file. And we can see if we console log jokes data, then we do successfully pull in the array of joke objects. Great. So now what I can do with this jokes data is I can create a new array of elements. Let's go ahead and call it joke, maybe joke elements. And I'll set that not equal to an array that I'm going to define with my square brackets here, but instead with the array that gets returned by calling jokesdata.map. .map takes a callback function, so we'll just stub that out for now. And it's going to look at each joke, and as it iterates over the array of jokes data, I'm going to have access to each joke in that array. We'll call it a joke object. And that's going to be an object, so this is a joke object. Well, it's not a joke object, it's not a fake object, it's an object that represents the data for a joke. So what I'm doing here is I'm taking this array of regular JavaScript objects and I'm going to turn them into an array of joke elements. So for each item in my jokes data, I'm going to return a joke component. And then I can pass the data from this JavaScript joke object down through props to my joke component. And by I can do that, I mean you're going to do that. So that's going to be a challenge. Let me type that out. All right, your challenge is to see if you can correctly pass the necessary props to the joke component in the .map and render the joke elements array so that the jokes show up on the page again. You can look down below to see what the structure of our joke components looked like. And after you've finished passing those props, as it mentions, don't forget to render the joke elements array. That can be kind of a pain to not realize why nothing's showing up. I'll hand it over to you now to work on this challenge. Okay, well, if we look below, we can see that our joke component is able to receive a setup prop and a punchline prop. And if we look at the jokes data that's coming in, we specifically have a property in each object that is called setup and another that's called punchline. So in my JSX, I'm going to include a property called setup, and I'll set it equal to the data that I find inside of my joke object dot setup. I think it's really important to make a distinction at this point. The data that we're pulling in from jokes data, this one has a predefined property called setup. Let's assume I were pulling this down from an API that I don't get to control. I'm sort of beholden to the property name that they chose on their joke objects. If, for example, these weren't called setup, but maybe something like question, then when I'm trying to render this data, I can't use joke.setup just because I thought setup was a better term. I have to use the one that they said, joke.question. In fact, let's just verify that this is working. I'm going to skip ahead and render my joke elements right now. I hope we don't get any errors because we're not passing in a punchline. Let's just see what happens. Okay, my punchlines are empty, but my setups are working. So the distinction I think is important to make is that the array of joke data that we're getting in, that array has a question property. I'm going to change this back in a second. But our joke component, which we got to define, we can choose whatever prop name we want to pass in. Because I'm calling it setup inside of my joke component, I'm still going to be using props.setup, whether the data coming in used the phrase setup or not. Just so that we're not getting our terminology crossed or any kind of confusion happening, I am going to put this back to setup, and then we'll go ahead and change this back to setup. But I remember in the beginning that being a confusing distinction. Just remember that you get to determine what you call your props in the components that you write. And when you're in control of the data, you also get to choose its structure. Very often you'll find that you're not in control of the data and you are stuck with whatever names they chose when they were creating the database. We can hit save and see that our setups are still working. Okay, let's just go ahead and finish this off by adding our punchline prop, and that is going to be equal to joke.punchline. We'll hit save, and awesome, our jokes are working again. Now we can see if we do a little bit of cleanup. Let's get rid of our challenge text and all of this commented out old stuff that we were hard coding before. We can see just how much simpler our code now is because we're pulling in data from an external source, which is oftentimes what you'll find yourself doing. And we can use regular JavaScript methods like the .map method to create an array of joke components and pass that data in. Keep in mind, our code here wouldn't change even if we had 1,000 jokes in our jokes data, unless of course you decided you didn't want to immediately display all 1,000 jokes on the page. Then we'd have a little bit of work to do pagination or whatever it might be. All right, now we're equipped to go back to our travel journal and not just be stuck with our single Mount Fuji trip, but instead we can take more trips and we can store that data in an external source, in this case just like a JavaScript file, and then iterate over that data to display all of the different entries that we want to display in our travel journal. So that's what we'll work on next. But before we do that, I do want to give you a little quiz about what we've learned regarding using the map method in our React apps. All right, it's time for another quiz, this time specifically about what we were just learning with .map. Make sure to actually click into the editor and type out your answers. And when you're done, you can hit play and we'll go through it together. Okay, number one, what does the .map array method actually do? The .map array method is a vanilla JavaScript array method. It's something that's built into JavaScript and has nothing specific to do with React. And you can run that method on top of any kind of array in JavaScript. You pass to it a callback function. It will iterate over or loop over every item in that array, run the function that you pass to it, and whatever you return from that function, it's going to put in the same index of a new array that gets returned from the .map method. A key part of that is that it returns a new array. And I'll go ahead and kind of summarize what I just said. So it returns a new array, and then whatever gets returned from the callback function provided is placed at the same index in that new array. Usually what we end up doing is taking the items from the original array and modifying them in some kind of way. Okay, question number two. What do we usually use .map for in React? Usually in React, we receive some kind of array of raw data, usually from an API. In our case, we're just stuffing it inside of a JavaScript file and exporting that array. but we receive that raw data and we turn it into JSX elements that can be displayed on the page. Okay, and number 3, I don't believe is something we've explicitly talked about, but it would require some critical thinking. Why is using .map better than just creating the components manually by typing them out? Well, I'd say there's a few reasons. First of all, we don't always know what data we're going to have ahead of time. In our case, we know exactly how many jokes we have and what the jokes data says. So we technically could manually type it out. In fact, we did manually type it out. However, in my experience, that's not usually how it works. So I guess answer number 1, we could say we often don't have the data ahead of time when we're building our app, so we simply can't manually type them out even if we wanted to. A second reason, though, that I think is maybe a little more important is that by using the .map method, we can make our code a lot more self-sustaining. In other words, if we were to manually type out all of our jokes like we had in the original version, and then our jokes data were to update, we would have to go back to our code and type out new jokes because new jokes got added to the data. However, when we're mapping over the array of data, we are accessing that array directly, which means that if there are new jokes added to the end of this list, simply refreshing the page is going to pull that joke into the app. It will re-render this array, including the new jokes that we added. If instead of adding it here, it, for example, got added to a database that we pulled that data down from an API, all we would need to do is fetch that data and the new jokes would be included and our app would render those new items. So let me try to summarize that here. It's not terribly unlike when we're writing a C-style for loop. Let's say we had let I equal 0, and oftentimes we'll find ourselves looping over the length of an array. So we'll say I is less than some array.length, and then of course I++, and fix this typo here. The reason we're using some array.length is because we don't want to know how long the array is. We just want it to iterate over an entire array, no matter how long that length is. So let me try to summarize this here. Essentially, it makes our code more self-sustaining. It doesn't require additional changes from us, the developer, to change the code whenever the data changes. Great job on this quiz. Hopefully you were able to answer all these questions. Now let's finally get back to our section project and start applying what we've learned. All right, everything that we've worked on so far has come to this point. Before we start, let me just walk you through a couple things really quickly. First of all, instead of having the markdown file that we had before with some of the information, I've created this data.js file. This is exporting an array of objects. Each object represents one entry in our travel journal. I've also added an ID property to each one. Don't worry about that for now. We're going to be talking about that really soon. But for now, you should have all the data that you need. When you import this array, which is part of your challenge, let's see right here, to import that array from data.js, map over that array to create an entry component for every item in that array, and then to render that array of entry components in place of the current entry component. This current entry component is displaying our Mount Fuji right now, but after you've mapped through the array of data and displayed that in place of this one, you should have all three of them showing up. I believe there's actually one really small style change that I want to make. I'm going to add a margin bottom here of 36 pixels just so that they're not shoved up right next to each other. Okay, the time has come. I know that you can do this challenge. It represents a culmination of everything that we've learned so far throughout this section. So it's possible this will be a little bit of a challenge. If you do find that it's way too hard of a challenge for you, then that's a good indication that you should probably pause doing this challenge, go back, revisit some of the lessons and the examples and the practices that we've done throughout this section, practice them again, and reach out to the Scrimba community. If you have any questions at all, head over to Discord. There is always someone from the community online that's willing to help. Okay, I'll hand it over to you. Okay, let's start by importing our data. We'll just call it data, and we'll get it from the data file. I can get rid of my challenge text. And I'm not sure if I've explicitly covered this or not, but I'm going to be doing the mapping inside of the body of my function, but before my return. It probably would have worked out just fine if you had done it outside of the component, but common practice is to do this as part of the body of the functions. Let's go ahead and start right here by creating a new variable. Let's call it entry elements. since this will represent an array of JSX elements. And I'll set it equal to data.map. So .map again will return a new array, and we want to use our callback function inside here. Stub that out. And for every one of the entries, we'll just say it's a single entry. We want to return some JSX. So we'll return, and I'm going to wrap this in a set of parentheses just so I can start this on its own line. We'll go ahead and return an instance of my entry component. And we can start taking the data from the entry and putting it into our entry component. Our image is going to equal, I'm going to use a set of curly braces because I have entry.img, and oh, nope, see, I almost made the same mistake. We are actually passing an object into our image. So I want to pass an object. Remember, the first set of curly braces puts me into JavaScript, and the second set represents an object, and I need to pass in a source. So my source is going to be, let's see, entry, that's this entry object, .image.src. Okay, great. And then we have an alt, which we will set to entry.image.alt. Now, this is clearly the longhand way to do this. Because our data does happen to match up, we have an image property, which is an object with an src property and an alt property. I actually can shorten this quite a bit. Instead of repeating each of the properties here, I can simply say my image is going to be entry.image. So I guess the way that I was starting it in the first place was actually going to be right. This might be a little confusing. The entry component is expecting the image prop to be an object, and that object needs to have a source property or an src property and an alt property. And if we go and look at our entry.image, let's see right here in data.js, entry.image, it is exactly shaped that way. It's an object with a source property and an alt property. So because our data happens to line up with exactly what our entry component is expecting, then I can just pass in the whole object. This is actually kind of foreshadowing of something else we're going to see soon. Okay, so I also need to pass in a title, and this is going to be entry.title. We'll do country, and I'm just kind of looking down here to see which properties I need. So the country is going to be entry.country. The Google Maps link, entry.Google Maps link. Oh, and I need my curly braces here. Oh, and this is not an object. These are my props, so I need an equal sign. Okay, my dates is going to equal entry.dates, and my text, entry.text. Of course, if I hit save, we're still going to be showing just Mount Fuji, and that's because I haven't yet replaced this. So let's get rid of this entry component, and instead grab our array of JSX elements and stick them right here. So a set of curly braces to go into JavaScript, and then we'll supply our array. This is the moment of truth. Keep your fingers crossed. Let's hit save. And awesome, look at this. We have all three of our entries showing up on our page. The images make it clear that we have different data for each one of the components, but we can look and see each one is unique to its own entry data. Awesome, this is some great progress, and actually we've covered a majority of what I want to talk about in this whole section of the course. Mapping data in React is one of the most common things you'll find yourself doing, and I personally think it's really neat that React has given us JavaScript primitive ways like the array.map method to accomplish the repetition of our components while passing in unique data to each one. I do have a couple of extra topics that I want to talk about. That's more of a sneak peek into the next section. But I do want to give another soapbox speech that says if this was too big of a struggle for you, first of all, that's completely okay. But second of all, it's a good indication that it's time to go back and restudy this, re-practice it, until you feel like you could do this from scratch if you needed to. As I said, reach out to the community for help, or to simply post a win that you were able to finish, sort of the MVP of our travel journal app. Once you've come down from this high of accomplishing such a great task, we'll keep moving forward. The coolest part about the way that we've set this up in React is that the display is a function of the data that we're pulling into our app. This just means that if we were to come to our data.js file and let's say just copy and paste these last three items, I can hit save, only changing the data, and we come to our app and check it out. We actually have those extra components showing up on our screen. Of course, as I've said, usually we'd be pulling this data in from an API, but that's beside the point at this time. We'll be getting there soon. Let me undo this so we don't have so many of the Geirangerfjord. Hope I'm saying that right. And let's hit save so we just have our 3 items there again. Now we notice that when we're hitting save, we're getting this warning in the console. And it says that each child in a list should have a unique key prop. And it even tells us where we're rendering that list. And this is a common warning that you'll likely come across many times when you're writing React code. Anytime you take an array of data and turn it into an array of components, or an array of React elements. React has an interesting system under the hood that it uses to keep track of what order everything is in when you give it an array of React elements. It's a little bit outside the scope of this course to really discuss why, but from a really high-level overview, if you were to ever include functionality where the user could add new items to this list or maybe remove one of the items from the list, React needs this unique key prop that it talks about in order to keep track of which one you're actually removing or where you're adding new elements. Again, it's a bit outside the scope to get into the nitty-gritty of why, but it's really easy to implement because all we need to do is pass a unique prop called key, and it actually has to be KEY. I know we've talked about how we get to choose the names of our props. Well, this is an exception. It has to be key, and the value that we pass to it has to be unique. So I can't pass, for example, a hard-coded 1 to it because then every one of them would have the same number. And you can see the warning says they encountered 2 children, in this case it probably should say 3 children, with the same key 1. Well, a really common thing for us to do, especially when we're getting data from a database, is that data, or that array of data, will usually have an ID attribute associated with it. And this is actually managed by the database. It ensures that these IDs will be unique across the entire collection in that database, or the entire table of that database. And so if your data does have an ID, in my case I just typed them in manually, then this is the first place to start when it comes to providing a unique key. So I can just say entry.id, hit save, and our warning goes away. Of course, in our case, because we only have 3 entries, I could have used pretty much anything here. The title, dates, text, link to Google Maps, the country, these are all unique across these 3. But of course, if I were to visit another place in Japan and have another entry for Japan, then that clearly is not a good key to use because it would be repeated over multiple elements in the array. Whenever you can, just stick with IDs. While I'm talking about that, if you do happen to have an array that doesn't have an ID, something I often will see beginners do is they will access the index, which is something that .map provides to your callback function if you need it, and then trying to use that index in place of having an actual unique property about your data. And I'll be completely honest with you, this is recommended against, but if I hit save, you can see I'm not getting any kind of warning. In my case, because I'm not going to be adding or removing any of these elements, at least not from the UI itself, the index will kind of get the job done in a pinch. But generally speaking, if you can avoid it, just don't use the index as your key. I'm actually pretty sure there's an entire article on the React docs that talk about this, or at least a section somewhere. So in a pinch, it will work, but whenever you can, use an ID instead. Okay, all the warnings gone. Our app is looking good. There's just a few miscellaneous topics that I want to make sure I cover while we're still on the topic of props. So that's what we'll be doing over the next couple scrims. One thing you might have noticed, especially if you were typing this all out from scratch, is that the amount of properties that we're passing to our entry component, it's getting a little bit lengthy. And I'm sure you can imagine if we were to have a lot more data included in each one of these objects, imagine an object that has something like 20 or 30 or more properties to it, it would become way too cumbersome to try and add a new prop for every single one of the properties in that object. One way that we can make this a little bit more concise is by noticing that what we're doing here is creating a prop for image, for example, and passing entry.image, title, entry.title, country, entry.country. Well, it sounds like our entry is interested in every property of the entry object that we're passing to it, which means instead of passing down every property of our entry as a separate prop, what I could do is just create an entry prop and pass the entire object down. Notice that I do need to keep my key here. This is something that's specific to React, as we talked about. So even though I am passing a part of my entry down, I need to tell React that it's got a unique key that it can grab on entry.id. but the rest of the entry object I can pass as a single prop called entry in my case. Of course, I got to choose this name. I could have said something like obj for object or just the word object, but let's keep it as entry. Of course, because I'm changing the props that I'm sending down, if I hit save, sure enough, everything is broken. Gosh, we're not even displaying a single thing. I thought at least some broken links would show up here. So let's go over to entry and have ourselves a little challenge. There it is. Your challenge is to fix our component. I am intentionally being a bit vague here because I want you to think critically and use this as an opportunity to gauge your understanding of props, what's being passed down as props, and how we can make changes to the code of our components so that everything starts working again. I believe in you. I know you've got this. I'll hand it over to you to work on this challenge. Well, if we open our console, and something that can be helpful on Scrimba is to open your actual browser developer tools console. On a Mac, I can hit Command-Option-J and it will open those directly. But I can see down here in the console, it says that it cannot read properties of undefined reading source. And that makes sense because before we were receiving an img prop, which was an object that had a source property, but we're no longer receiving img, which means this is undefined, and we get an error trying to read the .source property on top of the undefined value in JavaScript. If I want to temporarily bypass this error, I can use optional chaining. And I think this will, so this shows some elements at least showing up on my screen. We can clearly see that things are broken. So this will give me a chance to console log the props, which is always a good place to start when you're debugging something. Okay, and sure enough, if we look really closely, it's a bit of a mess when it's all in line, but we can see that we're receiving a single property called entry, and that entry prop has a value of an object where all of the other data is being stored. Which means all I really need to do is everywhere I have props dot, go ahead and select everything on the page. All I need to do is add an entry in front of that and then access the properties of that entry as it's nested inside. Let's clean up this console log. I'm actually going to remove my optional chaining there and we'll go ahead and hit save. And awesome, we're working again. Now, although everything is working, I think it's helpful to notice at this point that the reason we're magically working is because the data that we have inside of our data array matches exactly in terms of the language or the property names that we're using, matches exactly with what our entry is expecting. As a reminder, if we were to change what properties we were passing down, then we would have to make a change here to reflect how the data looks. Because we're passing this entire object down, we're now essentially stuck using the exact property names that are here. Sometimes when you're dealing with an API, you might have something that isn't truly conventional JavaScript, like you might be pulling in something that says Google Maps link, but with snake case instead of camel case. I'll go ahead and hit save, and we can see now that Mount Fuji, at least in the display, we no longer have an underline under view on Google Maps. And that's because the object that we're passing down expects it to say Google_Maps_link. In our entry, we're not doing that. Let's see, where's our link source? Right here. We're still using camel casing. So just something to keep in mind, when you are passing down entire objects, you will be stuck using whatever properties they give you. Let's go ahead and change this back. We can hit save, and now our link is working again. So there's certainly trade-offs. One really nice thing is that we just have a single prop here. We're passing the entire object down, and if you really don't like the way that the data is structured, or rather the way that the property names are set up, there are ways that you can rename them just for the sake of your own code. But we won't be worrying too much about that right now. All right, we are so close to done. There is one little thing that I wanted to show you regarding exactly what we have here. It's another relatively concise way that we can pass down all of the properties of our entry item here. And it does look a little bit unique, so I wanted to make sure I covered it just so that you weren't super confused by it if you did see it in the wild. So that's what we'll be touching on next. There's one last little syntactic trick that you can use when you're passing a full object down through props. And I wanted to touch on it just in case you did see it in the wild, because the syntax looks a little bit confusing. The trick uses the JavaScript object spread notation. But instead of spreading the object itself, this is our entry object that we're pulling from our data, instead of spreading the object itself like this, what we actually can do is remove our prop entirely, put a set of curly braces, and spread in our entry object. React will look at this and it will take all of the individual properties of our entry object and create a new prop that matches each of the properties of this entry object. So essentially, it would see that our data has an ID property, an image property, a title property, and let's just start with those because that's all I can remember offhand. And it would be essentially like doing exactly what we had before, where we say ID equals entry.id, image equals entry.image. And remember, image in this case is an object, that's totally okay. And title equals entry.title, and so on and so forth until it covered every single one of the properties of our entry object. Let me put this back to use this new spread syntax that we see here. But of course, we just went through changing this so that it passed down an entry object through props, and we have props.entry.everything. So if I go ahead and hit save, then we can see we're completely broken. And I considered having you do a challenge to do this, but I just made you do this work. So I'm going to go ahead and do this for you. Everywhere I have entry dot, I'm just going to multiple select and we'll delete that. So essentially, this is back to exactly the way we had it. I'll hit save. And awesome, everything is working again. In some ways, this is kind of like the best of both worlds. You don't have quite as much clutter here by having to say props.entry.image.source and so forth throughout the code of this component. And on the other side of the equation, over here, we get to simply say curly braces, ... entry. So this is more concise, and this is more concise. However, in certain circumstances, I find myself personally struggling with this method only because it really obscures what data is coming down through this entry object. In my case, I have to go all the way to my entry component and console log my props just to see what data is coming in. If I were to make alterations to this, like say I had a new property in that entry object that I needed to display somewhere, I'd have to make sure I understood exactly what was coming through. I guess it's really not that big of a deal when I say it out loud, but for the sake of this course, I'm going to leave this here for this scrim. But going forward, I'm likely either going to create a separate prop for each of the data points that I want to pass down, or I'm going to pass down an entire object and just kind of live with the more verbose syntax that we have to have here on the component side of the equation. And all right, folks, that marks the end of our travel journal. I'm sure there's lots of improvements that you could make to it. I would love to see them if you want to make your own design changes, or more interestingly, I'd love to see what places you have visited. Fortunately, all you have to do is go to data.js because of the way we structured this and make changes directly to the data. Hit save, and your own information will show up here. Head over to the Discord, post a screenshot of some of the cool places that you visited, or if you don't feel like going in that depth, just post a screenshot of your progress here with the travel journal. The Scrimba Discord community is one of the most welcoming places ever. The last thing we have to do is do a quick recap of everything that we've learned throughout this section, and if you're a Scrimba Pro member, we'll be giving you a solo project that you can work on that will be in a similar scope to what we've worked on in our section project with the travel journal, and we'll give you an opportunity to really test and push yourself to see if you're able to recreate something similar to this from scratch. If you're not yet a Scrimba Pro member, I highly recommend testing it out and trying one of these solo projects, because they make all the difference in not only this React course, but the Scrimba front-end career path in general. What a great job you've done on the travel journal project. I hope that it's been an inspiration to you to get out there and do a little bit more traveling too. What we've learned in this section has enabled us to build some pretty cool stuff. We started out by talking about why reusability is important in the first place. We saw that probably most of the websites that we visit have some component of reusability that is driven by its data, as opposed to just being hard-coded by a developer somewhere. There will likely always be static portions of whatever web page you'll build, but more often than not, you will find yourself using data to drive the content of your website or your web app. And we learned in React a primary way of being able to reuse our components is by providing props. Just like how functions have parameters that give that function the ability to be reused with any kind of data that's passed to it, props give React components that same power. And we learned how React can render an array of components, which allowed us to create an array of components from a raw array of data. In our case, we had our data just directly in our project, but more often than not, you would find yourself calling out to some kind of API to get that data, map over it, and then display that data to the page. This marks a giant step forward in our understanding of React and also the level of cool projects that we can build with it. So this would be a perfect time to head over to the Scrimba Discord community and post your accomplishment in the Today I Did channel. Go there to celebrate your own wins as well as congratulate others on the wins that they've been having recently too. Once you've had a chance to do that, this might be a good time to take a break because what's coming up is a really meaty section. The topics we are about to cover will really step up your React game and empower you to create truly amazing interactive web apps with React. Once you've had a chance to celebrate your wins and rest your brain a little bit, we'll dive right into that in the next section. You have done an amazing job so far in this course, and now we are finally approaching probably the most exciting section in this course, which is building interactive web apps in React. I am so excited because this section really unlocks a huge section of React that allows us to create really dynamic, exciting web applications. What we've been working on so far is first learning the fundamental building blocks of React by building static websites. This was really important for us because we needed to learn the syntax of creating our own components and generally, of course, how to spin up a React app from scratch. How React is even working behind the scenes and what its main philosophy is. Then we moved on to how we could build reusable components. We learned about props and how we can pass data into those components. This allowed us to use static data to generate portions of our web page, which is what set up the foundation for what we are about to learn. And I've done my best to make these sections really exciting, and hopefully you weren't like our grumpy friend Stanley here, bored out of your mind while learning these topics. Now, the crux of what we are about to start learning lies in understanding the difference between static web pages and dynamic web apps. We've been mostly working with static web pages in React so far, and you can tell something is a static web page based on the fact that it is usually read-only. In other words, there's no user-driven changes to the data behind the scenes. Some really common examples that come to mind of this are blogs. When I'm visiting a blog, I'm usually just consuming or reading the content on the blog. Now, there might be tiny interactive elements on most blogs these days, but I think you get the idea. That's not the portion of the site I'm talking about. The same goes for news sites. It's presented to us, we consume the information in a read-only way, but we're not updating the news that's written on the news site. Recipes are another good example of this, and I'm sure we could come up with many more. We are totally capable of building the front ends of these kinds of websites in React. However, what we are about to venture into is understanding how we can build dynamic web apps in React. You could classify something as a dynamic web app when it has read and write capabilities, or the user has ability to change the data. As such, these kinds of dynamic web apps tend to be highly interactive. Typically, these kinds of apps will have portions of the site that will display your data specific to you as the user of this app. Some examples that come to mind are a bank website. You log into your bank website, it displays your information, your account balances, allows you to transfer actual money, or at least the ones and zeros that represent money, and so forth. Also, pretty much any SaaS product or service like Airbnb. There's portions of their site that will display static information to you, like a list of properties, but you have the ability to filter through them and organize them by price or rating. You can click into them, and maybe most interactively, you can book the Airbnb and pay for it. This kind of leads into a whole section of sites that are e-commerce sites. The ability to add items to your cart and purchase it with your money are telltale signs of a dynamic web app. And these days, I'm sure if you were to look around, you would find probably hundreds of different web apps that you have signed up for and at least used in the past. To guide our curriculum through this section, we are going to be making a really exciting web app called Chef Claude. Chef Claude is a recipe app where you will input a list of ingredients that you have on hand, and at the click of a button, send that list of ingredients off to an AI API to generate a recipe for you based on your ingredients. And this project is actually going to have two options for different AIs you can use, one using Claude AI through the Anthropic API, and another using Mistral AI, which we will access through the Hugging Face API. Boy, that was a lot of acronyms. This project is super exciting. It's actually something I find myself using, and it's going to help us really grasp all of the concepts from this section in creating dynamic web apps with React. So without further ado, let's dive in and start learning. Sometimes when I'm starting a new project that might feel a little bit overwhelming, I try to find parts of the project that I already do know how to build. Up until now, we've only been building static pages in React, and the truth is that there are parts of this app that are completely static. So I'm going to give you a challenge now to create this header section. It's mostly just meant as, I guess, both a continuation of the previous section to make sure we're still practicing, and as a way just to warm us up for learning all about how we can make this app a really nice interactive app by the end of this section. So your challenge is to start by building the header component. You're going to do it in a separate file and then render it here in the app component. If you click on the screenshot here, it will take you to the Figma design file, and there's a couple things that I'm setting you up with just because it's a little more tricky. First of all, I've already included the Chef Claude icon.png file. That's the little robot with the chef's hat here in the logo. So inside of your header components, you can import that, as we've seen with handling static assets. You can import it and then render it as the source for this image element. In the CSS, I've also put a little bit of starter CSS here. Maybe most interestingly, I've set the font family to Inter already, which is being imported in our HTML file, so you don't have to worry too much about going to Google Fonts and grabbing that. Also, Figma has recently changed where it has obscured a little bit some of the CSS rules that you might need, and one that I found a little bit challenging was the box shadow that it has underneath the header. Right here, there's a tiny little box shadow that helps separate it from the rest of the body. And although it's a small detail, it actually makes a pretty big visual difference. And so the code for it is right here. Just feel free to copy and paste this into the box shadow of your header. Also, keep in mind the design on Figma, it is a little bit more optimized for a bit of a wider screen. If you want, you can follow exactly the sizing and just pull your mini browser a bit wider. Or there's the feature where you can maximize it to show up bigger inside of the Scrimba window. Either way is totally fine. If you do decide to keep this a little bit on the smaller side, which is what I'm going to do, I'm probably going to change a couple of the values that are in Figma just to make it fit better on the mini browser. The changes are minor, it's not that important to our learning, so feel free to do it however makes the most sense for you. Okay, it's your time to shine. Go ahead and get started on building the header component. Okay, I'm going to work a little bit backwards and pretend that we have already built a header component that I can import and render here. So let's go ahead and, let's see, we'll just call it header.jsx. It'll be its own file in the same folder as the app component. Because we have a relatively small scoped project, I'm not going to worry at this point about creating a separate components folder or making a really deeply nested structure in our project. So we'll just keep it like this. If we need to, we can always refactor later. And then right here, I'll go ahead and render my capital H header component. And I'm not going to hit save because we'll crash because this doesn't exist yet. So let's create that file, header, capital H header.jsx. And there it is. We'll create our function. We'll export default function header. And we'll do a little sanity check here. We'll say we have an H1 that will return that just says header component here. Hit save, and sure enough, it's showing up. Awesome. Let's get the content on the page, and then we'll worry about styling it. So I am going to use a semantic HTML header element, and we have a very simple header. Often with real businesses, just to make sure everything stays exactly as their brand needs it to be, the logo or the icon and the text will all actually just be a single image. In my case, what we have exported is just this little chef logo. So we will need to put some text there. So we'll render an image and we'll render, I guess we can call it an H1. It's kind of like the site header. Again, usually this is part of an image, so that's not what we would dedicate our H1 to. but I think we'll be okay. So we'll say this is Chef Cloud, and the source is going to be equal to the icon. I could, in Scrimba, give a path to the icon and say /images/chefcloudicon.png, and I think that should work. Yep, there's our icon. Better practice, though, as we've discussed, is to import any static assets. So I'm going to grab, let's see, this text here. We'll import it and call it the Chef Cloud logo, and we'll import it from that icon, or that path to the PNG, and put Chef Cloud logo here. It should be exactly the same. Yes, perfect. We have the content. Let's do some styling. I'm going to access my header. We'll give it a display of flex. We'll justify everything to the center, I guess in both directions, so we'll align items to the center as well. The design shows that there's about an 11 pixel gap between the icon and the text. We're going to make this icon smaller in just a second. Let's see, I'm having trouble seeing exactly what the header and the body is. Let me just temporarily give this a crazy background color. We'll say the background color is red. Okay, that's pretty good. The height seems a little bit large to me. It looks like in the design it's set to 108 pixels. Oh, that's even larger. Let's go ahead and use our discretion to change this to something different. 80 pixels seems a little more reasonable, and then we can go ahead and fix our image. And oh, let's grab this box shadow code while we're here and stick it there. Change the background color away from red. We'll get rid of that line. I think I'll look ahead a little bit and change the background color of my body to the background color that is in the design. And wow, that is very subtle. And oh, it looks like it also is coloring the header, so we'll need to specify that this needs to stay white. So this will be a background color of white. And yeah, that's working. Perfect. Okay, let's get access to our image. Because I'm only going to have one header and it's only going to have one image, I'll just select those directly as a descendant, or I'll select the image as a descendant of the header. I think that won't be a problem, but we can always add classes if we need a little more specificity. The width on this, I think it says it's 40 something. Let's see what it looks like as a 50 pixel width. That looks pretty manageable. Yeah, let's go ahead and stick with 50 for now. And then I will do the same, selecting my H1 inside my header. Okay, in the design, it has the font size set to 32 pixels, which is 2 rem. And I think that might be the default size for an H1, so I don't think I actually need that. Let's try the font weight. It shows as 400. And yes, that does make a difference, and it looks a little more sleek, being not quite as bold. So let's keep it like that. Sometimes we get issues with default margins, but it looks like that's not causing a problem here, so I don't even need to say margin 0. We've already got the font family set to enter. Let's comment this out and make sure that's working. It's subtle, but it's working. So I guess that's it. We've got our header all set up. I know it's a lot to spend this much time doing CSS in the middle of a course on React. I really do try my best to integrate some of the past lessons that you've had, especially here on Scrimba if you're taking the front-end developer career path, just so things don't get stale. You know what I mean? It's better to practice it now, even though it's not technically what we're learning. And as I've mentioned before, you do have my permission to skip some of the CSS that we do if it's something you already feel completely familiar and comfortable with. Okay, so we finished this top section, and although we are going to add some interactivity to our tiny little form here, the structure of the form, just being an input and a button, as well as the looks of it, can be started as static. So we're going to do that next before we move on to more of the meat of this section. When our users first come to the Chef Cloud app, they're just going to see the header and this little form here. We might decide to add a little blurb that explains what this app is supposed to do, but for now, the only other static thing that we need to really worry about is creating this form. It will, of course, have some interactivity with it, and we're going to learn all about how we can deal with forms in React a bit later in this section. But for now, let's go ahead and get this form added. Now, I have made you do a lot of this manual work. I know that it's just repetitive CSS work mostly, and so I'm going to give you a little treat. I'm going to work through this. I will keep it here in the recording, and it will be the remainder of this lesson. So if you're interested to see how I create and design this little form, then by all means stick around. If you're ready to move on from the static stuff, we're about to jump into some really exciting things, so that can be what you do next. So you're welcome to skip ahead to that if you want. I'm going to get started first. Let's see, let's head to our app. And underneath our header, I'm going to include another component called main. Now I need to wrap this in something because we can't render two sibling elements like that in React. I need to import main from /main. And then of course I need to create that. So we'll create a new file called main.jsx and spin up our component. As I usually like to do, I'll just return something simple to make sure things are hooked up. Okay, great. We're showing main component there. The content that we're concerned about at this point is very simple. We are going to probably be doing most of our markup here inside of the main component, but for now we can just create our form. And so first, because this is the main section of our app, we're going to surround it in the semantic main element, and then we'll add a form. I know this is just a simple single input and a button, but even stuff like this, I much prefer to put in a form. First of all, it's more semantically correct. We are creating a form here. It makes it better for assistive technologies to understand what's going on. We also get some built-in functionality when we put it inside of a form. For example, when a user fills the input out and then hits the enter button, it will automatically submit the form. It will have access to the form data if we need it, and it's just a whole host of benefits by using an actual HTML form. Okay, so in the design, we just have an input and a button. Typically, for accessibility reasons, we would want to make sure we also include a label, or another option that we can do is to add an ARIA attribute to our input that's called ARIA label. And so I'll set that equal to add ingredient so that anybody using a screen reader can very easily understand what they're supposed to do with this input. Okay, let's put this on its own line because we're going to add some extra properties here. We want this to be a type of text. We'll give it a placeholder, just like we saw in the design. We can say something like, for example, oregano. As a reminder, a placeholder is a great place to put an example of what should be entered as text into that field, and it isn't a great place to put the actual label, so I wouldn't want to say something like add ingredient as my placeholder. Okay, by default forms are pretty ugly, so let's hit refresh, and yeah, oh, our button has no text. We might want to say add ingredient there. Okay, let's see what we're working with. Perfect. Well, not quite perfect yet. Let's go ahead and style it up. Chances are I'm not going to be adding any more forms to this page, so I could just select the form element, but I'm not sure why. I'm feeling like I probably want to give this a class name, so I'm going to give it a class name of add ingredient form. Okay, I'll hit save so that applies. We'll go over to the CSS and start styling this. Let's access our add ingredient form. And I'm going to add a display of flex, even though we do already have inline elements, just so that it makes it a bit easier for me to center things. So I can justify content center. We'll add a gap of about 12 pixels, I think the design shows. And it's sitting right against the header. So let me also add some padding to the main element. We'll give it maybe 10 on the top and bottom and 30 on the left and right. And I guess I need to specify padding. And oh, when I did that, I see that my elements are stretching now. That's a default with display flex. So if I were to instead say align item center, that should fix that issue. Of course, our button is a little large. You know what? I'm going to cheat and just make this a little bit wider. I should probably add some kind of no wrap rule to the button, but for now, I'm not going to worry about it. Okay, let's access our input. I'm going to grab the style for my form and then specify the input on it. And let's give it some border radius of about 6 pixels. The default border is a little bit crazy, so we will add our own border styles of 1 pixel, solid, and then I'm just going to grab this color from the design. Okay, that looks much better. The padding is a bit tight there, so we'll add a padding of about 9 pixels on the top and bottom and 13 on the left and right. Awesome, looking good. I'm going to make this a little bit wider so add ingredient doesn't wrap again. The design does have a little bit of a box shadow around it, so I'm just going to paste that in from my dev mode in Figma, which you likely don't have access to for this design. And then one thing I noticed from the design is the input does get pretty wide as the screen gets wider. So I do want it to grow. I can use the flex grow property. We'll just set it to 1 so that as the screen expands, it does get wider. Although I do think I want to add a minimum and a maximum because it can get a little bit squishy right down there and a little bit too wide way out here. So let's give this a min width of, let's say, 150 pixels. and a max width of maybe about 400 pixels. So as we get wider, it should stop growing. Yeah, perfect. Okay, the input is looking pretty good. Let's go ahead and style our button, and then we can move on. So we'll access the button, and for whatever reason, I'm sure there's a good reason for it, but buttons do not take on the font family that's specified elsewhere, even if you specify it in the body here. So I'm going to make sure I specify the enter font family for our button. We'll also give it a border radius of 6 pixels, just like our input. The border is looking a bit intense, so I think for now I'm just going to say border none on the button. Let's give it a background color, and this is a color specified in the design. Of course, the text is now impossible to read, so we will specify the font color with the color rule. All right, that's looking a little better. And the button is pretty squatty. I could try to add padding to it, although I don't really want to add padding and try to guess to make it the exact same height as my input. Maybe what we can do is take away the align item center, and well, actually that just kind of makes it work. It just makes it look better. It's using the default of stretch as its align items, and that actually looks pretty good. I'm not sure that this will make much of a difference, but I'm going to specify a height on my whole form. The design looks like the input is 38 pixels tall, so we'll just add that. It doesn't look like it's making a change, but maybe any other structural changes that we make, that height might be good, or maybe it'll be bad and we get rid of it. For now, let's leave it in. Now the design does show a plus before the add ingredient, and it looks like our button is quite a bit wider. Now the design does show this little plus icon on the button before the add ingredient. And I could just go in and type that into the markup, but it feels almost decorative to me. So I think what I'm going to do instead is use a before pseudo selector and just say that the content is a plus, and then maybe give it a little bit of margin right just to separate it a little bit. And I need my semicolon here. Okay, that's looking good. All right, with this behind us, let's keep moving forward and start jumping into the meat of this section. And actually, our button is still looking a little bit squished, so let's see if maybe we give it a width of 150 pixels. I think the design shows quite a bit more. Oh, and I think the font size is a little bit smaller. The font size looks like it's set to 14 pixels, which comes out to 0.875 rem. And oh yeah, that makes a big difference. It also looks from the design that the font weight might be adjusted. Looks like it's set to 500. Let's see if that's making a difference. Oh, it's a very slight difference, but we'll go ahead and leave it in. Oh, and one last thing. I'm noticing that our form is shoved up pretty close to our header. It looks like in the design there's about a 70 pixel space between those. I think that's going to be a little bit large for such a small site here. So I'm going to call an audible, and let's see, our padding on our main element is 10 on the top and bottom, 30 on the left and right. I'm going to go ahead and specify, let's see, 10 pixels for the bottom, and then change this to, yeah, let's say 30 pixels on the top. This is a little bit less common. If you have just 3 values, then it's top, left and right, and bottom. Kind of a weird way. I'm honestly not sure how I remember that, but it's working great. Okay, we're done with the static portions of our page. We have a lot to dive into still. I think a really good idea is for us to take a step back and get a high-level overview of the project and make sure that we understand how we're going to go about building it. That'll be something we do really quickly in the next scrim. Other than just building the static parts of your page, it's a really good idea when you're starting a new project like this to try and take a step back and think about how you would approach solving the problem. Assuming you're fairly new to React, that might not be entirely possible at this point because you still have quite a bit left to learn, but I thought it would be helpful for us to get a high-level overview of how we're going to approach building this project. When the user first shows up, as I've mentioned, they will simply see our header and a little form like this where they can start adding ingredients. Once they start adding ingredients, we're going to change the layout of the page a little bit. We'll include this header that says ingredients on hand. We're going to map over the array of ingredients that they've entered into the form. And we're going to have a call to action down here where they can click this Get a Recipe button. This is where things get pretty fun. Clicking the Get a Recipe button will send the list of ingredients embedded in a prompt that we send to the Claude API from Anthropic. Claude is an extremely capable text completion AI that will take the prompt we send to it, which will include the list of ingredients, and it's going to generate a recipe. Now on this next screen I had to split it because we're going to be scrolling up and down the page, but you can see it will have a suggested recipe. It's going to have a basic text at the top that tells you what it recommends that you make, and then it will have a formatted list of ingredients and a formatted list of instructions. The way we're going to handle this formatting is fairly simple, but it's not something we have to be too concerned about right now. Now, there's still a lot left we have yet to learn, so don't let all of this feel like it's too overwhelming. I promise we're going to take it one step at a time, and by the end of this section, you are going to be able to complete this entire project from scratch if you needed to. All right, I'm too excited to wait any longer. Let's jump in. The primary thing that sets apart a static website from a web application is the user's ability to interact with the things that they see on the screen. And one of the primary ways that we do that is by listening for events. So let's talk about how we can add event listeners to our components in React. First of all, based on the prerequisites for this course, I expect that you already are familiar with the concept of adding an event listener in regular DOM JavaScript, where you would select some element and you would use the .addEventListener method. This method takes two parameters. The first one is the type of event that you want to listen for, like a click event. And the second is a function that should run should the click event ever happen on this specific element. Another way that you can add event listeners to elements is directly from the HTML. If, for example, I wanted to, well, let's say we have a button here, and it'll just say trigger event. Inside the HTML, I can add an attribute to my button called onClick, all lowercase like this, and set it equal to the string of a function that exists in my JavaScript file, maybe called handleClick. And I use a set of parentheses here to indicate that I want to run that function when the onClick is triggered, or rather when the click event happens. And although I seem to find this HTML method of adding event listeners a little more rare than using the addEventListener method in JavaScript, the way that we're going to do this in React is actually more similar to the way that we see it here. The syntax is very similar to how we do it in HTML. So let's go to our JavaScript. I'll get rid of this line here. And the way that we can add an event listener is one of the properties that we pass to this button. So I can add an onClick, but this time I'm going to use a capital C. As a reminder, sometimes it's easy to forget that we're actually inside of a JavaScript file, even though what we're writing looks a lot like HTML. And this JSX code that we have will be converted into a regular JavaScript object. That JavaScript object will then, by React, be turned into an actual DOM node that displays on the page. But because we're here in JSX, any of the attributes that we add to our React elements are going to be accessing the actual DOM node's attributes or properties. And in JavaScript that accesses the document object model, it does use camel casing like this. That's the same reason that we're using class name, because class name is the actual DOM node property. Now, because we are here in JavaScript, I don't need to set this equal to a string of a function that I'm trying to run. Instead, I can set it to the actual JavaScript expression that I want to run, which means if I want to, I can just stick a function right here in line, and whatever I'm going to run here, let's say console log clicked, the body of this function will run anytime a click event happens on this button. Let me hit save, and oh, we have our trigger event button. Let's go ahead and get rid of this. Okay, so if I hit click me, then we get the JavaScript that we put inside of our function actually running on the click event. Now, I don't personally love to put my functions right here in line. Sometimes I'll find myself doing it. More often than not, I will create a function outside at the top level of my component above the return. And so I might have something like function handleClick, and we'll go ahead and just put our console log back. And this leads us to our first challenge. Your challenge is to add the new function that we just created, handleClick, to the button. Go ahead and give this one a shot. Now, some of you might have been a little bit tricked by adding handleClick followed by a set of parentheses. I had mentioned that this is the way that we do it inside of our HTML. However, because we're here in JavaScript, if I include this set of parentheses, it's going to run this function as soon as the component loads or is rendered. Let me go ahead and hit save and watch the bottom of your screen for the console, and you'll see it immediately ran I was clicked, even though I didn't actually click the button. We don't want to include this set of parentheses here because that does indicate that we want to run the function immediately, as opposed to passing the contents of the function, or the functionality of the function, to the button element so that it will only run when the click event is triggered. So I'll go ahead and hit save, and now it will run I was clicked when I click the Click Me button. Awesome. Before I get too much further, I do want to point you towards the documentation on responding to events. Click this screenshot if you want to head to the React documentation for this. And I also included a slide that leads you to the mouse event handler functions, which give you an example of different mouse events that you can respond to in React. And this documentation is going to be helpful for you for the next challenge. All right, your next challenge is to log something to the console whenever the mouse hovers over the image. Now, because we're hovering, it's not going to be the click event, which is why I gave you the documentation here. Feel free to go check that out. And with that, I'll pass it over to you to finish this challenge. In that documentation, we can see that there is an event called onMouseOver, and there's also onMouseEnter. Either of these would have worked just fine for this challenge. Let's clean up this challenge text so we declutter a little bit. And I'll go ahead first and create my function here. We'll say handle mouse over. And then on my image, I can add an on mouse, capital M, over, capital O, equals, and then my function of handle mouse over. Let's have this console log I was hovered. Let's hit save and cross our fingers. And sure enough, when we hover over the image, we get I was hovered. We can do that really fast and get lots of console logs. Awesome. It can be kind of fun to check out all the different events that you're able to respond to. I think a lot of them you likely haven't even heard of and could probably find some really cool ways to use them. So feel free to poke around the documentation for the different handler functions. This site will take you to the section on mouse event handlers, but if you were to scroll up or down, you would see other ones like touch event handlers and pointer event handlers, keyboard event handlers, and so forth. So lots of really cool stuff there. Hopefully this is fairly straightforward enough. We're going to be doing a lot of event handling. It's one of the cruxes of having a web application over just something that's purely static. So lots of really fun things coming up. As we just discussed, when our users first come to our app, they're going to be presented with a pretty simplistic UI. And their task is to type in an ingredient and click Add Ingredient. When they start adding ingredients, they're going to be presented with a new section of the site, which will list the ingredients that they've entered out for them. If you think critically back on what we learned in the last section, you might recognize that what essentially we're going to be doing is adding the ingredients that the user is submitting through this form to an array, and then we'll be mapping over that array to display a list item for every item in the array. So with that in mind, I've set up a bit of a review challenge. I created an array of ingredients, and I want you to, as part of your challenge, map over this list of ingredients and then render them as list items. I've added a little unordered list. It's going to be completely unstyled, but you can render your array of list items right here. As a quick note, if you are already a little bit familiar with React, you will recognize that we're doing this in a weird way. I wanted to point that out now so nobody got confused as to why I was teaching it this way. By the end of this lesson, we're going to see the limitation we have. But for now, don't worry about that, and I'll hand it over to you to work on this review challenge. I will go ahead and create a new variable. Let's call it maybe ingredients list, maybe ingredients list items, just to be really explicit, and we'll set that equal to the array that comes back by calling ingredients.map. For each ingredient, which is just going to be a bare string, I will return, and I'm going to use a set of parentheses here so I can take advantage of the implicit return with arrow functions. I'm going to return a list item, and I can just put the ingredient directly inside there because it's just a string. For now, I am going to add my key because I know I'm going to get a warning, so I'll make sure to add the ingredient. Later, when we actually do this, we will figure out a way to make sure that ingredients are unique in our array. Okay, so I'll take my ingredients list items and render them right here like it told me to do. Let's hit save, and awesome. Our ingredients are showing up. Let's clean this up. Well, we just learned about event listeners, so I have another challenge for you. I'm throwing a little bit of a curveball here because in the last lesson, we only really practiced with mouse events, the onMouseOver and the onClick events. But between me giving you the exact event handler name and exactly where to put it on the form, I think you'll be able to figure this one out. So your task is to add an onSubmit to the form element and have the function, which you can define right here, simply console log form submitted for now. All right, let's get cracking. I'll go ahead and create the function first. We'll call it the handle submit function. It's going to console log form submitted, and I can add the onSubmit handler to my form, and we'll set it equal to handle submit. This is tangential, but you might be asking, why are we doing a handle submit on the form instead of a handle click on the button? I'd say there's at least a couple reasons. Primarily, it feels more semantic. We're submitting a form, we've created an actual form element, and clicking the button will submit the form. So what we should be doing is handling the submission of the form. Maybe more importantly, if a user hits enter in the input, well, that's not going to trigger a button click event. However, it will trigger a form on submit event. And so for free, we essentially get the capability to type into the input and hit return or enter without having to handle a separate event on the input. We haven't really done anything to handle the text that's in here, so it doesn't matter what's there. I'll go ahead and click, well, I have to save first. I'll type in here, I'll click add ingredient, and awesome, we get form submitted. We also can type in here and hit enter. And sure enough, we get form submitted. Now, later on in this section, we are going to do a much deeper dive on forms. So there's going to be a couple things that I add to my handle submit. I'll explain them briefly, but especially if you're not familiar with how forms natively work on the web, I'm really not expecting you to memorize this stuff right now. For now, let's start by cleaning up this challenge text to buy ourselves some room. And the first thing that I actually forgot to put on my input is a name property. Whenever we're submitting a form, our inputs all need to have a name. We'll see why in just a second, but I'm going to call this ingredient. Secondly, when I submitted my form, you might have noticed that the form actually refreshed the page. And now that we have a name on our input, we can actually see a URL change. If I were to say, I don't know, cumin, I'll hit enter, and sure enough, the page refreshed. And if you look up in the little mini browser URL, you'll see that it says $ingredient equals cumin. This has to do with the way that forms natively submit on the web. However, in our modern framework of React, we actually don't currently want this page to do a full refresh. And so I can prevent that from happening by grabbing the event that is passed to my handle submit function and calling event.prevent default. Let me hit save and put this back to just a slash. We'll go ahead and I can just say testing and hit enter. And awesome, our form didn't refresh, our URL didn't change, and we did get our form submitted running. Awesome. Okay, in order for us to do the next challenge, which is hopefully going to drive home the point that I'm trying to make in this lesson, I'm going to do a little bit of hand-waving coding. Again, if you're not familiar with this and it doesn't make sense, it's completely okay. Please don't be too concerned about it. My goal is to have you do a challenge where you take the ingredient that was typed into the input and try to add it to the ingredients list. In order to grab the ingredient that was entered into the input, I need to grab the form data that was submitted with the form that was submitted. In order to grab the text of the ingredient that the user put into the input box and submitted with the form, I need to grab that through form data. I can grab that form data on the form itself, and I can access the form DOM element itself through the event that was run when the handle submit function runs. So I can get the form data by creating a new instance of form data and passing the event.currentTarget. Then I can get the ingredient, so let's call it the new ingredient, by calling formData.get and then passing in the name, which is ingredient. This is the name of the input from my form. Let's go ahead and just console log new ingredient. We'll hit save. I'll type testing, hit enter, and check it out. We got our form submitted, of course. We can actually probably get rid of that console log. And we got our new ingredient, which is testing. That's pretty boring. Let's add, I don't know, what's a more exciting ingredient? Let's say jalapenos. Oh, come on, we can get an NEA in there. Let's do that. Perfect. Okay, jalapenos. Again, this wasn't intended to be something that we actually learned in this lesson, so I went through it really quickly. Please don't be too concerned about it, but do be concerned with your upcoming challenge. Okay, this is the challenge that is really going to drive home the message that I'm trying to get to in this lesson. We have access to our new ingredient. Instead of console logging it, I want you to add it to our array of ingredients. After you've done that, I want you to add a console log of your ingredients, because, spoiler alert, what we might be hoping would happen, which is to have the page update with the new item that they added, it's not going to work. Now, this hint says that it's a one-liner solution, so don't overthink it. I guess technically it's 2 lines because I'm also asking you to console log the ingredients. Okay, let's get your hands on the keyboard again and work on this challenge. Okay, so inside of our handle submit, we might be thinking, well, I can just push to the ingredients array the new ingredient. We'll go ahead and, as asked, console log the ingredients array, and let's hit save. We'll put in our jalapenos, add ingredient. Let's look at what we got. And sure enough, it got added to the list. However, and maybe this was a really, really roundabout way to make this point, we clearly have not updated our page. In a more imperative system, like if we were not using React and just building this site with regular JavaScript accessing the DOM properties, we commonly would find ourselves pushing a new ingredient to the list of ingredients, and then either manually adding a new DOM element to our unordered list, or running some kind of function that does this operation, maps over the new updated ingredients list, and pushes all of those elements to the DOM. However, with the declarative nature of React, we don't want to have to do that. We want to be able to just update our data, or the list of ingredients, and have React recognize that change and reflect it on the page for us. So that's the ultimate goal. I know this was kind of long, but trust me, what we're about to learn is maybe the most important feature that you will learn as a beginner in React. So again, this was a very roundabout way to get to this point, but what we're about to learn, which is the concept of React state, is the key to making all of this work for us. State is one of the most important things that you will learn about React. And so I'm using that fact to justify all of the hoops that I had you jump through in this lesson. So get excited. We are finally about to jump into state and learn how we can harness a major part of the power that React brings to web development. Over my years of teaching React, I found that one of the major confusions stems from not understanding fully the difference between props, which we have talked about in the last section, and state, which we are just now learning about. So I want to spend a little bit of extra time understanding the differences between props and state, and we'll start the comparison by talking first about props. In React, when we talk about props, we're referring to the properties that are being passed down into a component in order for that component to work correctly, similar to how a function receives parameters from above. Another way you could word it is by saying that properties not only are being passed down into a component in order for it to work correctly, but almost in a sense in order to configure that component to work in the way that you want it to work or to display what you want it to display. An important point when it comes to props, and something that distinguishes it from state, is that a component that receives props is not allowed to modify those props. Using a more technical term, props are immutable or unchangeable. And when we stop to think about it, this makes a lot of sense. For example, if we have our classic add two numbers function, we came to the conclusion that this function really is only useful to us if we're able to accept some parameters like numbers a and b. This is exactly what we're doing when we pass props down from above. Including parameters here, of course, makes it a much more flexible function that can do a lot more than just adding two hard-coded numbers, like if we were to say return 1 plus 2. Instead, as we've talked about a number of times, of course, I would use my parameters instead to make this function a lot more flexible to use with any number that I might want. This is the function definition, but the real values are being passed down when I call add two numbers. This is where I might put my 1 and 2 in. And let's just go ahead and console log the results here. And of course, this is going to return to us 3. However, we need to think of these values as immutable, especially when it comes to props in React. Because as you would expect, it would be pretty strange for me as the first line of my function here to say, actually, the value that you gave me for a doesn't matter at all. I'm going to set that equal to something completely different. And then naturally, that's going to really mess up our function. The person using our function, add two numbers, is going to expect the result to be 3, but instead they're going to receive a 44, which makes absolutely no sense. So just to be clear, don't do this, because the parameters coming in should be immutable. Similarly, in React, I wouldn't want to have a function, let's say it's our navbar, that receives props, and then to have any part of the body of my component say, well, I know you gave me a props dot, let's say logo icon, but then we say, I don't really care what you gave me, so I'm going to set this equal to some other icon.png. This would be pretty confusing if we're expecting to receive a prop called logo icon, and when we use this navbar, we create an instance of it and we pass down a prop called logo icon, and we set it to, I don't know, I'm kind of stretching here, let's say spatula.png. Doing this, we're trying to configure our navbar so that it will use this specific logo icon, but the contents of our navbar component are saying, I don't care what you had, I'm going to set it equal to what I want it to be equal to. So just like above, don't do this. To be clear, this doesn't mean that whatever component is rendering your navbar couldn't have a value that changes. Like if you had a button on your site where the user could click it and it would change the logo in the navbar. I'm reaching a little bit with this example, but that would be completely okay. Changing the value that we're passing down to our navbar is a very normal thing in React. In the same way that when we're calling add2numbers, I might be able to click a button and change the numbers that are being passed into this function. But specifically, the props that are coming in, or in this case, the parameters that are coming in, should not be changed in the body of the component. Okay, I think I might be beating a dead horse here, so let's move on, and now we'll talk about how state is different from props in that state is intended to change. So that's what we'll be covering next. If props are referring to the information that's being passed into a component for it to work correctly, or as we mentioned, to configure it, and if props are not meant to be changed from within the component that's receiving it, state, on the other hand, refers to any values that are managed by the component itself, kind of similar to any variables that are declared inside of a function. I say kind of similar because there is a difference, and we're going to talk about that in just a second, but it's important to note that anytime you have a changing value inside of your component that needs to be saved between renders, and more often than not, displayed or used as logic to figure out what needs to be displayed, you'll be using something called state within React. So even if the quick description that I gave here doesn't fully make sense to you, that's okay. I bet at the end of this section, if you were to come back to this lesson, it would suddenly start to make sense for you. There's a phrase that you might come across when it comes to understanding state in React, and that is that the view, or rather the user interface, the actual page that you get to see as a user, is a function of the state of your component. And there are three main points to consider here. First of all is this term called render. I've said it a couple times up until now, but you can think of the term render as simply running the function. Remember, all of our React components are simply functions, and we have to return some sort of JSX or user interface from that component. Well, when React runs into an instance of our component, in other words, if it sees something like this that looks like an HTML element, it's going to run our, in this case, app function. And that app function might create some functions within its body, it might set a couple variables, and usually, in the end, it will return some kind of view. Once React has run this app function, it's only going to run it again if either the props that it's receiving change somehow. Imagine if we were passing in a dark mode prop to our app component, and maybe it starts out as true, and then a user clicks a little toggle that switches it from dark mode to light mode, and then this would change to false. If that prop value changes, then React is going to rerun our app function, or in other words, it's going to re-render this app component. So that's one time that React will re-render or rerun that function, is if the props that it's receiving do change from above, or it will also re-render if internally it has a state value that changes. Now, a state value is different than just a random variable that you declare within the body of your function. You might remember when we had our favorite things list, we had just declared an array of strings, and changing that array did not update the view. And that's because that array was not being saved as a state value. It was simply saved as a variable within the component. And don't be confused, we really haven't talked much about the syntax behind how to create state yet, so we are going to get there, I promise. A second key point is that changing a local non-state variable does not cause React to re-render the component. I guess I kind of hinted at that at the end of point number 1. However, if you use a React-provided setState function in order to change a state value, not just a local non-state value, but an actual state value, calling that setState function will update the view. It will rerun the code in the function of your component. So that logically leads us to point number 3, where the view, or what the user sees, is simply a function of the state from within your application. If state changes, then React needs to rerun or re-render your component so that something new gets returned and replaces whatever used to be on the page. So you can see that this concept of state is really powerful in React. If we update our state, then React will automatically react to that updated state and it will display a new view. It might not be super apparent on its face, but this is a really awesome thing as a web developer because it means that we don't need to imperatively update the view ourselves. All we need to do is make sure that the state of our application, or you could kind of think of it as the data of our application, is as up to date as we want it to be. And as long as we do that, then React will handle the rest. It will update the view for us. It will change whatever parts of the DOM need to change as a reaction to the change in state. And we don't have to do any of that manual DOM manipulation, at least for the most part. A really simple, maybe overly simple analogy is of a light switch and a light bulb. A light switch represents the state of the, electricity in your room. If the light switch is turned off, there's no electricity running to its associated light bulb, and therefore the view is, a dark room, a light bulb that's off. If you change the state of the light switch by flipping the switch on, then the view will automatically update. In other words, the light bulb will turn on and the room will be illuminated. I think this is about as far as I can go with just explaining it. And so in the next scrim, we're going to dive right into the actual syntax. And I promise if what we covered here didn't make perfect sense, it's going to clear up as we get to see the syntax of it, see how it affects React, see how it's used within the React ecosystem, how changing state updates the view. All of that's going to make a lot more sense when we get to get our hands on the code and actually practice it. So let's jump right in. We saw in an earlier lesson that it's not going to work for us to simply create new variables here. Like let's say we have a variable that we're calling state and we set it equal to the string yes. We can use this variable to display what gets shown here. So I'll just put state in its place and we'll see that we do get the value yes. And to be totally clear, if this were changeable and then right below it, I were to set it equal to something else like heck yes, this actually probably isn't going to look very good in there. This is technically okay. I'm not sure why I would do this, but I can hit save and we get heck yes. I don't want to say no because of course state is important to know. The problem comes when, as a response to a user interaction, I try to change the state. For example, if I were to add an onClick inside of my button, and maybe I have a function called handleClick, and all that did was change the state. Actually, let's have clicking the button change it to heck yes, like this. And we put handleClick down in our onClick. Let's hit save, and watch what happens. I'm going to click yes, and check it out. Nothing happens. This is exactly what we saw with our array of favorite things. Simply changing a local variable is not going to make React rerun our component. Or in other words, it's not going to make React react to the change of state and display the updated value that it has. Instead, we have to use a function that's provided by React to save these variables in an actual state as far as React is concerned. This is just a local variable, no matter what we decide to call it. To set up a variable that React will place in the view and re-render whenever that state changes, we need to pull in that function from React. A very common way that you'll see this is to import a destructured useState hook from the React library. In fact, I would bet that as you're looking at React code out in the wild, this is probably going to be how you'll see it the most often. However, just to be totally clear that this useState function is coming from the React library, I'm going to import the entire React library. This is a little less performant when it comes to tree shaking and not pulling in all the stuff that you don't need, although with modern build tools that doesn't matter, but if that makes no sense, don't worry about what I just said. But I just want to be clear, I'm going to be importing React and then using React.useState in order to access that function. And actually, let me clean up some of this extra stuff. We'll be adding some of it back, but for now, this will just clear up any confusion. Let's change this because we don't have state anymore. We'll change this back to a hard-coded yes. And okay, let's be curious and we'll save the result that comes back from calling React.useState, and let's just log it to the console. Okay, interesting. What we get back is an array where the first value is undefined and the second value, well, Scrimba displays it as f parentheses, but it simply means that it's a function. Let's see what happens if when I call useState, I provide a value. Let's put a string hello and hit save. Okay, interesting. We get an array back, but this time instead of undefined for the first value, we get the string hello. When we pass in a value when we're calling React.useState, it provides an initial state. So if we know that our component needs to start with the state with a certain value, then we can pass it in here. Great. Well, before we talk about the second value, the function that's being returned in our result, I'm going to give you a challenge. Okay, this challenge will require you to do some critical thinking. Your task is to replace our hard-coded yes right here with some state that you initiate inside of React.useState. And we don't want it to say hello, we want it to say yes. So go ahead and get started on this challenge. The first thing we need to do is not say hello, we'll go ahead and say yes. And secondly, instead of hard-coding yes here, we want to use curly braces so we can evaluate some JavaScript. And then currently we're saving this array that we get back from useState as this variable result. So we'll go ahead and say result, but we only care about the first item of the result array, so index 0. Quick aside for people who are already familiar with useState, yes, we're going to be changing how we're doing this. We pretty much never index into the array that gets back from useState, so don't worry too much about that. Let's clean up the challenge text because I'm confident this is going to work. And sure enough, we get our value yes, that is now a state value as opposed to a local variable value. We can test really quick that this is working, so if I change this to heck yes, and hit save, sure enough, our state is correctly displaying there, and awesome. Okay, well, there's a couple of problems we have, because first of all, changing the code like this in order to change the state isn't viable. It's not something the user can do. And also, this way of doing this is kind of clunky, so as I mentioned, we're going to learn a better way to reference our state and give power to the user so that when they interact with the page, they can update the state and therefore change what's in the view. So that's what's coming up next. When we call React.useState, we're receiving an array in return. And as we mentioned, it's a bit clunky to access the index of 0 of that array. So what we do more often is leverage array destructuring in JavaScript in order to get back what we actually need, in order to give more meaningful names to what gets returned from our useState call. So let me go ahead and destructure this by putting a set of square brackets around it. And since we know that the resultant array has 2 items, I'm going to put a second item here. Let's just call it func for now, because we know that it's a function that we're getting returned. Now that I'm destructuring this array, result is no longer an array, which means that I don't need to index into that array in order to get the value. I can simply call result. If you're feeling a bit lost when it comes to array destructuring, I would highly recommend taking a pause and doing a quick ChatGPT or Google search about array destructuring to see if you can better grasp what's going on. One thing that's nice about this being an array that we're receiving in return is that we can call this value whatever we want. And as long as I update my code to say whatever we want, it's going to work just fine. If what was getting returned by React.useState was an object instead, we wouldn't have the same flexibility. We would have to use our curly braces instead of our square brackets because it's coming back as an object, and then we would be forced to use whatever properties that object had when we're destructuring it. So having an array is really useful in that case because we want to give this a name that is more indicative of the state that we're trying to save. So maybe let's call it something like isImportant. And once again, we'll make sure that we update that in everywhere it exists. Of course, hitting save gives us the same result. Next, let's go ahead and tackle understanding what this function is and how it will play an important role in using state inside of our React components. We've seen a couple times already how we can't just set up a value like important, set it equal to yes, and then have some kind of user interaction like a button click that changes the value manually of important to something else. While it will change the value in memory, it's not telling React in any way to re-render the page. And in fact, this is even true of values that we save in state. Let's change this to a let so that we can manually change it to something different. We'll say isImportant equals heck yes. And if I hit refresh, it will show heck yes here, but it would never react to, for example, a button click if we wanted the user to be able to click a button on the page in order to update that state. I'm not going to go down that rabbit hole, just take my word for it. I can hit refresh and see it says heck yes, but adding an onClick to try and change that will not update the screen just like we saw it before when we weren't even using state. However, the function that we get passed from React.useState, if we call this function and provide a new value, it will re-render the page. It will successfully update state and trigger React to re-render the page with the new state displayed. Let me hit save so that we don't have heck yes there anymore. And let's talk about the conventions for this function name, because just like isImportant, we get to choose what we call this function. And there's a really strong convention where we start the function name with the word set, as in we're setting a new value, and then you continue the name from the state variable itself. So it would be isImportant and set isImportant. I'm going to fix my I here so that it is capitalized just to make sure my camel casing is correct. And in order to use this function, I can simply call set isImportant and provide the new value that I want. And I guess it's already yes, this will be heck yes. However, I'm not going to hit save, and let me tell you why. We talked about how running this function will update the state to the new value, and it will have React re-render our component. Re-rendering our component essentially just means it's going to run the code inside of our function. So I'm going to put a pause here to give you a chance to see if you can think through what would happen if I were to hit save and React were to render this component. Hopefully some of you actually took a chance to hit save and see what would happen. I'm going to hit save and we can see that we get an error that says too many re-renders. React limits the number of renders to prevent an infinite loop. Why do you think an infinite loop happened? Well, remember, when we call this function, React is going to update the state and re-render. Re-rendering means rerunning this code. Rerunning this code means calling this function, which then updates the state and re-renders, which updates the state and re-renders, and on and on and on. So let me comment this out, and we'll get our state app back into a working state. And now I'm going to provide a challenge for you. Okay, this challenge comes in two parts. First, I want you to create a function called handleClick that runs set isImportant, and let's just give it the value of definitely for now. And then you'll add an event listener to the button so that it runs handleClick whenever the button is clicked. Go ahead and get started on this challenge. Okay, let's go ahead and create our function called handleClick. It's going to call the function that we were returned from useState, this state setting function, sometimes referred to as a setState function. We'll go ahead and call set isImportant. And because I definitely don't want to put no here because state is very important to know, so we'll say definitely. Then down on my button, we'll give it an onClick event handler that calls handleClick, clear up our challenge text, and we'll hit save, and let's see what happens. I'll click this, and the styling is not really working out for us, but we can see that the state changed. Maybe let's go back to heck yes. Click, heck yes. And at this point, we've hit a bit of a dead end. We were successfully able to call the state setter function that we got back, which we chose to call set isImportant. And in its simplest form, we were able to just provide a new value for state so that when the user clicks the button, it changes to that new value of state, re-renders, and displays the new value of state on the page. However, we're stuck because we can't get out of heck yes. If the user keeps clicking the button, obviously we have nothing else to change to. We've manually set it equal to the string heck yes. However, just because we're temporarily at a dead end doesn't mean we can't learning. So in the next lesson, we're going to get our hands on the keyboard a lot and do a series of challenges to try and help us reinforce the idea of state and setting state. You know, this whole section is all about state, and I think it might be useful for us to have a little app where you count how many times I'm going to say the word state in this entire section. But we do have an app that's a little bit more dynamic than what we were just seeing. And so this will be a good way for us to, step by step, practice setting up our state and practice including some event listeners where the user can change that state. So the first part of your challenge is to create some new state that will track our count value, where the initial value will be the number 0. And don't forget to replace the hard-coded 0 that we currently have with the state that you create as the first part of this challenge. Okay, go ahead and get started with this. To create some new state, we will simply call React.useState. We'll set an initial value of 0, and what this returns is an array, so we'll go ahead and destructure that array immediately when we receive it. First, we'll receive our count, and I guess you could call this something like state count, but let's just keep it simple and call it count. And the second thing is the setter function that they provide to us so that we can change that state and trigger a re-render in React. By convention, I will use the same name as my state, but I'll start it with the word set. So I'll say set count. And lastly, I can use my new count variable right here. And I'll hit refresh. This won't change much for us because we still don't have any interactivity with our buttons. But if I do change the initial value, like setting it to 10, awesome. Okay, we can see 10 showing up there. Let's go back to 0 for our starter point. Okay, let's jump to the second part of this challenge. I want you to create a function that's called add that will run when the plus button is clicked, and for now it can just console log the string add or something like that. No need to worry about changing state quite yet. As a reminder, it's a pretty strong convention to create any functions that your component will need to run inside of your function, but above the return. So instead of coming outside of your function up here and creating a function called add, you would want to do that inside your function, probably below where you're creating state. So right here. Okay, take it away. Okay, let's add a function called, well, add. And for now, the body of it will just console log the text add. And then on our plus button, which is, let's see, not this one, that's the minus. This is our plus button right here. We'll go ahead and add an on click and set that equal to add. All right, let's hit save and clicking the plus. Good, should console log add. Perfect. Add, and minus, of course, does nothing quite yet. Okay, this brings us to the next challenge. Up until this point, we've touched a little bit on what you could do in order to update the count, although we haven't explicitly talked about how we could do something like this, where every time they click it, a different value gets displayed. In other words, in the past, we've done a thing where we said something like set count and then hard-coded the number 1 in there, or I think in the last example, we had changed the text to heck yes for it being important to learn state. But of course, that meant that every single time we click the button, it just kept resetting the state to the same value. So that brings us to this challenge where I want you to see if you can figure out a way so that when you click plus multiple times, it will continue to increment the number. So give it your best shot, see if you can figure out how to do this challenge. Okay, hopefully that challenge went okay. All I need to do is call set count, and then for the value that I pass in here, it turns out I do have access to what the current value is with count, and so I'll go ahead and put in count. But I don't want it to set to the current count, I want it to set to 1 above the current count, so I'll say count plus 1. Let's hit save, we can hit plus, and awesome, this is working. Now, I do want to address a common misconception with beginners in React, and that is those of you that tried to do count plus plus. First of all, if we try to run this, we'll see that when I click plus, we get an error that says you can't assign to a constant variable. So you might have gone up here and said, well, let's change it to let. And I'll hit save. And look at this. I get some pretty funny behavior. I'm clicking it 2 times, and only after clicking it 2 times will it actually increment. Let's see what happens if we were to put the plus plus before the count. In case you're not familiar with that trick, it simply increments 1 to count before returning it, and so the value becomes the new incremented version. So let's hit save, and okay, technically this is working, but I don't want you to get too used to this, because this is a big no-no in React. Remember, doing count plus plus is the same as doing count equals count plus 1. And in React, whenever you want to change state, you will never, ever, ever change it directly in the way that we're doing here, where you say, here's my state variable, set it equal to something different. It's a big no-no in React, so try to remember that if you are ever modifying the value directly, then you're doing it wrong. On the contrary, saying count plus 1, it's not directly modifying count, it's simply providing the new value that we want our count to have to set count, which will then update state, re-render the component, and display everything correctly. Let me go ahead and change this back to a const. In fact, that should have been our first red flag when it was warning us that we were trying to change a constant. Hit save, and we're back to the way we were before, but at least now we're doing it the correct way. Okay, that brings us to the last challenge. Your challenge is to add functionality to the minus button. Of course, the functionality that it should add is to decrease the count by 1. Give this one your best shot. I'm doing essentially what I had in the add function, so I'm just going to duplicate my logic there. We'll change this to maybe subtract. I'll change this to -1, and then we will add an onClick. Actually, let me just copy this whole thing. We'll add that directly to our minus button and change this to the subtract function. Hit save, and awesome, we're going up and down. Perfect. Awesome work. It's great to get our hands on the keyboard and be practicing this. We had a lot of practice in this one. If you need, it's completely okay to go back and redo all of these practices from scratch. If you really want to add a little extra challenge, this would be a great time to come through and just delete all of the code that we've written regarding state and see if you can create it again from scratch. I won't leave you in a broken state like this, so I'll put it back, but just remember that you're here to learn, and learning comes through lots of practice. Once you're ready, we're going to move forward and see another way that we can use our state setter function. The way we have our code structured right now, it's technically working just fine. I can hit plus, it's incrementing. I can hit minus, it's decrementing. And the way we're doing this is by calling our state setter function, which we're calling setCount, and providing a new value for the state that we want it to have. Once we call setCount, it will change the state to the new version that we provide, and it will re-render with count now being that new version that we provided. However, there is another way we can use our state setter function, setCount in this case, where instead of providing the new value, we provide a callback function. In the body of this callback function, we need to return the new value that we want state to be on the next render of this component. If I were to essentially recreate exactly what I had before, I would just return count +1, which is basically no different than what I had. And we can hit save and see this is working as we might expect. However, the difference comes in the fact that this callback function is going to be passed the old value of the state before your setCount function ran. And so what I can do is take this old value, and instead of using count, which is my state variable, I can use the temporary version, which is old value, in place of what used to be count. I'll hit save, and we'll see this is also working. Now, instead of old value, I like to use prev and then the name of my state variable, so prev count in this case. This is a fairly common convention that I have seen quite a bit in the code, and it's one that I try to adhere to. I think it's a little bit more clear what state value we're dealing with. And at first glance, it might look like this is just a ton of extra work. But if I take advantage of the more terse syntax of arrow functions, I can simply say prev count, and then an arrow to return prev count +1. And in the end, it's not terribly different than what we had before. So why exactly are we doing this? Let me actually type this out as a written note for those of you that are maybe more visual learners. It'll give you something to refer back to and read through as we talk about it together. So a general rule of thumb is that if you ever need the old value of your state in order to help you determine what the new value of state should be after calling your setState function, or in our case we're calling it setCount, then it's a good idea to pass a callback function to your state setter function instead of using the state value directly like we're doing down here still. The callback function that you pass to it will receive the old value of state as its parameter, which allows you to then determine the new value of your state. This is going to seem a little bit crazy. Let me bring this back down to 0. Let's hit save. And I'm going to show you a difference that doing this makes, even though honestly it's not something you're likely going to run into very often. Let's go ahead and duplicate this line 3 times, and I'm going to duplicate the old version that we have down here 3 times as well. I'll hit save, and I want you to think, what do you expect will happen if I call the add function, or rather if I click the plus button, which then calls the add function, and when I hit the minus button, which calls the subtract function? Well, you would think that it would increment it 3 times if we hit the plus button, and check it out. It does. We immediately go up to 3. However, if I hit the subtract button, we only go down 1 time. All 3 of these set counts get batched together. The reason and specifics as to why are a bit outside the scope of this course, but this is a admittedly overly simplistic example of how using a callback function, if you need access to the old value of state to determine the new value of state, helps behave kind of the way that you might expect, whereas using the state value directly doesn't. Now, I don't want this to be anything that hangs anybody up. Let's go ahead and get rid of this. I simply wanted to show that there is a slight difference in the way that React handles the two. But again, for a majority of the time, you won't notice the difference, but this is a good rule of thumb to stick by, and it's the internal rule I'm going to use for myself as we continue through this course. Okay, that was a lot of talking. Let's do a challenge. Simply enough, your challenge is to update the subtract function so that it uses a callback function instead of using the state directly to determine the new state. Go ahead and give this a shot. We took a kind of roundabout way to arrive at what we have currently for our add function, but we can see that if I simply say prev count, arrow, prev count -1, we really only had a few extra characters to type, and now we have adhered to a little bit of a better practice anytime we're setting state that relies on the old value of state. I'm going to clean up this challenge text, but I'll leave this note here for anybody who wants some additional reading. And again, this would be a great time if you really want to challenge yourself to just come through and delete everything and see if you can recreate it from scratch. And I really mean that that's something you should do. It's not just me saying that would be nice if you did it. I mean, you should do this. Again, you're here to learn this stuff deeply, not just to passively watch me teach you about it and kind of think to yourself, yeah, I think I get it. Prove to yourself that you get it by doing it. It's not just going to give you those warm fuzzies when you actually complete it and everything's working. It's also going to strengthen you as a developer in React. And frankly, assuming you plan to look for a job, it's going to make you a more viable job candidate. There's so many benefits to getting your hands on the keyboard and practicing. It would just be a tragedy if you skipped through all of these practices instead of doing them, and finding ways to challenge yourself outside of the challenges that I give you. All right, stepping off my soapbox again. I think we have thoroughly covered the concept of state, so it feels like it's time for a little quiz. Okay, it's time for another quiz. As always, I'm going to insert a pause here. I want you to click in and actually type down your answers to these questions. Taking quizzes like this is scientifically proven to improve your ability to retain this information and recall it at a later time. So don't skip answering these questions. Okay, I'll hand it over to you. All right, number 1, you have 2 options for what you can pass into a state setter function like the setCount function that we had in our counter app. So what are those 2 different options? Well, for one, we can simply pass the new version of state that we want to replace the old version of state. This works great for any kind of state where we don't care what the old version of state used to be. We simply want to set it to some new value that has nothing to do with the old value. Later in the section, we'll be talking a bit about forms, and we're going to see where we make use of that. There's also lots of other applications for this first way of updating state. The second way is to pass a callback function to our setState function. This callback function needs to return what we want the new value of state to be, and this callback function is going to receive the old version of state as a parameter. And the purpose of that parameter is to then help us determine what the new value of state should be. Okay, numbers 2 and 3, I think we kind of touched on these already, but when would you want to pass the first option from the answer above? In other words, simply passing the new version of state that we want it to become. And this would happen anytime we don't care what the previous value was. We simply want to set a new value. And naturally and conversely, number 3, when would we pass the second option? It's the exact opposite. It's whenever we do care about the previous value of state, and we need it in order to help us determine what the new value of state should be. Okay, hopefully that was pretty straightforward. If not, that's okay. Maybe go back through this quiz again and see if the repetition will help out. Once you feel good about this, let's keep moving forward. At this point, it's going to be really helpful for us to review the ternary operator in JavaScript. If you feel like you've already got a good handle on it, then this challenge should come pretty easily to you. If not, then I'd recommend going over to the MDN docs on the conditional operator, also known as the ternary. You can click the screenshot here to go directly to the documentation on that. We'll be using it in this pretty simplified example. This makes a slight tweak to our app from before. Now it asks if we feel like going out tonight. We're not using any kind of state here. We're not handling the click of the button to change that state or anything like that. We're simply practicing the ternary here. So your challenge is to replace the if-else that's right here with using a ternary right here on line 8 instead. We have a variable called isGoingOut, and we have a variable called answer, which will contain the text. If isGoingOut is true, then the answer will be yes. If it's false, then the answer will be no. It's being displayed down here in the center of the button. Again, don't worry about clicking the button to change the answer or anything like that. You'll simply include your ternary here, hit save, and it should show the correct answer there. And then of course you can test it by changing this to false to make sure that your code is working. Okay, it's your turn. If you're not as familiar with the ternary, that's okay. We can see that the syntax actually consists of two different parts. One is a question mark, and the other is a colon. And it's really just a simplified way to have an if-else statement in a single line. So what I can do is I can say I want answer to equal, and then first we're going to check if isGoingOut is true. So we'll say isGoingOut equals true. And if it is true, then what I want answer to equal is the string yes. So that's essentially my if. If this condition evaluates the true, then this is what should get returned. My else is going to be separated with a colon, and then I'll have my string no. Now you can actually nest ternaries multiple levels down as a way to replace an if, else if block. But I personally find that a little bit more difficult to understand and follow, so I tend to stick to a ternary if I simply have an if-else statement. But otherwise, it's totally fine to use an if-else if or a switch even. So let's go ahead and get rid of our old code here. We can see it's quite a bit simplified. First, let's make sure that everything is working. So I'll hit save, and sure enough, we get yes. If we change this to false, we get no. Okay. Now there is another way that I can simplify this just a little bit more. We know that isGoingOut is already a Boolean, and so I don't necessarily need to equate it to the Boolean true. I can simply say isGoingOut, and that's already going to be the Boolean that I need. So we hit save, we see no, we change false to true, and we see we get yes. And actually, because I'm not block scoped anymore with the curly braces of my if-else, I could change this to a const if I wanted. Now, in this case, I've set aside a separate variable just to figure out what the string should be, and then I'm rendering that variable down inside the return of my component. But there's another way to do this, and that is to simply move my ternary into my component itself, and it will figure it out on the fly. This should be a pretty straightforward challenge, but we'll go ahead and keep our fingers warm so that you can keep learning. Your challenge is to move the ternary directly inside of the JSX. Remember, once I go into my curly braces inside my JSX, I can run any JavaScript expression that returns a value that makes sense in this context. So go ahead and give this challenge a shot. Simply enough, I no longer need my answer variable. I'm just going to take this expression and put it right in place of answer. We'll go ahead and clean this up and the challenge text too. And awesome, this is quite a bit simpler than what it was before. This might seem a little bit out of place, but we're going to see in the next lesson why this is helpful for us. This challenge will be a collection of the past few things that we've been learning. We're going to make it so that our users can actually click the button and change the answer from yes to no or no to yes. So your challenge is first to initialize some state. For the isGoingOut, we'll initialize it as a Boolean. You can choose true or false, I guess, depending on what your mood is like right now. Then, and the language I'm using is a little bit vague, I want you to make it so that clicking the button will flip that Boolean value from true to false or false to true. And then right now I just have this back as a hard-coded yes. You're going to display yes if isGoingOut is true and no if it's false. Okay, I believe in you. Give this your best shot. First we need to initialize some state, so we'll need to import, and as a reminder, we could just import the useState function from React. This is a very common way that you'll see this done. As I mentioned before, I'm going to actually import the entire React library just so that I can use React.useState only for the purpose of keeping it clear that this is a function that comes from React. I'll initialize the value to true. Well, who am I kidding? I don't really feel like going out tonight. Let's set this as false. And what gets returned is an array, so we will destructure that array. When we save it in variables, we'll say isGoingOut, and then by convention, I'll start my setter function with the word set isGoingOut. Okay, awesome. And you know what? I think I'm actually going to skip to this last one. It's completely fine if you didn't do that, but I want to display this as either yes or no, depending on my value of isGoingOut. And to do that, I'm just going to do an inline ternary like we just did in the last lesson. So I'll say is going out question mark. In other words, if is going out is true, then I want it to display yes, but otherwise I want it to display no. Let's see if this is working. I had said false, so let's see if it changes to no, and perfect. Okay, let's see. Let's buy ourselves some room here. We got done with those parts of the challenge. Now we need to make it so that clicking the button actually flips that Boolean value. Similar to how we are just doing this inline expression, if we want to, we can add our onClick function handler directly inside of the curly braces that we have here. I'm going to start by doing this, and then I think we'll see in a second why my personal preference is to put these functions up above the return section of our component. So I can just do this as an inline arrow function. And when the button is clicked, I want it to call setIsGoingOut. And if you remember, we just learned how there's two different options I have when I'm calling my stateSetter function. I can either provide the new value that I want state to have, or I can provide a callback function. Now I want to synthesize the quiz that we recently took and give you a chance to think through this. Which of those two versions do we want to use in this case? Well, we can simply ask ourselves, do we need to know what the old value is in order to determine the new value? And in this case, yes, we need to know if it was false so that we can flip it to true, or if it was true so that we can flip it to false. And I guess it's kind of a mixed answer, because the truth is I have a way to just flip a Boolean to its opposite. So what I can do is say it's not is going out, and that should get the job done. In fact, let's test that out. We'll hit save, we have no, we click it, and it says yes, okay, it's working. So you know what, maybe this is a little bit of a gray area in that question of do we need the old value or not, because we do need the old value, and I can just access the old value, and this will work fine. Maybe for completeness sake, we'll also see what this looks like to use an inline function. And you know what, I can already see this is getting a little bit crazy. We have our inline click handler function, and that is calling setIsGoingOut, which is taking a function. And I don't know about you, but this is maybe one level too much of inception for me. I think it's going to be clearer to move this outside of our return. So let's create a function and call it something like changeMind. And we'll take what we have here. Let's see, how far do we need to go? All these curly braces and parentheses are also really confusing when it's inline like that. And okay, I missed one. We'll clear out everything in here except that outer set of curly braces and simply call changeMind. This puts my mind much more at ease than what we had before. Okay, so if I'm going to use the callback function version of my state setter, then I can get the prev state, and maybe just for brevity, we'll just call it prev, and I can just immediately return the opposite of prev. Hit save, and no, yes, no, yes, no. Awesome. Let's clean up this challenge text. And one last thing I want to do before we move on is address this button. First of all, I admit this is not a very good user experience with our silly little learning app here. It feels weird to click no and have that be the way to change the answer. So if you're designing a real website with a user interface, maybe don't choose a button that clicking it will flip it to its opposite value. But since that's where we are right now, one thing that will be really important for us is to address the accessibility of this button. I'm going to put some of these values on their own lines so that we can add an ARIA label. To anyone using assistive technologies like a screen reader, the purpose of this button is going to be pretty opaque, and so I'm going to include an ARIA label that will both clarify what the state of this button currently is and describe what will happen if you click it. So I can say something like, the current answer is, and then I'll just stuff in the yes or no value that we're determining right here. So actually I can just copy my ternary and put it right there. So that's what the current answer is, and I could say something like click to change it. Little additions like this make a huge difference for a number of people, so this is an important thing to keep in mind while we're developing our code. Frankly, I should have included this earlier or probably just changed our button to something like an H2. So this might be a little bit overdue. Glad that we're adding it in now. Okay, great job with these challenges. If you did find yourself struggling to complete that challenge, then this is one of those perfect opportunities to take a break, go back a couple lessons, review what we've learned, try to practice them again from scratch. And eventually you'll get to this point, you'll be able to do this challenge with no problems, and that's a great time to pat yourself on the back, go take a walk, get an ice cream, do something celebratory, because we've made some awesome progress here. Once you're ready, we'll keep moving forward. Up until now, the examples of state we've been using have used pretty primitive values like booleans or strings. But a very common thing that you'll find yourself doing is including more complex data like arrays and objects in your state variables. And it warrants a little extra attention to see how we can update more complex state like arrays and objects. So let's start with arrays. And hey, this looks familiar. This is the little app we were using when we first started learning how we can't just save the values we want to display on the screen in local variables like trying to do this. But instead, if we want those values to display on the screen and to update when we change those values, we need to use React State. So we'll get started with a quick challenge. I want you to convert the code below so that instead of using this myFavoriteThings array in a local variable, you should instead create some state and set that state as an initial value of an empty array. Don't worry right now about the addFavoriteThing function. We'll get to that soon. Go ahead and get started on this challenge. I'm going to save this variable name, so I'm actually going to destructure what will get returned from our array. We'll go ahead and also include our set myFavoriteThings. And instead of this being an empty array, we're going to use React.useState. And we'll put that empty array as the initial value. And then, of course, I need to import React because I'm not currently doing that. So we'll import React from React. Okay, I think hitting save should be fine. Of course, add item doesn't quite yet work. I can do a quick test of this by taking maybe a couple items from the all favorite things sort of database of favorite things there and just sticking them here inside of my use state. And sure enough, okay, hitting refresh shows raindrops on roses and whiskers on kittens. Perfect. I'm going to undo that just so we don't get duplicated items when we do start adding to the array. Okay, none of that was technically new, but the reason that I wanted to record this scrim is so that we can see how we can make updates to our array. Well, at first it can be tempting to simply say, well, I know how to add something to an array. I can say myFavoriteThings.push. However, there's a couple things wrong with this. First of all, even if we do try to put something in here like a test, we can see it's not actually working. And the reason is because simply modifying the state value directly doesn't also trigger a re-render in React. There's something special about the setter function that we receive when we're calling React.useState that does trigger a re-render in React. So I'm curious, if I were to maybe console log myFavoriteThings and try this out, we'll see that sure enough, it is adding those items to our array, but because we're not using the set myFavoriteThings function, it's not triggering a re-render. There's something else that's wrong with this though, besides the fact that it's just not updating what we see on the screen. And that is that it's a pretty hard and fast rule in React that you never ever want to directly modify state. Using something like .push, it's a destructive action to arrays. It modifies the original array. It doesn't just return a new array with that modification, it actually modifies the original one. And just like when we had a variable called count and we decided we never wanted to do count ++, even if it was inside a state setter function like setCount, we talked about how this is a replacement for count equals count +1. And saying count equals something different is just a bad idea in React. Similarly, using something like myFavoriteThingsArray.push is always a bad idea in React, assuming myFavoriteThing is a state variable. Okay, so to modify anything in state, as we know, we have to use the setter function that we receive, so we'll use setMyFavoriteThings. Okay, so I'm sure you remember we have two different options we have to decide between when it comes to using this state setter function. Do we want to provide just a bare new value, or do we want to provide a callback function? I'm actually going to put in a pause here so you have a chance to think through this. Which of those two options do we want to do in this case? We provide a new value if we don't care about the old value at all. We provide a callback function if we do care about what the previous value of state was, or in other words, if we need to use the previous value of state to help us determine the new value of state. And in this case, we want to start adding items from the all favorite things to our favorite things or myFavoriteThings array. And so we need to remember what was already in the list in order to not only determine which of the new items we want to add, but also so we will continue to display the old items as we add new items to our list. So we'll go ahead and include a callback function, and we'll just call the previous state maybe previous fav things or prev fav things. That's kind of a mouthful. We'll include our arrow, and now we need to think, how are we going to update this array without modifying the original one? Because I still wouldn't want to say prev_favethings.push, even though it kind of seems like I'm accessing a different array. This is a reference to our original favorite things array, or my favorite things array. So this is also not something we want to do, but in true functional programming fashion, the way that I can update the array in React is by providing a brand new array. And then I can use all of the items from the previous array, and then I can start this array out by taking all of the items using this spread operator from the previous favorite things array. And then I can add my, let's just put this in angle brackets so that you know this isn't the real syntax. I'll put in my new item here. What this does is it accesses the previous version of my favorite things array, and it returns a brand new array. So it's not going to be modifying the existing my favorite things array. It's returning a brand new array that includes all of the items that were previously there, plus the new item that I want to add. Just for test's sake, I'm going to just include the string test here. And we can see that this is working. Awesome. It's of course not interacting with the all favorite things array yet, but we're going to get there in just a second. However, because I did kind of just blow through this and didn't ask you to put any critical thought into this, surprise, I have another quick challenge for you. Okay, I cleaned up the old challenge text, moved it down here, and your challenge is, I shouldn't be doing this, you should be doing it. Every time the add item button is clicked, it should add another string test to the list on the page like we just saw it doing. See if you can remember what we did. Before you just scrub back and see how I did it, think critically. Spend at least 3 or 5 minutes trying to figure it out. See if you can remember what we did. Hopefully this is a good wake-up call for anyone who was maybe passively watching. Okay, I'll hand it over to you. Anytime we want to change state, we need to use our state setter function. So the first thing I'll do is call set my favorite things. I need access to my previous array, and so the safest way to do that is to use a callback function. I'll just stub out this empty inline arrow function now. This callback function is going to receive the previous state. Maybe we'll go ahead and call this prev_fav_things, even though again, that's quite a mouthful. And we'll use an implicit return here so we can get rid of our curly braces, and we are going to return a new array that includes all of the prev_fav_things and adds test to the list. Now don't be too confused, we're not yet using these emojis, so the first time I click add item, I'm starting with an empty array and then adding the string test. The second time I'm clicking add item, I'm starting with an array that has just the single string test in it, and I'm adding a second one, and then a third one, and so forth. Let's see how we're doing. We'll hit save, add item. Awesome, it's showing up. Of course, we have key issues because we're not having any repeated items here, but now we are having repeated items there. That's okay for now. Awesome work. This wasn't a super simple challenge, so hopefully it wasn't too frustrating. Kudos if you were able to write this without even looking back, but it's completely okay if you did have to go back and study again. Okay, let's clean up this text so we buy ourselves some room back, and I'm actually going to put this on its own lines just so that it's a little bit easier to read. And oh, looks like formatting bumped everything out. That's great, that's okay. Okay, so I'm actually going to do this part because it deals with indexing into this all favorite things array. Honestly, this is not really something you'll find yourself doing in React, so I don't want this to become a challenge. I'm going to use the prev_fav_things array to figure out what index in the all favorite things array I want to add the new item from. So when the prev_fav_things array has nothing in it, it's going to be the index of 0, which is the same index of the new item in all favorite things that we want to add. So I'm just going to say all favorite things at the index of prev_fav_things.length. Again, this is sort of where this example starts to break down because this is not something you'll find yourself doing super often. Because React is just a lot of JavaScript, this is kind of a fun challenge at the same time. Let's cross our fingers, hit save, and see what we have. We'll go ahead and add items, raindrops on roses, whiskers on kittens, bright copper kettles, and warm woolen mittens. Awesome. Please, Disney, don't sue me. Awesome work on these challenges. Updating an array in state is something you'll find yourself doing quite often in React, so this is a great thing for us to learn and a great thing for you to practice as much as you can. Next, we're going to take a look at how we can update another complex data type in state, which is objects. All right, finally, at long last, we're back here with our Chef Claude app, and now we're armed with the knowledge that we need to make this work. As you might remember where we left off, we just had this local array of ingredients, and we tried to do an ingredients.push to push the new ingredient onto that array, and of course we saw that it didn't update our view. Now we understand that React doesn't update the view when just little local variables like this change. Instead, we have to put these values in state. Then, as long as we use the state setter function that React gives to us, we can change the data and rely on React to update our view to reflect the new updated data to our users. So your challenge is to do exactly that. Update our app so that when the user enters a new ingredient and submits the form, it will add that new ingredient to our list. I added a note down here. Just like before, I don't want you yet to worry about what's going on in these two lines of data. Just take the new ingredient and be grateful that you don't have to know this. No, I'm totally kidding. We're going to cover this later. By the way, when you work on this, you don't have to begin the array with these 3 items. You can put whatever you want. It can be empty. You can add a couple just to make sure it's working, whatever you want. So go ahead and get started on this challenge. All right, let's go ahead and import React so that we can pull in state. And watch this trickery. I'm not even going to delete this line. I'm just going to refactor it to use state. So we'll say ingredients, set ingredients, and that's going to be equal to react.useState. And then we will wrap our array. And let me make this small for a second. I think I'm going to keep this empty, actually. Yeah, we'll just keep it empty for now. Okay, so it's being saved in state. I think I can hit refresh, and everything should still be working. Awesome. Of course, we lost our items because we removed them from the array. You might have noticed also that I did remove the ingredients.push line because, as we've learned, we do not want to directly modify any of our state variables. We always need to do it through calling the state setter function. So at the end of my handle submit right here, I'm going to call set ingredients, and I do need to know the previous list of ingredients so that I can use that list in my updated list. So we'll say previous ingredients, and this will be a function, and I can just return a new array that's going to include all of the previous ingredients, and it's going to stick the new ingredient right there at the end. So geez, in the end, we really just added one line of code and refactored this line of code. Let's clean up our challenge text. We'll hit save, and moment of truth. Let's say we have some chicken. Awesome, chicken ends up right there. Now, of course, our form is not emptying. We're going to address this a little bit later when we talk about forms. So for now, I just kind of have to annoyingly delete the old entry myself. Let's say we have some limes and maybe some salsa. Awesome. Great work on this challenge. Chef Claude and myself are really happy with your progress in this section so far. So we had a chance to apply what we just learned about updating arrays in state. Next, we're going to see what it takes to update a different complex object in state, which is objects. Now let's take a look at what it's like to save objects in state. We have an example of a little contact card here, and we're holding an object in state which represents the information for this particular contact. The first 4 properties are all pretty self-explanatory. They display the actual information, first name, last name, phone number, and email. This last one is favorite. We are going to ignore dealing with that for now, at least in this first challenge. But ultimately, it's going to determine whether this star is an empty star or a filled star. But before we get there, I want to give you a challenge where you're going to fill in the values that are currently being hard-coded. So we've got the name, phone number, and email. And instead use the values that are being saved in this object in state from that we're currently calling contact. So go ahead and get started on this challenge. Of these 4 properties, the trickiest one might have been the name because we're saving the first name and the last name under different properties. All I really need to do is do a set of curly braces, and we'll pull in the first name by doing contact.firstname. And then outside of the curly braces, I can do an actual space. Because we're outside the curly braces, this will represent an actual space in the text. And then I'll do another set and add my last name. The tricky thing about this challenge is I'll hit save and it will look like nothing changed, but now it's using the dynamic values from our state. Okay, then we'll go ahead and just do the same thing for our phone number, contact.phone, and our email address, which was contact.email. contact.email. Hit save, and awesome. Okay, now let's deal with the isFavorite property. And ultimately, our goal is so that we can click the star icon and it will flip the value in state from true to false or false to true. And following the declarative nature of React, it will also update the actual icon here from an empty star to a filled star, and vice versa. We're going to do that actually in two parts. So for the last challenge in this lesson, we'll be making it so that the icon of the star will represent whatever the current value of state is. So if this is false, it will be an empty star, and if it's true, it will be a filled star. Let me actually type that out as a challenge. Okay, so your challenge is to use a ternary so that you can determine which of the two star images, which we're importing by the way, so either this star filled value variable or this star empty variable, should be used based on the value of contact.isFavorite. For now, you can just test how things are working by manually flipping this to true. And of course, when you do that, it should update the star to be the filled in star. So your ternary will be here. I'm going to be a little bit vague on the rest that you should be working on because I think you'll be able to figure it out. So I'm going to pass it over to you to work on this challenge. Okay, let's put in our ternary here, and we are going to be looking at contact.isFavorite, and if it's a truthy value, in this case it will actually be the Boolean value of true or false, then we want it to be star filled. Because I have this set as a variable as I'm importing it, it should just work out as far as becoming my image source. And otherwise, I want it to be star empty. Let's clean up this challenge text. And lastly, I need to take this star icon and come down to my image source where it used to be hard-coded as star empty, and now we'll use whatever the value of star icon is. Let's hit save. And okay, we're empty. We are not yet set up to make this click actually flip the value there. We're going to be getting to that very soon. But for now, let's change this hard-coded value to true, hit save, and awesome, we have a filled star. Okay, well, while you were changing the star icon in our image source, you might have noticed that we have an alt attribute here, which has a hard-coded value saying empty star icon. We also have an accessibility property called aria pressed, which is defaulted to false. And actually, you know what, this button should also have an aria label associated with it because this button doesn't have any text that makes it obvious what clicking it will do. So staying in line with the assumption that everything is not favorited currently, this I guess would say something like add to favorites. However, we want all of these values, the aria pressed, the aria label, and the image alt to change all based on the current value of contact.isFavorite. So before we move on and learn how we can programmatically flip this by clicking the button, let's go ahead and do a challenge that updates those things as well. Okay, in this challenge, I've given you the tasks that you need to complete, but I'm not going to give you any starter code or any hints as to what to do, because I believe at this point you should be able to accomplish these things. Again, the reason that we're doing this extra work is so that we can really take advantage of React's declarative nature, where the state that we're maintaining up above is what determines the display and the functionality of some of these elements on the page. So give this one your best shot, and we'll come back and do it together afterward. Okay, I think the aria pressed is probably the easiest because it should track one for one with whatever the value of contact.isFavorite is. This button is going to be represented as a pressed button to assistive technologies if the contact is favorited, and that just kind of makes sense. With the aria label, I can either say add to favorites or remove from favorites. And we've seen an example where we're doing our ternary up here. I think I'm also going to show an example of just doing an inline ternary here. I'll use a set of curly braces instead of my quotation marks so that I can evaluate some JavaScript, and we'll take a look at contact.isFavorite. We'll put our question mark, and if it's truthy, we want this to say, let's see, if it's favorite, then we want it to say remove from favorites because it's already favorited. And otherwise, we'll say add to favorites. And then we can just do the exact same thing with our image alt. We'll surround this in a set of curly braces. We'll check contact.isFavorite. And if so, then we want it to say filled star icon. But otherwise, it should say empty star icon. Most of this functionality is stuff that just sits a little bit behind the scenes and is only really viewable if you're looking at the source code or if you're using assistive technology. So I think we might just have to assume that it's working, and we'll clean up this challenge text, and we're in a pretty good place. However, most of this has just been prepping for what we're actually here to learn, which is how we can update our state when what's being saved in state is an object. We're going to see in the next lesson why that might not be as simple as we think and how we can go about doing it. We've set up our markup so that it will react to the changes in state, and this is exactly what we want. The only thing we're missing is the user interactivity with this star icon. The goal is, of course, to be able to click the star icon and have it flip from true to false or false to true, and by having it flip, I mean the isFavorite property on our contact object. So down here in our toggle favorite, this is where I would probably want to use my set contact. And we have to think to ourselves, do I need to know the previous contact in order to determine what the new contact is? And the answer is yes, I need to know what the isFavorite property was so that I can flip it from its old value to the, well, opposite of its old value. So we'll go ahead and use a callback function in here, and we'll grab the previous contact, and we will return an object. And the contents of this object can be a little bit tricky, so that's why we have a dedicated lesson for this. It can be tempting to think that I'm changing the isFavorite property, so I'm going to return an object that has not the current isFavorite value, but looks at the opposite of previewContact.isFavorite. And there is a bug with the way that we've written it here. Before hitting save, and even before testing it out, I'm going to insert a pause here and give you a chance to see if you can figure out what the problem is with the way that we currently have it written. Remember, in my callback function for my state setter function, the goal is to return a replacement state. And in this case, my state is an object that has 5 properties: first name, last name, phone, email, and isFavorite. However, what I'm returning is not an object with 5 properties, but an object with only 1 property, which means, let me go ahead and hit save. When I click my star icon, all of the other information disappears. However, it does look like our star is working as we might expect. I can flip it back and forth. It's correctly pulling in the opposite of what it previously was, but of course our contact is now just an object with 1 property. The best way for me to make sure that I copy all of the old properties is to simply spread in everything from the previous contact. And then I will include a new version of isFavorite. If you're feeling a little bit rusty on the object spread syntax like we have here, it's essentially like taking the old version that we had up here and just copying and pasting it down. We'll indent this correctly. And what we're returning is a new object that has all of the properties from the old one: first name, last name, phone, email, and the old isFavorite. But then we're overriding that isFavorite property with the opposite of what it used to be. And believe it or not, this is not a syntax error in JavaScript. It will simply take the last one that's declared. If you have multiple instances of the same key in an object, it will just take the last one that's declared and use that value as the final value for the object. Now, we don't actually want this hard-coded because we don't at any given time know what these values are going to be. So we'll come back to using our spread syntax here. Let's hit save. We have all our information back because it's a fresh render of this component. And moment of truth, let's click the star, and awesome, it's flipping back and forth as we would expect. Perfect. Okay, well, I would be doing you a disservice if I didn't give you a chance to write this, so I do have a quick challenge for you. Your challenge is simply to rewrite what we just did. If you're not entirely sure how you should do this, then I would recommend, rather than just skipping the exercise altogether and watching me do it for you, scrub back in the lesson and get a refresher on how we did it, and then come back to this challenge and try it again for yourself. All right, it's your turn to shine. Take it away. We need to use our setContact function. We do care about the previous version of state, so we'll access previewContact and use an inline function here. Rather than opening my set of curly braces and saying return an object, I'm going to make use of the implicit return by using a set of parentheses and wrapping inside of that the object that I want to return. I'll pull in all of the previewContact properties and then switch the isFavorite to be the opposite of previewContact.isFavorite. I probably should default this to false. I think that's more logical for a new contact in a contact book, but we'll go ahead and check it out. It's working just great. Awesome work on this. We have learned quite a bit about state, how to set state, some complex data types in state, and how we can make modifications to those. And now we're ready to move on to the next topic, which is dealing with forms. Although our Chef Claude app has just about as simple of a form as you could possibly have, it's got the single input and a button to submit the text from that input, you'll find that creating forms of one type or another will be a really common task that you end up doing in your React applications. Whether it be something that's very clearly a form, like a sign up or a login page, or something that's maybe a little bit more subtle of a form, like when you favorite a tweet or upvote a post on Reddit, any kind of interaction with the data that exists in a database from your application will oftentimes be handled by submitting a form. And if you've been developing for the web for a long time, you'll know that forms have been around for a very long time. Here in our HTML file, we just have a regular form element. It's got a couple of labels that are associated with a couple of inputs, and then an input type submit, which is our button at the bottom. The form property has a method attribute that you can give to it. By default, this method is get, and submitting a form with a get request. Actually, let me get rid of my action and my method. The default method is get, and I'm going to comment out my script here. So I'll refresh this and type in my first name and last name, hit submit, and you'll see that, first of all, there was a full page refresh that happened. It cleared out our form, but it also tried to navigate us to a different location. If you look in the URL, it says /, which is my home page, but then it stuffed the information that I put into the form into a query string in the URL. So commonly in the early days of the web, we would include an action property that would specify some kind of server code, maybe a PHP file, for example. And let me just say this is a GET request so that it stays the same as it was. I'll comment this back out, and let's go back to our homepage here. I can fill out my information, and we're going to get an error because we don't have a PHP file, but we'll see we hit submit, and it attempts to go to /API/myservercode.php, and then it puts the information from the form into the query string after that point. This is where a PHP file would then take that information, do some sanitizing checks on it, submit it to the database or whatever it might be, process it somehow, and likely return another HTML page that the browser can then display on the page for the user. Fast forward a little bit, and JavaScript became a little bit more of a popular way to gather information from a form and send it to some kind of backend. So let me get rid of this action because we don't have a PHP file, and I'll leave my method there for now. I'm going to have to manually go back to my index page here. And now we can look at our JavaScript and see that we have set up an event listener for the submit event on my form. When that submit event happens, we're going to capture the event, which has a bunch of information about the event that we're listening for. And the first thing we do is prevent the default, which includes refreshing the page. So now that we have that, we can see I can put in my name and hit submit. And instead of the page refreshing and everything clearing out or attempting to go to a different URL, we intercepted that in JavaScript. We maybe did some processing of the data from the form somehow, submitted it to this fake API, which of course is just console logging the data and the text submitted. We can see in the console we did get an object that contains both the first name and last name. Well, what comes next in the history of web development is a little bit rocky. In fact, when I was recording a course about React Router, I included a whole lesson that I called Hot Take: Forms in React Are Bad. I'm not going to dive into how React used to deal with forms because, as you can tell, I really didn't like the way that it did it. It was cumbersome, it was a little difficult to teach, but after the last about 8 years of teaching React, I can confidently and happily say that now forms were bad. They are so much better now in React 19 than they ever have been. By the way, I do need to point out that we are currently in a scrim with a Google slide of a screenshot from a scrim that had a Google slide which included a screenshot from a scrim. I think this is about as deep of an inception we've ever had on Scrimba. So you are learning React in a golden age because you will not have to learn forms the way that I had to learn them and the way that I've had to teach them for nearly a decade now, because React has shifted to using the native capabilities of form. Over the next few lessons, we'll be talking a little bit more about what I mean by that. But in the meantime, if you'd like, you can click the screenshot here, which will take you to the React documentation on the built-in browser form component. And you can kind of dip your toes into what we're going to be learning with form. Again, the form that we're building with Chef Claude is very simplistic, but we are going to dive a bit deeper into forms than we need for this project, mostly to cover our bases. But trust me when I say it's going to be a much more pleasant experience than it ever has been in the past. React 19 has changed the game. It's truly amazing the improvements that they've made. Okay, without further ado, let's jump in and start learning about forms in React. The next few lessons are actually going to be kind of a hybrid review of forms that you should already be familiar with at this point, and how we deal with them in React. Honestly, because of how React 19 can now deal with forms, this is going to be a little bit closer tied to just a review of forms in HTML. So to get us started, let's just start building out this form. And actually, I was going to get rid of this H1. Let's go ahead and call this a sign up form. And I'm going to have more elements. Maybe I'll put everything here inside of a section. Okay, so to start out a form, we will always start with a form element, an HTML form element. We're going to discuss some of the attributes that we can add to our form, but for now, let's also get an input in here. Input is kind of a crazy component or element in HTML because it's very overloaded. In other words, there's a lot of different types of input, and depending on what type of input you use, what gets displayed in the form is drastically different from another type. For example, if we have a type of text, it's going to show up as a regular input box. If we were to instead do a type of radio, we get a little circle that you can click. And these are intended to have multiple different options. I'm a little bit torn how I feel about this. It feels like maybe they tried to get input to do too many things, but I'm certainly not an HTML expert, so there's probably a good reason for it. Okay, so type is one of the most important things that we're going to add to our inputs. I would say maybe the second most important thing is to give it a name attribute. The name attribute is how we're going to access the data that is input into this input box by the user. So after the form is submitted, we'll need to make sure we have a reasonable name so that we can access that data. Since this is going to be a sign-up form, let's go ahead and put email. That will be the name. And actually, if I'm going to make this email, there's a dedicated type of email that I can use for this input. I think what that does mostly on mobile devices, it will pop up a slightly different keyboard that has that little @ symbol that's really accessible, and maybe a couple other little things with the keyboard change. Either way, it's a good idea to put it there. Oh, I also think it might be helpful for password managers, although I'm not 100% sure on that. Either way, you should always strive to put the correct type for your inputs. So we'll go ahead and use email. Okay, we can hit refresh and see this input is very unclear what it should be doing. And it can be tempting to then say, well, I'm going to use the placeholder attribute to say this is going to be where the email goes. In fact, I think this is something you will very commonly see, but it's a habit that I'm going to try and weed out of you right now. A placeholder is not the correct tool to use as a label for your input. A placeholder instead can be a great place to put an example of what should be filled in, like let's say joe@schmo.com. But for accessibility reasons, it's much more difficult for screen readers, for example, to make any sense of an input. It won't read the placeholder text, and so it's going to be difficult for anyone using a screen reader to know what they're supposed to do with this input. I can get around that with an ARIA label, but whenever possible, we should just use a label element. This is where we can simply say email. And if we actually take our closing tag for the label element and put it on the other side of our input, in other words, wrapping our input as a child of the label, then this label will automatically get associated with this input. And we can tell that easily by clicking email and see that our cursor is then focused inside of the input box. The design here is awful, so don't judge me for that. We'll fix it up soon. I'll probably fix it up after this lesson, so you don't have to watch me doing more CSS with a form. But for now, this will get the trick done. While we're talking about labels, if you can't put your label around your input the way that we did there, but instead would prefer them to sit side by side as siblings, you can still do this, but we do have to take a couple extra things into consideration. First of all, we need to associate this label with this specific input, and we can do that with an HTML4 attribute. If you're familiar with regular HTML forms and HTML labels, you'll recognize this as the for attribute in regular HTML, But because we're dealing with DOM elements here, it's not the JavaScript label element doesn't have a for property, it has an HTML for property. And so in React, because we're dealing with JavaScript, we will use that property, HTML4. Its value needs to be the ID of the input that you want to use. So we'll give this an ID of email and say that this label is associated with the input with the ID of email. So I can hit save, and you'll see I click on email and my cursor gets focused inside the input as well. I personally prefer the look of this, even though it does require me to do a little bit of extra work. I think it also makes doing CSS for this just a little bit easier, but honestly, whichever way you choose is going to be completely fine. Okay, I feel like I've been talking for a really long time. This might be a silly challenge, but I think it's time to get your hands on the keyboard. Okay, this is pretty straightforward. I want you to add another label and another input for our password field. And because we haven't done any styling on here, I'm going to just manually add a break element and then leave some space here for you to do your work. Make sure you use the correct type when you're adding your password input, and don't forget to fill in the other attributes that are necessary too. Go ahead and get started on this challenge. All right, simply enough, and maybe I'm going to be a cheater for doing this. I'm going to copy all of these properties and we'll update the data. So we have HTML4, we'll call this password, and then set the ID to password for our input. This will say password. The type, there actually is a dedicated password type. This is the one that we'll put in the filled in dots instead of the actual characters, just to keep it a little more private. We'll give it a name of password, and the placeholder, I don't think we need a placeholder for password. Hit save, and sure enough, we get the password field working. This lesson is getting a little bit long. I'm going to touch on one more thing. We'll dive just a little bit deeper into some of the other input types that are available to us, but the last thing I want to talk about is the button element. The button element is a little bit unique, and it has a quirk that is important to remember. If you've been doing any kind of HTML for a long time, you might recognize that there is a different type of input called a type of submit. And as I mentioned, different types of inputs can dramatically change the way it's displayed on the screen. Well, input type submit is no different, because let me comment out this button, and I think I have to move this out. We'll hit save and check it out. It doesn't really look like an input, it looks like a button. And that's true. If I wanted to change the text on it, I would have to add another attribute called value. Well, the default is submit. Let's, I don't know, say click. Okay, we see that's working. But this is where our button comes in, because buttons, if they're placed inside of a form, they act like an input type submit. Or rather, buttons also have a type property, and by default outside of a form, the type is button. Inside of a form, the type is submit. So a button makes a lot more sense to me, and I'm just going to give it the text of submit. All right, we have a super basic form. I'm going to give this a little bit of love in the CSS, and I'll see you in the next lesson. There's a few interesting things happening to our form when we try to submit it. First of all, let me go ahead and type in an email. Let's just put in b@b.com and, I don't know, password 123. We saw this before, but if I hit enter or I press the submit button, I'll go ahead and hit enter this time, we see that we're actually directed to a different address or a different URL, and it serialized the data from the form and put it up in the query string of that URL. Native forms on the web work this exact same way. If we don't specify a different type of method, the default is going to be a GET request. And a GET request involves getting information from a URL. In this case, even though we're trying to send data up to the server, the kind of tricky way that the web works is it tries to get a request from a URL and then includes a query string with the information that we're trying to pass to it. This actually works in a lot of cases and actually is a good idea in a lot of cases. For something sensitive like an email and password for a sign-up form, it's probably not a good idea to serialize and put that information in the URL. If we instead change this to a post method, and you'll notice that I'm typing these in all caps, that's actually just a convention in HTML. I can just keep it in lowercase if I want. In fact, I think I will leave it that way. If instead I use a post method, then it doesn't put the information from the form up in the URL, but instead it creates a post request and it puts that information in the body of that request, which is not something that we'll be able to just see right here in our user interface. Let me go back to just regular slash. I'll enter the same information and hit enter. And we can see we are still getting a full page refresh, but we are no longer putting that information up in the URL. Okay, how can we stop this full page refresh so we can process this information in JavaScript instead of, as the web was built, trying to send it directly to a backend file to process it? Well, as we saw in the Chef Claude app, we can add an onSubmit handler to our form, and we can prevent the page from refreshing by using that prevent default that we saw before. Let me go ahead and create a function called handleSubmit. It's going to take the event, and before I do anything else, let's go ahead and set this up as our submission handler for the form. I mentioned this before, but even for the most simple of forms, I prefer to be watching for the submit event on the form rather than something like the click event on a button for a number of reasons that I've already outlined. With that event, we can stop the page from refreshing by telling it to prevent the default, and we call that as a function. This makes it so that the page will not refresh. Again, hit save, put in the same information, and hit submit, and sure enough, nothing happens really at all. Let me just go ahead and console log submitted just to make sure that that's actually working. Okay, good. Our function is being called successfully. Now, this event that's being passed to the handleSubmit function is actually pretty powerful. It has a lot of information about it. First of all, I can get access to the actual form DOM node. So I can say something like const form, maybe it will say form L for form element, is equal to event.currentTarget. Or in this specific case, you also could just use target. It's a little bit safer to use current target in this case. And with this form element, I can actually create a new set of form data. So let's go ahead and create some form data. And I can create this by setting it equal to a new instance of the capital F form data. This is something built directly into JavaScript. You could go over to MDN and look it up and learn more about form data. But if I pass the entire form element to it, then what I get back is the data from that form. This form data object will give me access to each of the values of my inputs by using a simple get method. So I can say my first name, and no, we're not doing first name, last name. My email is equal to formData.get, and then I can use the name property. This is why name is so important to put in our inputs. I can use that name property of email to get the data from the form. So let's go ahead and console log our email. I'll hit save, and we'll put something in, hit submit, and sure enough, we're able to console log our email address. Okay, so we're able to listen for the submit event on our form. We have a function to deal with it. We're preventing the default refresh of the whole page. We're getting the form element from the current target of the event. We're then creating a set of form data. We're able to get the information from that form data, and we'll notice that the form is still filled in, so I'll have to manually call something like formL.reset, which is a method on form elements that allows me to reset the form. One thing to keep in mind as we go forward about this reset method, when you're doing challenges and you run this line of code, it's going to work just fine. And when you're doing it on your local machine or pretty much anywhere else, it's going to work exactly as you'd expect. For some reason on Scrimba in the recording, it's not actually recording the form reset. So I'll probably mention at some point that the form successfully reset, and it's probably not going to look like that in the recording, but just keep in mind that it really is working behind the scenes. In fact, I just reset this. I'll go ahead and type this information in, type in my super secure password of password, and I can hit submit. And sure enough, for me, the form did successfully reset. And then, of course, instead of console logging our email, we would gather the info from the form and probably submit it to a backend. This backend would be in charge of doing data sanitization and submitting that info to a database, or in the case of a sign-up form, maybe sending a confirmation email or something like that. Awesome, we've got a working form, but you might be thinking, hey Bob, this doesn't really look that great. This seems to be bleeding into that realm of imperative coding as opposed to declarative coding. And you would be right, but keep in mind that prior to React 19, it actually used to be quite a bit more difficult to gather form information. Or maybe I should qualify that. The traditional way of gathering information from a form, which used something called controlled components, which we'll actually be touching on in the next section, was quite a bit more cumbersome than, first of all, what we're doing here, and more importantly, what we're about to learn in the next lesson. React 19 has introduced a much better way to gather form information. So feel free to play around in the code here as always, and when you're ready, we'll jump into the next scrim. If you remember, we were talking about forms Back in probably the original spec for HTML, there was a property or an attribute that you could add to your form called action. And this is where you would tell where your browser should send the information from the form to. Oftentimes, this would end up being, for example, a PHP file. And the code in that PHP file would then receive that form and process it, save it to a database, return some kind of new HTML, whatever it might be. With our onSubmit that we're handling here, we're able to do a lot of this on the client side. And that's pretty nice, but we do find ourselves handling a lot of things imperatively within our own code base. For example, if I'm handling the submission in my JavaScript, of course, I'm going to want to prevent the default of a full page refresh. And since this is a form that I'm submitting, of course, I'm going to need to get the form element and create some form data from it. If I'm submitting the form, of course, I'm going to want the form to reset at the end. There's a number of sensible defaults that we kind of just wish were being handled for us. And in React 19, we can. React 19 allows us to not only use a regular action for a backend file if we need to, like we have here, but we also can pass a function to it. Maybe instead of sticking with the name of the event that I'm trying to handle, like handle submit and onSubmit, I'm going to go ahead and get rid of my onSubmit entirely. And maybe we just make this a little more declarative, like this is my sign up function. Now, because I can pass functions to my form actions, I'll go ahead and pass this sign up function. And when you're passing a function to your action, it doesn't receive an event because we're not handling an event per se, but instead it's just automatically going to receive the form data. This is awesome. Behind the scenes, the action function is going to prevent the default for us, so we can get rid of that. These next two lines of code were us trying to get access to the form data, which it's already giving us, so we can get rid of both of those. And it's going to reset the form for us automatically, so I can get rid of that. Let's go ahead and console log our email and just see if this really is all we need. We'll hit save. And oh, the warning actually brought up a good point. We had our method of post, but if we're specifying a function in the action, then we don't need to do that manually. So let's hit refresh again. I'll fill out this form and hit submit, and check it out. In our console, we have our email address, and we were able to do that in a single line of code. Also, the form reset, and the page didn't refresh on submit. If I sound probably unreasonably excited, it's because I've had to do it in a much, much more difficult way for a really long time. So bear with me and my excitement, which probably seems pretty silly to you. But something feels so good about just going back to the native web with a little bit of benefits mixed into it from React. Because I've been talking so darn much, I'm going to give you a very simple challenge, and then we're going to come back to our Chef Claude app and apply what we've learned over there. Currently, we're just getting the email from our sign-up form, but we're going to need the password as well. So I want you to get the password from the form as well and log it to the console just to be sure that it came in correctly. Short and sweet, I'll hand it over to you. All right, easy enough. I can get the password by calling formData.get, and the name value that we chose for our password input is, logically enough, password. So we'll just say password, and I'll console log the password. We'll hit save. I'll put this in. I've just been kind of mashing the keyboard for my passwords, and so yep, sure enough, we get the password in. Awesome. Of course, there's a lot more that needs to be taken into consideration when it comes to forms, but for now, this is going to be good enough to help us refactor our Chef Claude app. So let's jump into that. All right, we're back with Chef Claude, and your challenge is to use a form action instead of the onSubmit in this handle submit function that we're currently doing, and the onSubmit handler we have on our form. I want you to use the form action capabilities that we now have with React 19. So I'll pass it over to you to finish this challenge. You might remember, or as you were testing it out, might have noticed that we are able to add items to our list, but we actually didn't even put our form reset down at the bottom here. Fortunately, when we transition this over to use actions instead, we're going to get that for free. So instead of onSubmit, let's go ahead and set this up as our action. And I'm going to call this add ingredient. We'll change the name of our function. Changing the name of the function, by the way, is not required. It just makes it a little more, I guess, semantically sensible. So don't worry too much about that. Okay, we're going to receive the form data. We don't have to prevent the default. We don't have to create our own form data. We can leave this line of code in and this line of code. And we don't have a form reset from before, but we should just get that for free. Let's go ahead and clean up our challenge text, hit save, add oregano, and I'll hit enter first. And sure enough, that added to the list and our form cleared. Maybe I'll add basil and try clicking the button, and same thing. Awesome. That was such a quick challenge that I'm actually going to take some time to tell you how things used to be in React. We're not going to dive deep into it, but the way that we used to do form handling in React is we used to track the state of every one of our inputs. And on every input element, we would add an onChange event handler. Every single keystroke that happened inside of an input, or the clicking of a radio button or checkbox or whatever it might be, any single change to the information in the form, we would update our local React state instead of using the internal state that already exists in forms. Which meant every single one of our inputs had to have an onChange. It also had to have a value property so that we could make sure the input's value, or the actual text of the input, was correctly updated whenever state changed. And this whole setup was called controlled components. This was because React was in charge of controlling the state of the inputs and the form in general. And the truth is, there are still times here and there where you might find that useful. For the most part, you're not going to have to worry about that, and we can delete a lot of code compared to what we were required to have before. Now, although Chef Claude doesn't have any more requirements as far as our form goes, there's still a bit more that we need to learn about forms in React because, as I've mentioned, including forms in React is a very common task. So I want to make sure that I cover those bases. Even though our Chef Claude app isn't going to require these, I wanted to cover some other form input types just so that we have those under our belt in case we ever need them. We won't be covering every single one of the types, but this will be a good way to get our feet wet with other ways of collecting information from our users. The first one that we should talk about is a text area element. One thing that's unique about text area is, well, first of all, it's not an input type text area or anything like that. It's simply its own element. Also, it actually isn't a self-closing, it has a separate closing tag, which is the text area closing tag. The difference between a text area and an input is that it's intended for longer form text. You'll also notice that in the very lower right, there's a little handlebar for the user to change whatever size gets displayed here. But you also can set a default size in your CSS, is kind of the preferred way, or there's a property called rows and columns where you can change the size directly here in the HTML. Well, I guess we're in JSX, but it has those properties still. I'll go ahead and add a label for this one. And maybe since this is a longer form text, we'll, I don't know, say it's some kind of description that the user is going to be entering in. And we will need our HTML4 because we are not wrapping the label around our text area, although that would be a legitimate way to do it as well. We'll say it's for description, which means we need to give this an ID of description. And assuming we want to actually gather this information from our signup function up above, we will need to also add a name property, which will also be description. Cool, looking good. We'll keep this lesson kind of short and sweet because we are going to be diving into other input types that have a few extra considerations we need to keep in mind. But before we move on, there is something that I remembered now that I added to this code since we last saw it, and that is this default value property. In my case, I'm adding this default value simply so that I don't have to type new things in every time I submit this form. When we come back around to seeing what information we're getting in our form data, it's really helpful when testing this not to have to fill these values in every single time. Default value is a way to initialize this element with a default value. And this default value is still changeable. I could change this to whatever I want, but you might also be able to see some value in the default value property if you were loading up a form that you needed to pre-populate with the user's data. For example, I've seen apps where I go to maybe my profile section, and if I want to change maybe my address, it will show me a form, but it will pre-populate it or set a default value to the data that I had previously entered, but still allow me to change it and resubmit that form. So that's all that's happening here with the default value. I'll probably add more default values to the other elements as I go on, just so that it makes it easier to test submitting my form. Okay, in the next lesson, we're going to jump into radio buttons and see how they can be a little bit different than the other inputs that we've dealt with. The next input I want to talk about is an input of type radio. We'll hit save and see that we get nothing all that special here. I'm certain this isn't the first radio button you've seen. Radio buttons are used when you have multiple options for the user to choose from and you only want them to be able to select one at a time. Let's put a label on this button so that it doesn't look so silly, just as a circle sitting there on my page. And maybe just to show that it works totally fine to wrap our labels around our inputs, I'll go ahead and wrap a label around this particular input. Let's indent that input. By doing so, I think we lose a little bit of neatness in terms of the structure of our HTML, but we also gain back some of the fluff that we have to add just to associate the two together. In this case, I'm going to put my label text, and for now, let's just say label text, after my input. That way, once I've made another little change we're about to see, my radio buttons will be able to align neatly on the left side and the label will be on the right side. Even without any label text, I think because of the way my CSS is set up, if I hit save, we'll see that that's going to align to the left. And I think that radio buttons look a lot better if you have all of your radio buttons aligned on the left and then you have the label on the right. Of course, you can change that around and use some CSS grid maybe to get them all aligned on the right side, but let's just keep it like this. And for now, I'm just going to say label text because we're going to see what we're using this radio for. And awesome, we get label text. Now, let me go ahead and duplicate these. So we have a few different options here. And as I mentioned, one of the standout features of a radio button is that we're only able to select one of them. However, if we check, I can actually select all of these. So why exactly is that? Well, in order for them to be exclusive from each other, I need to give a name property to my radios, but that name property has to be the same for all of the radios that I want the user to only be able to select one of. Now, I'm going to make these radio buttons represent an employment status, so I'll go ahead and give the name of employment status to all three of these, the same exact name. Let's hit save, and now I can only select one of these at a time. Selecting a different one will change which one it's selected, of course. One thing that I really like to do when I have radio buttons like this is to surround them in a field set element. So I'll go ahead and take this closing tag and just wrap all of these in a field set and then do a format to indent those. And we'll just go ahead and hit save. Oh, and it looks like maybe we need to make a little change to our field set. Let me go ahead and add a display of flex and a flex direction of column on that. Okay, that looks better. Okay, so the field set gives us this little outline. When we're inside of a field set, we also can give a little label to the entire field set with a legend property, or element, I mean. And in that element, we'll go ahead and say employment status. And awesome. Now you can change the design for this. This is sort of the default. I've updated some colors and such, but I'm not going to worry too much about the rest of the design. Okay, instead of label text, let's go ahead and include our different options. We'll say unemployed, part-time, and full-time. Awesome. And because they have the same name, we can only select one of them at a given time. Now, there's a couple things we need to take into account. First of all, before we move on, in this text area, I'm going to add a default value, and maybe I'll just say this is a description. So we'll hit save. I'll go ahead and check part-time and hit submit. Oh, and in our function, we're only console logging the password. So actually, let me throw in a quick challenge here. Okay, the challenge I want you to try and do is grab the employment status from the form and log it to the console. Just when you're submitting the form, remember to choose one of the options because we haven't yet discovered how to create a default selected option. However, before anybody jumps into this and starts pulling their hair out, I want to give you a caveat or a note here to let you know that it's not quite going to work the way that you might expect, and we're going to fix what this problem is. So I just don't want to set you up for failure. Just know ahead of time it's not going to work quite yet. So give this challenge your best shot, and if you'd like, you can see if you're able to fix the problem that we run into when we try to do it the way it currently is written. Go ahead and get started on this challenge. Okay, well, let's just give it our best shot. We'll go ahead and try to grab the employment status, and that will come from formdata.get, and we'll pass in the name of employment status. Is that the one we chose? Yeah, employment status right here. I'll just copy it and paste it just in case. And let's go ahead and try to log employment status and see what happens. So I'll hit refresh, I'll choose part-time, I'll hit submit, and all we get is on. Interesting. So our radio buttons by default, they don't come with their own value per se. Or rather, the default may not be exactly what we need. In fact, let's hit save and to refresh the form, and I'll hit submit, and you'll see that the other option, if we don't select something, is null. But I'll go ahead and choose full-time, hit submit again, and now that value of on comes in. When we're creating radio buttons, we need to provide a value property, and this value is what we want the data to be when this form gets submitted. For example, if we're here on the unemployed, we might want this to say unemployed as the value. Think of this value as the actual value that you might save to a database. So I'll go ahead and fill these in as well. We'll say this one is part-time, this one is full-time. We'll hit save, we'll choose maybe part-time, hit submit, and now we actually get the value that we associated with the input that we ended up selecting, and that's the value that we were able to pull in from our form data. Okay, that's a lot of information that we just talked about, and all we've covered so far is radio buttons. However, they're pretty important, and it's good to know some of their nuances that we run into. The only other thing I want to touch on before we finally move on from radio buttons is how we can automatically select one of these, or I guess if you were pulling in existing information and wanted to pre-populate the correct choice, instead of using something like default value, which is what we have used above, instead we choose the input that we want to have the selected option already, and we use a different one called default checked. And we will set this equal to a Boolean value of true. Actually, well, let's hit save. We see that we automatically get full-time selected. I think we might be able to do the string true, and yeah, that works as well. But because we're here in React and we can put in real JavaScript values, let's go ahead and use a real Boolean. Okay, let's move on from radio buttons and talk about the radio button sibling, which is the checkbox. A very close relative to the radio button is a checkbox. Let me go ahead and create something very similar to this. Actually, I'll just copy this whole field set here. Let's change the legend to something where a user might select multiple boxes, maybe something like, I don't know, dietary restrictions. I'll go ahead and change all of these to a type of checkbox and update the names. Let me get rid of the default checked that we had here. Although, actually, I guess this is an important time to note that, let me go ahead and hit save. Default checked does work the same as it does with radio buttons. We can see that full-time here has a check mark, even though we haven't selected that. With checkboxes, though, because we can have multiple checkboxes selected at a given time, I can put default checked on multiple different items, and so we can have multiple different things selected at once. Let me go ahead and get rid of these default checked just for now. Actually, I'll go ahead and leave it on that third one. We're doing essentially the same thing we were doing before, so I will update the labels that I have here. And let's say maybe we have a dietary restriction of kosher, let's say vegan, and maybe gluten-free. And I'll update the values as well. Remember, when I submit my form, whatever I put in the value, if the box is checked, will be what gets sent to my form data. So with this one, we'll say kosher, and in this case, I'm choosing a lowercase k here. I guess it just depends on what data you actually want showing up in your database. That's what you would put here as your value. We'll say vegan, and the other values down here, so that will be gluten-free. Okay, so far so good. Let's hit save. We have our gluten-free checkbox already checked because of the default checked. And let's see what happens when we submit our form. So up here, I'm going to grab, let's see, I'll just duplicate the employment status one. We'll change this to dietary restrictions. Let's see, did I use an S? Yes, dietary restrictions. And so that's what I'll do my form data.get with. And let's see what happens when I hit save and hit submit. We'll look at the console. Okay. So we did get gluten-free showing up as one of the checked items. What happens if I check another one? Let's say kosher, submit, Interesting. I am only getting kosher. And actually, let me refresh this form to clear that out. We'll do both kosher and actually, let's just do all three. Submit. And check it out. We are only getting one of our options showing up in the form data when we get it. This is something that I think is pretty unique to checkboxes, and there's a really easy way around it. The form data object that we're calling this .get method on, it also has a method called getAll with a capital A. By including that, if I hit save, we'll check all three of these and hit submit. Now we get an array with all of the values that we expect to be getting with a checkbox that can have multiple things checked at once. So when it comes to checkboxes, they're almost exactly the same as radio buttons. Each one has the same name property. Each one has a different value. We can use default checked to automatically check it when the form loads. However, if we want to get an array of all of the checked items, then we will need to use formdata.getAll instead of just .get. The fact that we have to do this a little differently will play a bit more of a significant role in a lesson that's coming up very shortly on how we can more concisely get all of the information from a form. But for now, hopefully what we've done here makes sense. As always, please feel free to play with the code that you see here, and when you're ready, we'll keep moving forward. There are a ton of different input types, and it's certainly outside the scope of this course to talk about every single one of them. However, I do want to cover the select and option elements just as one final hurrah here with forms. We'll talk quickly about submitting the forms, and then we'll kind of get off this little side trail that we've embarked on and get back to our project and the topics that more closely relate to this specific project. Let's say I want to add a dropdown where the user can choose their favorite color. We'll go ahead and start with a label like we usually do. This time I'll go back to having a label that's separate from my select elements. And here we'll say, what is your favorite color? Because my select is going to be a sibling element, let me just get that started. I'm going to give an HTML4 attribute to my label, and maybe we'll call it favColor, and I'll have to give this an ID of favColor. Okay, so a select will give me the box, but in order to have a drop-down list with different options in it, I need to use an option element. I'll go ahead and fill these out for every color in the Roy G. Biv color spectrum. Let me go ahead and hit save. You won't be able to see this in the recording, but if you were to come click on this form and click the dropdown, you'll see a browser-implemented version of this dropdown box, which I'm sure you've seen a million times by now. A main thing that's different is in order to gather that information up in our function, I need to give a name attribute not to my options, but to my select. If we think about it, this makes sense because we need to gather the one chosen option, and the only place that we could give a name to that would make sense with that is the parent select box. Let's give this a name that is also favColor. However, in order for each one of these to have its own value, each one of the options needs to have a unique value. So I'll give each one of these a value property. And I'm just going to copy the color, and I guess I don't need this to be curly braces like this. We'll do a string, pass in the color, and then I'm going to be particular, I guess, and lowercase each of these values since I've been lowercasing my values before. Okay, awesome. We'll hit save. Let's go ahead and choose blue. We'll hit submit. And oh, you know what? I forgot to update this function. Let's not console log dietary restrictions. Now instead, let's get favColor is equal to formData.get favColor, and then we'll console log favColor. Okay, let's try it again. Hit save, go down to something like blue, hit submit, and sure enough, we're getting the value of blue with the lowercase b, because that's what we set our value to for that option. Now we can see that it's defaulting to the first item in that list. If I want to change that, I can simply add to my select, let's see, that's right here, default value, and set it equal to one of the values down below, like indigo. Now if I hit refresh, we see indigo is the default value that shows up. You also might be familiar with select boxes where what it actually says is something like choose your favorite color or choose a color. We can achieve that same thing by creating a new option at the very top. We'll give it a value of an empty string, and we'll give it the text of something like choose a color. Okay, we're partly there, and oh, we're still showing indigo. Let's get rid of our default value here. Actually, I'm going to leave this as a default value of empty string, since technically our choose a color is the value of empty string. And so, awesome, that now shows up. We actually wouldn't need this here, I don't believe, in order for it to show that, since it's the item in the top spot, but it doesn't hurt to leave it there. And lastly, assuming we don't want a user to be able to submit choose a color as their final answer here, we can add a property to the option that says that this is disabled. If I hit submit, now I'll hit save, and in my drop-down box, and you will probably have to click into this form to see this, but it says choose a color at the top, but it's grayed out. It's not an option that the user can select. We can still submit the form though. We get a value of null, and so if I need this to be a required field, then I can simply on my select add a required property. We'll hit save, try to hit submit, and we get a browser implemented warning that you might not be able to see here in the recording, but it says please select an item in the list. So I'm forced to come down and select an item, and awesome. As I mentioned, we're straying a little bit from our main topic of learning React, but forms in React can be a little complex. Fortunately, as of React 19, now that we're able to use this form action, we can finally rely on forms to maintain their own state and to simply collect the data using the form data object that we get inside of the function that we pass to our form action. As you can imagine, if our form had, say, 40 or 50 fields, it could become a bit annoying to have to select the data for every single one of them. There is a quick shortcut that we can use to more concisely grab all of the data from the form. It's not a silver bullet. Sometimes you will need to select all of the individual items by themselves. Maybe, for example, if you had to do some kind of manual sanitization of your inputs. Although in the end, you would probably want to use something that was a little more robust, like using the Zod library. But that's definitely a different discussion. So let's see one way that we can more concisely grab our data. Currently, we are going through every one of our inputs and grabbing the information from them one line at a time. And as I mentioned, there are times when this may be necessary, but if we had a form that was 40 or 50 or more different inputs, maybe first you would want to address why you have such a long form. But let's pretend the size of the form is outside of your control and you just need to simply grab all of the data. There's a utility that we can use built into JavaScript called object, capital O object, dot from entries. All I have to do here is pass in the entire form data object, and let's see what we get. If I console log the object, or the result from object.fromEntries, I kind of gave it away. We'll hit save, we'll submit our form. Oh, I have to choose a favorite color and submit, and we see that we get an object back. The object has all of the name values as properties in the object and the values in the form as the values to those properties in the object. If I'm trying to build up an object to then send to a database, it looks like I am most of the way there. However, if we look really closely, we'll notice, and you know what, I'm going to copy this object from the console since you can't see my arrow down there, and we'll just paste it down here. Okay, we can see with dietary restrictions, what we get back is just a string, gluten-free. And remember, sometimes with checkboxes, we want the user to be able to select multiples. However, if I do this and hit submit, and we look closely at the object that comes back, we still have the same structure. It just says gluten-free. Remember, with checkboxes, I had to use that formData.getAll in order to get the property from there, so I am unfortunately still going to have to do that. Let me go ahead and save most of the data. We'll just save it as the returned value from object.fromEntries. And then individually, I'm going to get the dietary, let's just call it dietary data. And that's going to be by calling formData.getAll. And separately, I'm going to get the dietary, let's call it dietary data. Actually, let me make this into a challenge. It looks like my old challenge text is up here anyway, so we'll just clean that up and give you a new challenge. I'm sorry that it's been so long since I've given you a challenge. Hopefully nobody got too complacent in the meantime. Since we are on a bit of a detour here, this is going to be a fairly straightforward challenge. I want you to see if you can remember how to grab an array of checked items from the dietary restrictions checkboxes. You should be able to then console log dietary data and get back an array instead of a single string. All right, get started on this challenge. I think it's more of a mini challenge at this point. All we have to do is say formData.getAll. GetAll is the key here. We'll give it the name of dietary restrictions. And let's go ahead and console log it just to make sure it's giving us what we want. You know what? I'm coming down here to change my default value to, let's say, blue, just so I don't have to keep selecting that. All right, I'll select another one, vegan, hit submit, and awesome, we get our array of selected items from our checkboxes. Now that I have an array, I can combine the object that I got with data with the array that I got with dietary data at the key of dietary data, essentially overwriting what data.dietary restrictions used to be. So I can just say maybe const all data is equal to an object that takes all of the properties from data and then includes a property called dietary restrictions, and the value is going to be dietary data. I also could simplify this a little bit just by choosing to name this dietary restrictions instead, and then I can go like that. And I'll just get rid of this console log because it's referencing the wrong variable name. I guess before we assume it's all working out, we'll console log all data, hit save. Let's select all three of these, hit submit, look at what we got. And awesome, if we look closely, dietary restrictions is an array that has kosher, vegan, and gluten-free in it. Okay, let's finally be done talking about forms. Let's get back to the main project that we're working on and start diving deeper into a topic that we did briefly see before, but now we'll actually take the time to understand it, and that is conditional rendering. Over the next few lessons, we are going to be doing sort of a mini-series on this topic called conditional rendering. And although it's going to span a few different lessons, mostly we'll just be talking about what it is and how we do it, seeing multiple different ways that you can accomplish conditional rendering, depending on your use case and your needs. Fortunately, understanding conditional rendering is not that difficult. In our Chef Claude app, the user is first presented with a simple input and a button. And only after the user adds some ingredients to the list will they first be presented with this ingredients on hand header with the unordered list below it, as it wouldn't be as intuitive to have just an empty unordered list and this ingredients on hand with nothing after it, unless something is added to the list. Also, after some ingredients are added, we can actually set this up to be after a certain number of ingredients if we want. We then will present the user with this section down below that says to get a recipe. Again, it wouldn't really make sense to show this on the screen unless there were some ingredients on hand. And lastly, we have an entire recipe that we need to display, but we will only have that recipe after the user clicks get a recipe and makes that round trip call to the Anthropic API. So everything in the suggested recipe and the recipe itself, that all needs to be, I guess you could say, hidden or not rendered to the page unless we actually have a recipe to display. So this is where conditional rendering comes into play. As you can kind of intuit from the name, it means that we render parts of our page based on a condition. If that condition evaluates to true, then React will render that portion of the page. If it's false, it simply won't be rendered. And as a reminder, when I say it won't be rendered, I mean it won't even be added to the document. You could search for it in the DevTools, but it wouldn't be there at all. I guess you also can set up conditional rendering so that it hides elements that actually are on the page, but for the most part, we're just not going to render it to the page at all if those conditions aren't met. So let's dive into this topic of conditional rendering, and then we're going to come back to the Chef Claude app and apply what we've learned. Here we're back in the Jokes app that we created in the last section, and I wanted to give us a challenge so that we could make it where the user could click a button and clicking the button would display the punchline. To get us started, I have a quick challenge for you. I want you to create a state that's labeled as isShown, and it will be a Boolean type that defaults to false. And then I want you to add a button underneath the punchline for each one of the jokes that, when clicked, will toggle the value of isShown back and forth. We're not going to worry at this point on any conditional rendering, so just so we can more easily tell that this is working, I'm going to console log isShown, but I won't hit save because it'll break your app. Okay, your turn. Get started on this challenge. We're going to use useState from React, so I'll make sure I import React from React. Again, a very common way that you'll see this done is simply to import useState from React. Just while we're learning, I'll keep it as import React from React so we can tell that this is state from the React library. I'll create my new destructured array. We'll say isShown and set isShown is equal to React.useState, and we'll create an initial value of false. While I'm still up here, I can probably clean this out. We'll create a function, and maybe we'll just call it toggle shown. This isn't strictly necessary. I could do an inline function on my button. Actually, you know what? Let's do that first. So I'll create my button. We'll have it say something like show punchline. I'll add an onClick to it. This onClick is going to be a function, and this function's job is going to be to call set isShown. We do care about the previous value of state so that we can flip it from whatever it used to be to the new value. So I'm going to say previous shown, and this is going to be an arrow function. We'll say previous shown and then return the opposite of previous shown. Now we can see this is why I like to do my functions elsewhere. This looks a little too crazy for me. So I'll go ahead, create a function, toggle shown. We'll take the code right here, paste it in, and we no longer need this anonymous inline function. Instead, we'll just call toggle shown. Now notice at this point, nothing relies on isShown in order to be displayed. And so that's why I have this console log here, just so I can see that it's working. We see that it's false, but let's open the console and we'll see something really interesting. We actually see false 5 times. I'm actually going to insert a pause here and give you a chance to think, why is it that we're seeing false 5 times? Well, if we go to our app.jsx, we can see that we're mapping over some data, and for every item in this array, we're displaying a joke component or rendering a joke component means that we're calling this joke function. If we go to our jokes data, which we're mapping over, we can see that we have an array with 5 items in it. So this joke component, even though from our app.jsx it kind of looks like we just have one of them, the fact that we have an array means that however many jokes we have in this array is how many times this function will get called, which means inside of our joke function, this console log is going to get called 1 time for every instance of our joke component. I'm guessing that was probably clear for most of you, but I just think it's good to reiterate stuff like that. Okay, let me hit show punchline, and we only get 1 new entry in our console, and we can see that it was set to true. Perfect. Okay, for this next challenge, I'm actually going to do this a little bit backwards. Let me start by typing out the challenge. Now, your challenge is to make it so that this paragraph only gets shown if the value for isShown is set to true. The reason I say this is backwards is because we haven't officially learned how to do this. But when we were just finishing up with this app in the last section, I left in this little snippet of code here that shows you exactly how to do it. We're going to talk about why this works in the next lesson, but for now you have a perfect template to help you complete this challenge. Oh, and let me just make sure this is clear. This is the challenge. So go ahead and give this your best shot, and then we'll talk through it. Well, in this previous example, we had been talking about jokes that may not have a setup, but were just kind of a one-liner joke that was more of just a punchline. And inside of our jokes data, we included a joke that didn't have a setup property. And so what we did is we surrounded our JSX in a set of curly braces, and we included first a condition, this double ampersand, and then the thing that we wanted to render if this condition had a truthy value. So we can do this exact same thing. Let's surround our JSX with a set of curly braces. That will allow us to evaluate some JavaScript. And I can start by saying if isShown is equal to true, then, or and, this paragraph. Again, we're going to talk about why this double ampersand works in this case. But first, let's go ahead and hit save. I'll click show punchline. We can see that the punchlines are missing now. I'll click show punchline on this one, and awesome, the punchline shows up. Now, many of you are probably thinking I can simplify this. isShown is already a Boolean, so I don't need to compare it to the value of true. If isShown is true, we get exactly what we need here. And just to show that's working, maybe this time I'll hit the punchline on the second joke. And because this state is being saved inside of the joke component, each one gets to maintain its own state. We're actually going to be diving deep into that idea a little bit later, but for now it simply means that I can click show punchline on just this one joke, and it's the only one that will show the punchline. Not only that, but I can actually click the button again and it will hide the punchline. We're going to address that user experience in just a minute. So this lesson has gotten a little bit long already, but before throwing throwing you into a challenge, I want to talk more about why this works. We're more familiar with the double ampersand being a way for us to compare one value with another when we're doing something like an if-else-if statement, as opposed to, in this case, where we're using it for conditional rendering. So why exactly does this work? That's what we'll be touching on next. We're pretty familiar with using the double ampersand when we have something like an if statement. I don't know, let's just say true. And, if we do a console log here, everything was true. We often think of this ampersand as a way to check the truthiness of the thing on its left and the truthiness of the thing on its right. If both of them evaluate to true or a truthy value, then this if statement will run. However, that's not entirely true, even though this condition would suggest otherwise. What's really happening here is a left-to-right evaluation. Inside of our if statement, the computer will first evaluate the truthiness of the left-hand argument. Of course, the Boolean value true is truthy, so then it sees there's a double ampersand. And because the item on the left was true, it's going to continue evaluating through the next expression. If this one also is truthy, then we know the whole thing will evaluate to a single true value, and the if condition will run. This jives with our understanding. If we were to change the second one to false like this, we can think of it as a left-to-right operation. Okay, that's truthy, and, well, that tells the computer that means that the item on the right-hand side also needs to be truthy. Then it reads false, and it says, oh, nope, this whole thing will evaluate to false, and the console log will not run. So I guess this would have to say everything was not true. So does it jive with our understanding if instead we were to change this first one to false? If we go from left to right, we might think, well, this is false. We then get the double ampersand. It notices that this is true, but because both items on the left and right were not truthy values, it evaluates the whole thing as false. However, we can see that this isn't precisely what's happening. Let me go ahead and change this true. This is not something that you'll see very often, but we'll change it to an operation that we can know if it ran or not. Let's say this code is running. I'm actually just going to comment out this console log so it doesn't become confusing. Let me change this to true. We'll hit save. We can see that in the console, we do get this code is running. Okay, well, what happens if I change this to false? I'll hit save, and the console log did not run at all. What's really happening is that left to right operation. It notices that this is false. It sees that this is a double ampersand, but because the first condition already evaluated to false, it kind of short circuits the rest of this line, and it doesn't need to even evaluate this because it knows that it's going to evaluate to false or some kind of falsy value. So in JavaScript, this console log won't run at all. Of course, if we were to reverse this, we put the console log first and then say and false, we will get the console log running because it's the first thing that it evaluates. It runs the console log function. It sees it's a double ampersand and it says, well, this was not a falsy value, so I'm going to continue evaluating, and then it gets false. It returns this falsy value to the if statement here, and it becomes false. So this property of the double ampersand short-circuiting the rest of this line is exactly what we're taking advantage of when we're using conditional rendering in the way that we're doing here. The double ampersand can be a quick way to either display something or not display something. If isShown is falsy, then this expression will just return a falsy value. And in our case, because isShown is a Boolean, React will interpret this as meaning nothing should be rendered in this spot. However, if isShown is truthy, then the double ampersand says just return whatever's on the right side here. If this is falsy, then the whole thing will evaluate to false and nothing will get displayed. But as we know, since we wrote this code, we're not returning anything falsy. We're following up our double ampersand with what we want to get displayed. So that was kind of a long-winded way to talk about this, but hopefully that helps make some sense of why the double ampersand works in this case. And as I mentioned, it can be a good way to either conditionally render something or not render it at all. In a little bit, we're going to quickly touch on a shortcoming of using this method for conditionally rendering. But before then, I want to get your hands more on the keyboard and have some practice. So that's what we'll do in the next lesson. This is a pretty straightforward challenge. Your task is to only display this h1 if there are unread messages in state. Right now we have 2 items hard-coded in here. We're not actually displaying the text of these messages anywhere, so it doesn't matter what it is. As long as there are items in that array, it should display this h1. And if there are no items in the array, then for now we're just going to have it be a blank page. This h1 won't be rendered at all. Let me put those back in there, and I think that's everything you need to know. So go ahead and get started on this challenge. Well, in this case, unread messages is not a Boolean value, and even an empty array is a truthy value. So we couldn't simply wrap this h1 in curly braces and say if unread messages and display the h1, because let's go ahead and hit save. We do have the h1 showing up, but even if it's an empty array, we still have the h1 showing up. It's best to be really explicit with what exactly we're looking for. In this case, because it's an array, we need to know if the length is greater than 0. So if the length is greater than 0, it will display this message. Let's actually get rid of this blank space here, and we'll say unread messages.length. And this is wrapping a little bit, so let me go ahead and put these on their own lines like this. Hit save, and awesome. We have 2 unread messages, and then of course if we added to this array, it would update that number. So we've seen how using this sort of short-circuited way of using the AND operator gives us a chance to determine whether something should or shouldn't be rendered at all. However, it does turn out there are some limitations to this. And to highlight those limitations, I'm going to give you another challenge. I'm fabricating this scenario a little bit here just to prove a point, but for this challenge, if there are 0 unread messages, I want you to display a paragraph, not an h1, but a paragraph that simply says something like, you have no unread messages. In this case, I do want you to use the AND operator just like we did above, and you'll just do it right here below the previous one that we did. And as it says, the logic is going to be the opposite of what we have for the h1, so that if there are unread messages, it will display this h1, and if there are not unread messages, it will instead display the paragraph that you're about to create. For anyone who's already familiar with conditional rendering in React, I know this is a silly exercise. I'm building up to another way that we can do conditional rendering. Okay, take it away. I can just copy the logic here down below, and in this case I'm going to say if the unread message count is equal to 0, then I want to display a paragraph that, and I'll just copy the text here. Okay, we'll hit save. We have 2 unread messages. If I get rid of those in state, okay, a paragraph, you have no unread messages. Perfect. Okay, well what we've done here is highlighted an issue where we essentially have an if-else statement. If unread messages.length is greater than 0, then we display this h1, but the only other option is if the length is equal to 0. Because it's an array, we can't have negative length in it. However, it's a little bit verbose what we're doing here. We are repeating ourselves for this unread messages.length check, and in this case we're only ever displaying one item or the other. So as you can probably tell that I'm driving towards a point that in this case, when we're trying to decide between displaying one thing or another thing, the logical AND operator is not going to be our best choice. Not only that, but let me actually clear up this challenge and clear up this that we just did. But it can be really tempting to see something like unread messages.length and try to infer a truthiness out of it. In JavaScript, the value 0 is considered a falsy value, and so it's tempting to say that if unread messages.length is a truthy value, then I want you to display this h1, and we might pat ourselves on the back and think that we're doing a great job here. You know, we might hit save, see that it looks like it's working, and ship it. However, let's see what happens if I empty my array and hit save again. We simply get the number 0 displayed. When this evaluates to the number 0, React will choose to display that 0 instead of just considering it a falsy value and not displaying anything. So unless we're very sure that we're being explicit in our condition and ensuring that that expression will evaluate to a real Boolean value and not just a truthy or a falsy value, there's potential for bugs to show up in our code, like having a random 0 floating somewhere on our page. Kind of in summary, the AND operator can be a good way to quickly either display something or not display it. If you use it, make sure that your expression will always evaluate to a real Boolean. Otherwise, there's another option that we can use to conditionally render things in React, and that's what we're going to be talking about next. We have kind of a funny UI bug right now, where if we click Show Punchline, it does show the punchline, but the button still says Show Punchline. Furthermore, clicking Show Punchline again actually hides the punchline. So knowing what you know now and what we've learned with the AND operator to do conditional rendering, I'm going to put in a pause here and I want you to think about how you might change the button to, say, hide punchline instead of show punchline. Of course, only at the appropriate time, when things are already shown. I'm not going to type this down as a challenge because I'm not necessarily expecting you to write the code for it, although you're more than welcome to go above and beyond and do so. So see if you're able to figure out a way that you could change the button to say hide punchline if the punchline is already shown. One way we could go about this is duplicating this button, having one that says show punchline and one that says hide punchline. We then would have to conditionally render one button or the other button based on the isShown property. So I would say if isShown is true and, well, actually, let's see. If isShown, we want this to say if not isShown. So if it's equal to false, then we want to say show punchline. And if isShown is true, then we want to display hide punchline. And we should see that this will work. It says show punchline, we click it, and now it says hide punchline. If you think about it, when the state changes, React is actually removing the old button and putting a new button element in its place. But we can already tell by the duplicated code that we can probably do this in a better way. And the better way that we can do that is by using a ternary. In this case, I wouldn't even have to duplicate my button, so I can just get rid of this, and the only thing that's really changing about this button is that first word. So let me back this off. I'm going to get rid of everything that we just added. And instead of saying show punchline, I'll go ahead and determine what this word should be in JavaScript. So I'll put a set of curly braces to jump into JavaScript, and I can use a ternary to say if isShown is true, then I want this to display the following string. Let's see, if it's true, then I want it to say hide, but otherwise I want it to say show. Let's hit save, and we'll click show punchline, and awesome, it now says hide punchline. Not only that, but because we are only changing the text of our button and not actually swapping out the entire button element itself, after clicking it, we still have tab focus on that button. So I could hit spacebar and it would toggle that button back and forth to hide and show the punchline for that one specific joke. So that's kind of an extra benefit because we're not swapping out the entire button element, but just changing the word on the button. So now that we know about the ternary, there is one last thing that I want to talk about, and that is that there is a little bit of pushback in the React community to using the AND operator at all. Because of that little bug that we saw before, where if your expression evaluates to a 0, it actually would display a 0 on your page. Bugs like that can be completely gotten rid of if we simply choose to use a ternary instead. So instead of an AND operator, I'll use a question mark, and as an alternative in my else, basically the second part of my ternary, or I guess the third part, the first part's the expression, second part is the truthy value that gets returned. In this third part, we'll say null. It's a little bit of extra typing, but it is kind of a prevailing thought in React these days to do this just to avoid any potential of having that 0 show up on the page, or just generally having your expression maybe not evaluate to what you think it's going to evaluate to. So there are some who would say just don't use the double ampersand at all and just always use a ternary with null as your alternative option. And we'll see that this is working exactly as we would expect. We're currently showing or hiding the punchline correctly. The button says hide punchline and show punchline. I think what I'll probably do is just leave this example with the double ampersand, and I'll leave this one with the ternary just so you see the alternative. And between these two options, with the AND operator and the ternary, I would say probably 90–95% of your conditional rendering needs will be met with that. If you do have something a bit more complex, like if based on whatever value you have, you might display more than 3 or 4 things, in that case, it might be better just to put your logic up here inside of your component to determine either what element should get displayed or what the text should be that gets displayed. Do all of that logic work outside of your return, above your return, I should say. Save it in some kind of variable and then just display that variable down below. Because we're just dealing in JavaScript here, you also could do something like create a function that takes a parameter and determines what the output should be, and then inside of your JavaScript expression down here, you could simply call that function, and that function would be in charge of returning the JSX, or in this case just the string that should get displayed. There's a million ways to do it, and it's kind of hard to go over every single one of them because, well, there's always a lot of ways to solve the same problem. Everything that we've covered here so far is going to be plenty for us to get back to our Chef Claude app. However, before we jump back into Chef Claude, I do want us to get some hands on the keyboard here and practice conditional rendering. We'll also have a quick conditional rendering quiz. So stretch out those finger muscles or do whatever you need to do to be ready to complete the challenge. Okay, let's give this one a shot. Your challenge is to display the correct kind of text inside this H1. If there are no unread messages, so if this is an empty array, it should display "you're all caught up." If there's exactly one unread message in it, then it should display "you have one unread message," and message will be singular. You don't have to display the singular word there. Actually, let me put the quote on the other side there. And if there's more than one unread messages, then you want to display "you have" and then the number of unread messages, but the word messages should be plural. There's definitely more than one way to solve this problem. So give it your best shot. Don't be too concerned if the way that I do it is going to be different than yours. Just see if you can get it to work. So I'll pass it over to you to work on this challenge. One way I could choose to go about this is to decide which H1 I'm going to display, one of these three based on the conditions that it has. I also could potentially choose to do a ternary, but because I have three different options here, it would likely have to be a nested ternary, which I personally kind of despise nested ternaries. I think there's always a better way to do things. In the last lesson, I briefly mentioned at the end that one thing you could do is to set a variable for what text gets displayed and then run your logic here above your return in order to determine what that text should be. If you chose to conditionally render your H1s using an AND operator or some kind of ternary, that is 100% okay. But just for the sake of seeing it a different way, I'm going to go ahead and create a new variable. I'll set it as a let variable so that I can change it. And maybe let's have this say, we'll just say text. And I'll just leave it undefined for now. Then I can just use a regular if block to say if messages.length is equal to 0, then I'll go ahead and set text equal to this message that says "you're all caught up." Else if my messages.length is exactly equal to 1, we'll set text equal to this message instead. And that needs to be a string and not have this formatting here. And otherwise, we are certain that it will be greater than 1, so we will just copy this down here. We'll change this to messages, and I'll use messages.length inside of my text, which means I need to use a template string, so I'll go ahead and put that interpolation there and change this to a template string, and the word messages is plural. Okay, so by the end of running through this logic, text is going to be exactly the text that I want, so I'll put a set of curly braces and just say text. Let's clean up the challenge, hit save, and we get an error, and that's because I'm checking message.length, not messages.length. Okay, cool. You have 2 unread messages. Let's lower this down to 1 unread message. Perfect. And if we make it an empty array, "you're all caught up." If this logic were to get much more complex than this, I might put this inside of a function and say something like determine text. We can simply put all of this inside, and then we'd want to make sure we returned the text. And actually, by doing that, I don't need to save a separate variable, so I could simply say return this string. We could just do that in each of those cases. And then all I would have to do is call determine text with my set of parentheses there to immediately execute it upon this getting rendered. Let's just see if that's working. So, okay, we get "you're all caught up." If I add a single item back in here, then I get "you have 1 unread message," and a second one, 2 unread messages. Perfect. Again, I actually didn't expect anybody to do it this way. If you did, bravo, in kind of thinking outside the box. I just wanted to show that there's a lot of different ways to handle this, and now that you understand the concept of conditional rendering, simply using JavaScript to determine what should get displayed to the screen, or if something should get displayed to the screen at all, the whole world of possibilities is going to open to you in how you actually accomplish that task. Just to shift gears a little bit, I do want to give a quick quiz about conditional rendering so that we can start thinking less in terms of the code and more in terms of the high-level concept. And then, as I promised, we'll get back to our Chef Claude app and apply what we've learned. Before moving on, let's do a quick quiz about conditional rendering. Just like before, I'm going to put in a pause here. I want you to actually click in and type down your answers. It's a great way to think outside of the specific syntax that we've been working with. So go ahead and answer these questions, and then we'll go through them together. Okay, number 1, what is conditional rendering? In a highly dynamic web application, we often have changing data or changing local state, and we may choose to display something different or not display something at all depending on that state. So one way we might answer this is that conditional rendering is when we want to only sometimes display something on the page based on some kind of condition. Okay, we also talked about 2 of probably the main ways that you'll see conditional rendering being used. One is by using the AND operator. So when would we want to use that? Well, it's ideal for either displaying something or displaying nothing at all. So it's good for when you want to either, yes, display something or not display something. When it comes to either displaying option A or instead displaying option B, that's when, number 3, a ternary is best used. So we can say it's good for when you need to decide which of 2 things to display. And yes, you can use nested ternaries to determine any number of things that you might want to display, but personally, that's where number 4 comes in. What if you need to decide between greater than 2 options on what to display, in which case the world kind of opens up to you. You could use an if, else conditional, and of course in that case you can have as many else ifs as you need. Or you might decide to use something like a switch statement. Or kind of implicit in this answer is basically any other way you might want to do it. Okay, great job on this quiz. Let's finally get back to Chef Claude and apply the conditional rendering that we've learned. All right, that was a long sidetrack on learning conditional rendering, but as I mentioned, it's something you're going to be doing quite a bit, and we're going to apply it right now. In our Chef Claude app, we have the input, and when we add ingredients, let's just say testing, it displays the list of ingredients. It seems like it's conditional rendering, but what's really happening is we have this unordered list that is always being rendered to the page, and it simply has no list items inside of it, which is why it looks like nothing's there. But what I'm going to do is paste in a more finished version of this that includes this ingredients on hand, the list of ingredients like we already have, and then this little call to action at the bottom that says ready for a recipe. So let me go ahead and paste in some pre-written code. We'll walk through it so that it's not too jarring, and we'll see that we are in dire need of some conditional rendering. All right, I replaced our simple unordered list with this new section, and let's take a second to walk through it. I know sometimes if someone just throws a bunch of code up here, it can be a little bit jarring, and I don't want to lose anybody here. First of all, I am going to make this a little bit bigger, just so we can maybe separate those words a little bit. So what we've added into the section first is a little H2 that announces the below list is going to be the ingredients we have on hand. Of course, it's a little bit weird because it's just a colon and then there's nothing after it. We do have our unordered list currently being rendered to the page, but because our ingredients list items is an empty array, nothing is displaying. And then we just have this little call to action that says, are you ready for a recipe? Generate a recipe from the list of ingredients. And it's got this get a recipe button. There's no on click on it yet. We're going to get to that in a little bit. But clearly what we have here is not a great user experience. It's really cluttering up the page with irrelevant information at the current starting point with having no ingredients in our list. Oh, and I almost forgot. I do have in the CSS some associated class names and styles, which is why it looks like it's styled already. Okay, let's apply what we've learned with conditional rendering and make it so that ingredients on hand and this ready for a recipe section don't show up unless there are items in our ingredients list. I'll type this out as a challenge. Just to buy some room, I'm actually going to minimize this for now. If we want, we can bring it back up or even make it really large so that we get a little bit better spacing. For now, again, I'm just going to minimize it. Okay, your challenge is using conditional rendering. I want you to only render this entire section if there are ingredients added to the list of ingredients. Assuming you went through the conditional rendering sections that we just finished and were able to do the challenges, this should be a pretty straightforward challenge for you. There's always more than one way to get things done, especially in React. So as long as when you first load the app, this whole section doesn't appear, and when you add an ingredient, it does appear, then you should be golden. Of course, when you do that, the ingredients on hand should have one item in the unordered list. All right, your time to shine. We can know if we have ingredients in our lists if the ingredients array that's being held in state has a length that is greater than 0. And so I will surround my entire section here in a set of curly braces, and I can set up a condition that says if ingredients.length is greater than 0, then I want to display this section. We learned two main ways that we can do this. I think I'm just going to use the double ampersand, and let's see if that's working first. Okay, well, that section is gone, so that's good. Let's hope it comes back. We'll add oregano to our list, and perfect, we get it showing up on the page. As I mentioned, you'll want to be careful when you're dealing with the double ampersand. If you have a habit of not being quite as explicit as using the greater than 0 so that this will actually turn into a Boolean, and you're relying on the fact that ingredients.length of 0 is a falsy value and might short circuit the rest of this, you're probably going to be disappointed. We can see if I hit refresh, I get a 0 actually showing up on the page. So you can either make sure that you're always very explicit and this is evaluating to an actual Boolean, or you can use a ternary if you want to be extra cautious. So you can say if ingredients.length is greater than 0, then display this, but otherwise display null, and we'll see that this is working as well. I can add oregano, that shows up, but if I were to rely a little more heavily on the fact that ingredients.length of 0 is falsy, then I wouldn't actually render a 0. Instead, I would get the expected behavior, and I can add oregano and then get the rest showing up on the page. They're just different schools of thoughts. You can choose whichever one you want. I think I'll go ahead and stick with the double ampersand and simply remember to put my greater than 0 in here. We'll just make sure that's working again. Perfect. Just to really drill this in, we are going to do another challenge, but we will do it in the next scrim. Towards the very end of this project, we are going to be sending this list of ingredients to a real AI API so that it can determine a recipe that we could make given the ingredients that we pass to it. However, if we just have a single ingredient, the chef might not really know what we're supposed to do with that. It also would probably generate a recipe that has a bunch of ingredients we don't have, which might still happen anyway, but try to imagine telling a chef to make something and the only ingredient you have on hand is oregano. However, currently we're prompting our user if they're ready for a recipe by having a single ingredient on there. So maybe for the sake of our user's ultimate culinary experience, let's update our app so that the getRecipeContainer div, which is this one right here, will only get displayed if our ingredients list has at least 4 items in it, because fewer than that and we might just not get very good results. Again, this is super similar to the last one, but I think it does help illustrate a little point that we'll see in just a second. Okay, go ahead and get started on this challenge. We're doing essentially the same thing that we were doing before. We're just going to surround this div in a set of curly braces and put a condition. And that condition is the same as the last one. Well, almost the same. We're looking at ingredients.length, but we want it to be greater than 3 this time. And I'll put my little short circuit and operator there. Let's clean up the challenge text and hit save and give this a try. I'll just add in some oregano, maybe chicken, some jalapenos, and maybe we have some cream of mushroom soup. Awesome. Okay, with the 4th ingredient added, we now have this ready for a recipe thing showing up down at the bottom, and that experience seems a lot more reasonable to me. All right, well, we do still have additional parts of our site that we need to render, including this entire suggested recipe section. So what we'll do is put a bit of a placeholder in its place for now before we start integrating any kind of AI, and later we can replace it with the real thing. So let's jump right in and tackle that next challenge. As you know, once the user has input a few ingredients, they're going to click this Get a Recipe button. That will send an API call out to the Anthropic Claude API, or as we'll see, there's other options as well, and return a recipe that we can display down below. We're not quite ready to reach out to the API, but I do see a chance for us to make some progress in our Chef Claude app that will give us a chance to practice both the creation of state, which honestly it's been a minute since we've done in this course, and some conditional rendering, which you're probably pretty sick of doing by now. So I'm going to give you this multi-part challenge that will kind of be a placeholder for now, and then we'll be refactoring this and building upon it as we make this app a little bit closer to its final form. The first part of your challenge is to simply create some Boolean state. You can call it recipe shown, and it's just going to represent whether or not we've gotten the recipe back from our AI chef. To start it out, you'll default the value to false. Then I want you to go over to recipecode.md, this file here, and you're just going to Command or Control A and Command or Control C to copy the entire contents here. What I've done is taken the response that I've gotten back from an AI when I was testing this out, and I've wrapped it in all of this HTML, or I guess JSX code. So you're going to grab everything here, head back to main.jsx, and down below you're going to paste it in place of this comment right here. If you hit save at that point, it's going to display it on the mini browser, but the next part of your task is to make it so that when the user clicks the Get a Recipe button, it will flip the recipe shown state from false to true, and you'll use conditional rendering to only display that entire recipe code content if recipe shown is true. A couple things. First of all, yes, this is just a placeholder. In the future, we will not be using recipe shown to determine if the content should be displayed or not. Instead, we're going to save the response from the AI in our state, and if that response is not null, then it'll do the same thing. It'll display the recipe content section. Secondly, and this is more administrative, you'll notice that I just hard-coded a few options in here so we didn't have to add 4 different ingredients every time we wanted to click Get a Recipe. Okay, I think you should be all set up to get working on this challenge. It's a little bit longer, it has a few more steps than normal, but I know that everything here should be something that you're capable of doing. So I'll pass it over to you to work on the challenge. All right, first let's create our Boolean state. So I'll do that here. We're going to create recipe shown and use set recipe shown as the state setter function, and that's going to be coming from React.useState. It's just a Boolean and we're defaulting it to false. I'm going to kind of clean these up as I go just to buy a little bit of room. Okay, now we need to go grab the markup in recipecode.md. I'm just going to grab and copy everything. Come back to main.jsx, and it's going to look a little bit bloated, but we'll just stuff it all here inside of this file. And I think I'll do a quick format here. Yeah, there we go. For anybody who is feeling pretty concerned that this file is getting pretty long and trying to attend to a few different needs for our app, you have a very good point, and we are going to be addressing that very soon. But for now, we're just going to have to live with the clutter a little bit. Okay, so that was step 2, copy and paste, pretty straightforward. All right, when the user clicks the Get a Recipe button, I want to flip the recipe shown state to true. I'll go ahead and create a new function. We'll say toggle recipe shown. This will call set recipe shown. It will look at the previous value of shown and flip it to its opposite. We could have also done this as an inline function. It's pretty straightforward, but I kind of prefer this way personally. And now let's come down to our Get a Recipe button and add an on-click handler to toggle recipe shown. Okay, that should be everything from 3, and then we are doing some conditional rendering. So we will surround our entire Chef Claude recommends portion. Let's see, that goes all the way to this section. We'll surround it in a set of curly braces, and we'll say if recipe shown is true, then display this section. All right, let's clean this up, hit save, cross our fingers and hope for the best. We've already got our ingredients there because they're hard-coded in. Let's click Get a Recipe, and look at that, we can scroll down and see the recipe that Chef Claude recommended for us. Or at least the one we're pretending it recommended for us. Well, that's not entirely fair. This actually came from the AI. It just didn't do it right now. Awesome, this user experience is actually turning out pretty great. However, I'd say there are 3 main issues that we have yet to solve, and this is going to set us up for what we're about to learn for the rest of this section. The first one is kind of a developer experience issue that we're experiencing here, and that is what we just talked about. This file has gotten quite long. I mean, in the end, it's only 81 lines of code. That's not actually that bad. I've seen much, much longer React components than this, but it does kind of feel like we're dealing with a few different things. First of all, this whole recipe shown section, it could probably be its own component. And the same goes for the ingredients. Maybe not. I could see an argument for keeping it here, but for the sake of practice, we're going to move this into its own component. I guess we theoretically could do the same thing with our form. I imagine I'm probably just going to keep this the way it is, but we have some cleanup to do so that our code is a little bit easier to reason about. In doing so, we also have some topics to learn that are regarding where state should live in our React component hierarchy, how we can pass state down to the components and still have them be able to change the parent state, and just generally understanding what all that means in the first place. Another maybe more user-centric issue that we're facing is if I'm scrolled to the top here, let's go ahead and hit refresh. I can't scroll down because my recipe section isn't displaying currently. If I click get a recipe, well, I don't have a lot of visual indication that the recipe is ready other than suddenly there's a scroll bar. And so if I start scrolling, then I realize, oh, it actually did respond with the recipe. So that user experience could be improved by having the app simply scroll down for us to let the user know that the recipe is ready for them. We also eventually will want to add some kind of loading state. Currently, clicking get a recipe just immediately displays everything here. But when we're dealing with the API, it's going to take some time for that response to come back, and we want to give the user some visual indication that it is trying to work in the background. And lastly, I guess this is both a developer and a user experience. Well, we want to get the recipe from the real AI API, not just from this hard-coded thing that we currently have. So we've made great progress. Awesome job on the challenges that you've had so far. I hope that you're still keeping up with them. Learning to code should not be a lonely task. You should be reaching out to the super active Scrimba Discord server and asking your questions there, getting help from people. It is totally worldwide, so at any time of day or night, there is always someone awake and active on the Scrimba Discord server. Feel free to play around with the code that you've written here, and when you're ready to dive in, we will first start tackling how we can improve the developer experience by offloading some of this code to separate components. Here we are back at our very simple counter app. I even removed the text that was saying how many times would Bob say the word state in this section. And that's because I just want to focus on the core elements that we need. Now, I'll be the first to admit this challenge is pretty contrived. Essentially, the task is to take this h2 and put it inside of its own component, and then pass our count value through props to that component so that by the time you're done, everything should work exactly the way that it is currently working. Read through the specific directions here that should give some hints as to what you need to do. And I guess before we start, I'll just promise you that this isn't just meant to be busy work. It's actually less about getting repetition and practice in this time and more about building to a point. So go ahead and get started on this challenge. I think I tend to like working backwards on stuff like this. So I'm going to cut out the h2 and render this fictional count component. And we will go ahead and pass it a number prop whose value will be the count that is being held in state. Okay, that does not exist, so let's pretend like it does for a second and import it. We'll just import it from a file that we'll call C count, and we'll create that file, count.jsx, and there it is. We'll go ahead and set this up. We know that we want it to take props. Because we need access to that number prop, I'll go ahead and return, if I can spell it right, we'll return the h1 that I cut out earlier, but now instead of count, I don't have that anymore because I'm not in a file where state is being created. Instead, I'm receiving that state through props, and specifically a prop called number. All right, let's see if we made any mistakes. We'll hit save, and okay, it seems to be working as we would expect. Okay, as I mentioned, that was pretty contrived. A component that just renders an h2 is probably overkill for most instances. I suppose there are times when you want your h2 to always be styled a specific way, and I don't know, maybe have some specific functionality attached to it. But the reason that we did this challenge is because I wanted to take a chance to talk about rendering. Let me go ahead and add a console log, and we'll say app rendered. And then I'm going to do a similar console log inside of my count. Of course, this time we'll say count rendered. We have briefly discussed what rendered means in React, and I don't plan on doing a super deep dive into everything that happens when React is rendering components. But the crucial things for us to understand at this point is when we talk about something being rendered, we can think of it as the function of that component being run. Here we're rendering the app component, which essentially tells React, hey, I want you to go to the app functional component, the function, and just run through the code there, run that function. So if we go to app, we see it's going to be setting up some state. It defines a few functions here that we use within the body of this component. In our case, we also put a console log here. And then we return some JSX, which represents the elements that will eventually get turned to DOM elements that get put on the page. And then it renders JSX, which represent React elements, which eventually will get turned to DOM elements that get placed on the page. And that's what the user actually sees. So let's see what happens when I hit save and open my console. Okay, we see we got app rendered. So the app function ran because our console log ran, so we know that it ran. And our count rendered console log, the one that's here, also ran. And that's because inside of the app component, we are rendering or creating an instance of the count component, which means React ran the count function, and therefore our console log ran. Okay, well, let's see what happens when I change the state inside of my app component. So I'll go ahead and let's click plus and check it out. In our console, we got app rendered and count rendered again. Both of them ran again. So changing the state inside of our app component is rerunning this function, although a really interesting thing to note is that the count value is now updated. It's not rerunning it and setting it back to 0. That's one of the main features of state. It maintains its value from one render to the next, which is happening behind the scenes in React. If this were just a plain function and nothing else special about it, then of course our value would keep getting reset back to 0, but that isn't happening. Not only that, but our count rendered again as well. And let me scroll down a little bit so you can see the instance of the count that we have. And I'm going to insert a pause to give you a second to think, why is it that count re-rendered, even though it was only state in the parent component or the app component that changed? Try thinking through that, see if you can make sense of why the count component re-rendered. Well, intuitively, we probably think, well, it's because it relies on this count value that exists within the app component in order to correctly display the number on the page, whatever the current value of state is. And that is true. It's a bit of a partial truth, but it makes sense if we go to the count component. If we didn't rerun this component with a new value for props.number, then what gets displayed would never update. Now, the reason that I say this is a partial truth, and I'm starting to flirt with the line of going outside the scope of what I really wanted to teach in this course, is because the truth is any components that we have inside of our app component, in this case, will get re-rendered. Whether they rely on the state or not, they will, by default, get re-rendered by React. There's a little bit of controversy about this and quite a bit of misunderstanding. The truth is, even if you have a component that doesn't technically need to re-render, doing so by React is super, super fast, and it's not something that often leads to any kind of performance issues. And if it does, there are things that you can do to improve the performance. Again, that's outside the scope of this course. It's most important to know that if we have a state change inside of one component, like we have inside of our app component, React will re-render its own elements that that component is in charge of re-rendering, and it will re-render all of the child components that are nested inside of the return of this component. If those components have their own children to display, those also will get re-rendered. I go quite a bit more in-depth on this topic in my advanced React course here on Scrimba. So once you finish this course, assuming you are planning on continuing to learn React, that will be a great resource for you. But in the meantime, what we've discussed here is good enough for us and opens a door for us to now start talking about state and props and how they relate to each other and how data gets passed around in a React application. Let's look at a slightly more realistic example than the counter that we just saw. Back in our contact card, if you remember, we had our little star icon and clicking the star would fill it in or empty it out. essentially toggling the isFavorite property on our state object. But let's say we wanted to move this star element to not just be the button with the image inside that we have here, but into its own component so that we could reuse it in other places in this app. So at this point, I'm going to type out a challenge for you to start working on. Okay, your challenge is to move the star image, which is actually this button with the image inside, into its own component, which you'll call star. The star component should receive a prop called isFilled that it uses to determine which of the two icons it will display. As a reminder, you will need to make sure that you take these two import statements and move them into the component that you create, the star component. While you're working on that, I'll want you to get rid of this onClick. This is what I mean here when it says don't worry about the ability to flip this value quite yet. So in doing so, you can actually just get rid of you know what, I'm just going to get rid of onClick right now here. After you've created that star component, here in our app.jsx file, I want you to import and render that component in place of the button element that we have here, and then make sure you pass the correct prop to it so that it will work as we expect, or at least it will reflect the value of contact.isFavorite. So you can switch this value to true just to make sure that that star suddenly fills in. Go ahead and get started on this challenge. I think I've done a lot of working backwards where I cut this out and render a component that doesn't exist. So maybe this time I will start forwards. I'll create a new file called star.jsx, and inside star, actually before I forget, I'm going to import these two lines here. I don't need them in here anymore. So we'll go ahead and import those, and then I'll create my component. I do know that I want this to receive props because I'm going to have an isFilled prop sent to it. And then I'll say return. We'll come back over to app. Let me grab this button and paste it in the return of the star component and format. And we used to be looking directly at the contact object and state, but we are now going to be receiving essentially this value of isFavorite from props. So this will be props dot, and I think we said to call it isFilled. So let me go ahead and change everywhere that we had contact.isFavorite to props.isFilled, and over in app I can now import that component. So I'll just do it right here. We'll import star from /star and render it in place of the button. And I'll hit save. I still need to pass the prop to it, but let's just see. Oh, it's gonna struggle a little bit because I don't have that prop passed to it. So let's go ahead and add isFilled is going to be the value of contact.isFavorite. And oh, nope, I do still have a bug. Let's see. Reference error star empty is not defined. And oh, yes, I have this right here. This line is no longer needed, but I do need to put that logic over in my other components. So let's see, I know what I'm doing here. Let's clean up that challenge and go back to star. And okay, perfect. Right here, we'll paste in that line of logic. And yep, it was expecting star icon, and we're no longer looking at contact.isFavorite. We need props.isFilled. I have star filled and star empty. Let's try again. Okay, cool. Now we get our app back up and running. Or I should say it's partially running because I got rid of my onClick on my button. We can see that clicking the star doesn't actually do anything here. We do need to test it though. Let's make sure we change isFavorite to true and hit save. Cool, our star is filling in. So now we just need to try and think, how are we going to make it so that our nested component, the one that is now inside of the star component, how can we enable the star component to make a change to its parent's state? In fact, I'm going to put in a pause here so you have a chance to think through that. You don't necessarily have to write any code. You're welcome to if you want. But think for a second, how might we be able to add some functionality back to our star component so that clicking it will then change the state that lives here inside of app? I remember when I was first starting out, I thought, well, I just need to add an onClick handler to my star component. And let's just see where that takes us. So I'll go ahead and add onClick, and we'll just pass in the toggle favorite function, hit save, and click the button, and not quite. It's still not working. Why do you think that is? Take a second to think, why is it not yet working for us? Remember how the properties that we're adding to our JSX elements map directly to the DOM elements that exist in JavaScript? In JavaScript, elements that we pull from the DOM, they have a class name property that we can change. And DOM elements like an H2 or a regular button or an image or any of these regular DOM elements, they also have a DOM property called onClick. Well, we're not quite directly working with a DOM element here. We're working with a custom component in React. Any of the properties that we put on our custom component in React, they're chosen by us. And so despite the fact that we named this onClick with a capital C just like we would if it were a regular bare DOM element, or in this case, a React element because it's JSX, which gets turned into a DOM element, this onClick is simply going to be yet another prop that we need to receive inside the star component so that it will work. This onClick is just another custom property or prop that we're passing to our star component, which we would then need to receive as one of the props in order to actually do something with it. Inside of my star component, this is where my regular React element of the button that I want to add an event listener to exists. So in order to get the onClick here, I need to put it on top of my button. So I'll go ahead and use onClick with the capital C, and the value that I'll pass to it is the function that I'm receiving through props called onClick. One thing that I sometimes do to clarify exactly what's happening here is I'll go to my custom component, and instead of giving it the exact same name as what would be placed on a regular DOM element, I might change it to something that's obviously more custom, like handleClick. Doing so won't magically fix it. I need to come over to my star and realize that I'm not receiving a prop called onClick anymore. I'm receiving a prop called handleClick. So I'll change this to handleClick, and let's just see what happens. I have my star, I click it, and it empties out. Awesome. We've talked about how we can pass any JavaScript data type down through props, and functions, like we're doing here, are no exception. We're passing this function down to our star prop so that we can put it on the native element, this lowercase b button element, so that it can correctly listen for the click event and run this function. Running this function will still interact with the parent's state in order to change it. So over the next few lessons, we are now going to dive a little bit deeper into state and props, the React hierarchy, and what the component tree looks like, and all kinds of really fun stuff. We'll get lots of chances to see different ways that we can structure our state and our props. And as a reminder, all of this is bringing us back to our Chef Claude app where we had kind of a long component and a desire to move some of those sections of the component to their own individual components that then get rendered by the main parent component. So without further ado, let's jump in and start seeing how React handles state and props and the component tree. At this point, I think it's helpful for us to look at how we pass data from one component to another in React. Let's look at a sample diagram of a React application. We can imagine that the rectangles closer to the top represent parent or grandparent components, and the lines simply represent that that component is rendering an instance of another component below it. The name of these components isn't important. In this example, the name of these components isn't that important. It's just important that we understand the hierarchy that's here. As you're building your application, you might realize that this bottom component here is in need of some state so that the user can change something and React will re-render that component. As you continue building, you might also realize that there is a sibling component, or in other words, a component that is also being rendered by the same parent that is also in need of the state that you just created in its sibling component. We're going to do a challenge in this code in just a second, but this is a perfect example of this. In our index file, we're rendering an app component. The app component is rendering a header component and a body component. And as we were building this, in the header component, we initialized some state for our current user's username. We set it equal to Joe, and that's what's being displayed up here in the upper right. However, as we started building out our body component, we realized that we need access to the currently logged in user so we can fill in this text where it says, welcome back, and then blank. We want this to say, welcome back, Joe. So think for a second, is there any way that we are able to pass the state that we created from this component over to its sibling component? Well, as it turns out in React, no, we can't. This isn't how data flows in React. In React, data can only flow downwards. It only works in one direction, from a more parent component down to children components. So take another second to think, how could you make it so this component that is currently saying data please can get access to the state from its sibling component? Because data only flows downward, the easiest thing that we could do is simply to bump that state up to a parent component and then pass that information down through props. This way, both of these bottom-level components can have access to the information that it needs. Well, what will inevitably happen as you continue to build out your app is you'll find that you have yet another component that needs access to that information. And once again, we find ourselves being unable to pass information from the component that we just gave state to its so-called sibling component that now needs access to that state. And it's important to note that we certainly can't go from any child component up to I guess you could call this an aunt or uncle component, because there's not even a reference in the code from this bottom component to any other component in the hierarchy. So this also is not something that we can do, which means, once again, we are forced to pull our state up to a higher level and pass down through props to the components that need it the information from that state. As you can imagine, this can get a bit cumbersome over time, and there are a number of different solutions that can help us avoid having to pass props many levels down. Tools like Context, which is built into React, or third-party libraries like Redux or ZooStand, which were created to help this data management problem. All of those topics are outside the scope of this course, and so we are just going to be sticking with state and props. However, I can offer a little plug for my advanced course here on Scrimba, where we do dive into context, and we learn how we can use context to avoid having to drill props through so many layers of our component tree. So let's apply what we just learned about moving state up and passing its information down through props by working on a challenge. Here we are in our header component, which is currently the location of the state that we created for our username. Your challenge is to raise this state up a level and then pass it down to both the header and the body components through props. And then the last part of this challenge will be to make it so that in the body component, we aren't looking at this blank space here, but instead we're able to render the username in its place. Go ahead and give this challenge your best shot. In this hierarchy, we can imagine that this box right here is the app component, and it is rendering the header and the body. But right now, our state is living down here in the header. So as we saw, we need to lift that state up so that it will live in the app component. Let's go ahead and cut this state out. We'll go over to the app component, and we will just put it right there. And I had already imported React from React in these components, just in case you wanted to play around with putting it in different locations. But at this point, we can get rid of those. And I guess while we're here, we'll clean up this challenge text too. Okay, let's come back here where we just put our new state, and we can pass that state down through props. We'll just maybe call it a prop of username, and we'll set it equal to the value of username from state. And now let's see what happens. I'm going to hit save. I'm probably going to get an error that talks about how username is not defined. So we can go through and fix those. In our header, we are referencing username, but we don't have state here anymore. Instead, we are going to be getting this from props. So I can just add props.username in its place, and let's see if that works. Yes, our header has Joe in it. Let's go over to our body. We will also accept props here. And once again, instead of these hard-coded underlines, we are going to get props.username. Moment of truth, hit save, and perfect. Our body also says, welcome back, Joe. We can also double check that this is working by changing Joe to something else like Bob. And perfect, it changes in both locations with only one state change. Understanding that data flows in a single direction, and that direction is always from parent to child components, or downward in the tree, can be extremely helpful for you as you start working on architecting your React applications. I think the last important thing to touch on with this before we move on is to know that it's best practice to keep your state as locally defined as it needs to be. In other words, if this component down here on the bottom were the only one that needed state, then that's a great place to put state. If its sibling needs access to that state, then moving it up just one level is the best way. It might be tempting to think, well, I'm going to stop refactoring this. I'm just going to shove my state at the top of my application and then pass it down as many levels as I need to. But as a rule of thumb, that's generally not a good idea. And if you do have state that is truly global across your entire application, that's usually the time to start looking at one of those alternative solutions that I mentioned, like Context, Redux, or ZooStand, or something like that. Okay, with this under our belts, I think it is time for us to do a round of challenges to help us really cement in what we have been learning about when it comes to props and state in React. This is the beginning of a series of challenges that we are going to work on so that we can reinforce what we've learned in the past up until now, and so we can prime ourselves to learn some new information. And we're just going to be building a silly little series of buttons that actually was inspired by my Rodecaster Pro, which is what I use for mixing the sound from my microphone. And it has these 8 buttons over on the right side that are kind of fun pastel-y colors. And they are just for doing sound effects. I literally never use those buttons, although I think they're programmed with sounds. Let me see what they do. The funny thing is, while this is recording, I actually can't hear what it's doing. So I'm going to turn that off. We've got some funny sounds over here. The point is, when I press these buttons, they light up. And when you press them again, they turn back off. And so that's the inspiration for the project that we're working on. The first part of this challenge is first to initialize some state with a default value that is the array of pads that were pulled in. I called them pads because they're technically called sound pads. So don't let that be confusing. If we go to pads.js, where we're pulling this in, it's an array of objects. They have an ID, a color, which we're going to use eventually, and an on value, which we're also going to be using eventually. For the purposes of this challenge, you should find yourself only needing access to the ID, although I'm not going to tell you why yet. That's going to be part of your challenge. So you'll be creating some state inside of this app. You'll initialize the value of that state with this array that we're importing. This is honestly kind of a strange thing to do. We're going to see exactly why we're putting it in state later. But then what I want you to do is to map over that state array and to display each one of them as a button element. I've already written some CSS for you, so it should show up in a 2x4 grid. And as it mentions here, don't worry about the on property or the color property quite yet. Once you've mapped over that array, you'll put the elements right here, or I guess if you want, you could just map over it right here inside of the markup. So go ahead and give this one your best shot. All right, first things first, let's go ahead and create some state. We'll call these, I guess, pads, and we'll use setPads as our state setter function. That'll be equal to react.useState. Of course, I need to import React in order for this to work, so let's do that. Not improt, let's import React from React and initialize this with the array of pads. Okay, that is part 1. Part 2, let's go ahead and create some, I don't know, maybe we'll just say button elements. And that will come from pads.map. For each pad, I'm going to return a button element. I'm going to use a set of parentheses so I can do an implicit return on the next line. And we'll bring in our button. And one thing I always find myself forgetting to do is to actually render my elements after I have created them. So let's go ahead and do that now. We're going to have a little error, or a warning, I guess. Oh, you know what? Pads 2. That's funny. I chose a bad name here because that's exactly what I'm calling my objects coming in. You know what? You probably chose a different name for this. I'm actually going to change the name of this one to pads data, just so that I can still call this pads inside of my component. Okay, let's see if we hit save and get the warning I was expecting. Yeah, each child in the list should have a unique key prop, and that's because we're mapping over it. We need to make sure that we provide a key. And fortunately, I gave you the IDs for each one of these. So that's what we'll use in this case. Because we manually did it, we know that they're unique. So let's give that an ID, or a key of pad.id. We'll hit save. That warning goes away, and awesome. Okay, this is really just to partially reinforce what we have been working on up until now, and also to set us up a little bit more to learn about state and some ways in which we will oftentimes find ourselves dealing with state inside of a React application. Great job on this challenge. Let's jump into part 2. Okay, sorry if I led you astray. Before we move on to part 2 of this challenge, we actually need to spend a little bit of time to finally learn about inline styles in React. This isn't something that we use terribly often in HTML, but in HTML, you can provide an inline style directly on your HTML attribute. by using the style attribute. Whatever I put inside of the quotes, inside of this text, will get rendered by the CSS engine. And so I could say something like background dash color colon, and I don't know, let's do something crazy like red. Okay, I'll hit save, and we see that it's applying. And actually, this inline style is taking precedence over the CSS rule that I already have, changing the background color of the body. Let's go ahead and undo that. It's a little bit of an eyesore. We'll hit save. Okay, that's a little better. We can do a very similar thing in our React code. Anytime we have a JSX element that is going to be turned into a native DOM element, basically anything that is a real HTML element, we can pass a style prop to it. However, because we're in JSX, we're not going to set this equal to a string where we say something like background-color, but instead we're going to set this equal to an object. Now, I have found this to be a tricky thing for beginners in React. If you remember, when we do a set of curly braces inside of our JSX, it first puts us into JavaScript. So this is not setting it equal to an object. It's simply saying, I want you to evaluate some JavaScript inside here. The JavaScript that we want to evaluate in here is an object, and so I need my second set of curly braces. In fact, sometimes what I end up doing, just to avoid that confusion, is I'll create a separate variable, let's call it styles, and set it equal to an object, and then replace that kind of silly double object looking thing with my object that I defined elsewhere. You definitely don't have to do it this way. It might not be that confusing to you to just have your object nested inside, but let's just see what it looks like this. Now, I'm creating this object in JavaScript, so if I want to access the background color, an important thing to remember is that I need to use my CSS properties as the camel-cased version of those properties. First of all, because, well, it won't make sense for us to have a key that tries to do background-color, but perhaps more importantly, we need to remember that we are working inside of a JavaScript file, even though it looks like we're typing HTML. If you remember, in regular DOM JavaScript, if we wanted to get an element, we'd say something like document.getElementById something. And if we wanted to alter the style of that, we would say .style, and then we could access the background color property of it and set it equal to something. The reason this is camel-cased is because that's how they have it set up in DOM JavaScript. And so I need to camel-case my CSS properties. I think you understand that. Let me go ahead and get rid of that. And let's just see that this is working. Well, remember, we're styling the button elements right now. So if I change this to the string red, awesome, we get our red buttons. All right, well, in this case, we're just hard coding a color to change the background color of these buttons. However, usually in React, you'll find yourself doing something like this, adding an inline style, when you need it to be something that's more dynamic. Let me show you an example. I'm actually going to clear out the button styles there, and we can just get rid of this object. And I'm going to set up a little challenge for you. And I want us to imagine that we want to enable a feature for our app that allows it to receive maybe a prop called dark mode. Let me actually put these on their own lines just to buy myself some room. Okay, so here in our index.jsx file, this is where we're instantiating our app component. And let's go ahead and imagine that we are adding a dark mode feature to our app, and we want this to either say true or false. Let's go ahead and say true for now. And we will come over to our app component, and we'll make use of that incoming dark mode prop to change the background color. And, well, really, I mean, that's something I want you to do, so I'll type this out as a challenge. Okay, these are still red from the previous time we refreshed. Let's go ahead and change it or save it so that it updates. And your challenge is to use a ternary to determine what the background color of the buttons should be based on the incoming dark mode prop. If it's set to true, then set the background color to this color. And if it's false, then set it to this color. Go ahead and get started on this challenge. Well, we're passing a dark mode prop to our app component, but we are not receiving it at all. So let's go ahead and grab props. And you know what? As a reminder, I think what I'll do this time is I'm going to destructure this immediately and just grab dark mode directly from the incoming props object. Either way is totally fine. I just wanted to remind us that this is an option. Let's go ahead and create our styles object. We also could have done this inline directly here in our button. And we'll change the background color camel cased. 2, and then we'll take a look at dark mode. We'll use our ternary here. We'll say if dark mode is true, then I want it to be this color. And otherwise, we'll have it be this color. Lastly, I need to include my style attribute here, and we'll set it equal to the styles. Let's clean up this challenge text, hit save. Okay, so they are dark because dark mode is set as true. And if we come over here and change it to false, they are light. Awesome. Hopefully you can start to see that this can be applied in a lot of different ways. The way that we've done it here is pretty simplistic. We're going to apply this idea to our SoundPad over the next couple lessons, and we're also going to see how we can do dynamic class names. Feel free to play around with this and just experiment with the different kinds of things you can do dynamically with your styles. For example, maybe you make it so that if there's an even number of pads that are coming in from pads data, then they display in one color, and if it's an odd number, then you display it in a different way. I don't know. The world is your oyster. Doing stuff like that, though, is one of the best ways to just explore what's possible. Really, exercising your curiosity is going to be one of the best ways that you can learn. So play around as much as you want. When you're ready, we will move into part 2 of our SoundPads challenge. These buttons are looking a little bit boring, especially if we compare them to the buttons on the Rodecaster Pro that are nice and colorful and bright. So let's address that now. Your challenge is to first create a separate component that we'll just call pad and replace this button element with that new pad component. I want you to pass this pad component a prop called color, whose value will be the color property from our pad objects that we have. And inside the pad component that we're about to create, I want you to apply an inline style to the button. And maybe that wasn't entirely clear. When you create the new pad component, you're going to take this button, and that's what will be returned from the pad component. I want you to apply an inline style to that button so that it can set the background color of the button to the color that we're passing to our component. We're not yet dealing with the on property. We're going to be doing that soon. You might have to read through this challenge a couple times. There were some things that I skipped out on to give you a chance to figure them out on your own. And so I'm going to pass it over to you now to work on this challenge. All right, I'm going to copy this button. We have a bit of change to make. We'll create a new file called pad.jsx. In that file, let's go ahead and set up our component. Since I copied that button, I'll go ahead and return that directly. And I'm going to remove the key because I'm not going to be doing any repetition here inside of the pad component, but instead we'll be doing that in app.jsx. Let's go ahead and import our pad from the file called pad. And we'll replace our button with an instance of this pad component. We don't need a closing tag here because it's going to be self-closing. And yes, the key can stay on here. That should fix the issue with needing a key. Actually, I'm trying to think if this would be broken. Let's hit save and okay, yeah, we've got our buttons on the screen. Okay, so that is number 1. Number 2, let's pass the pad component a prop called color. Okay, let's do that right here. Color is equal to pad.color, and we are passing the pad component a color prop, but we are not receiving it at all. So let me go ahead and receive props. And we could either do our inline style. Actually, yeah, let's just do our inline style right here on the button. We'll set style equal to an object, and that object needs to be inside of the first set of curly braces. Also, it's important to remember that we don't want to call this styles or something else weird. Currently, we're dealing with the actual button element, so we need this property to be correctly spelled. Okay, inside this object, I'm going to set the background color equal to props.color. And before I hit save, let's go back over to app. We'll see how we're doing. We passed the color prop, and we applied it inside the component. We'll deal with on soon. Okay, let's clear some of this text out and cross our fingers. We should see a little bit more of a colorful display here. All right, let's hit save, and that looks so much better. Sorry for any of my OCD friends who are wishing that the order was exactly the same. I'm kind of feeling that pain too. Well, the order is the same, it's just in a different orientation, and the way that I marked down the buttons was left to right and top to bottom. I don't know. I did it in a weird way. I'm sorry. Still, our buttons are looking great. In the next part of the challenge, we're going to finally make use of that on prop and apply something similar to our dynamic styles that we have, but instead, this time it will be a dynamic class name. So once you have made sense of what we've done here and you've had a chance to play around in the code, let's jump into that next part of the challenge. Oh no, our buttons are not lit up anymore. And that's because I added some CSS that turns them off by default. Or in other words, it just adds this opacity of 0.1 by default to the button. However, I did give us a way to include an opacity of 1, and that is if our button is to have an on class name. Let me bump this up here, and we'll see if the button is supposed to be on, then it will have this full opacity and the colors will be nice and bright. But I need you to work to make that the case. So part 3 of this challenge is to update the code so that if the button is on, or in other words, if the data says that on is true, then the button should get a class name of the string on. This is even a little more vague than last time, so I'm hoping that you've been paying attention and doing the challenges. If not, that's okay. Go back, try them again. It should be a good primer for this challenge. So I'm going to insert a pause here, and you can start working on challenge part 3. In order for this component to know whether it's on or off, we have to pass that data in to our pad component, just like we did with the color. So I'm going to add a new prop called on and set it equal to the value of pad.on. Remember, this on property is coming directly from the pad's data. Well, maybe I should say indirectly from the pad's data. We're saving pad's data in state as this value of pads. That's going to be the same thing. We're going to talk about why we're doing that really soon in an upcoming lesson. And so this pads is the array of objects, and we're mapping over it, so each one of them has an on property. We're passing that down to our pad component, so let's go ahead and receive it in props. And we can always do something like console log props.on just to make sure that's coming through. And we see that we did get 8 instances of this console running because we have 8 instances of our pad component. And if we were to map this closely to pads.js, we'd see that it is in order as we would expect. Okay, let's close the console, get rid of this console log. And in order to add a dynamic class name, I can access the class name prop that I would pass to my button, or attribute, I guess, that I would pass to my button. But this time, instead of hard coding a class name here, I can evaluate some JavaScript. There's a few ways that I could do this. I could say, first, I need to check props.on, and if that's truthy, or true in this case, then I want to add the string on as my class name. Otherwise, I guess I could do an empty string. This should work, so I'll hit save, and awesome. Some of our buttons are turned on, and let's see, it's buttons number 1, 3, 4, and 8. If I were to come here, we'd see that 1, 3, 4, and 8 are the ones that matches perfectly. Okay, now instead of an empty string, just for information's sake, I could put null here, and that would work as well. Now, some of you may have tried to use the double ampersand, as we learned in conditional rendering, to only include the string on if props.on is truthy. And let's see what happens. I'll hit save. Our buttons are working, but let's check out our console. It says that it received false for a non-Boolean attribute class name. Remember, when we're using this double ampersand, if this is a falsy value, it will return whatever that value is. And in this case, it returned false, and so it's like we were setting the class name to false, and React wasn't super happy with that. In fact, it even has a super helpful message that says, if you used to conditionally omit it with the class name condition double ampersand value, pass class name condition question mark value, otherwise undefined instead. And oh, that's an interesting way to do it, using undefined. I guess since the documentation or the warning says to do that, maybe instead of using null, we'll go ahead and just follow what they said. I think null would also work just fine here. All right, let's hit save. Our warning's gone. Awesome. Great job by the React team for including such a helpful warning. Great work, my friend. Again, play around with this code as much as you want, and when you're ready, believe it or not, we still have more to learn with these sound pads. Over the next 2 lessons, we are going to be seeing 2 different ways that we can architect this silly little app that we're making. With regards to having multiple of these pad components and having some state that controls whether or not they are turned on or off. We're receiving their initial values through this array here, but we do want the user to be able to click them and have that on value flip from true to false or false to true. So in this lesson and in this challenge, we're going to see one possible way that we could do this. And in the next lesson, we'll see another way we could do it, and we'll talk about which one is likely the better option for us. So what we have right now, and I've created this diagram to make this a little easier to comprehend, we have our app component, which is where we are importing our pads.js data. We're mapping over that array of data, which in this case I've simplified to only show an on property. We're mapping over that array and we're creating our pad components. Of course, we have 8 of them. This diagram has 4 for space's sake. And as we're mapping over the array of pads, we are passing down to it a prop called on, which passes the correct Boolean value down to each of these components. Those components are then using that on value to determine whether or not the class name of on should be displayed. And we can see we're doing the same with color, but let's just focus on for now. The first option for how we can have these pad components control their own on state is by initializing new state in each one of these components. We would then take the value of props.on that's coming in from above from our app component and set that as the initial value in our state for each one of these components. Then we would have a function defined inside of the pad component code that would allow it to flip its own value from true to false or vice versa. Of course, because we are rendering multiple instances of this pad component, each one would have its own state, which React would be keeping track of, and clicking each one individually would change just that one component's value in state. So let's implement this by working on this challenge. Your challenge is to create some state inside of the pad component, which will control whether it's considered on or off. To initialize the state for the initial value of that state, you'll use the incoming props.on value. Then you'll need to create an event listener so that when this pad is clicked, it will toggle from on to off, or of course the other way around. And by the end, everything else should already be set up so that clicking the pad itself will make it flip and you'll be able to turn them on and off, each individually. So go ahead and get started on this challenge. We need the useState hook from React, so we're going to import React from React. And let's just initialize it right here. We'll just say this is going to be on and set on is equal to react.useState. And the initial value is not just going to be me deciding to hardcode something, but instead we're going to set it as the value of props.on. Let's clean this challenge text up. I already know what I need to do. So I'm going to have a function that I'll choose to call toggle, and it's simply going to call the setOn function. It will need to know the previous version of it and just flip it to the opposite. So we'll just say the opposite of prev-on. And then I will add an on-click handler to my button, which calls toggle. Fairly straightforward how we have this set up. At least let's hope it works. I'll go ahead and click these. And oh, of course, I missed one last thing. I don't want to be looking at props.on. I just want to be looking at the local state of on. Let's try that again. And awesome, look, everything's working, perfect. Okay, well, this seems pretty darn straightforward. So why would I care to try a different way of doing this? As I mentioned, there's more than one way we could approach this problem. There's probably more than just 2 ways even, as there very often is in web development and programming in general. So in the next lesson, I want to see another way that we can structure this. And my goal here isn't to first teach you a bad way of doing it and then teaching you a good way. It's simply to help drive a point home when it comes to the interaction between props and state and just architecting React applications in general. As always, play around with the code as much as you need to in order to understand what we just did. If you want, it doesn't hurt to scrub back to before I did this and try it again on your own from scratch. When you're ready, we'll move on. There's actually a name for how we set this up in the last lesson, where we're taking an initial source of truth, this array, mapping over it and creating components, passing information to that component through props, and then the most relevant part to what we're talking about here, setting state based on the initial value of the incoming props. And then, of course, the reason that we would set state internally is so that this component would be able to change that state. The name of that is called derived state, which makes sense. It's deriving its initial state based on incoming props. Well, as it turns out, you probably don't need derived state. This is a screenshot from the legacy React blog, and you can see in a couple places it warns you that this is an old version of their blog, but in reality, the information on this page still holds water pretty well today. You can click on the screenshot if you want to read more about it, but we're going to be talking about the biggest problem with derived state, which is that you can end up with multiple sources of truth. You see, the way that we have this written, we have the state living in the app component, which is supposed to represent the current state of all of the pads. But in reality, once we derive state inside the pad and allow it to update itself, as soon as any of these pads gets clicked, it's going to be out of sync with the parent state that we had. And because of that, we have two different sources of truth. On its face, this is probably the most straightforward way to get something that looks like it's working. So I can click these, they appear to be updating just fine, and maybe that's all the features we want, at least for now. However, because we have two sources of truth, certain potential features in the future suddenly become a little bit more difficult to add. For example, let's imagine that we wanted to include a button down here that simply said, turn all of the pads off. Because this exists outside of the individual pad component, it would be here in the app where we'd add that button, maybe just right here down below the rendered array of pads. However, actually implementing this feature would involve some kind of crazy seeming workarounds. And that's because if we were to simply set pads and turn every one of those pads off, well, our pad components wouldn't care. They're not making use of this pads array state. In fact, let me take a second to implement that feature, at least how it should be working if everything were working the way we'd expect, just to, I guess, prove a point that it's not going to work. Okay, so here I've included a button that says turn all off. Clicking the button right here will run this turn all pads off function. That function is running this console log just so that we can see that it's running. And then it's calling set pads, which if we look is the first time we're calling set pads and updating this pads array in state. It looks at the previous array of pads and then it maps over them and basically says, just give me all the data from the previous pad, just so we don't lose the color and such. But then it changes on to false for all of them. Let me hit save. We'll click turn all off and we can see our console log is running, but of course our pads are not turning off. Don't worry too much about the implementation details of this function. We're going to be writing something very similar to this. But the point I'm trying to make is if we need any kind of control over all of the data in these pads, then we are going to be better off structuring our code in a different way. So what we're going to do is we're going to remove the state from the individual pad components. And as such, they won't need to update their state. So we'll be able to get rid of those toggle functions. And instead, we're going to make use of the state that already exists inside of our app. Then we will still create a toggle function inside of our app, which gives us the ability to toggle one of the objects in this array, and will update the local state of this array inside the app component by using setPads. Because we're updating this local state, it's going to re-render all of the pads, and almost all of them will receive the same on prop that they received before, except for the one that got clicked. The way we'll know which one got clicked is by passing this toggle function down to each of the pads. When the pad gets clicked, it will send a signal up to the parent component. It will tell it which pad got clicked based on some ID number that we'll pass to it. The toggle function will update that one item in the array, everything will get re-rendered, and that one item in the array will then be different from its previous value, and so it will flip. Now, believe me, I know this sounds more complex, and that's because it is. However, this is the best practice in React when you're dealing with state in this way. It's better to have a unified source of truth, because now we don't have a separate source of truth on each pad. They are simply reflecting this single source of truth that exists in state on the app component. Now, I'm going to give you a challenge that will get us part of the way here, and then we'll be working through the actual implementation details of this toggle function together. So let me go ahead and first I'm going to get rid of this turn all off code, and then I'll include a challenge text here. Okay, your challenge is to first create a toggle function, and for now, all it needs to do is log clicked to the console. Then I want you to pass that function down to each of the pad components and set it up so that when that individual button gets clicked, it will run the function that we passed to it. All right, I'll hand it over to you to work on this challenge. All right, let's do this. We'll create a function that we call toggle, and it's just going to console log clicked. Then when we're mapping over our array of pads data, we will add, let's just call the prop toggle, and we'll set it equal to the function toggle. Okay, we'll head over to our pad component, and now we're receiving a prop called toggle. And well, look at that. That's the same function name we gave it here. Let's go ahead and delete this, and then instead of toggle, this will be props.toggle. We're going to lose the ability to flip that state, but that's okay. Let's go ahead and click it, and okay, we're getting our console log running. So this has been a great way for us to get a high-level overview of the approach we're going to take, but it feels a little bit like the scrim has gotten long. So in the next lesson, we're going to talk about how we can implement this toggle function so that instead of just console logging clicked, we can make it toggle the state of the button that was clicked. We're currently passing the toggle function, which we defined in our app component, down to every instance of our pad component. Currently, all it's doing is console logging clicked, and that is definitely working. Of course, that's not the ultimate goal. Now, one thing that's important to note is that each of these pad components has access to props.toggle, the toggle function that we're passing down to it. But because this toggle function is defined in the parent component, there really is only one toggle function. It's not like we've duplicated this toggle function 8 times, which means there isn't any built-in connection for the toggle function to know which button triggered this function. I think technically we could try to grab the event and use something like event.target to figure out which button it was that caused the click event. But as you become more experienced in React, you're going to learn that accessing DOM nodes like this is kind of a code smell. It just doesn't feel right. It's not really the React way to do this. So let's say in our toggle function, we receive the ID of which button was clicked. Then we would be able to look through the array of our pads, find the one with the ID that was clicked, and flip its on value to the opposite of whatever it used to be. In fact, sometimes what I like to do is write this out as sort of pseudocode or comments in this case. So we'll say map over the pads array. If the current item has the same ID as the one passed to this function, flip its on value. Okay, so let's start thinking about this. We're passing the toggle function down, and if we come to our pad component, we have a tiny roadblock. First of all, I can't just say, well, now I want props.toggle to take a parameter, because if you remember when we first learned about event handlers, we don't want this set of parentheses here. It's going to call it as soon as this function runs, so I'll hit save. And oh, of course, I got rid of my console log to demonstrate that. Let's say toggle function. Okay, let me hit save. Okay, we see that immediately, without me even clicking it, it ran this props.toggle function. That's not exactly what we want. And I guess a second problem is even if we could do this, we don't get to choose what gets passed as a parameter to our event handler functions. This is something that's built into the DOM. It will always be the event that gets passed to these functions. So how can we work around this so that we can pass an ID? We don't have this ID defined anywhere. We're going to get there in a second. But how can we write this so that we can pass an ID to this function instead of it automatically receiving an event object? Well, a super easy way to work around this is to say, I'm going to create an anonymous inline function here, and this is the function that the event handler will run. This is the one that will receive the event as its parameter. I don't need this, but the only thing this function will do is run props.toggle. And now, because I'm outside of the event handler function, I can pass whatever parameter I want to this function. Okay, so all we're missing now is this ID, and then of course the code for the toggle function. How can I get access to this ID? Well, you might be thinking, hey, we're passing the ID down through this key prop. Well, there's one little problem. Let me come here and console log props.key, and I'm going to get rid of my console log for the toggle function. We'll hit save, and we get an immediate warning that says, hey, key is not a prop. You can't access it. It's going to be undefined, so don't try to do that. If you need to access the same value, then you should pass it a different prop. Okay, so we can't access props.key, but of course, nothing is stopping us from passing another prop. Let's call it ID, and we'll pass pad.id just like we did with key. Now over in my pad component, I can console log props.id, and I get my 1 through 8. These are the ID numbers of these 8 color pads. Perfect. So now instead of passing the ID, I can say props.id. We'll get rid of this console log. Let's go over to our app and console log the ID that we're passing to this function. Hit save, click it, and look at that. That was number 6. 1, 2, 3, 4, 5, 6. Perfect. Should be 1, 2, 3, and so forth. Awesome. Everything's working. And now inside of our toggle function, we have access to which of the elements in our pads array was clicked. And we can start executing our plan here. And you know what? I was planning on doing this one for us, but I feel like I've been talking for way too long. So I am going to type this up as a challenge. All right, we're stepping up our game a little bit. I did briefly show you an example of what we're going to be doing here earlier, but I definitely didn't expect you to memorize it, so this is going to be a bit more challenging of a challenge than we've done before. But don't let that discourage you. I know that you'll be able to do this. It's definitely one of those opportunities where you might want to turn to ChatGPT or Claude or some coding assistant, or ask in the Scrimba Discord community if you need a little extra help, as opposed to just skipping ahead and watching me do all the work. You could say it's where the rubber hits the road. This is really where the progress is made. And I did try to give you a little bit more step-by-step instructions instead of being vague like I've done before. So the overview of the challenge is essentially to make everything work again, but the steps to do so is I want you to call setPads and update the state of the one pad that was clicked based on its ID. To do that, you're going to map over the previous pad's array, and if the current item that you're iterating over has the same ID as the one that is passed to this function, then you're going to return a new object with all the previous values staying the same as they were. If you need to refer back earlier in the section to how we update an object in state, this would be a good time to do that. Make sure you return a new object where all of the other values stay as they were, but the on value will be flipped to the opposite of what it was before. If the IDs don't match, then just return the previous item as it was, completely unchanged. Take your time with this one. It's completely okay if this takes extra time, extra brain power. It's completely expected. I know you can do this one. I'll hand it over to you to work on this challenge. All right, let's clean this up to buy ourselves a little bit of room. The first thing I'm going to do is call setPads. I need to know what the previous array looked like, so we'll say prevPads, and this will be an arrow function. And I think the thing that makes this more challenging than some of the other challenges is that we're going to be then calling prevpads.map. And whatever we return from prevpads.map is the array that will replace the original pads that we had, thus setting state and re-rendering all of the pads in this array. But the part that makes this tricky is .map also takes a callback function. And so because I'm getting tired of seeing the word pad, let's maybe call it item a little bit more generic this time. And this is going to be another callback function. Well, actually, I'm going to open this up on its own line here. All right, so now that we are looking at the individual items within the previous pads array, this is where I can start to look to see if item.id is equal to this ID that's being passed into toggle. And if you remember in the instructions, it said, if the IDs match, then return a new object where the on value is flipped. And if it doesn't match, then just return the item as it was before. Well, if we think about it, this is a perfect time to use a ternary. And it might get a little bit long horizontally here, but what we can do is return, and then we'll check if item.id is equal to the ID passed in. And if it is, then we're going to return a new object that has all of the properties of item, but where the on property is the opposite of item.on. This should look very familiar. I think the structure might be a little bit different, but this is very similar to when we were updating our contact card as we were learning about updating an object in state. We're getting an error because we need to finish off our ternary. If the IDs do not match, then we can just return the item exactly how it was. We don't need to make any modification to it. If you're relatively new to software development and maybe new to JavaScript in general, this might look kind of crazy to you. But trust me, if you take the time now to think through how this is working, and the longer you are writing code, the more easily your brain will simply be able to make sense of what's going on here. This is not a terribly uncommon thing to happen in React, and there certainly are other more verbose but possibly easier to understand ways to write this, but I promise it's going to be best to just take the time to understand what we've written here. Maybe before I go too high up on that soapbox, let's make sure that this is working. Okay, moment of truth. All right, and there's one more thing that probably made this challenge a bit tricky. We can see I'll hit save, I'll click one of these, and geez, it's not quite working yet. Let's go over to pad and see if we can debug it. Well, notice first of all that we still have our state that we're using, and we're using that state as the expression that should be determining whether or not the on class is added. So let's get rid of this state. I'm sorry if that threw anybody for too big of a loop. And we'll change on to props.on, the version of on that's being passed from above now. And let's try again, hit save, cross your fingers, and click these buttons. Perfect. Now, I know that we wrote a lot of extra code, especially compared to the way we were doing it before, where each pad component had its own state and its own way of updating that state. However, now we're set up in a much more React-like way, where we have a single source of truth. That data flows in just one direction. It passes down through props to the components that need it, and those props can trigger changes through these callback functions, or these functions being passed through props, which will trigger a change to the main single source of truth in the state of the parent component. I completely understand if that seems absolutely crazy, but do remember, if we now wanted to add a feature like, for example, a button that said turn all of the buttons off, we could do that really easily. We would just have a button. When we click it, it would do something very similar to this, except instead of checking if the IDs match, it would simply return what we have here, but a hard-coded false. And that's it. It would change every item in the pads array, and by changing this state, React would automatically react to that change, updating our button elements and thus displaying new buttons on the page where they're all dimmed and turned off. All right, we've made some great progress when it comes to our understanding of state in React and props and how the two can work together, where it's best to keep your state. Although there's a lot more to talk about with that topic, we are long overdue to get back to our Chef Claude project and find some ways that we can apply what we've been learning to that project. We're in a pretty good spot with our Chef Claude app. If we scroll down, we can see it has gotten a little bit long. Mostly that's because we're hard coding in a response from the Claude API for now. But for the sake of practice, what I'd like us to do is refactor our app so that a couple of these sections get put into their own components. This will help make things look a little bit cleaner, and for the most part, it's just going to be some good hands-on practice. So your challenge is first to move the entire recipe section into its own Claude recipe component. And that is this section, let's see, right here. Everything from this section tag down to this closing section tag. Again, this is hard-coded for now. We're going to change that up when we get real results from the Claude API. And the second thing is for us to move the list of ingredients, or the section that has all the ingredients in it, into its own ingredients list component. Doing this is going to be more than just cutting out parts of the markup here and putting it in its own component, then rendering that component, because remember, those components are interacting with state in one way or another. So that's going to require you to think a little bit more critically about how you're going to communicate between the parent and child components, whether or not state needs to move down to a child component or live in the parent component. I'm going to leave all of that up to you while you work on this challenge. And then, of course, as always, we're going to be going through this challenge together. So let's go ahead and I'll put in a pause now. You can start working on this challenge. All right, I'm going to buy myself a little bit of room by cleaning up this challenge text, but I will do that right after I create those components. So we need a Claude recipe component and an ingredients list component. And I didn't make this part of the challenge, but I'm actually going to put these under a folder called components, mostly just so that it's a little easier to find in my list here. In fact, I might end up moving main and header into this components directory as well. But for now, let's not worry about that. Okay, so I'm going to create first a Claude recipe.jsx file, and I'll also create an ingredients list.jsx file. I'll stub out a function here, so we'll just export default function ingredients list and return, this is sort of my version of a console log for new components. Ingredients list component. I'm going to just copy this and paste it here and then change this to Claude recipe. And it looks like I spelled ingredients list wrong right here. Okay, we'll fix that. Then in our main, we'll go ahead and import those new components. And we'll make sure that's coming from the components directory. And we'll do the same thing for Claude recipe. Actually, I'm going to put Claude recipe on top here. All right, let's hit save. I don't think anything should change because we haven't rendered those yet. Okay, I'm going to clean up this challenge text. And let's see, for the Claude recipe, oh, actually, you know what? I am going to put Claude recipe below ingredients list because that's how we're rendering them on the page. So we'll do the ingredients list. Actually, let's do the Claude recipe first because I think this is going to take a little less work for us. So I'll take out this entire section. I'm going to render the Claude recipe component. And then let's hit save, and I need to click get a recipe for that to show. And okay, we're getting the Claude recipe component in our H1. Okay, let's get rid of this H1 and paste in that section. We'll hit save, click get a recipe, and okay, we have that section done. Now notice that in this case, I'm doing my conditional rendering on the parent component here in my main. This recipe shown is only being used to determine whether or not this component should get rendered, but I don't have any data to pass down to Claude recipe, at least not yet, because it's all hard-coded. The ingredients list, however, is going to be a little bit different. Let's go ahead and this section right here, I'll cut this out and replace it with an instance of ingredients list. And then in my ingredients list, I will get rid of my H1. Actually, let's hit save. And okay, we get our ingredients list component. That's perfect. Okay, let's replace this now with the section that we cut out. And we will likely find that we're going to break. I'll hit save, and sure enough. In fact, I know what the problem is, but let's look at the console. Ingredients list items is not defined, and that's because it's right here, ingredients list items. Okay, so we have some things that we need to pull down. We can kind of see from this view that we have ingredients list items missing, we have ingredients missing, and we have this toggle recipe shown function missing. Now, if you got stuck on the challenge before getting to this point, I'm actually going to put in another challenge here. Now that we've gone partway through, I want you to give it another shot, just in case it didn't work out for you the first time. If you were able to get this all working, great on you. You don't have to do this challenge. But if not, this is another great opportunity to get some real practice in. So I'll put in a pause now for you to give this another shot. All right, so these values are defined on our main component, and we need to either bring them in from the main component through props, or there might be some things that we can actually compute here inside of the ingredients list. Let's see, let's start with this ingredients array. This seems like a pretty important thing for our ingredients list to have knowledge of. And we'll remember those ingredients are coming from our form, and the state is being set here in the parent. Because the form does not live inside the same component ingredients list, I don't think there's going to be a meaningful way that we can move all of that down into ingredients list. Instead, let's go ahead and pass the ingredients through props. So I'll say ingredients is equal to ingredients. And for the sake of my horizontal space, I'll go ahead and put some of this on its own lines. And then we'll go to our ingredients list. Let's pull in props. And this will now be props.ingredients. All right, so I'm probably not going to get anything yet when I hit save because we still have a couple of other undefined things. This ingredients list items, let's check this one out. If we go back to our main component and find where we were creating ingredients list items, we're doing this based on the ingredients array. Well, we have access to this ingredients array inside of our ingredients list items. So why don't we take this out of here and make it a little bit more locally scoped, I guess, to our ingredients list? It seems appropriate because our ingredients list should probably be the component in charge of creating this ingredients list items. Now I need to change this from ingredients.map to props.ingredients.map. And let me actually comment out this button for now and hit save. Look at that. Okay, that's working. And our ingredients are showing. Now, the reason I commented this button out is because let's see, where was it? Right there? Yeah, we get this toggle recipe shown that we don't have inside of this component yet. So let's think for a second. Do I want to bring this toggle recipe shown function? Let's see, where did we define that? Right here. Do I want to bring this function down inside of ingredients list, or do I want to pass it down through props? Well, my main component, it needs to know whether the recipe is shown or not so that it can conditionally render the Claude recipe. If I were to bring all of this state down into the ingredients list component, there wouldn't be a great way for me to pass that value of recipe shown back up to my main component and then use it for conditional rendering. So it makes sense to live here, and so we will need to pass that value down through props. Let's give this a new prop. We'll just give it the same name of toggle recipe shown. So that'll be toggle recipe shown equals toggle recipe shown. Let me put these on their own lines. Then we will go grab it from props, and this will be props.toggle recipe shown. We'll hit save, and look at that. I think we should be at a working place. I can click get a recipe that shows my hard-coded recipe, and awesome. This was a long challenge. We had to do a lot of work here. And in the end, it is maybe a little bit questionable whether that was worth it or not. We did get to remove quite a bit of code from our main component and sort of offload that work to a couple of components that are maybe a little more honed in on what they're supposed to be doing. So it's neither right nor wrong per se. Architecting your React application will just take years and years of experience to figure out what you like best and what makes the most sense for your team. But I do think this was a good exercise in thinking through where should state live? How should we get information down to our other components if they even need them in the first place? Where should things like this map that we're doing live? So hopefully you understand what I'm trying to get at here. And at this point, the only major feature we have left to add to Chef Claude is actually getting the recipe from the AI. This is super exciting. This is where we actually get to make this app work the way it's supposed to work instead of having a hard-coded recipe like we currently have. So in the next lesson, we'll be seeing how we can sign up for these different AI engines. There's going to be a couple different options for you to choose from, and then we'll get to see how we can implement actually calling out to those AIs, sending them our ingredients list, and getting a recipe back in return. So get excited. That's what's coming up next. All right, let's finally add AI to our system so that we can be pulling in a real recipe rather than the one that we have hard-coded. In this scrim, I'll walk you through two different options for AIs that you can sign up for. And the only reason that I'm offering two different options is because when I first started creating this project, Anthropic, which is the company that created Claude AI, was offering a $5 credit to anybody who would confirm their phone number. And although $5 may not sound like that much, it goes a really long way, especially with the version of the Claude API that we are going to be using. However, since then, they have taken away that offering. So if you're okay putting $5 into a Claude account, then you can sign up with Claude. I promise you it's going to go a lot further than it seems. The grand total that I have used in all of my creating of this project and testing has been, I think, less than 1 cent. Also, Claude is a very capable AI. It's one of the best that's out there. But as I mentioned, if you're not interested in putting $5 into your Anthropic account, then I'll be showing you another option using Hugging Face, which will be completely free. So I'll help you get set up with an account on both Anthropic and Hugging Face. Let's start with Anthropic. You can click the screenshot here to take you to this very page to create an account with Anthropic. And once you've gone through this initial phase, it will take you to a sign up page where you'll want to make sure you put in your full name and whatever nickname you want to include here. Make sure to check the box and click continue. This will ask you questions about your organization. If you don't have an organization, then I guess you could just put your last name here or something. These other two inputs for industry and website are optional anyway. So once you put in an organization name, you should be able to click create account. Once you click create account, it should drop you into sort of a dashboard prompt page. And from here, you'll want to go ahead and click get API keys. This will take you to your settings, specifically under the API keys for your settings there. As I mentioned, in order to create an API key and make any use of it, you will have to add at least $5 to your account. So the first thing we'll do is go over to plans and billing. And there you can see the little warning up there that says to get started, you have to upgrade your plan and purchase some credits. So click upgrade. This will pop open a modal. You'll want to make sure you choose this build option on the left. I think that's the default, and then click continue. And then it's just going to ask you a couple questions. You can see I put in my organization name as Scrimba. Once you fill these out and scroll down to the bottom, go ahead and click continue. Then you'll be prompted to add your billing information. And once you fill all that out, you'll be able to click continue and you'll have some money in your account. Okay, with that behind us, we can click over on API keys, click create a key. You can give this key a name, something that will be clear as to what you were using this key for. So it really doesn't matter what you name it. I guess I chose to call this my first key. You could choose to call it recipe app or chef Claude or something that's specific to the project if you'd like. Then we'll click create key. And this modal is very important. You don't want to close this modal before you have a chance to copy the key. Once you close this modal, as it says, you won't be able to view it again. Make sure you copy that key and maybe temporarily paste it into some kind of text editor so you can reference it again. We're going to be talking about this pretty soon, but this is a key you want to make sure doesn't get published on GitHub with any of your repositories, is never really referenced in your front-end code at all. Again, we'll be talking about that in an upcoming lesson. So for now, just make sure you copy this key before you close the modal, or you're going to have to create a new key from scratch. Once you have that key, assuming you are following along with us here in Scrimba, you'll want to go over to your Scrimba account. So in version 2 of Scrimba, this is kind of the homepage that you're dropped into. Go ahead and click your own little avatar in the upper left. And in this submenu here, you'll see the option for settings. Click settings, and you might need to scroll down just a little bit, but under Scrim settings, you'll see this button that says edit your environment. Go ahead and click that. And this is a place in Scrimba that allows you to add environment variables that are accessible from any of your scrims. When we as the teachers are recording anything that requires an API key, for example, we're going to use a variable shorthand, which will be referencing your own personal environment. Well, for us, it was referencing our environment when we recorded it. For you, when you run the code, it will reference your environment. So you'll go ahead and click new key. And from here, you'll need to include a name and a value. The name will be what is referenced in our code base, and I'm going to be using Anthropic _ API _ key, all in capital letters. So assuming you are following here in Scrimba and you're using the Anthropic API, make sure that you get this exactly right, the same way that I have it here. Otherwise, you're going to have to change it every time you do one of your challenges. Then for the value, you will paste in the API key that you copied from the modal before, right here. Once you've pasted that in, you can go ahead and click save. Then in any scrim, when you see me writing with this saved in your environment, inside of any Scrimba with that API key saved to your own Scrimba environment, anytime I reference process.env.anthropic _ API _ key, just like I did in this line, it will look up that environment variable in your own environment and use it instead of the one that I used when I was recording. Now, as I mentioned, the Claude API is one of the best AIs that's out there, at least at the time of recording this. I've noticed that it's giving me excellent results. And even though I did have to put $5 into my account, it costs me essentially nothing to use it. Like I said, I've used, I think, a total of 1 cent since I first began creating and preparing this project. However, I did want to include an option that was completely free as well. And in the admittedly limited testing that I've done with it, it also is producing great results. And that is by using an AI model that's hosted by Hugging Face. You can, if you haven't heard of Hugging Face, you can kind of think of it like the GitHub for AI models. Some of the AI models that are hosted by Hugging Face are free, and some of them are paid. So creating a Hugging Face account is free, and the model that we've chosen is also a free model. So you can click on the screenshot here to go to the sign up page for Hugging Face. And just like before, you'll go through the account creation process. It's going to ask you for some information about your profile. It looks like the only things that are required here are a username, a full name, and then to agree with the terms of service in this checkbox at the bottom. Once you've done that, you can click Create Account, which will drop you into sort of an introductory page. But you'll notice that at least at the time of recording this, there was a little alert at the top that required me to confirm my email. So I went to my email, I clicked the link that was there, and that dropped me into this page where it says my email address has been verified successfully. At this point, you don't need to worry too much about creating an organization or joining an organization. Instead, we are going to create an access token similar to the API key that we created with Anthropic. Click on the sort of placeholder avatar in the upper right, and from this menu, you'll go ahead and click on Settings. In the submenu on the left, we'll go ahead and click on Access Tokens, and from there, we will create a new token. On the Create a New Access Token page, the only things that you'll need to worry about is giving your token a name. I've chosen this time to call it Recipe App, and the only checkbox that we need to worry about is this one right here under Inference that says we want to make calls to the serverless inference API. So make sure you check that box. We can scroll down a little bit and then see nothing else is checked. We can just click Create Token. Just like with Anthropic, this is going to give us a modal that once we close it, we won't be able to access our API key again. So make sure you copy this, paste it into some kind of text editor just temporarily until you have a chance to put it in an environment variable, either in a .env file on your machine if you're doing everything locally, or inside of Scrimba, just like we did before with the Anthropic API key in our environment variables. Just like I did with Anthropic, I'm going to be using the name hf_access_token. So make sure you type this in exactly the same way, or it's going to be a little bit annoying to have to go back and forth changing the name from the way that I recorded it. And of course, don't forget to hit save. Now, as I mentioned, I'm going to offer a really easy way for you to have one or the other of these. So for the remainder of this project, I'm going to be offering a way to make your API calls to either one of these, and I'll try to make it as simple as possible to switch. I'm going to be using the Claude AI because I have already added money to my account and I've been getting pretty good results with it, but I'll be trying to make it as easy as possible for those who want to follow using Hugging Face to do so in a really easy way. All right, that was a lot of talking and not enough coding. So let's jump in and start making calls to the real Claude API. So in the next lesson, let's finally start sending our prompt to a real AI and getting back a real recipe so we can replace the hard-coded one we have. Let's finally make use of AI to generate our recipes when given a list of ingredients, as opposed to this silly hard-coded thing that we've done so far. Now, because this isn't a course all about AI and how to use AI APIs, I'm just going to have the code written for you, which I'm sorry if that's a little anticlimactic, but the truth is I wanted to stay focused on learning React here and not getting too sidetracked by learning AI. That said, I did include a link here to a course here on Scrimba called Intro to AI Engineering, taught by Tom, and it's an excellent introduction to help you get your feet wet when it comes to AI engineering. You can click the screenshot here. It's just a short 90-minute course, but I would recommend doing so maybe after you finish this section in React. So I've written the code that will use both the Claude API and the Hugging Face API, and we can find that right here in a file that I've called ai.js. Now, in the last lesson, you should have created an environment variable either for the Anthropic API key or for the HF access token. And a quick warning that I wanted to make sure I got out of the way at this point is that if you're following along on your local machine instead of here on Scrimba, I need to remind you that you do not commit these API keys to any repositories. Here on Scrimba, we have a dedicated system set up for creating environment variables that are specific to each user. They don't get exposed to the public, but if you're following along locally and you're using, let's say, a file called .env, and you have your Anthropic API key in there, you need to make sure that you git ignore that file. If you don't know what that means, it's outside the scope of this course, but a quick Google search should help you out. Additionally, because the API calls we're making are coming directly from a browser environment to the respective APIs, you can see I've added this property here called dangerously allow browser. That means that we can make API calls to Anthropic directly from our browser as opposed to having to relay it through a server. This means that if you were to deploy your project anywhere live online, like Netlify, for example, anybody who comes to your site could dig around through the code and find your actual Anthropic API key or Hugging Face access token or whatever private variables you think are private but actually aren't. Really, the only way to secure these API keys is to relay these requests through some kind of server, whether it's a server that you have created or a serverless function on whatever deployment platform you're using. So here inside the Scrimba environment, you have nothing to worry about, but locally, make sure you heed this warning that I've given you. Okay, let's walk through this code so that you at least get a high-level overview of what it's doing. When you're interacting with an AI, you need to give it some kind of system prompt that helps set the stage for the AI to know what it's supposed to be tasked with. As you can see, I've created this system prompt that says you are an assistant that receives a list of ingredients that a user has and suggests a recipe that they could make with some or all of those ingredients. I did end up having to specify that the AI does not need to use every single ingredient that is mentioned, and it's allowed to include some additional ingredients that they didn't mention, but as I said, try not to include too many of those. Another really important instruction that I added to the end here is to format the response in Markdown so that it would be easier to render to a web page. We're going to come back to this and see how this is really helpful for us. Oh, and something I just realized is I'm importing things like this Anthropic constructor or this HF inference constructor from these libraries, but I have not included those as dependencies. So I'm just going to go ahead and make sure I add those as NPM packages to my dependencies here. In Scrimba, I just add the dependency here in the interface. If you're following along locally, you'll need to npm install exactly what you see here and here. Now with Anthropic, I'm creating this Anthropic instance. This is all part of the software developer kit that they give me. I had to pass my API key so that it knows who I am when I'm making requests. And because I am making these requests directly from a browser, I had to include this property dangerously allow browser and set it equal to true. You can see with Hugging Face, I do something very similar down here. I have to pass my access token to this new instance of HF inference. Again, the details of this are not that important for you to know, but do make sure you follow these comments because if you didn't follow along in the last scrim where we add these to your environment variables on Scrimba, you will need to do that before this will work. Then I just have two custom functions that I wrote. This first one, get recipe from Chef Claude, which takes an ingredients array and makes a call to the Anthropic API to create a new message. Or down here, I'm using get recipe from Mistral. Now, Hugging Face is like a host for different AI models. And in this case, I found that Mistral AI was actually a really good model that came from Hugging Face, and it was giving me pretty good responses. Depending on when you're watching this, chances are this model may have been updated, so you might want to go to the Hugging Face website and just see what Mistral models there are, and you might need to change the model that we're using here. With Anthropic, I did opt to use this Claude 3 Haiku version, and at the time of recording, this is actually the cheapest version that they have with Anthropic, and it was giving me great results. So it was fast, extremely cheap, and giving me great results, so I think it's a great one to stick with. As far as I can tell, there isn't too much of a benefit with one of the more expensive models, which can be 10 times the cost per API call. In each of these cases, in one way or another, I'm passing in that system prompt variable, the one that we defined up here above, sending this off to the respective APIs, and then just kind of drilling down into the responses to get the content that comes back from the AI. It looks like I have a little bit of error handling here on the Mistral side. I probably should include that in the Chef Claude side too. Okay, again, that was just meant to be a high-level overview. You do not need to understand everything that's going on here. If you would like to learn more or practice with it, you can go to the Intro to AI Engineering course and learn a little bit more about it there. So what does this mean for you? Well, it means that inside of our main file, when we want to use an AI to generate the actual recipe, all we need to do is import one of the two functions that I wrote here in our ai.js file. Then in the appropriate spot, I'm not going to show you exactly where because that's going to be an upcoming challenge. All you have to do is call the function and pass to it the array of ingredients that we're saving in state here in our main.js file. So this is awesome. Yes, I've done a bit of this work for you, but you can see that it's not that much code. We're working with less than 60 lines of code here, and that includes 2 different AIs that you can get these recipes from. We truly are living in a modern age. This is awesome. Okay, now that we're all caught up on what's happening in the background with this AI.js file, we are now going to jump in and, well, make use of these functions. This is where it starts to get really fun. So in the next lesson, I'm going to have a challenge for you. This is a really fun part of this project, actually pulling a real recipe from the AI. Because we're pretty far through this React course, I'm going to make this challenge a bit more vague and give you a chance to really think critically and synthesize all the skills that you've been learning and practicing up until this point to solve this challenge mostly on your own. Now, just so that it's not completely overwhelming, we're going to go through a bit of the problem-solving process, and to do so, I'm going to give you this kind of in-challenge mini quiz. So I have 2 questions here, just like our regular quizzes. I want you to click into the editor and type down your answers. Hopefully this will help guide you in the correct direction so that in the next lesson, when you actually start writing your code, you'll at least have a good idea of where you should be starting. So go ahead and answer the questions in this mini quiz. All right, for number 1, I want you to think about where the recipe response should live inside of our React app and how you're going to make sure that it doesn't disappear between each state change in the app. Or I guess another way to say it is to make sure it doesn't disappear every single time the app gets rendered. I'm not talking about if you were to hit refresh on the browser, because that would probably require using some kind of browser storage like local storage, and that's a little bit outside the scope of this project. Well, once I get the recipe back from the AI, I'm going to save that in React state. So that can be my answer here. I'll say I'm going to save the response in React state. By doing this, I can make sure that if I were to add another ingredient and then click get a recipe again, the old recipe wouldn't just completely disappear, or any other state changes that I might decide to include in this app. React state allows me to save information from one render to the next, and if I ever change that state, it will cause a re-render. So for now, in React state is going to be a great place for us to save that response. Number 2, what action from the user should trigger getting the recipe? We have these functions that I pulled in, get recipe from Chef Claude and get recipe from Mistral. At what point am I going to call these functions? Well, I know it's not going to be as soon as my app loads, because I need my list of ingredients. I need the user to be able to add to the list of ingredients, but it's when the user clicks this get a recipe button. Hopefully that was pretty straightforward based on the UI that we've chosen here with a button that literally says get a recipe. So for number 2, when the user clicks the get a recipe button. Although this question seemed a bit straightforward, when you actually go to work on this challenge, I think you'll find that it might be a little bit more involved than you might think. When we refactored things, we passed our function that get a recipe button is calling down through props to another component. That's all I'm going to say for now, because now we should be set up in the next lesson to have you actually work on the code for this challenge. All right, here we go. Our challenge is to get a recipe from the AI, and this time you're actually going to write the code. So either using the get recipe from Chef Claude function or the get recipe from Mistral function, make it so that when the user clicks the get a recipe button, the text response from the AI will be displayed below. Currently, we have it hard-coded so that when we click get a recipe, it's just toggling the recipe on. And of course, this is just hard-coded, but what it should be doing is displaying the real recipe from the AI. Currently, we're using this recipe shown state. I'll leave it up to you to determine whether or not this is still important to have. And keep in mind that we did ask the AI to return Markdown, so it will just be displaying raw Markdown. It's not going to look very pretty quite yet. We're going to end up using a package that will render the Markdown for us. This is a bit more of an involved exercise, but I know that you'll be able to do it. Don't be afraid to reach out to the Discord community if you need help, or to look back on previous lessons if you're forgetting some of the syntax. That's a completely normal and okay thing to be doing. Also, don't hesitate to use a tool like Claude or ChatGPT to help you out. Pretty much any of those things would be much, much better than just skipping the exercise because you got a little bit stuck. You got this. Go ahead and get started on this challenge. Sometimes when I'm building a new feature like this, I like to start at the point where the user is interacting with the code, which in our case would be this get a recipe button. So let's go down and look at that button. And actually, it's over here in our ingredients list. we're passing this toggle recipe shown function down to ingredients list, and it's pulling that in through props. And right here, our onClick says toggle recipe shown. This was always intended to be a temporary measure, and the state that is changing when we click that button, this recipe shown state, we could continue to use it in order to conditionally render the recipe from Chef Claude. But honestly, I think we'll be better off just saving the response from the AI in state. And if that response is truthy or is not an empty string, then that's the value we can use to conditionally render this whole section down here. So the first thing I think I want to do is rename this function, because we're not just toggling whether the recipe is shown, we're actually getting a recipe. So let's say get recipe, and yeah, that's good enough. I was going to say get recipe idea, but get recipe gets the job done. So now that we've changed that function name, we'll go ahead and pass the real function down. We might as well change our prop name while we're at it to the same name, get recipe, and we'll need to go over to ingredients list to fix that. So props.getRecipe. Okay, that was all just for changing the name. Let's go back and change how that function works. Instead of setting the recipe, whether it's shown or not, we are going to call get recipe from, I'm going to use Chef Claude. And if we remember, these functions are expecting a list of ingredients, which we are saving in state. So I can just pass in my ingredients to the AI function. Now, assuming you did this challenge from scratch without too much help or skipping ahead to watching me do it, you may have run into an issue because the functions that we're pulling in, they are async functions, which means by default, they are going to return a promise. Let's go back to our main. This means we can either use a .then to unpack the promise afterwards, or a little bit more of an updated syntax is we can use async await. So I'm going to make this an async function. We'll await the response, and we'll save that as a recipe idea. Or maybe let's call this something that's clear. It's from an AI. We'll say generated recipe, and this should be in Markdown, so I'm going to say Markdown. That might be overkill. Let's just call it recipe Markdown. Okay, that's good enough. Okay, I like to do sanity checks whenever I can before I get too deep into a feature without having tested it and then have no idea where I've broken things. So let's go ahead and console log recipe markdown. We'll hit save and see if we need to fix any bugs. Okay, let's click get a recipe. We're waiting a little while the AI is responding to us. And let's open the console. Awesome, check it out. This is the response text from Anthropic's Claude API. And sure enough, given the exact same list of ingredients, it keeps recommending spaghetti bolognese. If you look closely, you can see the text includes things like hash marks and dashes. This is all part of Markdown, and so we are going to be displaying that correctly later, but we'll notice that if I try to scroll down, nothing is there because we're no longer setting the recipe shown inside of our getRecipe function. So instead of console logging our recipe markdown, let's go ahead and save this to state, and let's create the state first. Instead of recipe shown, let's just call this recipe because this is where we're going to save the recipe text. Instead of starting this as a Boolean, we'll start it as an empty string, and then I will call set recipe with the recipe markdown. So we'll just do that right here. And then we can use the state of the recipe to determine what should get rendered. Right now we're saying recipe shown and Claude recipe. We'll just make this say if the recipe has a truthy value, or in other words, as long as it's not an empty string, then we'll display the Claude recipe. We haven't yet, of course, replaced the hard-coded stuff in Claude recipe, but let's make sure that our conditional rendering is working. I'll click get a recipe, and after just a little bit of time, we can see that we can scroll down and it's displaying the Chef Claude recipe. Let me close our console to buy a little bit of room. And now what we can do is pass this recipe down through props to Claude recipe. So we'll just say recipe equals recipe. And over in our Claude recipe, we are now going to be receiving props. And I'm actually just going to get rid of everything that was hard-coded here. And let's just render the text from props.recipe. Hit save, click get a recipe, and here we go. Okay, much less beautiful, but it's Markdown. We're going to format it in a really easy way using a third-party package. But for now, this is working awesome, and it's really exciting to have a real recipe coming in. Of course, currently we have the ingredients hard-coded, so just for fun, let's go over to our main file. We'll get rid of the hard-coded recipe ingredients, and actually let me get rid of this challenge text too. We'll say that this is an empty array and probably doesn't need to be on its own line anymore. Let's hit save, and I don't know, let's come up with some good stuff. Let's say we've got some chicken. We'll still say we have all the main spices, just so it knows that we've got what we need on hand for spice. Maybe we have some corn, maybe some heavy cream, and we have some pasta. I don't know, let's go ahead and give this a shot. We'll click Get a Recipe. Takes a little bit of time now that it's reaching out to the real API. And let's see, it wants us to make a creamy chicken and pasta bake. Boy, that sounds really good. Great work on this challenge. Hopefully you were able to get through it. And honestly, I don't even feel bad if it was a struggle, because that is where the learning happens. Let's go ahead and format this so that it doesn't just look like a giant wall of text, and we'll essentially be at the last phases of this app, at least for now. Let's get this crazy block of text formatted so that it actually looks presentable for our user. And the really good news is we aren't going to have to do any of this manually. Because we asked the AI to return the recipe formatted in a Markdown format, we can use a package called React Markdown. I think there's a number of other ones, but this is a very popular one, to turn the Markdown formatted text into something that renders as HTML. You can click on the screenshot here to go to the NPM package for React Markdown. I believe it will automatically bump you down to the section that shows you how to use it. And since you will often find yourself using third-party packages to help you out in your React codebase, we are going to turn this into a challenge. First, let me come over to the Claude recipe here, and I'll type out the challenge text. You know, reading documentation is one of the most common things you'll find yourself doing as a software engineer, and oftentimes other people have written code that does the task that you are trying to do. So it's really common to find a third-party package like we have here with React Markdown that can just accomplish our task and allow us to complete features a lot faster. So I think this will be a good exercise, even though it's more React adjacent using a third-party package. So your challenge is to see if you can figure out how to use the React Markdown package. I've included it here in the list of dependencies, but if you're following along on your own machine, you will need to make sure that you npm install React-Markdown. All of that information is going to be here on the npm page anyway. But I want you to use React Markdown so that you can render props.recipe, which currently is this big block of text, into something that's at least a little bit more presentable. And actually, you know what? Something I've already taken care of that I completely forgot I had taken care of was over in our index.css. I added a couple of rules that will help format the resulting markdown that gets turned into React elements a little bit nicer. This means all you'll have to do is add this suggested recipe container class to the section right here. I guess I should probably type that in too. Okay, that should be pretty straightforward. All right, it's your time to shine. Go check out the documentation for React Markdown by clicking this screenshot and give this challenge your best shot. All right, over in the documentation, we can see that what we need to do is import React Markdown from React-Markdown. And this thing that we're importing is a component. Unlike all of the custom components that we have been using so far, like our ingredients list component is a self-closing component, our Claude recipe component is self-closing as well. If you look in the documentation, you can see that this React Markdown component has an opening and a closing tag. And so we will go ahead and render React Markdown. And on the other end of props.recipe, which we're passing in, we will render the other half of React Markdown. And this is small enough, I don't think we need this to be on its own line. We'll just do that. This concept of having separate opening and closing tags for your custom components, it's something that you'll see pretty regularly in React. It's using a concept called children, but for the most part, I'm not going to be covering React children in this course. Instead, that is something that I cover in my advanced React course. Okay, let's hit save. You can see I put back in my default ingredients from the last scrim that we created, and I'll click Get a Recipe. Once that recipe comes in, let's scroll down, and wow, look at that. That is looking so much better than it did before. Let's go ahead and add our class name here just to see how that changes things. This was, I'm not going to guess it. Let's go over here, suggested recipe container. And let's try again. We'll hit save, click Get a Recipe, and we can scroll down, and awesome. Okay, this looks a lot more like the design that we saw in Figma. The last thing that I want to add here is a transition that's a little bit nicer than just jumping straight into this text. So I think I'm going to add an H2 here that just says something like Chef Claude recommends. And then we need to keep in mind that for those using assistive technologies, if we're conditionally rendering this section, we need to add an aria live equals polite. This way, when React conditionally renders it to the page for the first time, it will be announced and read through the assistive technologies. Let's go ahead and hit save, and we'll just see what our new H2 looks like. Okay, Chef Claude recommends. Awesome. And that, folks, represents a perfect stopping point for us in our Chef Claude app. Now, it's not perfect by any means. We actually are going to be revisiting this again in the next section, but we have a few more things that we need to learn about first. And you are probably getting pretty tired of spaghetti bolognese and creamy chicken and pasta bake. It's a lot of carbs to be taken in. We have learned so much in this section. The things that we've learned in this section represent some of the most commonly used things in React. And so before we move on, I'd like to do a quick recap to take a look back at everything we've learned before we're ready to move on and continue learning some awesome things about React and continue working on some amazing projects. Holy cow, we have made it to the end of section 3. This was a meaty section, and you have finally built your first interactive React app. Congratulations. With the knowledge that you gained and practiced in this section, the sky is the limit as to what you can build. Let's do a quick recap of the things that we've learned. In the process of building our Chef Claude app, we learned about event listeners, which are the basis of interactivity on the web. From there, we spent a long time learning about state in React. State gives us a chance to maintain data between re-renders of React and cause new re-renders in React so that we can follow the paradigm of React, which says that the UI, or what the user sees, should be a function of the state. This gives us a super declarative API in React, which allows us to simply update the data that React is maintaining and rely on React to update the view accordingly. We discovered a number of different ways that we can conditionally render parts of our app based on the state or the incoming props for any given component. This gives us not only flexibility in what actually gets displayed to the browser, but also gives us a chance to add another interactive element to our app. We learned all about forms in React, which gives us a chance to collect information from the user and do something with it. We could send it off to a database to be stored, which of course is a very important component when it comes to interactive and dynamic web applications. Then we took a little bit of a side quest from Chef Claude and learned about some different state management strategies, different ways that we can architect our app, and the pros and cons of each of those ways. We'll actually be getting a chance later on in this course to revisit this topic of where state should be held and controlled. I know I've said finishing the other sections were huge accomplishments, but believe me when I say this is the biggest accomplishment yet. We covered so much ground that you would really be doing yourself and the community a disservice if you didn't go over to the Scrimba Discord community and post an awesome celebratory message in the Today I Did channel. You worked really hard in this section, so you deserve some praise. Now, we have one more section in this course that will be focused on learning new topics, and then we have a couple really fun projects lined up after that. Once you've had a chance to do a little happy dance and to rest your brain for a little bit, let's keep moving forward. Welcome to section 4 and the last section where we'll be focusing on learning new things in React in this course. This entire section is all about how we can handle side effects in React. And in the years that I've been teaching React, I have found that understanding side effects in React can be one of the more tricky things that even seasoned React developers can experience. When React transitioned away from class components into functional components and started using hooks back in version 16.3, the way that the world thought about React kind of changed forever. There wasn't nearly as much talk about side effects in React as there is these days, which once you understand the concept of side effects, actually turns out to be a good thing. Let's take a quick look into what we'll be learning in this section. We've already learned about the new way that React handles forms, with form actions and some other APIs that are a bit outside the scope of this course. However, there are instances where you may still want to do forms in the way that they used to be done in React, which is using controlled components. The app that we'll be building in this section, which we're going to talk about in a second, uses controlled components, and so I figured this would be a good opportunity to cover that topic. Then we'll be taking a bit of a studious aside to talk about functional programming and how the React philosophy has really centered around functional programming. This will give us a better understanding of the concept of side effects and how we can best think about them in React. Then on a more practical level, we are going to be creating a side effect so that we can fetch some data. There's a lot of different ways to deal with fetching data, but we will be seeing how we can fetch some data as soon as our app loads. Then for the majority of this section, we will specifically be talking about side effects, what they are, how we can create them in React, what pitfalls we need to be on the lookout for, and so forth. And of course, this wouldn't be Scrimba if there weren't a ton of hands-on challenges along the way. Speaking of which, to drive this curriculum forward, we are going to be building a meme generator. It's a pretty straightforward app. It has an input for top text, so when you type into this top text input box, on every keystroke, the text on the meme image will update. And then, of course, the same for the bottom text. When you type into this input, the bottom text will update on every keystroke. And then you have the option to click a button, which will get a new random meme image from a list of popular meme images that comes from the meme API called ImageFlip. We'll also have a quick chance to apply the concepts that we learn in this section to add a feature to our Chef Claude app from the last section. So, no more delay, let's jump right in. To help us guide our discussion about side effects, we are going to be following this meme generator project. And unlike the previous projects where I actually have us start it completely from scratch, we are going to be beginning this one from a starting point. So before I just threw you into an unfamiliar code base, I wanted to walk through the code here and give you a chance to walk through it yourself. I think it's helpful to have somebody explain the code, but I think it's even more helpful to take the time to go through things on your own and maybe even try to change things. Fortunately, the starting point for this app is really straightforward. We can start over here in our index. We're just creating a root and rendering the app component. The app component is simply importing the header and main components and rendering those. The header is simply this purple header up top, and the main is, well, everything else on the page. The header is as simple as it might seem, and the main is currently not doing anything React-y other than simply rendering the JSX. You can see we're hard coding the image, the top text, and the bottom text. The one thing that is a little bit different about this, and we're going to be talking about this soon, is how the inputs kind of look like they belong to a form and the button kind of looks like it submits that form. But the truth is, that's not exactly how this one works. The user will simply type into the top text input box, and that will, every keystroke, update the text that displays on the image, up at the top, of course. The bottom text does the same for the bottom, and clicking the button doesn't submit any form anywhere, it just randomly gets a new meme image. This project will be a little bit on the simple side. I know a lot of memes these days have text in different positions than just the top and bottom, but we're not going to get that deep into it. As I said, everything is just hard-coded right now. In the next lesson, we're going to be moving this into React State, and then we'll jump into building this project. And the main reason we're doing this project is learning how we can make fetch requests to an API as soon as our app loads. Before I just jump into the next lesson, I'm going to put a pause in here to give you a chance to look through this code, make sure you understand what's going on. Again, it's not terribly complicated. It's kind of just like walking through some HTML, but doing so should hopefully prime you to have success through the rest of this project. So take some time now to peruse through the code. All right, hopefully that was helpful. In the next lesson, we are going to move some of this information into state. All right, let's get started right off with a challenge. I want you to move the hard-coded meme information that we have down here into React State. The state should contain an object that has a top text, bottom text, and image properties, and then set the initial values of those properties to the values that you see below. In fact, you know what? I'm going to make a change here just so that it's clear. This is an image URL. At this point, we're not going to worry about hooking up the inputs or the button, so you're just simply creating state and using that state value instead of the hard-coded ones down below. Go ahead and get started on this challenge. All right, let's go ahead and create, let's call it meme and set meme, and this will be equal to react.useState. And I need to, before I forget anything else, import React from React. And actually, you know what? We've had 3 sections where we're importing the entire React library, and I mentioned specifically that it makes it a little bit easier to know that useState is coming from the React library, but I think you probably get it for now, so I'm just going to switch it up. We're going to destructure useState and pull that in from the React library, and then just call it useState like this. Honestly, this is probably the more common way that you'll see it, so I think it'll be good to see it both ways. All right, my initial state is going to be an object, as it mentions down here, and we're going to have a top text property, a bottom text property. And I'm just setting these equal to empty strings for now. We're going to fix this in a second, and then an image URL property. Okay, for the top text, we have one does not simply, and up right there. Bottom text, walk into Mordor, and let's grab this image URL as our starting point here, clean up the challenge text, and we need to switch these to now use the state value instead. So this is going to be meme.imageURL. This one is meme.topText and meme.bottomText. These kinds of refactors are not super thrilling because I will hit save and it essentially looks like I didn't do any work. But we've primed ourselves to now be able to update our state, which will, of course, update the UI. This whole section is about side effects and using a built-in function from React called useEffect, but I kind of want to take care of some of the other items that we have. For example, being able to type into these inputs and have them on every keystroke update our text. So I guess we have, pun intended, a little bit of an aside to take before we get into side effects. So in the next lesson, let's hook up these inputs so that they can update our state. In the last section, we learned all about forms and how we can add an action property to our forms in order to catch the information whenever that form gets submitted. I mentioned at the time that that represents an update to React. This is something new in React 19 that is very, very welcomed. Before this update, we had to use something called controlled components whenever we created a form. And truth be told, I think it was one of the worst parts of React. It was overly complex. It felt like it was reinventing the wheel. And with that glowing review, we are going to start using controlled components. Don't get me wrong, there are still instances where controlled components make sense in React, and we are about to see one of them. Remember, with our two inputs here, we aren't collecting information from the user and then submitting it somewhere for it to be processed. That's really what a form is intended for. Instead, we just want every single keystroke that the user types into our inputs here to update immediately on the page, which means every change of the inputs is going to update our local state. As such, we don't need to use the underlying ability of forms to maintain and hold their own information and then submit it all at once in a form data object, but rather we want to set it up so that we have an event listener on our inputs, let's see, this input and this input, that on every keystroke or change of the input, we want it to update our state. Now, I thought about doing a whole aside and giving you a series of challenges for this, but truth be told, because with React 19 we have form actions and a couple other slightly more advanced hooks that we were given to deal with submitting forms, I'm actually just going to walk through this and hope that it makes as much sense as possible. Again, this is not the crux of our section, which is supposed to be talking about side effects. First, let's see the onChange event listener working. So I'm going to add an onChange event listener, and I'll call a function, which I haven't created yet, called handleChange. Whenever the change happens, let's create this function, handleChange, and I'll just console log changed for now. Let's hit save. I'll click into the box. Let me open the console. I'll click into the box and I will type some characters. Okay, you can see every single keystroke, spaces, letters, everything, it called my handleChange function. Okay, well, how is this helpful to us? What I can do is I can look at the event that comes through on my handleChange. Since this is an event listener, the value passed to that function is information about the event that was fired. I can grab whatever text is currently in this input box off of the event and then set my top text or bottom text. We're going to see how to do both. I can set the value of that text equal to whatever the input box currently says. So from this event, I'm going to pull off a value. And I'm just going to destructure it right off the event. We're going to get the actual value from event.target. The event is the event that was fired. Target is the element that fired the event. And actually, there's another one. You know what? I think I'm actually going to use current target. You don't need to worry at this point the difference between the two. The point is, I'm going to console log my value. We'll hit save, and I will type into the input box again, and you can see in our console The first character I typed, it logged the value, which was just the letter T, then TY, TYP, TYPE. Every keystroke is now being logged to the console. Okay, well, I think this is probably a good point at which I can get your hands on the keyboard and give you a challenge. This challenge is only going to partially solve what we're working on, but it'll be a good way for me not just to be droning on. Okay, your challenge is to update the top text value in the meme state object, this one right here, every time the top text input box is changed. Now, for now, I don't want you to worry at all about the bottom text. In fact, I removed the onChange event listener on the bottom text input box, just so it wouldn't be confusing. This challenge will harken back to how you can update a single property in an object's state. So if that's feeling a little bit rusty for you, you may want to open up the lesson in the last section where we went over this. Or of course, you could ask in the Scrimba Discord for some help, or just plug it into Google or ChatGPT, and you should be able to find an answer pretty quickly. All right, your time to shine. Go ahead and get started on this challenge. Anytime we want to update state, we need to use our state setter function. So I'm going to call setMeme, and because we don't want to erase all of the other properties of our meme, we do need access to the previous version of the meme. So I'm going to use a callback function, and what I'll return will be an object, but because I'm inside of an arrow function, I need to wrap that object in a set of parentheses just to be a little more confusing. We'll bring in all of the properties from the previous meme, and we'll change our top text to be whatever value is currently in the input box. Let's clean this up, hit save, and we'll say, shut up and take my money. Cool. Awesome. On every keystroke, this was updating. And because React is so good at what it does, it was updating really quickly. There was really no delay in every keystroke for having it re-render and display the new text. Okay, I think we've bitten off quite a bit in this lesson. We're going to learn how we can make our bottom text input box also work without having to write an entirely separate function for it, as well as learning one little gotcha when it comes to controlled components and what the term controlled components means in the first place. All of that's coming up next. All right, what even is a controlled component? Well, remember how I talked about that forms have their own ability to hold their state internally? I mean, we can see that when I type into my bottom text form, this is some text, this value is being saved somewhere. It's being rendered to the screen by the browser, and that's because forms have an intrinsic built-in ability to hold this data. In this case, React is not controlling the output of this form or the actual display of this form. A controlled component, on the other hand, is one that React is in control of. Me changing this text doesn't change anything else on the page. So an uncontrolled component is, for example, an input box that React is not in control of and doesn't reflect the current value of state. Any controlled component is one that React is in control of and does reflect the current value of state. The idea when React was kind of in its early stages, actually just up until very recently, the idea was that React should hold the single source of truth for anything that is being displayed on the page. So text like this that didn't conform to using state in React felt a little bit like an anti-pattern, I guess, in the theory of React. All this means is that, as we can see, I'm able to type something different in my input box than what the bottom text is supposed to be according to React. I have two different versions of truth. In order to make this a controlled component, there are two things that I need to do. The first is I need to be able to update state every time there's a change inside of my input box. This is exactly what we did by adding this onChange event handler in the top text input box. However, there's one more part to this, and that is that the current display value of our top text input box doesn't reflect what the top text state says. It kind of looks like it because our placeholder is actually the same thing. Let me actually change this to something different, and I'll hit save. Okay, you can see something different is correctly displaying in our meme, but both of our input boxes are empty. Again, they don't really look empty because of the placeholder. I guess that was a little bit confusing. But in a true controlled component, we want to manually set the value of this input box equal to whatever the current value is in state. In our case, it would be meme.topText. So now we can see the input box actually reflects the current value of state, by saying something different. The two sources of truth have been united into one. It's just held by React. And I can change this, and whatever changes in the top text input box will change on the page as well. So those are really the two parts when it comes to having a controlled component. We need to have the component or the input box accurately reflect what the current value of state is, and also every single change will update that state. And as such, React now has essentially kicked the form's ability to maintain its own separate state internally to the curb, and it's taking control over everything. It's kind of like being a control freak in this case. In our case, because we want the state to update on every keystroke, it actually makes sense for us to use a controlled component here. So let's do the same thing for the bottom text. We're going to give it a value of meme.bottomText, and I'll also copy this on changeover. At first glance, it might look like we kind of have to use a second function, because right now we are hard coding that this handle change function will change the top text. In fact, if I hit save and then start changing this, we can see we start to get some weird errors happening because there's a little bit of fighting happening between these two values. Oh, well, and I guess I'm displaying the bottom text value, but I'm trying to update the top text accordingly. Fortunately, instead of having to create a completely separate function, I can use the name value that each of my inputs have in order to correctly update which portion of state I'm going to change. By the way, I know that we're moving kind of quickly here. My old course had probably 6 straight lessons on controlled components and different kinds of inputs, but with React 19 kind of making that mostly obsolete, I really just wanted to fly through this. So I'm sorry if anybody is feeling a little bit lost. That's really okay, because again, we're here in a section about effects. I want to get to learning about side effects as quickly as possible. Here we're pulling in the value from event.currentTarget. I can also pull in the name property. That's exactly this right here, name of either top text or bottom text. And by ensuring that bottom text is spelled exactly the same way as the bottom text property in our state, instead of hard coding top text here, I can use a set of square brackets and say whatever name is currently changing the input, that's the property on the state that I want to update. Again, it's okay if that makes no sense at all. Let me hit save. I don't want this to say something different. Let's have it say one does not. Simply, we'll hit save again. Okay, so I can start to change this one. Great, one does not. And then we'll just go ahead and change this. And look at that. It's correctly reflecting the respective pieces of state depending on the name property from each of the inputs. All right, geez, that was quite a whirlwind. As I said, that's not really the important part here. We have part of the core functionality working with the top text and bottom text. Now, finally, let's dive in, start learning about side effects in React, and see how that even applies here to the meme generator project. The next task that we have in our meme generator app has to do with fetching some data. You see, we could hard code all of the memes that we want to include as possible images that we get when we click the Get a New Meme Image button, but that's not as fun. We want to use an API that has the currently most popular meme images in its database. And we're going to be using an API called the ImageFlip API, which has a dedicated endpoint to give us 100 of the currently most popular meme images. In order to get those, we are going to have to make a fetch request to the database with all the meme images. Our site will make a request out there, and because it's asynchronous, we don't know exactly how long it's going to take for it to respond, but eventually a response is going to come back to our React app, and we are going to store the array of meme images in our local state in the React app. Then from the array of meme images that we got back from the database, we will randomly choose one every time the user clicks the Get a New Meme Image button, which means clicking the button itself isn't going to be making a fetch request and returning a response, but instead simply loading up the app will have the side effect of grabbing that array of data from the ImageFlip API. Then everything else is just going to be processed locally within our app, like randomly choosing an item from that array of 100 meme images. So if we're not kicking off a request when we click the button, I want you to think, when are we going to be kicking off this first request to get all of the meme images? Well, to be honest, I think I gave the answer away in something I said earlier, but we're going to grab all of these meme images as soon as our app loads. And describing it that way makes it sound like it should be really easy. In the end, it really is easy, but it requires us to have a basic understanding of the functional programming paradigm, how that relates to React, and how we can initiate this initial request upon the loading of our app for the first time. So just to help us have a greater understanding of what a side effect even is, we're going to take a really high-level overview at a programming paradigm called functional programming. I'll caveat this lesson by saying that I am definitely not an expert in functional programming, but I think a really high-level overview of functional programming will be helpful in understanding a little bit more deeply how React works and what the philosophy behind creating React was. It's also going to help us when we're talking in terms of side effects, which is what we're currently working on in our little side quest here. There are a number of main principles with functional programming, and we are just going to be touching on a few of them. The first one that I want to talk about is the concept of pure functions. A pure function is one that if it's given the same inputs, it will always produce the same outputs. And running that function will never have any kind of change elsewhere in your system. This is where the concept of UI as a function of state comes from. All it simply means is that the whole job of your components that you're writing are to take input, which in one example might be incoming props from some above component, and given those props, its entire purpose is to return a user interface, some kind of DOM elements that display on the screen. And if it's written correctly, no matter how many times your app component is rendered, if the props are the same, then the UI that's produced will always be the same. Now, if the props that are coming in exist in a parent component and that component changes those props somehow, maybe those props are actually part of state in that parent component, then the change in props will cause our app component to re-render and potentially produce different results in the user interface. And this exact same principle applies if what changes is an internal state change to our component. Changing that state will then produce a new user interface. And as long as that state change is the same, it doesn't matter how many times your app component re-renders, it will always produce the same user interface. And we talked early on about how React is in charge of doing all of the nitty-gritty behind the scenes, and we as developers just get to worry about making sure that our state or our incoming props are being represented correctly so that what React produces in the user interface is, well, represented correctly on the page. As such, it's really important that the code inside of our components is pure. In other words, it doesn't change anything outside of its own system. And this leads us to the next main principle, which is immutability. And we've talked about this. If we have a component that's receiving props, it's very important in React that we never change those props to anything else. Otherwise, doing this means that our props are mutable. And in functional programming, and especially here in React, props are immutable. The truth is, state is also considered immutable, which might seem a little weird because we have been changing state quite a bit throughout this course, but all it means is that we're not going to be directly mutating state. We're not going to change state equal to something else. We will always use the setter function that we receive with useState in order to make any changes. In the end, what's really happening behind the scenes is it's not just setting state equal to something different, it's replacing that state with a completely brand new version of it, which then causes our entire component to rerun with that new version of state. Feels a little bit like splitting hairs, but it's an important thing in React to understand that immutability is key. Lastly, and this relates quite a bit with the first one of pure functions, but hopefully ties in our main concept here, is that our components in React should avoid side effects, which just means that if we are going to run our app component or create an instance of our app component like we do here, then we need to make sure that it will not affect any kind of outside system. Imagine, if you will, every time I ran this component, it made some sort of post request to add an item to a list in a database. This would prove pretty problematic because if React needs to re-render our app component, I don't know, hundreds of times, if every time it did it, it was adding something to a list in a database, you probably understand why that's a bad thing. We could really end up with major outside problems if we were to allow our components to do anything like this. Okay, so where does that leave us? Well, we are going to discover that side effects are still kind of an important thing for us to have in our web applications. We want to be able to mutate data in databases and do things like add values to local storage or subscribe to WebSocket connections. And so we need a solution in React that allows us to avoid side effects as much as possible, but also to escape from that paradigm whenever it's necessary so that we can keep developing what we need to build. So this leads us into the conversation of how we can deal with side effects in React. A really common thing that you will need to do in your React applications is to fetch data outside of your own React app. And in order for us to fetch that data and then display that information on our page, we need to perform at least two steps. First of all, we need to fetch the data or get the data. So we'll call this step number one. And for number two, we need to display the data, which requires us to save the data in state. First, we'll see what might seem like an intuitive way to do this, and then we're going to find out quickly why that's not quite the whole story, and we'll have a pretty major bug in our component. I'm going to be using data from the Star Wars API. It's just a simple API that can return information about the Star Wars universe, and we'll save that in state and display it just as a JSON object. It's going to look more or less like this with a bit more information. This is just stringified and hard-coded, this object, but we'll replace that in a second. Okay, well, we'll take this naive approach first. We'll go ahead and fetch data from the Star Wars API. This is the endpoint we can use to get the character in the Star Wars universe with the ID of 1, which happens to be Luke Skywalker. And then fetch returns a promise, so we'll go ahead and resolve that promise, which will give us a response back. The response contains a bunch of extra information, metadata about the response itself, the body of the response, and so forth. That body, in this case, is coming back as JSON, and so I can pull the JSON out and turn it into a JavaScript object. And then I can get that data, and what I usually like to do is just console log it to see what it looks like. Okay, let's clean up our notes here. Let's hit save, open our console, and okay, we got the data in. Everything seems to be great. All right, well, let's say instead of calling this generically state, let's say this is Star Wars data, and we'll go ahead and set the Star Wars data. And actually, I've had a lot of talking in these last few scrims, so let's give you a challenge real quick. All right, this isn't practicing anything new per se, but I do want to get your hands on the keyboard as always. So instead of console logging the data, I want you to save it in state and then display it to the page. Essentially, you'll just be replacing this hard-coded object with the data that is saved in state. For anyone in the know already, yes, this is not the correct way to do this in React. We're very soon going to see a problem that we'll run into. But for now, I'll put in a pause and have you work on this challenge. All right, well, instead of console logging the data, let's go ahead and call set Star Wars data with the data instead. And we'll go ahead and replace this object with the Star Wars data. Let's clean up the challenge text. We'll hit save, and it started as null. You probably saw that pretty briefly, and then it replaced it with the object. Awesome. So what's the problem, Bob? This seems like it's working great. Well, we can highlight what the problem is by adding in some code here. Let's just put in a console log that says rendered. And keep in mind, any code that we have inside of our component is going to run anytime this component renders by React. So let me go ahead and hit save, and we don't even need to open up the console to see that we are stuck in an infinite loop. We didn't notice this happening behind the scenes, but all of the code, including this fetch request that we were running, was happening many, many, many times in the background. Let me comment out this render just so it stops displaying that to the page. But even though we're not seeing the rendered console log multiple times, there is this fetch request happening infinitely in the background. In fact, I'm going to comment this out so that we have an opportunity to talk about it. Okay, this one's going to take some critical thinking. I'm going to put in a pause here, and I want you to think about why it is that we are stuck in an infinite loop if we have this fetch request uncommented. Think back to everything that you've learned about how React deals with state, how it decides what should get displayed to the screen, and how it decides whether a component should be re-rendered or not. So take a minute to see if you can figure out why we were stuck in an infinite loop. When we had our fetch request uncommented and the component rendered, it ran through the code here. It performed a fetch request, or I should say it kicked off or started a fetch request. Because the fetch request takes some time to complete, it then came to this return and displayed this null on the page because we initialized our Star Wars data as null. Then, in what probably feels like an eternity to a computer, the response finally comes back. It pulls the body of the response out and changes it into a JavaScript object, and then, most crucially, it sets that data to local state. What is it that React does when we change local state? If we change local state, React will re-render this component. It needs to display the most updated version of state to the page, so the component has to re-render. However, when we set Star Wars data and we re-render this component, a new fetch request gets kicked off. When that one completes, it sets the Star Wars data, which re-renders the component, which calls a fetch request, which sets the Star Wars data, which re-renders the component, and we get stuck in an infinite loop. Now, I haven't hit save since I uncommented this, so this fetch request is not currently happening in the background. But I'll just pre-warn you, if you do want to play around with this code, if you hit save, it's going to start kicking off this fetch request, so just be aware of that. So how do we avoid this problem with how React deals with setting state and re-rendering if we want to include a fetch request that only happens one time? Well, this is the natural next step in our discussion about side effects, and specifically a hook that React gives us called useEffect. So let's dive right into learning useEffect and see how it can help us solve this problem that we're facing. Let's kick off the discussion about useEffect by looking once again at what React's primary tasks are. As we've discussed, the main thing that it's in charge of is working with the DOM and the browser in order to render user interface to the page. Very helpfully, along with that, it's going to manage any state for us between render cycles, which gives us developers a way for a value to be remembered from one render to the next. And because we have state and we have props, React is in charge of updating the UI. Once again, kind of like we talked about in the first point, it will update that UI whenever the state or the incoming props change. There's a lot of other things that React, of course, is doing behind the scenes, but I think it would be fair to boil down all of the very detailed things that it does to these kind of main tasks. Well, this naturally leads us to ask, what can't React handle on its own? And primarily, React can't really do much regarding outside effects. Some examples of this are interfacing with local storage. If we're relying on a value from local storage and that value changes one way or another, React isn't automatically going to update itself based on the changes from local storage. I guess let me also be clear about local storage and the rest of the items in this list. I'm not saying you can't use these tools with a React application. I'm simply saying React isn't automatically connected to them. And so we need to connect these things manually ourselves. Another example of an outside effect that React doesn't automatically connect to is an API or any kind of database interaction. We need to manually call out to an API and receive the data that comes back in order to then display it on the screen. This is exactly what we were doing with the Star Wars API. Along that same vein, anything dealing with subscriptions like a WebSocket connection, React doesn't automatically know how to connect to outside systems or what to do if data were to come in and change, and so we need to take that into account as we're writing our code. Essentially, this could just be boiled down to basically anything that React isn't in charge of, which is what we saw in the last slide. So how can we deal with these outside effects? Well, that's where the useEffect hook comes in. Whereas it's really important for our React components to be pure components and follow some of those principles of functional programming that we talked about earlier, useEffect gives us a way to sort of create an escape hatch. In fact, escape hatches is exactly what the React docs talk about. You can click on the screenshot here to go to this page talking all about escape hatches. This goes beyond the scope of just useEffect, but if you scroll down to this section, which says synchronizing with effects, it will talk about useEffect a little bit. Feel free to read through this sort of as a reading the textbook before class sort of thing. And once you're ready, we're going to jump into the syntax of useEffect. Let's learn how we can apply the useEffect hook to fix the issue that we were having with our Star Wars data re-rendering this component in an infinite loop. Before we get started, I want to give you a chance to go check out the UseEffect documentation. The screenshots that I had given you before talked more about how to use UseEffect. This one actually gives you the real syntax, and so this would be a good chance to go check out the documentation before running through the rest of this scrim. We can see from the signature here that there are two parameters that we need to pass to UseEffect. The first one it calls setup, which turns out to be a callback function. And the second parameter is optional. That's what the question mark here means. And it's an array of dependencies. In this scrim, we're going to talk about the setup callback function, and in the next one, we'll talk about the dependencies. So let's come back to our code. And if I uncomment this console log and hit save, we can remember that we are stuck in this infinite loop of rendering. And the reason is because of this set Star Wars data line, which is causing a re-render of our component, which is kicking off a fetch request, setting Star Wars data, and so forth in the infinite loop. Let me just comment out this line here and hit save. That will stop the infinite re-rendering for now. UseEffect is a function that we can import from React in a very similar way that we were doing with React.useState. We can call React.useEffect. And as I mentioned, there are two parameters. The first one is going to be a callback function. Now, almost exclusively these days, you'll see this written as an arrow function like this. But just in an effort to make this completely transparent, I'm going to put an inline function declaration like this, and then we'll switch it back for an arrow function later. I think having the function keyword here makes it much more apparent that we're working within a callback function. What UseEffect allows me to do is inside of the code of this callback function, I can put any code that is going to have some kind of side effect outside of the React ecosystem. In the case of our fetch request here, where we are trying to get data from an outside system, this would be the correct kind of code to put inside of a side effect with UseEffect. More specifically, the code I put inside of this callback function is the code where I want to synchronize data from an outside system with our internal React state. Now, I have a confession to make, and that is that if we were to uncomment this setting Star Wars data line and hit save, we're going to see that we are still stuck in an infinite loop. So what went wrong? How come our UseEffect didn't solve everything? Let me actually go ahead and comment out this line again. So on its face, it would seem like putting this code inside of our UseEffect made really no difference. And the truth is, without the optional dependencies array, which we're going to be talking about in the next lesson, that's kind of true. There is one minor difference that I think is important to note at this point, and that is that any code you put inside of this callback function is guaranteed to only run after React has mounted your elements to the DOM, or in other words, painted the elements from your component to the page. We can get a glimpse into this if we were to console log maybe effect ran here inside of our callback function. We'll hit save. We can see we first get rendered and then we get effect ran. And the truth is that has nothing to do with order. If I place this console log below that one in terms of where it sits on the page, we're still going to get rendered first. And that's because it's running through this code, reaches this console log, runs this console log, renders the elements to the page, and then runs our function inside of our UseEffect. So that's kind of a slight difference between just having this code sitting outside the UseEffect, similar to our console log here. But for our purposes, when we uncomment this line, we're still going to be running this effect function on every single render of our component. So let's dive in and talk about that dependencies array and see how it's going to help us solve this problem. I've made a small tweak to our little sample app here, and that was to add this counter and a button to increment the count. And of course, I changed this to dark mode for any of you who felt blinded by the last example that we had. The only reason I added a counter was so that we had a really easy way for us to force React to re-render this component. We can see in the console that the first time we load this up, we get the rendered console log here, and then we get our effect ran console log as well. If I go ahead and click the add button, we can see we get both of those console logs running again. This shows us that the UseEffect callback function we have is running on every single render of our component, which is why moving this set Star Wars data line inside of the UseEffect didn't solve our problem. However, what we'll learn about now will solve this problem, and that is the second parameter that we can pass to the UseEffect function. If by default, the first parameter, this callback function, will run on every single render, the second parameter gives us a chance to stop it from running on every single render if we want it to. And in practice, you pretty much will always want to include this dependencies array. I can't think of too many times when you would want your UseEffect functions to run on every single render. So what exactly goes here? Well, it is called a dependencies array, so this will always be an array of values that React is going to watch between one render and the next. If any of the values in this array change between those two renders, then React will know that it should run this function again. So let's play with this for a second. Let me go ahead and put the count value that we're tracking in state as a value inside of my dependencies array. I'll click Save. We can see we got rendered and effect ran. So now we know that this effect will run on the very first render of the component. And let me click the Add button, and we see we got rendered and we got effect ran again. Let's dive even deeper and see what happened behind the scenes. The very first time this component re-rendered, I'll hit refresh now so we reset our count to 0. Count here was evaluated as the value of 0. Our console log rendered ran, React then painted this div and its child elements to the page, then it ran this effect function. And behind the scenes, it's storing this array with the value of 0 so that it can compare the dependencies array on the next time this happens. So I go ahead and click Add. Now what happens? Well, this count value, which remember it's saved as count, React incremented the count from 0 to 1. It painted the stuff on the page. And then it looked at this effect function and its dependencies array. And this time the dependency count had a value of 1. And so behind the scenes, React was looking at what it used to be the last time this effect ran, which was an array with a 0 in this first index here, or I guess the 0 index. And then it compared it to what it currently has, which is an array with a 1 inside. And the logic of React says, well, it used to be an array with a 0, now it's an array with a 1. These are different from each other, and so I need to rerun this callback function again. So as you can imagine, it's called a dependencies array because this callback function depends on the value that you're putting inside the parentheses here. All right, let's do two things. First of all, I've been kind of changing this value of count. I think it's important for us to remember that this is still a variable. It's not a hard-coded number, but I think that can be a good practice for us. I want you to think what would happen if I hard-coded this as a 0. I'm going to hit save. We get rendered and effect ran. So I'll put in a pause here, click the add button, and try to see if you could explain why it's doing what it's doing. Okay, I'll click the add button, and this time we only got rendered logging to the console, which means that this callback function did not run this time. So what's going on here? Well, because I've hard-coded a 0 inside of my array, the first time our component rendered, it saved this dependencies array as an array with a 0 inside, and the next time it rendered, after we clicked the add button, it compared it to the hard-coded array with a 0 inside. And this time, because these arrays contain the exact same data as each other, React thought, well, I don't need to rerun this callback function because nothing has changed. Nothing that this function depends on has changed. And so I don't need to try and synchronize with any outside system again because nothing has changed. Okay, so that's the first thing. Let's go ahead and set this back to count. The second thing is let's go ahead and uncomment our set Star Wars data. I'll hit save. And check it out. We are no longer caught in an infinite loop. I'm going to put in another pause here, and I want you to try and reason through why it is that now that we have this dependencies array here, we suddenly are no longer stuck in a loop when we're setting our Star Wars data. Before, when we were setting our Star Wars data, it was re-rendering our component, which was causing our useEffect function to run again because we hadn't taught it when not to run. Now, our count has not changed, even though we're setting our Star Wars data and re-rendering this component, which is why we got a second rendered console log displaying. Because our count has not changed, we are no longer making another fetch request. So now I want you to think what's going to happen if I click the add button. Well, clicking the add button is going to change my count value, which is going to make it so that between the two different renders, my count value inside my dependency array will have changed, and therefore I will be kicking off another fetch request. So let me click the add button, and we can see that we did get rendered, effect ran, and then rendered again. It's a little hard to tell because the data hasn't changed since the last time, but it did re-render this, and it did make another fetch request. Okay, we are way too long overdue to have you do a challenge, so let me type out a challenge for you. All right, your challenge is to rewrite the useEffect. For now, we're going to have it rerun anytime the count changes, so anytime this add button is clicked. And for now, you don't have to go fetch data from the Star Wars API or anything like that. You can simply console log effect function ran. So give this your best shot, see if you can remember how the useEffect function works. I can create a new side effect in React by using React.useEffect. The first parameter is a callback function. Before, we were using a function declaration like this, although I did mention that the much more common way you'll see this is by using an inline anonymous arrow function. So we'll go ahead and switch to doing it that way for now. I'm just going to copy this effect function ran console log, and I need to make sure to include my dependencies array so that it only runs when the count value changes. Let's clean up this text. We'll hit save. I'll click add. And we got effect function ran a second time. Okay, if this is your first exposure to useEffect in React, first of all, congratulations on doing that challenge. The syntax can seem a little bit weird. But second of all, you might be wondering, why are we putting count inside of this dependencies array? We've learned that the dependencies array can give us some control over when this effect function runs, but it might not seem super apparent why we're putting count in here. And the truth is, we probably shouldn't be putting count in here. So that's what we're going to be covering next. All right, so we've learned that the dependency array gives us some control over when our effect function runs. And we learned that React is going to compare the values inside of our dependencies array from one render to the next in order to determine whether this effect function should run again. So how do we determine what we should put inside of our dependencies array? Well, I think if we take a second to truly understand what values we should be putting inside of our dependencies array, it will suddenly start to click for us. Right now we have this count value in here, and that was simply to show that this effect function will run whenever we increment the count. But if we look at our code, there's no code inside of here that depends on the value of count in order to correctly synchronize with an outside system. Changing count is simply going to call another fetch request to the Star Wars API, which knows nothing about count nor depends on count to get correct data. So let's see what happens if we simply remove count from our dependencies array. I'll hit save. Okay, we can see we got rendered, which is the very first time our component rendered. Then behind the scenes, React put this div and its children on the page, first with an empty array displaying as the data down here. Then our useEffect function ran, and this console log ran, which is why we see effect ran in the console. The fetch request kicked off. It took a little while for the data to come back, but eventually when it did, we set the Star Wars data with that data, and React triggered another re-render. Keep in mind, when it ran this effect function, it looked at our dependencies array, which was an empty array. Let me go ahead and type this down just in a comment here. So this was on the first render. It had an empty array. Set Star Wars data triggered a re-render. It did the whole re-render thing and placed the new information on the screen with the correct Star Wars data. Then it looked at our dependencies array this time around. And what it did is it compared an empty dependency array to another empty dependency array. When it saw that nothing in these arrays had changed, because there is nothing in the array, it said, I don't need to rerun this effect, because nothing that this effect depends on has changed. And because we've removed count here, count is also not something that this code depends on. So if I click add, I'm simply going to get rendered every time, and the effect is not going to run anymore. All right, well, we've learned quite a bit of stuff. What I'd like to do is in the next couple lessons, I want to first do a quiz that we can talk a little more high level about what useEffect is helping us with. And then we're going to have just a small series of challenges to give us some more practice in understanding useEffect. All right, it's quiz time again. Just like before, read through these questions, click into the editor, and type down your answers. For question number 1, it's been a little bit of time since we talked about functional programming and pure functions, so don't hesitate to open up that lesson on functional programming in another tab or something and review that before answering this question in the quiz. So go ahead and answer the questions in this quiz. Okay, number 1, in what way are React components meant to be pure functions? And actually, I'm going to pull up my old slides on this one right here. The idea of the pure functions was to say that a component, when it's given certain props, should always return the same user interface. And the same thing holds true of a state change or any internal state in the component. Given the same state values or the same props values, it should always return the same user interface. And so that's the main idea of pure functions in React. So given the same props or state, a component will always return the same content, or the same UI that gets rendered on the page. Another aspect of having pure functions in React is that rendering your component, or running that component function, will never affect any kind of outside system. We talked previously and imagined a scenario where maybe our component, every single time it rendered, were to add an item to a list in a database. This would be very blatantly not a pure function because every time it runs, it adds a new item to a database, which means we are very much affecting an outside system. So that's just another important aspect of having pure functions in React. That leads us very naturally to what is a side effect in React and what are some examples? Well, really a side effect is any code that affects, or we could even say interacts with, an outside system. It's a little nuanced, but even doing a GET request to an API is considered a side effect, even though we're not really making a change to that outside system. Simply interacting with the outside system makes it a side effect in the realm of React components. Some examples of this might include interacting with local storage, anything dealing with an API, or making a connection like through WebSockets. One we hadn't really talked too much about was doing any kind of manual DOM manipulation. All of these are services or systems that exist outside of React, and so interacting with them inside of your components is considered a side effect in React. So number 3, by contrast, what is not considered a side effect in React, and what are some examples? Well, in this case, it's really anything that React is in charge of. Some examples of which are maintaining state, keeping the UI in sync with whatever data you're working with, rendering DOM elements, and certainly there's a lot of other things that React is in charge of, but all of those would be considered not side effects in React. All right, number 4, this is kind of the meat of this quiz. When does React run your useEffect? Well, it will always run your useEffect code as soon as the component loads, or let's say renders. And more specifically, it's when it renders for the first time. This most commonly happens when you first refresh your page or launch your app and it gets loaded into the browser for the first time. Although it could also be if you were conditionally rendering something and it was not present on the page before, but then some state value changes and it becomes present on the page. That would be considered the first render for that component. React will also run your useEffect function every time a component re-renders, assuming you have no dependencies array. So on every re-render of the component, assuming no dependencies array. And maybe to answer this next one, when will it not rerun the effect function? Well, that's going to happen if between renders, the values in the dependencies array have not changed. And lastly, how would you explain what the dependencies array is? Well, spoken more literally, it's the second parameter to the useEffect function, but more importantly, it's a way for React to know whether or not it should rerun the effect function. I know it probably feels like I'm beating a dead horse with this useEffect thing. The reason I do this is because I do find that useEffect tends to be the most confusing topic in React, not only for beginners, but is widely misunderstood by even seasoned veterans in React. I really want my students of this React course to come away from the course having a pretty solid understanding of useEffect, when to use it, when not to use it. And so we are going to have a short series of challenges that we'll do to help us really drill in useEffect, as well as another aspect of useEffect that we have yet to learn. Along the way, we're also finally going to come back to our meme generator so we can apply what we've learned regarding useEffect to that app. All right, in order to get our repetitions in, the first part of your challenge is to write our useEffect from scratch. I want you to fetch the data from the URL that is right here and save it in the Star Wars data state. While you're doing this, make sure you don't get stuck in an infinite rendering loop like we did before. Go ahead and get started on the first part of this challenge. I'm going to copy this URL and then just get rid of this challenge text, and in its place, we will call React.useEffect. I'll put a callback function as my first parameter. And before I forget, I'm going to put my second parameter as an empty dependencies array. We'll revisit this and determine whether or not we need to add anything to that dependencies array. What I want to do is fetch the URL that I copied. We'll say .then, we'll get the response, and we'll pull the JavaScript object out of that. And then we will take the data that we get and we will set Star Wars data with that data. Now, before I hit save, I want to think to myself, anytime I'm creating an effect, what does this effect rely on? Are there any values that I need to make sure I include in my dependencies array so that if that value were to change, I might need to fetch new data or do some other kind of interaction with an external system? And in this case, no, none of the values that I'm using inside of my fetch request rely on anything outside. I just want to get the data that lives at this URL. So by putting an empty array, essentially it's like saying, I just want you to do this fetch request the first time you mount, and then you won't have to do this fetch request again later. We'll hit save. We start with an empty object very briefly, and then the data comes in and we fill it in with the data from the Star Wars API. Okay, that should have just been repetition there. The next challenge we do will expand upon this a little bit more. Okay, I've made a couple really small changes here. First of all, I'm beginning my count value at 1, and secondly, I've changed the text of the button to say get next character. Notice that the URL on the Star Wars API says /people/1. Well, this /1 is the ID of a character in the Star Wars database. And if I were to do 2 or 3 or 4 or 5, I would get new characters being returned to me through my API request. So what I want you to do is to combine the count value, which has up until now been kind of a silly way just for us to trigger re-renders, and make it so that when we click the Get Next Character button, it will change this 1 to a 2 or a 3 or a 4, or whatever the count currently is, and get new data for that new character. While you're doing this, remember to consider your dependencies array, what may or may not need to be in there. All right, go ahead and give this challenge your best shot. Well, the first thing we want to do is not have this 1 be hard-coded. So I'm going to use a template string and simply replace my 1 with some interpolated value of the count. I did change this from a 0 to a 1 because I don't believe there's a character with an ID of 0. So let me hit save, and we should see that, okay, we're still getting Luke Skywalker because this was set to a 1. If I instead were to hard-code the initial value for my count state to a 2 and hit save, we should get, yes, a new character, C-3PO. Okay, well, we don't want to start at 2. Let's start at 1, and I'll hit save before I make any kind of change to the dependencies array. And let's go ahead and click Get Next Character. Okay, we see that the count is 2, but our data did not update. And that's because our use effect doesn't know that it should be watching for changes to the count value in order to determine if this function should run again. But we actually are depending on the count value now. Before we weren't, but now it does matter. If count changes, we need this effect to run again so that we can accurately reflect the new information on the screen. So in my dependencies array, I'm going to add my count value. We'll hit save. We get Luke Skywalker, and I'll click Get Next Character, and there it is. We get C-3PO. We can go to the next one, R2-D2, Darth Vader, Leia Organa, and so forth. I really hope this hasn't been overkill, and I hope that use effect is at least starting to become clear if it hasn't clicked quite yet. The more you use it, and the more, honestly, bugs that you find with use effect, the more solid your understanding of it will be. As I mentioned, we do still have some more to learn about with use effect, but it's been so long since we have seen our meme generator project that I think we should go back to that, apply what we've learned, and honestly, I think once we have done that, we'll mostly be done with that project. It was a pretty quick one. So let's jump back into the meme generator with a challenge. Okay, everything that we've been learning about use effect has led to this moment. The way that we are going to structure this app is that as soon as the app loads, we're going to make a call to the image flip API. And I've included a screenshot of the documentation as well as a link. You can click this screenshot to go to this link, and you'll need this in order to complete the challenge that we have. So the way that this app is going to work is as soon as our app loads, it should make an API call to the image flip API, and it will get an array of memes. So it's not going to be that when the user clicks get a new meme image that it makes an API call, but instead when the app loads, it will get, I think it's like 100 memes. Then clicking the Get a New Meme Image button will simply randomly choose one of the items from that original array of 100 memes that we got when the app first loaded. The only reason that we're doing it this way is because I don't think that the image flip API has an endpoint to just get a random meme image, at least not one that's free. So this will work for us for now, and your challenge is to write the code that gets an array of memes from the ImageFlip API as soon as the component renders for the first time. Again, you'll need to check the ImageFlip documentation. In fact, I'm going to leave this up for just a second so you have a chance to click here. And when you get there, you'll find the correct URL that you'll need to call in order to get that array of memes. Once you've gotten the array of memes back, you'll need to save it to state so that we can access it from the component in React. At this point, I don't need you to worry about this get a new meme image button. And I do want to give you some fair warning. If you're tempted to use an async await function, I'm going to ask you not to do that, but instead to use .then in order to resolve the promises that come back from fetch. We're going to learn why after this challenge. All right, your time to shine. Get started on this challenge to get the array of memes from the ImageFlip API. Well, since we need to kick off this request as soon as the component loads, this would be a great time for us to use effect. This is an example of a side effect in React because we want to synchronize our local state from within this main component with an outside system, which is the data that lives at the ImageFlip API. So I've imported useEffect from React, and I can call useEffect here. The first parameter is a function, and because it's the more common way you'll see it, I'm going to use an inline arrow function. And before we write this code, I'm going to immediately start thinking about the dependencies array that I need to include here. So what does our side effect of fetching data from the API depend on in order to make sure that it is correctly syncing the data from the ImageFlip API with our internal state? Well, in our case, it doesn't rely on anything. It doesn't depend on anything in order for that sync to happen correctly. In other words, there isn't any local state that if it were changed, we would need to go refetch data so that it was correct. In our case, we're simply getting a list of 100 memes, and we're going to be using that list for our app. So I want to make sure I include the dependencies array because I don't want this fetch request to happen every single time state changes and the component re-renders, which remember happens every time we type in the input boxes here. So I need to make sure I include this, and effectively this is like saying I only want you to run the side effect one time when the component first mounts. All right, so what do we want to do? We want to fetch. And if we go to the documentation, we can see there is an endpoint called get_memes, and we can find the URL there. And so I'm going to paste it in. It's just this one for the api.imageflip.com/getmemes. And I need a closing quotation mark there. And as I mentioned, for now, we are just going to resolve this with a .then chain. We get a response back from fetch, and we will need to call res.json. That's going to parse the JSON body that we get from making this API call into JavaScript, and we can access that with data, or this is just a parameter, you can call it whatever you want. Let's go ahead and console log this data. Okay, we'll hit save. I'll open up my console, and perfect. It looks like we get the data correctly. If we look closely, the data that comes back is an object. It has a success property, and I guess confusingly, because we chose to call this data, it has a data property, which is an object that has a memes array. And so that's how we need to dig into this response data to access the array of memes. So again, I guess kind of confusingly, it's data.data.memes. By the way, quick side note, when I hit save, it's refreshing our app, which is kicking off yet another fetch request. However, refreshing your browser is something completely different than just changing state locally. There's a difference between clicking refresh, which reruns all of the code from React, and changing state, where React simply determines what needs to re-render to the page, but doesn't refresh your browser. So that's just why hitting save and refreshing is causing the fetch request to run again. And this time it looks like in the console, we accurately got the array of memes. If I scroll down here, it's pretty long. In fact, it's long enough that it doesn't even show everything here in Scrimba. By the way, if you're following along here in Scrimba, you can open your developer tools, and anything that we console log here will also console log in your developer tools. So that can be a good way to look into more complex items that we're console logging, like this array here. Okay, well, we don't want to console log it. We want to put it in state, and that state does not exist. So we're going to create a new one. Maybe we'll call this, let's call it all memes, and we'll pull in set all memes is equal to use state. And this is going to be an array, so I'm just going to initialize it as an empty array. And then instead of console logging, we'll call set all memes, and yeah, we want to set this array in state. Let's close our console. Since we're not console logging anymore, we can get rid of our challenge text. And actually, I'm going to keep this hint here for now because we're going to talk about that in a second. I can hit save. It's not going to be very clear that this is actually working, but I trust that set all memes is working the way it's supposed to work. So why did I give you this hint that says not to try and use an async await function? If you're familiar with async await, it might have been tempting to say, well, I want to use await for resolving these promises. And so I want to make this function an async function so I can use the await keyword and make this code a little bit tidier. If you're not quite as familiar, it allows you to do something like this where you say, well, the response is equal to await the finishing of this promise. And in this case, response would also be a promise. So we can say const data equals await res.json. And then we can simply set all memes to data.data.memes like this. This is quite a bit tidier. I personally like using async functions. However, when you're using useEffect, you can never make this function an async function. So before I screw everything up, let me get rid of all this. And in the next couple lessons, we are going to talk a little bit more about useEffect because there is a really important aspect of useEffect that we have not yet had a chance to cover, and understanding it is going to explain why we can't make this into an async function and what we can do to work around that limitation. So once you've had a chance to make sure that what we've done here makes sense, I will see you in the next lesson. We'll start this one off with a pretty simple challenge, just to get your fingers typing on the keyboard and make sure you're awake. We have this very simple app that has a button with the text of toggle window tracker, and then we have a window tracker component. Notice that the button isn't currently set up to do anything. That's going to be your challenge. Over in the window tracker component, right now, it's just displaying this H1 that says window width, and then it displays the window width at the time that it was rendered. We'll notice that if we change our window width, the display doesn't actually update. But if I were to refresh, we would get a new value of 494 here. We're going to address this a little bit later. For now, though, we can just focus on this first part of the challenge. The first thing I want you to do is to create new state called show and default it to true. Then I want you to make it so that when you click the button, it will toggle that show value. And thirdly, you should make it so that you only display this window tracker component if show is set to true. I'll hand it over to you now to work on this challenge. All right, let's go ahead and create some state. We'll say react.useState, and I'm already seeing I'm going to have to import React from React in order to do that. React.useState is going to give us some values back, so we'll say show and set show is equal to React.useState, and we'll default it to true. All right, and then we need a function so that it will toggle it. I could either do this in line with my button, or my personal preference is to make a named function out here. So I'll say function toggle, we'll call set show. It will look at the previous value of show and just return the opposite. About as simple of a set state function you can have. I'll add the onClick event to my button that calls toggle. And lastly, I need to conditionally render my window tracker so that it will only display if show is true. So I'll go ahead and use the $& method. Let's clean up our challenge text, hit save, and toggle window tracker. Okay, perfect. Now let's take a look at something. If I go to window tracker, remember that this window.innerWidth is being calculated as soon as this component mounts to the page, which in our case will happen as soon as we refresh the browser. So I refresh, we're at 418. If I resize this a little bit and refresh, it recalculates, we're down to 390. However, I also can toggle my window tracker off, change my window size, and toggle it back on, and we'll see that we're at 470. And actually, I don't have to toggle it off first. I can resize it. We'll notice that the 470 doesn't change, but if I toggle it off and then on, we get the new value. So why exactly is it doing that? Well, when I toggle it off, it's being completely removed from the page. I'm not just hiding it from view in CSS or anything, it's actually getting removed from the document itself. And so when I put it back on the page, this window.innerWidth is being evaluated again, and the new inner width of my window is being displayed. However, we can do better than this. If we want this number to display more in a live fashion while I'm updating the width of the window, what we can do is listen for a dedicated resize event on the window itself, and then add some state to our window tracker and update that state with the window.innerWidth every time the window is resized, or rather every time the window resize event triggers. By updating our state on our window tracker, we can have React re-render this component and give us a live view of what the current window inner width is. However, because I need to run this event listener on the window itself, I don't have a dedicated on resize event like we do with other DOM event listeners like we have been using thus far. So in order to add this resize event listener on the window, I'm going to have to do some more manual imperative DOM manipulation. And because I'm going to be interacting with a system outside of React itself by trying to interact with the window of the browser, I want you to think for a second, what tool does React give me so that I can interact with those outside systems and sync the internal state in React with it? That's right, it is useEffect. So I can go ahead and use React.useEffect. I'll put my callback function inside here. And when we try to think about our dependencies array, one thing that can be really tempting is to try and look at window.innerWidth and say, well, anytime window.innerWidth changes, then I want to rerun my effect to synchronize window.innerWidth with the state that we're going to set up in the future. However, something that's important to remember is that window.innerWidth is actually a static value. Right now it's 388, so this would be kind of like me putting in 388 as a hard-coded value here. And then we have to remember that when I resize my window, I'm not telling React to re-render anything. I'm not changing state or doing anything like that, at least not yet. So as tempting as it might seem, putting the window.innerWidth in there isn't going to be the solution here. So let me go ahead and get rid of that. So instead of that, we are going to add our event listener on top of the window. So I'll call window.addEventListener, and the event that I can listen for is actually called resize, and we'll pass a callback function that will run anytime the resize event happens. And for now, let's just go ahead and console log resized. All right, let's hit save. I'll start resizing, and look at that. We get our console log running every pixel, I think, essentially, that the window gets resized. All right, well, the next step is something that I think you should be able to do pretty easily by now, so I will type this out as a challenge. All right, here's your challenge. First of all, I want you to create some state called window width and default it to the window.innerWidth as its initial value. Then whenever the window width changes, you should update that state to the new window.innerWidth. And then down here below, instead of displaying window.innerWidth, you should display the new state that you created so that it updates every time the window width changes. In the end, you can see what we're doing is we're interacting with an outside system by adding a manual add event listener to our DOM, and then syncing our local state to the source of truth, which is the outside system that we're grabbing the window.innerWidth from. By syncing internal state with it, we'll be able to actually display to the user the value from that external system, or the window in this case. All right, it's your time to shine. Go ahead and get started on this challenge. Okay, let's call react.useState, and I'll create the variables that I'm going to save this as. This will be my window width, and we'll call it set window width. We'll initialize this to the window.innerWidth as the initial value. Then instead of console logging resized, I'll call set window width. And in this case, I don't really care what the previous value is. I can simply reset it to whatever the current window.innerWidth is when this event was called. Then lastly, I'm setting window width in state, but I'm not actually using it anywhere. So I will replace window.innerWidth with the state value of window width. Let's clean up our challenge text, hit save, and we'll try resizing the browser. And look at that, our window width is accurately reflecting on the page for the user to see. Well, now let's take a look at a little bug we have. Remember, our window tracker component is only displaying if the parent component. Great job on these challenges. Unfortunately, I have some bad news, and that is that we have a bit of a bug in this in our code. And the bug exists over in our window tracker, but because this lesson has gotten a little bit long, we are going to talk about the bug and what the main fix is for it in the next lesson. We have a pretty sneaky bug that lives in our window tracker component right now, and it's not immediately apparent what the problem is. Using the app makes it seem like everything is working just fine. We get our window width updating on the page. We can toggle it on and off. If it's off, we can resize and it doesn't look like anything's happening. So what's the problem here? Well, we can highlight it if we were to add a console log back into our resize event. Let's just say resized. I'll hit refresh. If I resize it, I'm going to try and just resize it one little section. I think it'll maybe go by 2 pixels. Okay, so we got a single console log running. Well, let me toggle off my window tracker. I'll do a resize. We'll do a single pixel again. Okay, it's still resizing, even though my window tracker component doesn't live on the screen. Okay, well, what happens if I toggle this back on and off a bunch of times and then try to resize the browser? Right now we have 2 resized in the console. I'm going to go just a single pixel here and take a look at that. It looks like we got 7 new resized console logs showing up just by doing one resize event. So why the heck is this happening? Well, remember, useEffect gives us a chance inside of React to interact with or sync state with some kind of external system. In this case, when we're adding an event listener to our window object, this is happening outside of React. I'm registering an event listener with the browser. When I toggle the window tracker off, I'm not giving any kind of instruction to the browser to say, hey, I'm done with that event listener, you don't need to listen anymore. When I toggle the window tracker back on, it's remounting the window tracker component, and in the first time that it mounts, it's adding another event listener. Kind of a silly analogy I came up with. I imagine myself walking into a store, asking a store employee if they have, I don't know, a certain item in stock. By doing so, that employee has to go maybe back into a warehouse to check to see if they have it in stock. And in the meantime, if I just kind of abandon my cart and leave the store, at no point did I tell the worker that, hey, I actually don't need you to do that work anymore. And kind of to stretch the analogy a little bit thin, when we toggled our window tracker on and off a bunch of times, it's kind of like me going from one employee to the next, asking them to go do a task for me, and then just kind of leaving them and not needing them to complete their task. Because we're creating a side effect in React, it's really important that if we reach a point where we don't need to interact with that outside system anymore, like, for example, if we're toggling off our window tracker, then it's really important that we clean up any of the side effects that we have created. In this case, we're adding an event listener. It's going to be important that we remove the event listener. If instead, on the mounting of our component, we had created a WebSocket connection with a server, then it would be important if we unmount that component to disconnect that WebSocket connection. Fortunately, in React, this is a pretty easy task. Remember, when we created our useEffect, we passed a callback function as the first parameter to useEffect. But as it stands, we're not currently returning anything from this function. So you might be wondering, well, what does React do with the value that we return from the function that we pass to useEffect? And as it turns out, what we can optionally return from a useEffect is a function. In fact, just to make it abundantly clear in the syntax, I'm going to use a function declaration like this. So behind the scenes, React is going to call the function that we gave it, and it's going to save as a variable the function that we return from our useEffect callback function. And when this component gets unmounted and React determines that it's time to potentially clean up any of the side effects that we have created in our useEffect, it will take the function that we give to it and it will just run the code. It doesn't know what's in that code, so it's up to us to make sure that we clean up any of the side effects that we created in the first part of our function. With the addEventListener method, there is sort of a sister method called removeEventListener. And in order to make that work, I have to pass it the exact same function that I used when I was setting it up. So in order for that to make sense, I'm going to have to move that function into its own named function. And let's give it a name, maybe watch window width. I can pass this named function to my addEventListener, so that's working again. And then in my cleanup function from my useEffect, I need to call window.removeEventListener. And I'm going to remove the resize event listener that we created and need to pass my watch window width function so that it knows which of the functions it needs to remove. Let's see, we still have our console log in here, so we should be able to test to see if this is working. I'll hit refresh. Let's resize just to make sure we're working okay. Okay, we got 4 of those. That's because I moved it a few times. If I go really slow, I can get it to do one at a time. Let's clear that out. I'll turn off my window tracker and we'll try resizing. Okay, we're not getting our console log. I'll also kind of turn it on and off a bunch of times, and now it's on. Let's try to resize it just by a little bit, and sure enough, we only get the console log running once. So as a recap, because we have an empty array here, we are just calling this useEffect one time when the component first mounts to the page. When we do that, we're setting up an event listener for the resize event on the window object, and it's going to run this function if the resize event ever happens. Then we're returning our cleanup function, which says if this component ever unmounts, just run whatever code I put inside of this function so that I can be sure I don't have any of these side effects just kind of floating around inside my browser. So as long as my component is on the page, this event will work just as we might expect. As soon as it leaves the page, React runs our function, which removes the event listener, and therefore I no longer get my resize console log running. In fact, one last thing that we can do just to see for sure that this is happening is if I add a console log inside of my cleanup function saying cleaning up, let me hit save, we can trigger the resize event like this. Okay, we get resized, and then when I toggle it off, I get cleaning up. So one final recap before we move on. useEffect allows us to interact with outside systems and potentially have side effects inside of our React code, which normally should be side effect less. It takes two parameters. The first one is the effect function, and the second one is the array of dependencies that determines when that effect function should run again. At bare minimum, if we include an empty array, it will only run the first time this component mounts to the page because it depends on nothing else to rerun. And at the most, if we were to not include this array at all, it would run on every single render of this component. In fact, we can delete this dependencies array and hit save. We'll see that it's going to run both resized and cleaning up every single time this component re-renders. You will pretty much always want to include a dependencies array and think very carefully about which values you want to be watching in order to trigger this effect again. Then lastly, the callback function as the first parameter to useEffect is allowed to return a function which will clean up any of the side effects that you might have created inside of your useEffect code. Returning this cleanup function is something you will want to always be aware of, but it isn't something you always have to do. It's relatively common to have your side effects not have anything that's lingering and needs to be cleaned up. So just know that it's here as a tool for you to use if you need it, but it's not something that you absolutely have to correctly write a useEffect. As always, if you need to go through the content that we've been talking about with useEffect, that's completely okay. It is what I have found to be one of the most confusing topics, not just for beginners in React, but for even seasoned React veterans. useEffect is great as a tool whenever you absolutely need it to kind of have that escape hatch from the React ecosystem and the React functional programming paradigm. But it is something that can be commonly abused for those who don't really understand what it's for or what the common workarounds are for it. With practice, I know that you are going to be an expert when it comes to understanding effects in React. We're actually going to have a chance to apply what we just learned about useEffect and the cleanup function to our Chef Claude app from the last section. But before we find ourselves juggling too many things, I want to tie a nice little bow on our meme generator because currently our get a new meme image button doesn't work. We're saving the array of all memes in state, but what we need to do now is randomly choose one of those meme images when the button gets clicked. This is going to be more of a quick algorithmic challenge rather than dealing with any side effects, but I really want to finish off this app so we can move on from it. So let me type out a challenge for you. All right, your challenge is to get a random image from the array of all memes when the user clicks this Get a New Meme Image button. Once you have gotten a random image from the array, make sure that you write whatever code it is that you need to write so that the image you selected will display on the page. As I've done a few times, I'm being a little bit vague because I want you to think how that's going to work. So go ahead and give this challenge your best shot. Let's work in the same order that the user is going to be interacting with the page. So down on our button, see that's right here. Let's add an on-click event listener for a function we have not yet written. We'll say, maybe call it get meme image. So let's go ahead and write this function. I'm just going to do that in place of the challenge text, get meme image. And this is where it's kind of just an algorithmic challenge. So what I can do is get a random number from 0 to the length of the array. We'll just say array.length. Then we will use that random number to get a random meme object from the array. And then we will need to set state. And that's the state of the current meme, which is the object we're saving in state up here. All right, so let's get a random number. We can just say const random number. And honestly, getting a random number is something I sometimes have to look up, but we can simply say math.floor, math.random times all memes.length. If you've never seen this before in JavaScript, maybe just copy this line and paste it into ChatGPT and have it explain it to you. It's not too terribly difficult to understand, but it's enough to know that this will get a random number between 0 and the highest index in our all memes array, which means we'll never try to index outside of the array. So that was that step. We want to use that random number to get a random meme. And I think I can just do this together. We'll say maybe new meme URL is equal to all memes at the index of random number. And those meme images have a .url property. You weren't like expected to know that per se, but along the way of doing this challenge, you probably wanted to console log the new meme that you indexed into, or console log all memes just to see what the structure of each one of those meme objects was. And you, at that point, should have seen that there's a URL property. Okay, and then we're going to set the state. Well, we're setting the state of an object, and we don't want to lose the top text or bottom text. So I'm going to say set meme. I need to know what the previous meme was, and I'm going to return a new object that has all of the properties from the previous meme, but changes the image URL to the new meme URL. This should be straightforward enough for you at this point in the course. If not, that's completely okay, but it is probably a good indication that you need to do a little bit more studying and a little bit more practice before just kind of plowing ahead with the course. Okay, let's test it out. We'll hit save, get a new meme image, and awesome. Okay, we got a new meme image, and this is going to work with all of the images from that memes array. Again, as I mentioned, some of the memes don't just take a top text and bottom text, so it'll be a little bit hit or miss how funny these memes that you create are. Awesome, we can mark the meme generator as completed. I'm sure there's other things that you could decide to do with this project, and as always, feel free to do that. Play with this code, add your own features, and most importantly, go to the Scrimba Discord and share your awesome work. Okay, I want to jump back for just a few short lessons to the Chef Claude project, because now that we understand useEffect, there's a little but really nice feature that we can add to that project. So once you've had a chance to say goodbye to the meme generator, let's continue forward. I wanted to go over a pretty truncated view into refs in React and the useRef hook. I say it's really truncated because we're going to be going through it pretty quickly, only because I have an improvement that I want to add to our Chef Claude app that will require us to use refs. And actually, this reminds me, before we move on, I was getting a little bit bugged that we had not moved some of our components that really should be in a components folder. And really quick, before we jump right into the slides, I did make a couple really simple changes to our Chef Claude app. Primarily, I moved some of the components into a components folder. I think before I maybe had the main component and the header component sitting outside in the project root, but they felt a little more natural inside the components folder, so I moved them there and then fixed the references that we had with our relative paths in each of those components that needed them. Just wanted to make sure I highlighted that before anyone got confused why it was looking a little different. Okay, so what are refs in React and what is useRef? Refs are fairly straightforward. They are very similar to state, except for two major things. The first one is that you can mutate refs directly. With props or with state, we know that it needs to be immutable, and the term immutable might not, on its face, make a lot of sense because you might be thinking, well, we do change state all the time. That's how we trigger re-renders in React. But to split hairs, when I'm talking about mutable, I'm saying we're not saying something like, okay, here's my ingredients state, and I'm going to push a new item to my list of ingredients. This would be directly mutating state when we know that we're supposed to use the state setter function. Behind the scenes, React is not just setting our old ingredients array equal to something new or doing something like .push. It's following a more appropriate functional programming paradigm where behind the scenes, it's replacing the old version of state with the new version of state and then kind of queuing it up to re-render the page. So let me get rid of this line. And refs, on the other hand, are things that we can mutate directly. We can just set them equal to something different. And maybe more importantly for us, changing a ref doesn't cause a re-render in React. For reasons that might not be immediately apparent, refs tend to commonly be used for accessing DOM nodes without needing to assign IDs to them and run DOM manipulation commands like document.getElementById or query selector. Refs give us a way to access those DOM nodes. Creating a ref in combination with using a ref prop, which we're going to see in just a minute, give us a chance to do some of those manual DOM manipulation tasks. And again, the reason for this might not be immediately apparent, but that's okay. We're going to get to it. I did mention this is a very high-level overview of refs. I do dive a little bit more deeply into refs in my advanced React course, which is kind of the natural progression after this free intro to React course, where in one of the sections I cover refs in a little bit more detail and give you a little bit more practice with them. All right, why am I talking about all this? In our Chef Claude app, we are getting our recipe. We can click the Get a Recipe button, and if we look very carefully, we'll see that the scroll bar, when the AI finally gets back to us, the scroll bar on the app will appear and we can scroll down and see the recipe. However, as far as the user experience goes, it's not that great. We don't really give a clear indication to the user that the recipe has finally loaded, and unless their page just happens to be a little bit longer, like we see here, in this case, it's a little more obvious. They can click Get a Recipe, and what used to be blank will then become populated with the recipe once it's loaded. But I don't know that we want to bank on this, because their browser might be a little bit shorter like this. So what can we do? Well, there is a DOM node property. I'm putting DOM node here as a placeholder, called scroll into view. And as the name suggests, when you select a DOM node and you call scroll into view on it, the browser will automatically jump down to that section. So if our DOM node were this entire recipe section, whenever scroll into view is called, the browser will jump down so that that sits at the top of our view. And actually for us, that might be a little more jarring. We might want to have this section be what we scroll into view, just so that it's a clear transition between where they see it here at the bottom and they'll still be able to see it here at the top. So the trick is, how do I get access to this DOM node? Well, in vanilla JavaScript, all we would do is we would add an ID to one of our elements, and then we would call a getElementById. And that might be able to work for us just fine. However, React is really centered around having reusable components. We haven't spent too much time talking about reusability. That actually is another topic in my advanced React course that we spend quite a bit of time talking about. We go really in depth on reusability in React. But the point is, if I were to reuse this component or render my main component for whatever reason multiple times, I would end up with two elements that have the same ID on the page. And if you know anything about HTML, that's just a no-no. You're not supposed to do that. So this is where refs come in. Refs give us a chance to access a DOM node so that we can call methods like scroll into view. And they are easy enough to create when we use the useRef hook in React. So I'll go ahead and create a new ref here. Since we are allowed to mutate our refs directly, I won't need to do the same thing I did with useState, where I'm given a state setter function. But instead, I can just give my ref a name. Let's call it the recipe section, because I'm going to be scrolling down to the recipe section. And we set that equal to react.useRef. Kind of a standard practice. If I am using my ref to set on a DOM node, I'll initialize it as null. And now that I've done that, what I can do is take any element that I want to have access to the native DOM node of, and I can set a special ref property. Now, I don't actually want to put it on the input, but I'm just using this as an example. Ref is a dedicated property in React. It's set aside for the use of setting these refs on DOM nodes. And so if I did want it on my input, I would say ref equals curly braces recipe section, just like that. Now, let's get it off this input. This isn't actually where we want it. Let's think, where is it that we do want our ref to exist? Remember, the purpose of the ref is so that we can call scroll into view on it when the recipe loads, so that the browser will automatically scroll down. And I think we decided that this ready for a recipe sort of call to action would be a good place to scroll down to. So where does this live? I think we ended up putting this inside of our ingredients list. So if we go to our ingredients list, sure enough, here's this section. And we have this div right here that says ready for a recipe. That's this div right here on the page. So this is where I'm going to set my ref. I'm going to say ref equals curly braces, and we don't have access to this recipe section quite yet because it exists on the parent component that is rendering ingredients list. So I want you to think, how can we get access inside of this child component to the recipe section ref, which currently only exists inside of our main component? What mechanism do we have in React to get access to that? If you said props, then props to you. That's correct. So here is our ingredients list. We can go ahead and say we're creating a new prop called ref. Now, I don't want this to be confusing because I did just say that ref is a dedicated property in React. It means something special, but I probably should have qualified that. It only means that if it's put on a lowercase regular React element. Kind of like how on a button, lowercase b button, I can say on click, and this is the actual event listener. Whereas if I'm working with a custom component like ingredients list, if I say on click, all I'm really doing is creating a new prop, a custom prop, that just so happens to be spelled exactly the same as the native DOM property for onClick. The same exact thing goes with ref. So I'm going to set ref equal to recipe section. That's the ref that we created up here above. And this means that I can go to my ingredients list, and we need to make sure, yep, we're receiving props, and I'm going to be receiving this through props.ref because that was the name of the ref that we gave it. In this case, because we're working with the lowercase d div, regular native DOM element, or what will get turned into a native DOM element, this ref does mean something special. All right, well, this lesson is growing a little bit long, so let's go ahead and do this. I am first going to just console log recipe section so we can get a better idea of what this ref looks like, and we're going to open our console because we need to look very closely at something. I'll hit save. Down in our console, we see that recipe section is an object that has a current property. I'll be completely transparent here. I'm not entirely sure why refs, when they're created, are always objects with a current property, but that's just something you'll have to get used to. The reason it says null is because that's what we initialized it here. If I were to instead say this is a string, and hit save, we can see now it's an object with a current property, and its value is the string that we initialized it with. So that's all that's happening down there. Let's change this back to null. I'll hit save, and now I'll click get a recipe. We'll wait for the API to return its response. And now take a look at this. Our recipe section ref is now an object with a current property, but the value of that current property is a div. Now, Scrimba's console is representing this almost like a JSX element div, but it's really representing a native DOM element for the div where we set our ref inside of our ingredients list right here. Okay, this lesson has gotten quite long. I do have a challenge for you, and it's going to harken back to useEffect. So once you feel comfortable with what we've done here, again, I know it's been kind of a whirlwind, we will jump right into that and actually implement our scroll into view feature. One thing I realized I might need to clarify is why, when we first render our page, the recipe section ref is set to null, or the object with the current property is set to null. In my case here, because I am console logging it immediately after it's created on line 11, it's still set to null, and React hasn't yet had a chance to render the elements on the page. As soon as the elements on the page get rendered, ingredients list gets rendered, which then includes this section down here where the ref is being stored. At that point, the ref is then immediately stored as this div, but we're just not getting a chance to see that because we are console logging it before anything has been rendered to the page. Clicking the Get a Recipe button, when the recipe response comes back, it sets state and it re-renders the component, which then reruns our console log line, and we get to see, even though it's a little bit delayed, the fact that the ref has been accurately set on that div. In fact, I think we could also see that if we just add another ingredient here. I'll hit enter, and yeah, sure enough, in the console we can see that the recipe ref is set to the div. Just wanted to clear that up, just in case anyone was confused why it was initializing as null. Okay, let's apply refs so that we can add the feature that we want to add, where the page will scroll down. So the problem that we have is that we want to scroll down to this ready for a recipe section only after the Claude recipe section is rendered to the page. Or in other words, when recipe, as we're initializing it, is not an empty string anymore. Maybe keeping in mind that this is a section all about useEffect, I'm going to put a pause in here and give you a chance to think from a high-level architecting overview. what might need to happen in order to solve this problem or add this feature. If we think about it, we are hoping to create a bit of a side effect because we want to scroll the browser down, which involves doing a manual DOM node method call. And we want to synchronize that action or that side effect with a value that React is holding in state with recipe. And so this brings us to your challenge. I want you to add a new side effect that calls recipeSection.current.scrollIntoView. But it should only do this if the recipe is not an empty string and if recipeSection.current is not null. That's an important thing we'd want to make sure. We can't scroll it into view if recipeSection.current is not the div DOM node, but is null. We're going to get an error if we call scroll into view. So we need to make sure of that as well. The important part of this challenge is I want you to think carefully about what values you would want to include in your dependencies array. What will this side effect actually depend on in order to perform its action correctly? Once again, I'm being a little bit vague. I want you to put on your thinking cap and give this challenge your best shot. So go ahead and start working on this challenge. All right, well, to create a new effect, we're going to call React.useEffect. Alternatively, of course, we could just destructure that from the React library up above. UseEffect takes two parameters. We have a function and a dependencies array. Let's worry about the dependencies array next. We'll first work on this function. So the clue to the code we're going to have here is written in the challenge text, if the recipe is not an empty string. So we'll need to add a conditional here. If the recipe does not equal an empty string, we could theoretically also just say if recipe is a truthy value. I think I'll opt to be a little more explicit and specifically say if it's not an empty string and recipe section.current does not equal null. Once again, I probably could just say and recipe section.current, but we'll stick with being explicit here. If those things are true, then I know that I want to call recipe section.current.scrollIntoView. Well, let's think carefully about what we might want to include in the dependencies array. What would happen if we put nothing in the dependencies array and we just left it as an empty array like this? In fact, I'm actually going to put in a pause here so you take a second to think about that. If our side effect depends on nothing, which is what it means to have an empty array here, then this useEffect would run when the first time when the component first mounts, and when the component first mounts, recipe is equal to an empty string, and so our scroll into view would not get called. This is exactly what we would hope that it would do. We don't want it to try and scroll down to it right at the beginning when the component is first mounted. But because we're telling it that it depends on no external values, then it's never going to call this useEffect function again. So an empty array is incorrect inside of our dependencies array. We want React to rerun this side effect anytime that recipe changes. If the state value for recipe changes, we want it to rerun this effect to determine if it's time to call scroll into view. So let's clean up this challenge text and we'll hit save and give this a shot. I'm going to click get a recipe and check it out. It scrolled us into view. That's awesome. Now, one thing I'm sure that you noticed is that it did it pretty abruptly. It just kind of jumped down the page immediately. And if you are already familiar with the scroll into view method, you might be shouting at your screen, wait, there's a better way to do this. Unfortunately, there's a small limitation, and this lesson has gotten a little bit long already. So we're going to talk about that bug in the next lesson and see a little bit of a workaround for it. But in the meantime, if this useEffect that you wrote here made sense to you, then kudos. That represents a big leap in your understanding of side effects in React. And if it didn't, that's okay. Having a solid understanding of useEffects took me quite a while to grasp. So it's definitely nothing to be ashamed of, but it does give you an indication that it might be time to go back in the course and maybe review some of the lessons that we've had previously. Once you're ready, we are going to add some code that will do a little bit more of a smooth transition down to this ready for a recipe section, just to make the user experience a little bit better. In the previous lesson, we got our scroll into view to work, although we did notice that it's a little bit abrupt. The user experience isn't as great as it could be if instead of immediately jumping down the page, if it were to smoothly scroll down the page to this Ready for Recipe section. And the reason that it's jumping immediately is because that's just the default behavior for the scroll into view method. But as I mentioned, if you've used scroll into view before, you might be saying, hey, there is a way to do this, and that's by adding a configuration object where you can say the behavior should be smooth. And if you happen to be following along on your local machine, then you could put this into your code and it would just work correctly. However, for those of you that are following along here in the Scrimba interface, there is a small problem, and that is that, well, behavior smooth just doesn't work. Let me show you what I mean. We'll click Get a Recipe, and when the response came back, we can see it might have scrolled like a pixel or two down the page, but it simply didn't scroll smoothly down to the section that we wanted it to. And the reason for it is a little bit interesting. It's actually not a bug in Scrimba. It's a known bug in at least Chrome-based browsers that use an iframe. For whatever reason, if you have an iframe that you're trying to run scroll into view with a behavior of smooth on, it just doesn't work. And our Scrimba environment is a little bit unique because we do have an iframe that displays our mini browser. So this behavior smooth isn't going to work inside of Scrimba, but in your local environment and pretty much everywhere else, unless you're using an iframe, it should work just fine for you. I did find a little bit of a workaround. I'm not going to really dive deep into the code, although I'm going to paste it here for you to have a chance to play with, and just so we can see that it's working. So right here, it's simply figuring out exactly where on the page or in the viewable area of the browser that it should scroll down to, and then it's using window.scroll with behavior smooth. And for whatever reason, this works just fine inside of a mini browser. So let me hit save. We'll go ahead and click Get a Recipe. And sure enough, we got a nice smooth scroll down to where we wanted it to go. I'm going to leave this line of code commented out just so if you refer to this, you can know that this in pretty much every other environment is going to work just fine for you. But I'll leave my real code here so that we get the behavior that we want. Great work making it this far through this section. I know that side effects can be a little bit hard to grasp, and I know that from going on about 8 years of teaching React at this point. Hopefully, the way that I presented it was able to demystify what side effects are and how and when to use useEffect in React. If it does feel a little bit hazy or cloudy to you still, that's completely okay. Use this as an opportunity to join the Scrimba Discord if you haven't already and start asking questions there. See if any of our amazing community members can help clarify for you when and how you should be using useEffect in React. And believe it or not, this essentially wraps up the scope of all the topics that I wanted to talk about in this Intro to React course. However, because we're here on Scrimba and because we have such a strong emphasis on getting your hands on the code, for the remaining of this course, we are going to be in full-on project mode. We have some awesome things coming up. So even though we're done with these topics, the real benefit of this course is going to be with getting your hands on the code and practicing as much as you can building projects. Let's do a quick recap of what we've learned in this section, and then we are going to dive headfirst into some awesome project building experiences. Wow, can you even believe how far we have come in this course? It truly is mind-blowing, especially if you look back at some of the topics we were covering in the first section of the course. Your understanding and capabilities in React have truly expanded. We have come to the end of the new instruction in this course. That said, some of the most important tasks I have yet to give you in the upcoming sections. Before we jump straight into those, let's do a quick recap of what we have learned in this last section. We started off with some quick lessons about controlled components. Since we wanted to update our state on every single keystroke of our input boxes, we had to make them into controlled components. React 19 has introduced new ways to handle forms, which are quite a bit more intuitive and in line with the native web platform, but there are certain circumstances where controlled components can still be important to know. We took a quick dip into theory as we talked about functional programming in React and how React adopted the paradigm that it currently has, which helped us understand the whole concept of side effects in the first place. Then we looked into how we can fetch data with React, not necessarily when a user interacts with our page to request that data, but when the app loads for the first time. And that led us into understanding the actual application or syntax of applying side effects in our React app. You're about to dive into some really exciting projects, and so this would be a great time to express your excitement about finishing Section 4 over in the Scrimba Discord community's Today I Did channel. Clicking the screenshot will take you directly there, where you can celebrate with the other people who are also completing great tasks today. All right, I can hardly wait. Let's jump into some project work. The remainder of this course is going to be 2 back-to-back capstone projects, starting with this first one, which is a game called Tensies. Now, let me be completely clear. Ask anybody in the field, and they will very frequently tell you that project building is the way to learn something new. There is no way to get better at React than to have your hands on the keyboard practicing React as much as possible. So although we won't necessarily be learning much new content in these remaining 2 sections, they do represent the most important parts of this entire course. Do not, under any circumstances, skip these capstone projects, or you will only be shorting your own education. Really, I don't mean to go on too big of a guilt trip, but this is where the real learning happens. If you're not familiar with the game of Tensies, it's a game that's a little bit more geared towards children, as it deals with rolling a bunch of dice. The way that you play, and there's a GIF here that will kind of animate and show you how it works. You roll your dice, you try to get all 10 dice to have the same number on top. And so in our game, which we'll just move over here to the live version, I can click the dice that I want to hold. When I roll, it will roll all the dice except for the ones that I held. And let's see how lucky I can get here. We're just going with the 4s. There's another one. And this is usually where I start to get pretty unlucky in my rolls. Okay, there's one more. And okay, we have our last 4 here. What's really fun about this app, and you won't be able to see it here in the recording, but if you refresh here and play through the game, you'll see that when you click the last number and all the numbers are the same, then a really fun confetti drop starts from the top of the browser window. The button changes to New Game, and clicking it will, of course, start a new game. Feel free to look through the code ahead of time if you kind of want to get a lay of the land and see all of the fun things that we're going to be working on. And keep in mind that this project is going to be one where I am simply giving you a challenge and then expecting you to work through the challenge, even if it stretches your capabilities and understanding a bit, and then we go through it together to make sure that we're on the same page. Well, what are we waiting for? Let's jump right into the first challenge. Here we are starting from an almost completely blank canvas. The only things that we have are our React and React DOM dependencies installed. Our index.html is bare bones, as it usually is in a React app, although I did include the inter font from Google Fonts, so you don't have to worry about that. And our CSS is very sparse, just some very basic styles so that we can start from a good place. Hopefully this feels good to you. I know it's probably a little daunting. It's been a while since we have set up a React app completely from scratch, but that's exactly why we're doing it. So the challenge this time is just to start up a brand new React app. Some notes on how I'd like it structured. I want you to create a separate app component that will be in a separate file. Then here in the index.jsx file, I want you to import and render that app component. Inside the contents of the app component, just render a main element. It doesn't have to have anything inside of it, but then what you'll do is just style everything so that it looks like this very beginning state here where we have this blue background color and the main element, which is the white box here with the rounded corners. Click on the screenshot here to go directly to the Figma file where you can get all of the specific styles, including the colors and how much of a rounded corner there is and everything like that. All right, let's jump right in. Go ahead and spin up our brand new React app. If you had to go back to some of the earlier lessons and see how we scaffold a new app in React, believe me, it's completely okay. In fact, the recommended way of spinning up a new React app is by using Vite, and Vite will bootstrap all of this beginning stuff for you. So truly don't be fretting too much if you don't remember how to do these beginning lines of code. That said, we are going to go through this together. I need to import React DOM from React-DOM, and I'm going to call React DOM to create a new root element, and we have to tell it where that root is going to exist. So not a string, we need document.getElementById with the ID of root that's going to reach into our index.html and find the div with the ID of root right here. And this will serve as the root for our entire React app. Everything will get stuffed right here inside of this div. I'm just going to chain on top of the create root the render method, and I'm going to have it render the app component that I have not yet created. But for now, let's pretend we have created it. We'll import app from ./app, and let's go ahead and create that file, app.jsx. I honestly can't remember if I taught this earlier in the course, but whenever I'm creating a new file that is intended to be a React component, Best practice is to give a capital letter to the file name. So since app.jsx is going to export default function app, this is going to be my app component, I want to make sure that the file name starts with a capital letter. Okay, this app component just needs to return a main element for now. So that's what we'll put in. And just to make sure I can see it, let's go ahead and type something here. We'll cross our fingers and hit save. And oh, we got an error. Let's see, react.createRoot is not a function. And yes, I missed this critical part here. This has to come from the client library in React DOM. Okay, good. Here we go. Type something here. Not too big of a bug. That's okay. Okay, let's spend the rest of our time doing some styling. I can see from the design file in Figma that I have this kind of dark blue background color. So I'll set background color to the dark blue that I see in the design. And then we will select our main element and give it the background color from the design as well. It's kind of like a whitish color. It's a little hard to see, but underneath type something here, we have that white box. Just to make it a little more visible, let me give it a height for now. We'll give it, maybe let's say 400 pixels just to start out. And I'll make my thing a little bit bigger here so we can see that bottom border. Let's actually start with 300. I'm going to be changing this in just a second, so this shouldn't be too big of a deal. And I need that blue border around everything. I think I'll accomplish that with some padding. Let's go ahead and give this some padding of 20 pixels. All right, we need a border radius for the rounded corners, so we will add a border radius of 5 pixels. And really quick, let's address the issue on mobile sizes. We see, first of all, this will just expand to as wide as we decide to go with our browser, and we hard-coded this height of 300 pixels on here. I think we can do a little bit better than this by adding some view height that allows the box to take up the entire view height, but we'll also do some max height stuff so that it doesn't get out of hand. Let me make this a little bit tall and just try to give this a height of 100 view height. And well, actually, we're able to scroll here. I think that has to do with our padding. Let's go ahead and move our 100 view height to the body. We'll add a height of 100% to the main element, and then I'm actually going to change the display of the body to flex. We'll use a flex direction of column. And then we actually have a layer between our body element and our main element. And that is a little bit tricky to find, but remember, we are stuffing our entire React app here inside of the div with the ID of root. And so we need to make sure that that div will fill its entire parent container. So I'm going to select the div with the ID of root and tell it that the height should be 100%. Okay, we don't get a scroll bar. Let's see if we make this bigger. Okay, we have that 20 pixel padding around everything, and the box is resizing accordingly. I think there's a point at which it's going to get way too big. And so on this main element, I'm going to give it a, let's put it right here. We'll call it a max height of, I don't know, let's say 400 pixels. Maybe we'll do the same thing for a max width. And then I think I will make this float in the middle. And actually, what I'm controlling here is the div with the ID of root. Let's see if this works. We'll just center everything. So I'll do justify content center and align items center. And this always kind of gets me. I think because we are going multiple levels down between the body and our main element, we just need to pass along some of these styles. So I need to make sure that my width is also 100%. And I think I need to do that same thing with my main element. And then we will actually move the max height and width to our div with the ID of root. And yeah, that looks like it might have done it. Our main element is a block level element, so it should already be taking up 100% width of its parent container. The only reason we had to add this to the div with the ID of root is because creating a flexbox for its parent changes the display for its child, the div with the ID of root. For any of you who are much better at CSS than I am, there might be a better way to do this. I would be happy to hear about it in the Discord, or you can reach out to me on X. But for now, I'm going to stick with this. I'm also going to just resize this browser so that we don't have to think too much about it. Let's go over to app and remove the type something here. Hit save, and it looks like we are in the same starting point that we're supposed to be in. And listen, I know that starting from a completely blank canvas can be a really challenging thing when you're first learning a new technology. So don't feel bad if you were feeling a bit stuck. It's also been a really long time in this course since we have started a new React app from scratch. So if that was a little bit of a struggle, that's completely okay. From here on, though, we are going to be having challenges that should be pretty doable for you at this point in the course. So take it as just another sanity check. If the upcoming challenges do represent too big of a challenge for you, it's not something to feel bad about, but it is a solid indication that you might need to go back and rework some of the practices and projects that we've done in the previous sections. So without further ado, let's jump in and start adding some more content to our Tenzies game. In this part of the challenge, we are going to create the dice that actually show up on the page. We're just going to have some hard-coded values for now. So other than simply creating a component, this is going to be a pretty CSS-heavy challenge. Because this is a capstone project, I am going to ask that you do the CSS. I know in the past I have said that we should just focus on React, but due to this project being intended to practice all of the skills that it takes to build new apps in React, I do want you to do the CSS for this. That said, once you're done getting these dice kind of in the center of the page like this, the rest of our CSS will be relatively simple in comparison. I've also tried to give you some hints in the challenge text, but we'll get there in just a second. Your challenge is to create a die component, and yes, die is the correct singular of dice. Unfortunately, it will make the rest of this project sound a little bit violent, but I promise I'm a benevolent actor here. This is going to be a fun project. Your die component should take a value prop where it will take in whatever value it's going to display on the dice as a number. And I don't know that I wrote it here, but it should render a button with that value displayed. Then for now, I want you to render 10 instances of this new die component. We'll just render it manually, so it'll be here actually 10 times, where you'll pass in a value to each one, where the value is somewhere between 1 and 6 inclusive. Then I want you to add the styling to the main element and the die components so that it looks like it does on the slide. As a hint, what I would recommend doing is creating a container around the 10 die components that you render, and using a display of grid to get them evenly spaced in the 2 rows with 5 columns like you see here in the picture. Speaking of the picture, just like in the other ones, you can click on this screenshot to take you directly to the Figma design file, so you can find things like the code for this drop shadow or the font size or whatever else you might need the design for. So I'd recommend making a container so that you can get your grid evenly spaced with the dice, and then turning the main element, which is what we have as this white background, into a flexbox to make it easier to center up vertically and horizontally the container for your dice. I wrote both of those hints down here so you have access to them easily. All right, I know you've got this. Let's get started on this challenge. I'll start by creating a new file called die.jsx, a totally innocent version of die, and then we will export default our function die. We already know it's going to take props because, well, the challenge said for it to take props. It's going to have a value prop. And this should return a button because this is going to be clickable by our users. We want to make sure that we use the button element so that we get all the free accessibility stuff that comes with the button element. And what goes inside will be props.value. Props.value might seem like it's a little bit out of the blue, and that's because we haven't rendered any die components. Let's go ahead and see, I can get rid of this. We'll import die from ./die. I'm going to put this on its own line to start. And we will just have a presentational div. This is just going to be the container. Let's give it a class name and call it dice container. And inside, I can render 10 instances of my die component, and I'll just pass in a value of 1. It's also okay if you chose to pass it in as a string. I don't think it's going to matter too much for us at this point. And then I will just copy and paste this 10 times. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, one more, 10. And it's probably not going to be pretty, but let's go ahead and refresh. And sure enough, we get our 10 buttons on the page. Awesome. At this point, I think we will mostly be over in the CSS. So let's go over here. And I guess we're already here in the main element. So let's go ahead and change this to a display of flex. I'll give it a flex direction of column, and we will justify content center and align items to the center. Okay, nice. That got all of our buttons just right there in the center of the page. Let's go ahead and select our dice container, change this to a display of grid. And I'll be completely honest here, CSS Grid is not something that I have a ton of experience in, so I usually end up turning to ChatGPT to help me come up with the styles that I end up putting in my grid. Let's go ahead and change our grid template so that we have 2 auto-sized columns. So that's going to be auto-auto. And then we want 5 1 fraction unit rows. And so I can use repeat 5 times of 1 fraction unit. Awesome. We can give some spacing to this with a gap of 20 pixels. And now let's work on our buttons a little bit. So these will just be the buttons inside the dice container. So I'm just going to select it like this. And I'm just going to put down some of the CSS that I can find in the design. So we have a height of 50 pixels, a width of 50 pixels. There's a pretty cool box shadow in the design, so I can just copy the value that I found there. It's going to have a border radius of 10 pixels, and it looks like we get some interesting default borders from the button, so we'll just say border is none. The button kind of has its own color, and it's a little too similar to the background, so we'll give it a background color of pure white. And oh yeah, that makes it stand out a lot better. The font is pretty small. Let's give it a font size of, let's try 2 rems. Oh, that's really big. Let's try maybe 1.75. That's a little more manageable. Although I think we probably could bump up the font weight to bold. Oh yeah, that's looking great. Buttons automatically have the text as centered, but for whatever reason, buttons do not automatically have a cursor of pointer. So I'm going to add that. You won't be able to see this in the recording, but if you refresh the app and hover your mouse over each of these buttons, you'll get that familiar Mickey Mouse glove hand that indicates that it's clickable. We're rendering all ones right now. I think one thing I have found is that buttons don't tend to inherit the font family from any parent elements. Although honestly, I don't think we've set the font family here. I'll do that later. And we are going to be using the enter font. And maybe we'll just include a sans serif as a backup. And actually, I said I'm going to do that later. I'm just going to copy and paste it right now. But we can see that if I didn't specifically put a font family on my buttons, then for some reason it doesn't inherit the font family from the parent. So we'll leave it in both places. While we're doing that, we should probably test all of the numbers so we're not just basing our decisions on all ones. I'll go ahead and include 2, 3, 4, 5, and 6 and hit save. And awesome, yeah, these are looking great. And I dare say that we probably are pretty close to the design, so I think we can call this one a win. Again, yes, that was a lot of CSS, but also again, this is fortunately the last of the major CSS challenges that we're going to have, at least in this project. Great work on this challenge. Next, what we'll do is get rid of our 10 hard-coded die components and more programmatically generate a random list of 10 numbers. So that's what's coming up next. When we're faced with a slightly bigger challenge, like generate 10 random dice components and display them to the screen, sometimes it can be a little bit overwhelming. A great practice to get into is to learn how to take those larger problems and break them down into smaller pieces so that you can solve each piece at a time. In fact, this is one of the key things that hiring managers and people giving tech interviews are looking for. They're looking for your ability to break down a problem into smaller pieces, solve those individual pieces, and put them together so that they create a solution to the entire problem. So we are going to break up this challenge of getting 10 random dice elements on the page into 2 parts. First, I just want you to write a function called allNewDice. And actually, you know what? I'm going to, on the fly, decide to call this generate all new dice. That returns an array of 10 random numbers between 1 to 6 inclusive. For now, you can just manually call this generate all new dice function and log the results to the console. As with any algorithmic challenge, there's more than one way to do this. If you need help learning how to create a random number in JavaScript, then a quick Google search or asking ChatGPT should be helpful to you. However, because we're inside of a learning environment here, I highly recommend you don't simply copy and paste this challenge text to ChatGPT and have it give you an answer. That is only going to short your own learning and take away a perfect opportunity to think critically and how to solve this problem. That said, I don't expect you to have memorized how to generate a random number in JavaScript. So just use your best judgment. Make sure that you're putting your effort into this so that you are not shorting your own education. All right, that's enough of that guilt trip. Go ahead and get started on this challenge. All right, let's write a function. Actually, I'm going to do this inside my app component. I'll create a function called generate all new dice. And even creating this function is something that we could break down into smaller parts. Let's say first we need to create a new array, and it'll just be empty. Then we need to loop 10 times since we're trying to create 10 numbers. And inside that loop, we're going to generate a random number between 1 and 6, and we will push that number to the array. And outside the loop, we will simply return the array. Okay, let's solve it this way. And then I think I'll show another way that you can solve this just to show you that there's more than one way to solve these kinds of problems. We'll create a new array. Let's just call it new dice, and it'll be empty. We need to loop 10 times, so we'll just use a regular C-style for loop. I equals 0, I is less than 10, I plus plus. We'll say a random number is equal to, and we can use math.random, and actually we'll go math.floor, math.random. And if you're looking for a number between 0 and some other number, you can multiply this by 6 and then add 1, or we can simply say, let's do math.ceiling. Instead of rounding down, we're going to round up. And that way our lowest number will be a 1, and we won't have to add 1 in the end. So that's our random number, and then we will simply say new dice.push, the random number. And let me start clearing out some of these comments here. And then all we have to do is return the array of new dice. Let's go ahead and console log a call to generate all new dice and see what happens. Okay, let's open our console, and it looks like there's 10 numbers there. They're all between 1 and 6. Let's hit save again just to make sure. Yep, that one's good. That one's good. Okay, I think we're pretty safe that our function is working like we want. Can clean up the challenge text. Just for fun, I thought I would show another way that you can do this, and it's actually the solution I think I'm just going to leave here. So this was a very imperative way to do this. Another more functional programming approach would be for us to use some array methods. What I can do is simply return a new array. I don't tend to find myself using the new array constructor very often, unless I'm doing exactly what we're doing here. The array constructor can take how many items that array should have, and arrays have a method called .fill, where we can just fill every item in the array with something that we want. For example, some throwaway value like a 0. This by itself isn't super helpful, but we can now use a .map method to look at every item in the array and put our math.ceiling, math.random, I probably shouldn't have deleted this, times 6 code. So this will map over the new array with 10 items. And actually, let me show you this. So if I get rid of this map and hit save, we see we get our array with 10 zeros in it. That's what's happening in these first 2 lines of code. We map over that array and fill it. And for every item in it, we simply return a random number from 1 to 6. And okay, it looks like we are getting a working function once again. One way isn't necessarily better than the other. I don't know what the difference between the performance metrics would be in the way that we had it before and the way we have it now. I kind of like this functional programming approach, so I'm just going to leave it like this, but it truly doesn't matter that much. Okay, well, let's move on to the next part of this challenge, where instead of just generating a random array of numbers, we turn that into new die components. That way we can get rid of this manual die component repetition that we have here going on. We created a function where we can create an array of 10 random numbers, but next we need to find a way to move those 10 random numbers from just being here in memory in React to the page. Doing so requires us to create some state. So that's your challenge, to create some state that will hold our array of numbers. You can just initialize that state by calling our generateAllNewDice function. That way, when the app loads for the first time, it will call this generateAllNewDice function and just have those 10 random numbers ready to display. Then right here in the code, I'm actually going to put a comment here that says map over dice here. I want you to map over that array that's being held in state to create an array of die elements. This says elements, should say components, and then render those in place of our manually written 10 die elements here. Remember to pass a value into them so it can correctly display the number from the array in state. When you do this, you'll probably run into that warning about having to have a unique key prop for each one of your items. You can just ignore that warning for now. We're going to change things up in a little bit to fix that warning. Okay, you should be set with everything you need. Go ahead and work on this challenge. All right, let's go ahead and import use state from React. And just right here at the top of the function, we'll create some new state. Let's call it dice and set dice. And then just right here at the top of the component, we will create some new state. We'll call it dice and set dice is equal to use state. And we will initialize it with the array that comes back from our generate all new dice function. So we'll just give that a call. Then what we could do is just get rid of these 10 manual die components here, and we could do our map right here and say dice.map and kind of do the logic there. That's a completely legitimate way to do this. However, my personal preference is to create a separate variable inside the body of my function before the return where I can say something like dice elements, and it just feels like a little bit of a better separation of logic for me. I guess I'll just go ahead and render these dice elements since my cursor was already down there, and we can say dice.map, and for every number inside this array, I can render a die component where the value is that number. So this is where we can see if it works. The dice on the page currently read 1, 2, 3, 4, 5, 6, and then 4 ones. If I hit save, it looks like we, get a bunch of random numbers. Let's hit save again, and awesome, this is working great. Let's clean up some of our comments here just to keep things clean. And as I mentioned, we got this warning that says we need a unique key prop, and we'll be fixing this in the future when we change our array from being an array of just plain numbers into an array of objects. But that isn't quite what we're going to be working on next. The next thing we'll do is include a button that allows the user to re-roll the dice without having to refresh the whole application. The next challenge we have is to add a roll button so that when the user clicks the button, it will generate 10 new dice for us. Later down the line, we'll make it so that clicking individual dice will hold them and exempt them from the roll button. But for now, we'll just generate all 10 new dice. So the challenge is written out here, and you can add your new button down here. There's one little change that I wanted to point out, and that is that I've made a mistake on the font that I was supposed to be pulling in. I was pulling in the Inter font, and so I updated this to pull in the actual font from the design, which is Carla. And then I updated our CSS to use Carla instead of Inter. So sorry for anyone that was looking at the design and wondering what I was talking about with the Inter font. Okay, you should be equipped to work on this challenge, so I'll put in a pause now and give you a chance to add a roll button to our Tenzies app. Okay, let's start by adding our button first, and it's just going to say roll. It ain't going to be pretty, but let's refresh it, and okay, we have our roll button, and now let's hook it up to actually work. So I'll go ahead and add an on-click on it that will call, let's see, what should we call the function? Probably roll dice. So we will need to make sure we create that function, roll dice, and it's going to update the dice on the page by updating state. And we have this set dice function, so that is all we're going to be doing inside this function of roll dice is calling set dice. And in our case, we currently don't care what the previous dice used to be because we're just generating 10 new dice. So I can just say generate all new dice. And this might be it other than some styling. Let's hit save, click roll, and yeah, look at that. All our dice are being regenerated. So let's go style our button just to make it look not quite so ugly. I'll probably first want to give it a class name. So let's give it a class name of maybe roll-dice. And we'll select it in our CSS. This will be the button with the class of roll dice. And it looks like in the design, we are sitting at about 50 pixels high and about 100 pixels wide. There's no border, but there is a border radius of about 6 pixels. I'll just grab the background color from the design, which is this kind of purple color there. The color of the text, though, needs to be white. The font size looks like it needs to be a little bit bigger. Maybe let's try something around 1.2 rems. Yeah, that looks pretty decent. And just like before, we did not bring in the font family because buttons don't inherit the font family. We can see if I add the font family of Carla, it does make a difference. Because we have both of those buttons, I think I might just have a button selector that uses that font family, and then I can remove it in these two places. And actually, while I'm at it, I'm going to move this cursor pointer up to my generic button selector, and that way, again, you won't be able to see it in the recording, but if you refresh it, you'll see we now have a cursor of pointer on all of our buttons here. And then the only other thing for now is to give it some spacing. We actually have a couple of other elements we're going to be adding to this page, like the title and a little instructional paragraph. So I think what I might do is, instead of manually adding I think the design shows about 25 pixels on the bottom, I'm going to come up to my main container, and instead of justifying the content to the center, I'm going to say space between. Oh, that is too much. There's one that we don't use quite as often called space evenly, and yeah, that one looks pretty good. We might be changing this later as we add more elements to the page, but that's okay. Just make sure our button is still working, and awesome. Whoa, this is an awesome tensies roll. Look at that, we have 5 threes all at once. That's great. We are not able to hold the dice quite yet. But as it turns out, that is the next challenge we're going to be doing. We need to make it so that when the user clicks the dice, it will hold that dice and exempt it from clicking the roll button so that only the unheld dice will get changed. Before we move directly into that though, I wanted to make sure that you are feeling comfortable with these exercises that we're doing. This challenge should have been a relatively straightforward challenge for you, assuming you were able to get through all of the previous challenges and the previous sections. As I've said before, if you found that this was a pretty difficult challenge for you, then I would recommend taking a pause, going back, redoing some of the previous challenges. Maybe you took a little break since you took those sections of this course. That's completely okay. But it is probably time to revisit those so that you can refresh yourself before just trying to force your way through the rest of this capstone project. If, on the other hand, you felt pretty comfortable with that challenge, awesome work, and let's move on to learning how we can hold the dice. The next challenge we're going to have is to make it so that the user can click on the dice to hold it so that when they click the roll button, it won't change the dice that are being held. To do this, we need to have more information about each individual die than just its current value. Up until now, we've just been saving an array of bare numbers, but our challenge for this lesson is to update that array of numbers in state so that it becomes an array of objects instead. That way, each object can have a value property which will contain the same number that we were using before, but also additional information about whether that die is being held or not. And that's just going to be represented with a Boolean. When you make the change from having dice be an array of numbers to an array of objects, it will also break another part of our code. So make sure that while you're doing this, you update things so that we're back to a working state. All right, the time is yours to work on this challenge. Let's find the place in the code where we were originally adding just a bare number and change it to add an object instead, and that is this line right here. When we're mapping over our array of 10 numbers, instead of just putting a bare number in there, we can instead put an object in its place whose value is going to be what we had here before. And oh, I think I have my braces off a little bit right there. Okay, whose value, but also have an isHeld property, which we will default to false. Oh, and because we're using an arrow function, I need to surround my object with a set of parentheses just so that it doesn't think I'm beginning the body of the function like that. Let me go ahead and put these properties on their own lines just to clear up the spacing a little bit. And now let's try to think through the other places in our code that was expecting our state to have an array of numbers instead of an array of objects. And I can see one right here. We were mapping over our array of dice, and I chose to call this num because it was just a bare number. But now I'll go ahead and call this maybe a die object. And so the value should be die object.value now. I'm not seeing anywhere else that we would have any problems, so let's hit save. Let's click roll, and okay, we're back to a working state. Perfect. In an upcoming challenge, we of course are going to make it so the user can click on these buttons and hold them in place, which effectively would mean that we find that specific die in the array and flip its isHeld value. But before we move on, I want to address each child in the list should have a unique key prop warning that we've been getting. Remember, when we map over an array and we create an array of JSX elements, React needs a prop that's dedicated to JSX elements called key so that it can keep track of items every time something gets re-rendered. And it's crucial that that key be unique to this specific die. Now, of course, we couldn't use dieObject.value as the key because the whole purpose of this game is to get all of them to have the same value. Very often, you'll find yourself mapping over an array of data that gets pulled down from an API, and more often than not, that data includes some kind of ID that was generated by the database that's holding that data. And if you have something like that, then perfect. That's definitely what you should use as your key because it's pretty much guaranteed to be unique to that object. In our case, though, we're generating our data right here. And so we need a way that we can add an ID property to our dice so that, first of all, we can add it as the key prop here so that React knows how to distinguish this individual die component from other die components in this array. But it's also going to end up being pretty helpful for us when it comes time to hold the dice. So one thing that I can do is use a third-party package. There's a really simple one that's called nanoID. So I'm just adding that to my list of dependencies. I can import nanoID from the package nanoID, and this will generate a unique ID number for me by simply calling nanoID like this. I'll hit save, and we'll see that, oh, of course, we are still using dieObject.value as our key. We need dieObject.id as our key, and okay, awesome. Now our warning goes away. Okay, so our data is primed so that each individual die component has a way to know if it's held or not. But of course, we don't yet have a way for the user to change that. So that's what we'll be doing in the next challenge. Very soon, we're going to add the capability for the user to click the die so that it will be held. But unless we add some special styling for dice that are being held, it's going to be a little bit difficult to test this out. So the first thing that we'll do is style our held dice, or in other words, the dice who have an isHeld property to true, so that when they are being held, they will have this kind of light green background color. The way that we'll test this in this lesson is I'm just going to change the isHeld property to true for all the dice. So when you have successfully completed this challenge, all of them should turn that light green background color. So that's what your challenge is. I need you to add conditional styling to the die component over in die.jsx, so that if it's held, or in other words, if isHeld is equal to true, its background color changes to this light green color, which I've given you the hex value for right here. There's different ways that you can handle this conditional styling. I'm going to leave it up to you to decide which one you want. And remember, currently the die component doesn't yet know if it's being held or not. And I'm going to leave it a little bit vague like that, so you'll have a chance to figure out what that means and how to fix it. Go ahead and get started on this challenge. The first thing I need to do is to make sure that I am teaching the die component how to know if it's held or not. Currently, we are only passing a value down to our die component. And so I'm going to put this on its own line to buy myself a little bit of room here and pass in the isHeld prop, or I should say a prop that I'm choosing to call isHeld because it happens to be the name of the property in the object. So the value will be dieObject.isHeld, and that way each of the die components will know through props if it's held or not. Now at this point what I could do is either conditionally render a class name, as in the class name could look at props.isHeld and either apply the green background color or not by adding or removing this class name. But I think what I'm going to do is just use an inline style. So in my button, I'll say style equals, and then I could either pass my styles directly here, or something I tend to like to do is to add a separate object up here and pass in the styles directly. Remember, these styles are accessing the native DOM properties. And so when I want to change the background color, especially because I'm here in an object, I can't as easily use background-color without surrounding it with a set of quotation marks. Instead, I need to use the capital C color, or the camel-cased version of this property. And I can use a ternary that says, let's look at props.isHeld. And if it's true, then I want the background color to be that green color that we see right here. So let me copy that and we'll paste it in there. We'll just set the color to white, which is what it is in the CSS. All right, I think we might be all set up. Let's hit save, and sure enough, look at that. We get all green colors, and that's because we had changed this from false to true. If I change it to false, then we can see that it all turns white again. Okay, now we are ready to tackle the challenge of holding each die whenever it gets clicked. We talked previously in our section about state about a concept called derived state. And generally speaking, we found that it's better to have a single source of truth where the state is held on the parent. Well, it turns out our Tenses game is a perfect example of this. It might be tempting when you're first starting to write React to say, well, I want each dice to be able to know if it is currently being held or not. And so you might go to your die component and add new state to it that says bring in the incoming prop of is held, and then set internal state that can be used to display whether the die is being held or not. And then you would create a function inside of the die component that when the die component is clicked, it would flip that internal state for that one single die. However, as it turns out, if we're looking forward to the mechanics of our game, we can only know if the user has won the game if all of the dice are being held and if all the dice have the same value. But if each die component were in charge of flipping its own state, it would become out of sync with the state that's being held in the parent. In other words, when we first load our component, this first die that has the value of is held of true gets passed down to the die component. But if the user clicks it and flips it to false, that doesn't change the parent state where it says is held as true. And so hopefully you can see that that would become a problem. So although it does tend to be a little bit more code, a more correct approach that does not rely on using derived state would be to get rid of the state from the die components, keep the state that is currently in our app, and create a parent hold function that we pass down to each one of our die components. This hold function would take an ID so that when one of the dice is clicked, it would call the hold function, pass to it the ID of itself, and the parent state would be able to loop over the array of dice objects, find the one with the ID that was called in the hold function, and simply flip the is held property of that one die. That was a lot of talking. I hope this diagram helped visualize what I'm talking about. And so the first part of this new feature is what we are going to be working on now. I want you to create a function that's just called hold, and it will take an ID as a parameter. For now, all the function has to do is console log the ID. Then I want you to figure out how you're going to pass this hold function down to each instance of the die component so that when each one is clicked, it will log its own unique ID property. And I did mention here that there's more than one way to make this work, so just feel free to choose whichever one you want. In the end, because each one has a unique ID, the way that you will tell if it worked is if by clicking this first button, it will display one ID, and then clicking another button will display a different ID. We're starting to creep up on a little bit more difficult challenges here, but I know that you've got it in you to get this done, so go ahead and get started on this challenge. Okay, let's get started. I think I'll put my function just down here below roll dice, and we'll say this is hold. It's going to take an ID as a parameter and simply console log that ID. Well, now what we need to do is figure out how we can pass this hold function down to our components. Let me clean this up to buy some room. And clearly, in order for each die component to have access to this function, we need to pass it down through props. I'm going to put each of these properties on their own lines just to, again, buy some room. And we'll go ahead and pass the hold function, just like this, down to our die components. However, we hit kind of a blocker at this point. Remember, when we go over to our die, we're receiving props.hold now, and I can simply add to my button, let's see, right here maybe. Let me put this on its own line too. Right here, we can say on click, it's going to call props.hold. Here's where the problem begins, and I wouldn't be surprised if some of you doing this challenge ran into this issue. If I go ahead and click 4, we'll see that I don't get an ID, I get something that says synthetic base event. If I click another one, they're just all saying synthetic base event. I'm going to put another pause in here and see if you can figure out what's going on here. Remember, these on-click events, the function that you pass to it, we don't get to decide what parameter it receives. It will always receive an event object. So we need to think back, how can we provide our own parameter if we want to call a function? Well, instead of just passing props.hold as the function that gets called when onClick happens, we can instead kind of wrap that in a function that says this is the function you should run when the onClick for this button happens, and this function will call props.hold. And at this point, I can put in whatever parameter I want. Well, we run into another problem. I don't have access to the ID here in my component. So simply enough, what I could do is just come down here once again and also pass my ID property. So this would be dieObject.id. Once again, this ID is coming in clutch for us. And over in the die component, I'm now receiving props.id, so I can pass that in right here, props.id. Let's try this again. I hit the 4, and there's a crazy looking ID that was generated by NanoID. We'll click 5, and sure enough, a completely unique different ID. Just for giggles, I had mentioned that there's more than one way to do this, and so I figured I'd give you a chance to see what that might look like. There might be more than just these two ways, obviously. But here, what I can do when I'm passing down my hold function, instead of just passing down the hold function as a whole, I can do essentially what I did in my onClick and say, I'm going to pass down this unique function, and this will end up being a closure that captures the ID value that I passed to this parameter right here. And so in that case, I don't even need to pass my ID down. And when I'm receiving it, I don't need to do this anymore because props.hold is now a closed function that already contains the ID of this specific die component. I think the way that we had it before might be a little bit more intuitive, but because this is working and just for the sake of seeing a different way to do something, I'm going to leave it like this. Okay, we're making good progress. Next, we need to make it so that we're not just console logging the ID when the user clicks the button, but instead we are updating the isHeld property on the correct die in the array. Let's make it so that users can click the die, and instead of it obviously console logging the ID, it will change its isHeld property to true. Or if it's already true, it'll change it back to false. You'll know that you've succeeded in this challenge if clicking a die will change it to green, since we have already set that up over in the die component. However, keep in mind that we haven't yet implemented the feature where clicking roll will only change the dice that have not been held. And as a hint, although this is more like a reminder because I've said it before, that there's more than one way to accomplish this. So don't spin your wheels too much trying to make sure you get it exactly the same way that I'm about to do it. If clicking the dice changes it from white to green or green to white, then that's how you'll know you've succeeded. This will be one of the more difficult challenges that we have throughout this whole section. But fortunately for you, we've actually done something nearly identical to this in the past when we learned about state using this little sound pads exercise. You can click the screenshot here to go back to that exercise if you need a refresher on what we ended up doing so that we could flip these on and off. So you should be prepped now to have everything you need to work on this challenge. All right, I'm going to buy some room by getting rid of the challenge text since I know what we need to do. Instead of console logging the ID, we need to update our state. Because we're holding our state in one unified place here in the parent component to all the die components, we can simply call setDice. And our task is going to be a little bit more complex because we have a whole array of dice that we're looking at, and we only need to change the isHeld property of one of those dice. As such, I do need to know what my old dice were, so I'm going to use a callback function. And I think for the sake of clarity to start this out, I'm going to open the body of this function and use an actual return keyword here. Remember, dice is an array of objects, and so what I need to return when I'm calling setDice is another array of objects. And I can get a new array by calling oldDice.map, and I will look at each one of the dice, or each die, in the array of dice. And the most important thing for me at this point is to check if this die has the same ID as the one that was clicked, or the same ID that we're receiving as a parameter to our hold function. So I could do an if statement and check if die.id is equal to ID, or I can just use a ternary, which will allow me to be a little more concise. I'm going to return and then first check if die.id equals the ID. And if it does, then what I want to return is a new object, and it will contain all of the properties from the original die, but the isHeld property is going to be the opposite of die.isHeld. If the IDs don't match, that will be my else section in my ternary operation here. I can simply return the old version of the die. I don't need to change it whatsoever. Okay, first let's check to see if we are working. I'll hit save, and boy, that is a terrible tenses roll. I don't know if I've seen one that bad in a long time. I guess we have 3 6s. Oh, no, it's not. And oh, look at that. We have 4 6s. Oh, awesome. Clicking them makes them green. Awesome. As I said, if we didn't want to hold them, I could click them again and they would flip to the opposite of is held. So we get to go back and forth. And as I mentioned, clicking roll is just going to refresh them completely. We don't save any of the dice, which is fine. That's what we're going to be working on next. Well, let me come back to my code and do a quick refactor. I mentioned using an explicit return like this, but because I'm using arrow functions, I can rely on implicit returns. So let me pull this up to its own line. And boy, this is going to get a little confusing. Okay, I've gotten rid of that explicit return. Here I am mapping and using another arrow function. So I think I can do another implicit return. I might have to open some parentheses. Let's get rid of our curly braces and let's see. Actually, I don't think I need that one. And I don't like the spacing of this. Let's see. Okay, that makes... And okay, yeah, that works. I don't know that it's really that much easier to read, but I guess it saves us a couple lines of code. Whatever. Let's just hit save to make sure this is still working. And let's see, we have 3 2s. Perfect. Or maybe we change our mind and we select the 4s. Great work. Okay, the next big feature we have is to make it so that when we click the roll button, we don't lose our held dice, but only re-roll the dice that are not being held. So that's what's coming up next. Other than checking if the user has won the game, I think this is the last major feature that we have to add to our tenses game. Your challenge this time is to update our roll dice function so that instead of generating all new dice every time the button is clicked, it will look through the existing dice in the array and only roll the ones that are not being held. As a hint, this is going to look really similar to the hold function. I guess we didn't call it hold dice, we called it hold. And it's helpful to remember that what we mean when we say you're rolling a die, really you're just going to be updating the value property of that die object. I'm not going to get any more detailed than that. I want you to figure out how to finish this challenge. So the time is yours. Go ahead and refactor our roll dice function. We know that we're going to be updating our state, so we do still need set dice here, but instead of generating all new dice, we are going to look at the old dice array and we'll map over it, checking each die along the way if it is being held. So we'll use this arrow function and we will map over old dice. And for each die in the array, I'm going to check if die.isHeld is true. I'll just use a ternary here. And if the isHeld property of this particular die is true, then I don't want to change anything. I just want to return the same die object. Otherwise, I'm going to return a new object that has all the same properties of the original die. This is important because it allows us to keep our ID that we generated when we first created the dice objects. But I want to change the value property to be a new random number, which I can just get by calling this code up here. Let's go ahead and I think we have it right. Let's get rid of this challenge text, hit save, and we got a good amount of 2s here. All right, moment of truth. We'll hit roll, and look at that. All the dice except for the ones being held rolled. So I can play through the rest of this game holding the dice as I go. And we're getting pretty lucky so far. There we go. All right, well, this brings us to the beginning of the last feature, and that is that we need to be able to indicate to the user that they have completed the game. As it stands right now, if I click this 2, they're all green, and I know personally that that means I've achieved tenses, but I can still hit roll. There's no way for me to reset this game other than to refresh the page. And maybe most importantly, there is a critical lack of confetti dropping down from the page. All of those are things we are going to be working through as challenges. But before I do that, speaking of indicating some information to the user, I am just going to paste in some of the elements. You can see from the design, we have a header and a little paragraph that instructs the user how to play the game. So those are not really worthy of a challenge at this point. I'm just going to paste in some of that markup. as well as provide a few styles here. Let's see, I'll just put it right here below the main, and we'll just paste those in right there. Let's hit save. And well, I think I want a little bit more space above my button or below the dice container. So let's see, where are we? Right here on our dice container. Let's just put a margin bottom, maybe 40 pixels. Okay, yeah, that's looking pretty good. Great work on getting this challenge done. And all of the challenges in this feature, we're now able to hold the dice and continue rolling the ones that are not held, which is essentially the crux of playing tensies. As always, feel free to play around with this code as much as you want. Make sure that you understand it before just plowing ahead. Once you're ready, we will move on and start implementing some of the logic for what happens when the game is over. Okay, guys, I have a confession to make, and that is that this is not the first time I have taught this course using this project, the Tensies project. In the previous version of this React course, I also went through pretty much all of these same things with the Tensies game. However, as I was reviewing some of the things that I taught back then, I realized that I made a mistake. And so I wanted to make sure that I got it right this time and that I gave you a chance to think critically, because what we're about to cover is a mistake that not only I made in the past, but one that I see very often in the React community, especially with beginners in React. And so we're going to take a little break from writing code and we're going to put on our critical thinking hats. Our goal is to indicate to the user that the game is over if, first of all the dice are being held, and second of all, if all the dice have the same value. If those two conditions are true, then we can consider the game as being over and won. So let's start planning ahead and think how we might accomplish this. Some questions that we can consider would be, first of all, do we need to save a game1 value in state somewhere? If you think the answer is yes, then why? And if you think the answer is no, then why not? And secondly, do we need to create a side effect with React.useEffect to synchronize this game1 value, whether it's being held in state or not, with the current state of the dice? These two questions are meant to guide you in your planning session here as we decide how we're going to implement this feature. So I'm going to put it on pause here. Just like when we've taken quizzes in the past, I want you to type your answer into the comments here, both for number 1 and number 2. And then I want you to have a conclusion section where you write out a simple plan of how you're going to implement this feature. So I'll go ahead and put in a pause here. Don't skip this step. This is a crucial thing for you to get practice with as you're learning. Take some time now to answer these questions. What I taught in the previous iteration of this course and this part of the challenge was I created new state, and I said we're going to have a variable, a state variable called tensies, and we'll call set tensies. The reason I chose tensies is because in the real game you're supposed to shout tensies when you have gotten all of it. It's really a race against other people. And so that was equal to useState, and we set the initial value as false. And then I also created a side effect that watched for any time the dice state changed, and then checked for conditions to see if tensies was true. In other words, if all the dice are held and all the dice have the same value. And as I'm sure you have guessed by now, I realize now that this was not the correct way to do this. So if we're looking at the answers to these, do we need to save a game1 value in state? Well, as it turns out, the answer is no. Remember how React will re-render our component every time the state changes? Part of re-rendering the component doesn't just mean it updates what's on the page, but it means that it reruns all of the code inside of our function. So instead of setting a new state variable, all I need to do is derive the value of whether the game is won or not based on the current value of dice. In fact, this setDice function is the only state setter in our code that's going to cause a re-render anyway. Instead of creating new state, I can simply use the state that already exists with dice, and every time the component re-renders, I can check again to see if the game1 conditions have been met. I'm not going to write this code because we are going to do that in the next lesson, but I will write a comment that simply says, check if the game is won. And I can do this on the top level of my app component. This code will run after every single re-render. In other words, every time the dice get set to something different. And I can use this variable that I create, if the game is 1, to add whatever features I want to add, change the text of the button, or make the confetti fall down. If instead I were to save the game1 value in state, then I would need to include a side effect so that I could synchronize the dice state with the game1 state. And so question number 2 definitely would depend on what your answer to question number 1 was. If you answered yes, then you would likely need a side effect so that you could synchronize those two pieces of state. But since we answered no, we don't need a side effect. So we can, again, say no, we don't need a side effect. I think when we write the code for these features, we'll get to see exactly why we won't need these things, and we can keep it as simple as possible. So our conclusion is that we can derive the game1 status based on the condition, or we'll say conditions, of the current dice state. Because of this, we can calculate whether the game has been won on every single render just in regular code here at the top level of my component. And so maybe to be more specific, I'll just say on every render. As I mentioned, this is a really common pitfall in React. In fact, so much so that there's a dedicated article in the React docs that's dedicated to teaching you that you might not need an effect. So many developers in the early days of the useEffect API were misusing it that the team had to put together a whole tutorial to teach people to stop using side effects when it isn't necessary. Specifically, it says that they are meant to be an escape hatch from the React paradigm. They let you step outside of React and synchronize your components with some external system. In our case, we're not trying to synchronize with an external system. We're just trying to derive a value based on our current state. I hope that makes sense. I know that's a bit theoretical, but again, I think you'll see just how easy it is to add this new feature where we can determine if the game has been won without having to deal with state, without having to deal with side effects. So without further ado, let's jump in and get our hands back on the keyboard so we can start typing some more code. We'll do this in a series of smaller challenges. The first thing I want you to do is simply to log game1 to the console only if the two winning conditions are met, which I've outlined here and we've talked about before. For now, you don't even need to save a variable. You can simply put a conditional right here at the top level of our component. Go ahead and get started on this challenge. The tricky one with this challenge has more to do with getting these winning conditions right than it does pretty much anything else. We can simply have an if condition that if it evaluates to true, will console log the game is won. And so the trick is simply making sure that we get these conditions correct. And there's a lot of ways to determine if all the dice are being held and if all the dice have the same value. I'm going to make use of an array method called .every. It lets you pass in a callback function, and if that callback function returns true for every item in the array, then the entire expression evaluates to true. So for example, I can say if dice.every, and we're going to look at each die in the array and say if die.isHeld, then return true, or in this case, it's simply going to return the value of die.isHeld, which means if every die is currently being held, then this entire expression will just evaluate to the Boolean true. Whereas the .map array method returns a new array, .every simply returns a Boolean. Okay, so there is one expression. We also want to check if every dice has the same value. Well, if every dice has the same value, I could just arbitrarily choose one of the dice, get its value, and check if every item in that array has the same value as the first die. I'm going to put this on its own lines, I think, just to maybe space this out a little more easily. And we'll say if dice.every, not dive.every, dice.every. We'll look at each die, and we could say if the current die's value is equal to the very first dice in the array, so dice at the index of 0 .value, then that means that every dice has the same value. So let's get rid of our challenge text. Let's hit save. We should not get game1 because our winning conditions are not true yet. And I guess we need to play through this game. 3s look like a good start. And whoa, look at that. 4 more 3s in one roll. That's crazy. And okay, here we go. So when I click this, we should get game1 in the console. Perfect. Okay, now that we've been able to figure out the logic for our winning condition, let's go ahead and do a second part to this challenge. Okay, for challenge part number 2, I want you to create a new game1 variable, and I'll leave it up to you to determine what its value should be. It should be pretty straightforward since we just wrote the logic for it. And also, if game1 is true, I want you to change the button text so that it says new game instead of roll. This by itself won't make the new game feature actually work. That's something we're going to do in a couple challenges from now, but it'll be one step closer. All right, I'll hand it over to you. Well, we don't need to check the conditional or run any code at this point, but we do want the values that are being held inside of our conditional. So I'm just going to cut those out and delete here. We'll create a game1 variable, and that's just going to equal whatever the Boolean value is from these expressions. And remember, what we're doing here is deriving the game1 value based on the current state of the dice array, which means every time the dice array changes, or in other words, any action that we take that might call set dice, our component will re-render, the entire app function will run again, and we will get an updated version of game1. Of course, it's just a Boolean, so it'll be false most of the time you're playing the game until the very last click, but I think you get the idea. Okay, for number 2, let's change the text of the button based on this game1 variable. We can get rid of the challenge text, and we will, let's see, right here, I'm just going to put roll on its own line so that we can, instead of hard-coding roll, use a ternary. We'll say if game1, then we want it to say new game, but otherwise it'll say roll. Okay, I'll hit save, and I'm going to play through this game. I'll skip ahead so you don't have to watch it. Okay, moment of truth. I'm going to hold the 2, and sure enough, that changed to new game. I don't actually love that it is wrapping like that. Let me come to the button in CSS, and I think it's this one. We'll change the width to 150. Yeah, that looks a little better. Actually, you know what? I think instead of hard-coding this as 150, I think that's going to look a little bit wide when the text just says roll. I'm actually going to allow this to adjust the width based on the text that's in there. So I can say white space should be no wrap. I don't want the text to wrap. Then I can set the width, I believe, to auto. And at that point, I probably want to make sure I give some padding to this. And I just referenced the design. It looks like we can say we're about 6 pixels on the top and bottom and 21 pixels on the left and right. Okay, so if I hit save, I guess I have to go to one of these to hit save. The button resized and it still has some decent padding. I think that's a little better. All right, I think the next challenge is going to be by far the funnest challenge that we have in this entire project. And that is to make it so that when the game gets won, we get the awesome confetti drop in our app. So let's jump into that one next. This one is definitely the most fun challenge in this entire project, and that is to make the confetti drop when the game is won. There's a really fun package called React Confetti, and it couldn't be simpler to use. I've already installed it in our project. You can click on the screenshot here to go to its GitHub repository and read through the use section. It will recommend including a width and height prop, but for now we can just ignore that. It will default to the window size. They recommend doing that because if you resize the window, then your confetti will be the wrong size. I guess that could be a challenge that you do based on the work we did with side effects in section 4. But for now, again, just ignore the height and width props. I've already installed the project in our dependencies, and there is one major caveat. At the time of recording this, because React 19 has not officially been launched, and we've been using the release candidate version for this course, React Confetti doesn't quite yet work on the release candidate of React 19, so I did have to downgrade to React version 18.3.1, which is the most recent stable version of React. React 19 has been on the very precipice of being released for a number of months now, so by the time you're watching this, I wouldn't be surprised if React Confetti works just fine on the official release of React 19. But for now, we're going to deal with it this way. Oh, and I almost forgot, I have a fun GIF that shows you exactly what will happen when you have won the game. The confetti will drop, our text will change to new game, like we did in the last section. That button won't quite work yet. But like I said, this is the most fun challenge for sure. Okay, your turn. Get started on this challenge. Okay, we can see from the documentation that what we need to do is import the confetti component, and it's just a default export from the package, so we'll import it from React Confetti. We have our game1 variable here, which is what we will use to conditionally render the confetti component. So we'll say game1 and then render the confetti component. Like I said, it pretty much couldn't be simpler. Let's get rid of this challenge text, hit save, and I'll fast forward through this so that it's a winning game. Okay, one downside of the way that the recordings work here on Scrimba is that any elements that are displayed on the canvas of our web browser don't actually get recorded into the scrim. And the confetti is using the canvas to create all of the colorful confetti shapes. So I'm going to click 3 here, and sure enough, I can see the confetti dropping. And I'm sure that you did this challenge and succeeded in it and were able to see the confetti drop on your end as well. At this point, in order to start a new game, the user would have to refresh our page. So let's go ahead and implement the logic we need so that the new game button works, and I believe that will wrap up the last feature that we need to add to our Tenzies game. You know what? I changed my mind. There is one more topic I want to touch on that's a little more boring than actually implementing the new game functionality. So we're going to get this one over with first, so that we can end on a high note of adding the last feature to our game. What we're going to be talking about has to do with this line of code here on line 7, where we're initializing our state. We're calling useState, and then we're giving it an initial value, but the way that we're giving it an initial value is by calling a function. And at first glance, this might seem like it's fine. This is the initialization of the state, right? So it's only going to run this line of code one time and then handle any changes to that state behind the scenes. Well, let's remember that every time we make any kind of state change in our app, like when we click a button to hold it or click the roll button, we are changing state in our component, which means that React is going to rerun all of the code inside of this function. And part of running this whole function includes calling this generateAllNewDice function. Because React is handling the state behind the scenes, it's not going to update the state per se just because we called this, but it really is calling this function on every state change, and I can demonstrate that by adding a console log to generateAllNewDice. Let's say generateAllNewDice was called. Okay, let me hit save. That'll refresh the app, and we can see that we get it one time, which is what we would expect. But when wow, look at that, we have 6 sixes. Every single time I hold one of these dice, it's also calling generateAllNewDice again. Now, the code inside the generateAllNewDice function is not that intensive. It's doing a few things. It's mapping over an array with 10 items, which JavaScript can do extremely fast. For each one of those items, it is calling this nanoID function, which I imagine is not very expensive, even if you're doing it 10 times. But then in the end, React is just discarding everything that is returned from this array after the first time it runs it, because it knows it doesn't want to reset the state. So how can we address this issue? Well, fortunately, React made it really easy. When we're initializing our state, we can provide a regular value for the initial state like we're doing here. It might not look like a regular value, but since we're calling this function and that's returning the array, that's pretty much equivalent to providing just a bare value. Alternatively, we can provide a function for React to run, and then that function needs to return the value that we want to use as the initial state. By doing this, React will make sure that it does not rerun this function on the subsequent re-renders of our component. So I still have my console log here inside of the generateAllNewDice function, but if I hit save, we get it once for the first time, but then as I'm holding dice and clicking roll and changing state otherwise, our component is re-rendering, but it is not rerunning our generateAllNewDice function again. Again, in this case, the performance benefit is a little bit underwhelming, but if you were doing a more expensive operation in order to initialize your state, this would be a perfect way to ensure that you only have to do that one time. Let's clean up this console log and we can close our console. And now, as promised, we'll move on and make it so that the new game button actually starts the game over from scratch so the user can play again. This is another example of a challenge that I'm going to be pretty vague about and just give you more of a Scrum-style user story and leave it up to you, the developer, to figure out what needs to happen in the code to accomplish the task. The task at hand is to allow the user to play a new game when the new game button is clicked. And I guess it's probably redundant to say, and they've already won. The new game button currently will only show up if they've won the game. And actually, that's all I'm going to say about the challenge. So I'll hand it over to you to work on adding this feature. Well, so far, all I've done with this button is conditionally render the text depending on the value of game 1. But of course, this onClick is always going to call roll dice, whether the text says new game or it says roll. One approach I could take is to conditionally render a button that says roll that calls roll dice if game 1 is false, and otherwise render a completely different button with a completely different function that it calls if the game is won. However, to me that feels like a bit of extra work that I don't really need to do. Instead, what I could do is simply update the logic for my roll dice function so that it checks if game is won, and if it is, then it will do one thing, and if it isn't yet won, then it will do another thing. So let's come up to our roll dice function, and the code that we have here is code that I really only want it to run if the game is not won. So if not game 1, then I'll move this code inside of this conditional. But now I can add an else, which means that the game is won, where I can just set the dice to be all new dice. And fortunately, I created a function called generate all new dice. When I generate all new dice, it will reset all of them to an isHeld of false, which means that our value for game 1 should now be false, and the confetti will stop playing, all the green will go away, and the numbers should be shuffled again. Let's go ahead and hit save. I'll spare you watching me run through this game by skipping ahead. Okay, I'll click the last 6. I'm seeing the confetti on my end. And now the moment of truth, if I click new game, awesome, everything starts over from the beginning state. I can see an argument to be made that we are kind of overloading this function, and it might be better to conditionally render a second button, but I think for now I am probably just going to leave things the way that they are here. At this point, all of the features of my app have been added. However, there is one crucial thing that I've neglected to do. Because we have a highly interactive app here, especially when you're dealing with games, there is a lot to consider when it comes to making sure that your app is accessible for those using assistive technologies. In an effort to keep us laser focused on practicing React-specific things, we haven't yet touched on those, but I would definitely be doing a disservice if we didn't include them in our app. So in the next lesson, I'll walk through a few of the accessibility changes that we need to make to our app so that it is usable by everyone. Because we chose to use a button element for our die components, we get a lot of accessibility benefits for free just from HTML. In general, for accessibility purposes, it's important for clickable items to usually either be a button or an anchor, like a link leading to another page. Otherwise, you have to start considering using tab index to make sure that it's accessible via the keyboard, and setting the role as a button, and all sorts of things. So using a button here was already an accessibility win. That said, because the information in the button simply has a number in it, we can improve how assistive technologies announce the buttons by adding an ARIA label property. And because we have some data here, I can get pretty descriptive with what my ARIA label should include. So I can say something like this is a die with a value of, and I can stick in some variables here. We'll say props.value. And I think it especially would be helpful to know whether it is being held or not. And so I could add in a ternary here that says, let's check the isHeld property. Oh, and it looks like I used the wrong curly brace here. And if it's being held, then we can say it's actually going to read out the word held, but otherwise it's going to read out not held. So this is already a huge improvement. It's probably the lowest hanging fruit for improving the accessibility in our Tenzies app. Something that is very similar and related, but also can be really helpful to include, is a property called ARIA pressed. This is a way to indicate to assistive technologies whether or not this button, which is kind of acting like a checkbox or a toggle, is currently being selected or not. We're kind of covering that by including the term held or not held here, but this can also just be another easy thing to add, and we can simply give it the Boolean value of is held. The next thing we can do is make it a bit more obvious when the game has been won. Right now, we're really only indicating that the game has been won by dropping a bunch of confetti, but for those who might not be able to see that confetti or notice that the button text has changed from roll to new game, we can add what's called an ARIA live region. This is a section of our markup that, when changed, a screen reader will make sure to announce whatever content we put therein. And doing so doesn't even have to mess with the visual representation of our app normally. Let's come down to where we're conditionally rendering the confetti, and I'm going to include a div here, and I can include the ARIA live and set it equal to polite. Anything that I put inside of this div will get read out by a screen reader whenever the content therein changes, so I can conditionally render based on the value of game 1, maybe a paragraph that says something like, "Congratulations, you won, press new game to start again." Of course, by default, this will add a new paragraph to our page, which we may not want to do, and so we can actually include some CSS with a class name. Oftentimes it's called something like SR only, for screen reader only. And in our CSS, it will make it so that paragraph is never visible on the screen, but it will get read by assistive technologies. So I'm just pasting in here an SR only set of rules that I have copied from another project. It basically goes above and beyond to ensure that anything marked with SR only will never actually get displayed on the page. Now, at this point, there actually is one more accessibility improvement that I'd like to add, but it touches on something that you have learned in this course. And so I'm going to turn it into a challenge and give you a chance to look back at something we learned in section 4 and see if you can recall that information, or maybe go back and restudy it so that you can complete the next challenge. And we'll be doing all of this in the next scrim. I'll actually be truly impressed if you're able to do this challenge without referring to past materials. So if you're feeling a bit lost as we talk about what this challenge requires, don't feel bad whatsoever, because it was something that we kind of just got a quick sneak peek on in section 4. But I do want you to give this your best shot. I want you to go back to section 4 if you need to review the lessons that we learned there, and then bring that knowledge back to this challenge to try and apply it. In cognitive science, recalling information like that and then applying it is one of the best things you can do to retain that information for the future. A quick change that I've made to our code just temporarily is when we're creating new dice, I just gave it a value of 5. That way we don't have to keep playing the game whenever we want to test the end scenario. I probably should have done that a bit sooner, but if we take a close look, I can hold all of the dice, and when I hold the last one, we can see that the button focus is actually here way on the first button in our list. For a keyboard user, that means in order to access the new game button way down here, I have to hit tab about 10 times just to get down to that button before I can hit spacebar or enter to trigger the new game button. Definitely not ideal. So our challenge is to make it so that when the game is over, the new game button automatically receives keyboard focus so that keyboard users can easily trigger it without having to tab through all the dice first. The code we need to add to make this work is not that extensive, but I did want to give you 2 major hints to help guide us along the way. The first one is that focusing a DOM element with the .focus method, which exists on DOM nodes, requires accessing a native DOM node. I want you to think back to section 4. What tool have we learned about that allows us to do that? Then, in order to automatically call the .focus method on a DOM element when the game is won, requires us to synchronize this local game1 value, or variable, with an external system, which is the DOM. So think again, what tool have we learned about in the past that allows us to synchronize React with an external system? The answer to these 2 questions is hopefully going to guide you in the right direction to solving this challenge. Again, if this is feeling pretty over your head, that's okay. You can click this Mario box to get a power-up, which will take you back to the lesson where we learned about the answer to number 1, and then the next lesson in that same course will lead you to the answer to number 2, and hopefully give you the tools you need to come back here to solve this challenge. So without further ado, I will hand it over to you to work on this challenge. In React, the preferred way to access a DOM node is by using a ref. We can create a ref by pulling in the useRef hook and then simply calling useRef. Usually we will initialize it with null if we're using it to access a DOM node, and we'll save it as a variable, which let's call it buttonRef. At its core, refs allow us to save values between the render cycles without actually triggering a re-render itself. Many times this ends up being used to access a DOM node from the markup that gets returned from our component. With this button ref, I can use a dedicated property on all React elements, like this lowercase b button, called ref, and I can set my button ref on this button. By doing this, when React renders these elements, it's going to set button ref equal to this DOM node, which I can then call methods like .focus on. As a reminder, I can come up here and console log my button ref. We'll see that at first it ends up as an object with a current property whose value is null, and that's because we initialized it with null. But then after it rendered the button down here, it set it equal to something different. We're just not seeing that in the console log. If I click one of these, then it triggers a re-render of our component, and this console log runs again, now with the correct value of button ref, which again is an object with a current property whose value is the DOM node of that button. Scrimba makes it look like it's kind of a JSX element or something, but that's just a simple representation of the actual DOM node. Okay, so with hint number 2, I want to automatically call .focus on my buttonRef.current only when the game1 variable is true. And in this case, we need to synchronize our local game1 variable with the DOM by manually, imperatively calling the .focus method on that button. So what tool do we have that allows us to synchronize our local React stuff with an external system like the DOM? Well, that tool is useEffect. And so I'm going to pull in useEffect. Let's get rid of this console log here. And at this point, I can get rid of my challenge text. And below game1, because I'm going to need to add game1 as an item in my dependency array, I need to make sure I do it after we define it. I can call useEffect, and I'll pass the first parameter, which is my callback function. And before I forget, my second parameter, which is the dependencies array that looks at game1. This way, this effect will only run on the very first time that the component renders, and then again if game1 ever changes. This gives us an opportunity to check if the game is won. Then we can simply call buttonRef.current, that's the property we have to access in order to actually get to the DOM node, and then .focus. Let's see how we do. We'll hit save. I'm going to just select all of these 5s. And when I click the last one, our new game button gets focused, so all I have to do is hit spacebar and we get a new game. This is a much better experience for any of our keyboard users. And a benefit for me, the teacher, was a great opportunity to review some of the topics that we learned in the last section. This has been an awesome project, and now we have finally rounded out the last features. Since we're here at the end of this project and near the end of this section, this is a great time for you to maybe do a little bit of a self-assessment. Look back at all of the code that we've written in this project and think to yourself, is this something that you could write by yourself if you needed to? I, as an instructor, can only do so much to request of you to do all of these challenges by yourself without just letting me hold your hand through them. And in your self-assessment, if you feel like maybe you could have done a better job, then there's absolutely no problem with going back to the beginning of this section, looking at that blank screen that asks you to spin up a brand new React app, and seeing if you can do the series of challenges again. If you really want to be a crazy person, you could simply highlight everything and hit delete and try to build it again from scratch. Things like this terrify me personally, but I know some people really thrive on challenges like that. Before I have a panic attack, let me Command-C that and get all of my code back. Oh, and I can't leave it like this, where our game is basically useless with this automatic 5 number being put in every one of our dice. All right, that's better. Congratulations on making it this far. It truly is a major accomplishment. I hope that you're feeling proud of yourselves, and I hope that you can find a great way to celebrate this win. Forgive the pun, but you, my friend, are on a serious roll. What a great job you did on that significant series of challenges. And what a fun project to build. This is one of those projects that I can bring my kids in and have them play, and they actually have fun playing it. It is so rewarding to build something like this that other people can enjoy. And the fun doesn't have to stop here. I have a few extra credit ideas that you can roll with if you want. For one, you could try adding a timer and/or a roll counter to see how quickly you can win the game, or in how few rolls you could win the game. You could style the dice so that they actually look like real dice with pips instead of numbers. And you could deploy your project live so that others can play on their own machines. The possibilities are endless, but one thing that I do want to make sure you do is to head over to the Today I Did channel in the Scrimba Discord community. There's really no better place to celebrate with others that are also working on similar improvements and content as you. And it doesn't have to stop there. Feel free to share it on your LinkedIn or your X accounts. If you're planning on looking for your first job in tech, then there's no better way than to engage with the communities that are around you. Once you've had a chance to celebrate for a little bit, remember that the job isn't done. We have one more really awesome capstone project in this course, and so that's what we'll be gearing up for next. Everything in this course has culminated up to this final capstone project called Assembly Endgame. In this game, you are fighting the forces of evil to try and save the world's programming languages from being extinguished, only leaving the assembly language left. Okay, let's be real, it's just a rebranded version of Hangman. But instead of drawing a little person, every time you get a wrong guess, you eliminate one of the programming languages from the world. So let's see, we've got a 5-letter word here. Oh, shoot, so E is not in the final letter, so HTML, it's been real. We've lost HTML. Let's try A. Oh no, CSS is gone. I? O? Ah, look at that. Okay, we've lost JavaScript, but we still have React on the line. Ooh, this is tough. Let's try an L. Let's see, is this the word floor? Nope. Oh no, we've lost React. Maybe blood? Ah, look, it is the word blood. So we are still left in this world with some usable languages, and we can see that we've won the game. This is going to be a super fun project to work on. You can click on the screenshots here to see the different designs that we have over in Figma. And I want to take this chance to re-emphasize the importance of trying to do all of the challenges on your own before watching me walk through the solutions. This is a critical part of your education, and it can be so tempting at even the first slight hiccup in trying to complete one of the challenges to then just click continue and watch me do it and think to yourself, oh yeah, I think I kind of understood that. I could have gotten that. That is very tempting, even for me, so don't fall into that trap. If you do feel like you get stuck, rather than just skipping the exercise and watching me do it, turn to the Scrimba community and ask for help. Or for more immediate feedback, start a conversation with ChatGPT and ask it to help clarify any questions that you have. You might even want to preface it with, don't write the answer for me, but help me understand this. Going through that process, although much more tedious than just watching someone else do it, is the way that you get better at this. All right, strap yourselves in for the battle of the welfare of our programming community. When you're just starting out building a project that's as exciting as this one, at least I think this is an exciting project, it can be so tempting to just jump immediately into the code and start building the project. However, it's a really good habit to get into to spend some time planning out your project. Even if you're not wireframing it and writing down a whole bunch of steps that you're going to perform, simply getting a high-level overview of the project and thinking through it ahead of time before diving deep into building it can really help set you on the right path. So before we code anything, I wanted to take some time to do a little bit of project planning together, and my hope is that it will help set a good direction for you as we go through the next series of challenges that we have. So I have a few questions that I came up with, and these are certainly not the only questions that might help you plan your project ahead of time, but one of the things that I like to ask myself, especially when we are given a design like we have here, remember you can click on these screenshots to go to the Figma design so you can inspect all the specific details of them. When we're given a design like this, something that I like to ask myself is, what are the main containers of elements that I'm going to need? As it turns out, this tends to be a great place to start scaffolding your app when you are coding it, so that you don't find yourself too deep down one rabbit hole without being able to show any progress on the other parts of the app. Another thing that you can think about is what values you're going to need to have in this app. Because we're working in a React app, you can think specifically what values need to be saved in state and what values might I be able to derive from the already existing state. Another thing that's important to keep in mind is the user that's using your app, and so you could ask yourself, how will the user interact with my app and what events do I need to be handling? So I've typed these questions out right here. Actually, I'm going to put a little bit of extra space between them because just like a quiz, I want you to type in here the answers that you come up with on your own. There's no right or wrong answer for this. It's really just to get your mind working from a higher level view of the project to help guide your development from this point forward. I'm going to move the slides over to the screenshot of the game so you can refer to this, especially when you're answering questions 1 and 2, which might prove to be a bit of a help while you're answering these questions. So I'm going to put in a pause now, and I'll give you a chance to type out your answers to these. Okay, the first one, what are the main containers of elements I need in this app? Let's just use our winning state version here in the middle. We can see there's kind of a header up at the top. It's just some static information. We have this bar in the middle that seems to present some kind of game status. We have the you win or the game over, but we also saw when we were playing the game that it will give you messages along the way. So it's kind of a status section. Below that, we have a list of languages, which will be updating as you're playing the game. Next, we have the actual word that we're trying to guess with a blank spot for every letter of the word and the letters filled out that we have correctly guessed. Then we have a keyboard section, which is the main point of contact with our user. This is where they'll be clicking around to make their guesses. And finally, a new game button at the bottom, which will only show up at the end of the game. Identifying all of these sections gives us a great starting point with how we can start scaffolding or bootstrapping this project. Okay, let's see question number 2. What values will need to be saved in state versus what values can be derived from the state? I think the answer to this will become more apparent as we start writing our code, but it's still helpful for us to think about it ahead of time. Perhaps an even more enlightening question isn't what will be held in state and what will be derived from state, but simply what values do we need to know about? For example, we need to know if the game is over or not. Whether that's something that is saved in state or derived from state might become a little more obvious as we're writing the code, but it's good to know. We need to know if the game is over. We need to know if the user has won or lost. We need to keep track of how many wrong guesses the user has had, as well as what the randomly selected word by the game is, and which letters the user has already guessed. Knowing which letters the user has already guessed and the correct word will help us determine which keys on the keyboard should be green versus red versus yellow. The display of the new game button at the bottom will probably be determined by that value that we determined earlier, whether the game was over or not. And there might be a few other little hidden ones here and there as we go throughout the app. Now, you'll notice I'm not necessarily typing the answers down here. I think it's helpful to type the answers down, but for the sake of time, I'm just going to be speaking them out loud. Okay, we kind of touched on this already. How will the user interact with the app and what events do I need to handle? It seems like the main point of contact is our keyboard here. The user will be clicking on the keys, which should cause re-renders where it will determine if that was the right guess, wrong guess, change the keyboard, update our word, or kill off another programming language. So the keyboard is probably the main point of contact with our users. And lastly, a new game button, which of course will only show up when the game is over. Hopefully you can start to adopt a quick planning session like this into your own workflow, because I truly believe it's going to help you not only avoid pitfalls that you might not have seen otherwise, but to, in general, become a better architect of your code because you've given yourself the opportunity to plan things out ahead of time. All right, now let's take what we have just discovered through this project planning session, and now with a better overview, let's start building some pieces of this project. I've always felt like a great way to start making progress on an app is not to get too bogged down in getting all the functionality working right away, but instead to just get something on the page. So we're going to be taking little bites out of building this project by first just adding a little header section that includes the title of the game and a little description paragraph. The overarching goal for the next few challenges is to build out the main parts of the app, but we're just going to start with this little piece for now. One thing that can be helpful to note as you're working in CSS is that I have already made the body a flex container with everything justified to the center, which is why game goes here is in the center. I've also changed the background color, the text color, the font family, and a few other things. Similar to the Tenzies app, as we're building out the main structure of the site, we will be spending a bit more time in CSS. And because this is a capstone project, I also expect you to write the CSS. I know that might not be everybody's favorite thing, but when you get a job as a React developer, they are going to expect that you know how to write CSS. Okay, go ahead and get started on this challenge. You might have noticed in the final version of the code that we saw that we had opted to kind of just put everything here inside of our hangman function. And actually, note the name of this is a remnant from when I first started writing it. Let's call it assembly endgame. So we could spend a little extra effort by moving things out into other components, but at least for now, while I'm scaffolding, and potentially for the entire lifecycle of this app, I'm just going to be putting everything here inside of my assembly endgame component. So instead of game goes here, let's go ahead and create a header element. And because this is the title of the game, this is an appropriate place to add an H1. We'll say assembly endgame. And then let's add a description in a paragraph. And I am just going to paste in the text from the design. Let me start out by making this a little bit more narrow. And I think I'll wrap this just to save a little bit of horizontal space. Okay, we're going to have some design that we need to work on, which I think will be next. So I'll come over to my CSS and let's go ahead and select our header. Because we're just going to have one header, I don't know that I'm going to bother to give it a class name. I think it'll be enough for us to just select the element itself. The body is justifying this to the center, but the text still needs to be centered. So we can say text align to the center. And well, actually, no, that might be the only style on the header specifically. Let's go ahead and select our H1 now. And we will bump the font size down a little bit because the default styling is a little bit large. Let's go ahead and say 1.25 rems. The design also shows that it has a little bit less of a bold font weight, so we'll set that to 500. And yeah, it makes a tiny difference. And then we have to look a little bit closely, but in the design we can see that the color is slightly different from anything else. It's kind of a yellowish color. At least that's kind of how it looks on this background. Okay, let's go ahead and select the paragraph now, because that also has a different font size, which if we convert it from pixels in the design to rems, we get about 0.875 rem. I don't love how it's wrapping. It looks a little bit wide to me, so I'm actually going to include a max width. And let's try 350 pixels. Okay, that's wrapping a lot nicer, at least to me. And then we do have a different color, so we'll set that to the same color as the design. All right, this is a good start. Next, I think we'll just kind of work our way down the page. We'll start on this status section. We're still in these challenges where we're building out the main parts of our app, mostly focusing on having the static elements on the page. We'll worry about interactivity later. So your challenge this time is to build the status section, which comes right below the header. For now, because we're not worrying about having it be too dynamic, you can just hard code in a winning game state. Maybe that will boost your mood through the rest of this scaffolding process. So go ahead and get started on this challenge. As with most of these CSS challenges, there are certainly many different ways that you could do it. So don't feel like the way that I'm doing it is necessarily the best way or the correct way. It's probably just the way that makes the most sense to my brain. So below our header, I'm going to add a section. And while I'm here, I'll go ahead and give it a class name of, let's call it game-status. We'll get the content in here and then start worrying about the design for it. The style for the you win text inside of this status is not only a little bit larger, but the semantic meaning of it, I think, holds a little bit more weight to the status of the game. So I'm going to make it an H2. We've already used an H1 on this page, so we'll just move on to the next one. And we'll hard code in you win. And then below it, we'll just put a paragraph that says, well done. Awesome. Okay, I'll hit save so those elements will show up on the page. And yes, we have some styling to do. Let's go over to our CSS. We already created a game status. So I'll select game-status. And sometimes I like to give myself an indication as to what kind of element this is being attached to. So I'll do something like section.gameStatus. For now, we are going to hard code in the background color that's the green winning color. And because there's two elements in here, I could try to space them correctly and everything, but I think I'm just going to set this to a display of flex, use a flex direction, not flex basis, but a flex direction of column. I'll align the items to the center, and it looks like it's already justified to the center. I don't think I need to say justify content center. Yeah, but doesn't appear to be doing anything. It looks like there's some default styling applied to the H1 and to the H2 and the paragraph. So let's select those individually. I'm just going to bring this line down and then access the H2. We'll set the font size to 1.25 rem. Oh, and it looks like in the design, the color is different. Oh, actually, the color for both is different. So let's just do that in the parent here. We'll change the color to that kind of more yellowy color like our header up here. While we're at it, let's see what it looks like to get rid of our margin. And well, 0 is going to be not enough. So first, let's maybe do this to the paragraph as well. I'll set a margin of 0. Yeah, it's a bit squeezed, and I think if I make this something a little bit bigger, like 5 pixels, and we'll say 5 pixels. Oh yeah, that looks much better. Let's see, there's also a border radius, which we missed. So border radius of 4 pixels, it looks like from the design, just to round out the corners of the status. And then I want to separate it a little bit from this header. I can use either margin top and margin bottom, or I can combine them and use margin block, which is a helpful way to just provide margin to the top and bottom of an element. And okay, yeah, that separates it in a nice way. All right, this is looking good. On to the next challenge. In the next part of this challenge, we will add the list of languages with elements that are sometimes referred to as chips. They're just like little badge elements on the page. So that's the challenge this time. I want you to create those language chips. However, it's going to be a little bit more involved than that. I've provided to you a new file called languages.js. This is an array of objects, each object representing one of the languages that will get displayed on the page. Collecting them together in objects like this allows me to not only provide the name, but also whatever background color and regular color they should be using. I mostly didn't want that to be super tedious for you to have to do manually or to have to create 9 separate elements down here in your markup. Because this is a capstone project, I'm going to continue being pretty vague, but I did want to give you a hint for the layout, and that is for the container that you use around these elements. If you set it to a flexbox and make sure that it can wrap, it should make your job a lot easier. You might also need to apply a max width so that it doesn't just try to span the entire width of the page. For reference, I'm going to be using a max width of 350 pixels. Okay, that's all the hints I'm going to give you. Get started on this challenge. All right, let's create a new section. This section will act as the container for my language chips. And as such, let's go ahead and give it a class name of, well, let's just call it language chips, language-chips. Now, I'm not going to hard code anything here, but instead I'm going to import my list of languages from, let's see, languages.js export const. Okay, this is not default exported, which means I need to destructure it. And this is going to come from languages, and this needs to be a relative path. Let me just make sure this is working. I'm going to console log languages, and okay, good. They're coming into this file just fine. With that array of languages, I can map over them and create new elements on the page for each one of them. A common thing to do is to do that map operation directly here inside of your markup, although my personal preference has leaned towards creating a separate variable here in the body of my function before my return. So I'm going to create a new variable that I call language_els for language elements. No, let's call it language elements. And this is going to be an array from calling languages.map. We'll look at each language. And let's go ahead and return, we'll make these spans. They seem like they're maybe appropriate as a span. The text inside will be lang. Was it name? Let's go check. Yeah, lang.name, and then we have background color and color. So we will use those in our styles. Actually, let me put this down in this section first and hit save just so we can see that this is working. Okay, that is terribly ugly, but we're on the right track. So inside of the span, I can provide an inline style, and so that's what I'm going to do. This needs to be an object, and actually, for the sake of saving my horizontal space, I think what I'll do is create a new variable, which means I can't do an implicit return anymore. Let me shuffle some things around here. We're going to return this span. I can get rid of this. And by doing that, I can now just create, I'll say styles is equal to an object where the background color is going to be lang.background color, and the text color or color is going to be lang.color. And then I can just pass in my styles object right here. The other way would have worked fine too. This feels better to me for some reason. Let's see if that made any difference. Okay, well, that's a good step in the right direction. I think in our CSS, we can style both the language chips as well as the individual language chip. So let me give this a class name, or rather give each one of these a class name. And I'm just going to call it chip for now. We'll hit save and then go over to our CSS. Oh, actually, let's fix this warning first, where we need to add a unique key prop. Our list of languages doesn't have an ID for each object, but the name is guaranteed to be unique because, well, we're not going to be adding to this list. So I'll just use the lang.name as the key, and I'm going to start putting these on their own lines. So let me add a key, which is equal to lang.name. Okay, good. Our warning is gone. Let's go over to our CSS. We have language chips that we need to style and chip that we need to style. So section dot language dash chips. I had mentioned that we should change the display to flex and that we want it to wrap. So I can set the flex wrap to wrap. Okay, awesome. We need a little bit of space in there. They're really crammed in together. Let's give it a 5-pixel gap. We want things to be a little more centered. Let's justify the content to the center. And I had mentioned that I'm going to be adding a max width of 350 pixels. Okay, let's work on the individual chips, and I think that might finish us off. Those were spans with a class of chip. And let's see, in the design, it shows they have a border radius of 3 pixels and a little bit of padding around them. Looks like it's about 4.5 pixels. Wow, that's actually looking pretty great. Let me try resizing the browser here just to make sure that we're doing pretty good. And yeah, it's not a big deal if that wraps down, but we probably won't be getting too much smaller than this anyway. Nice work on completing that challenge. Let's move on to the next one. All right, let's display our word on the page. To do this, you will want to first create a current word in state, and for now, just for fun, we can initialize it as the word React. This represents the random word that the game will choose for us, but for now, we'll just hardcode it. Then, in order to display each of the letters, you'll map over the letters of the word, which means you'll need to turn it to an array first, because .map only works on arrays, and then display each one as a span element. Inside that span, just make sure you're capitalizing the letters. And then just generally style it to look like the design. Just a little hint in case it helps anybody, in order to get the little underline at the bottom of the box, you can simply use the border bottom property in your CSS. All right, go ahead and get started on this challenge. Let's create some new state just here at the top of our component. It will be for current word. And of course, set current word equals. And let's see, we're importing React. I think I'm going to import useState like this and call useState. And we'll just initialize it as the word React. I guess we could initialize it as capital letters, but this looks like it's screaming to me. So I'm just going to use React like that. All right, well, let's create another section where this can be held. I'll give it a class name of word. And I could do my map right here inside of my markup, but once again, I'm going to keep it consistent by doing it up here. Maybe let's call it letter elements. And I need an array to work with, but what I'm saving in state is a string. I can simply turn a string into an array by calling current word.split on every empty space, which if we console log letter elements, we can see gives me an array of all the letters in the word. And now that I have an array, I can map over it. All right, for each letter, I'm going to return a span, and we'll just put the letter in the span. We'll give it a class name. And actually, we can just select the span inside of Word. Yeah, let's do that. I'll hit save. Oh, we need to actually render this, so I'll take my letter elements. We'll put it here in the section. Okay, well, that's underwhelming, but let's go ahead and style it. Over in our CSS, we will select our section of Word. And I think I'll probably reach for Flexbox once again. We'll set the display to flex. We'll center it with justify content. I'm going to buy some room by putting a margin bottom on my language chips above there of, I think the design shows about 36 pixels. And let's put some effort now into the span. So I'm just going to select the child element of the span inside of my section. And each item will have a height of, let's see, the design shows 40 pixels. So we'll say 40, and then we'll also do a width of 40. a background color of this kind of dark color from the design. And then they are sitting in the upper left. I think for each span, I can also use a display of, let's try flex. I might have to change this. We'll justify the content to the center and align the items to the center. And I'm just realizing that we're working with lowercase letters here. Not the end of the world, but I had asked to uppercase them, so I should probably do that. Here we'll say dot to uppercase. Okay, that is better. And of course we are getting our key prop error. And we're console logging stuff still. Let me clean something up here. Let's see, right here, we're console logging the letter elements. Let's get rid of that and we'll hit refresh. Okay, we're still getting the key prop issue. So when we're mapping over this, I guess we need to decide what unique property we're going to use. Now, this isn't something I normally would advise doing, but because we're working with something that isn't guaranteed to have unique elements, I might be working with a word that has multiples of the same letter. I can't just use my letter as my key, but I do know that I'm not going to be removing any letters from this list or rearranging them or anything. I mean, in the game, I might be hiding them, but the word itself is not going to be rearranging the letters. And because of that, I can actually access another property inside of my callback function for .map of the index of each item that it's mapping over. And for now, this is going to work just fine as a key because, again, I won't be rearranging anything and it will never get confused by React. Okay, that suppressed that warning for us. Looks like we're almost there. Let's go back to our CSS. I think we can bump up our font size. This would be the equivalent of 1.125 rem. Okay, let's add that border bottom of 1 pixel solid, and then it's this color from the design. And in the design, it shows a little bit of space between these. Let's add a gap of 2 pixels. And not to the word, but to the word list here. All right, wow, that is looking awesome. Again, I know we're doing a lot of CSS here. We just have one more major element that will take a bit of CSS, and that is our keyboard. And after that, we'll finally be able to start jumping into the functionality of this app. Arguably, the most important part of this app is the keyboard. It's the main thing that our users are going to be interacting with. And it's your challenge to get it up on the page. I've created a static variable that just has all of the letters in the alphabet that you can use to map over the letters and display the letters in the keyboard. Make sure that you make each letter in the keyboard an actual button element because, well, semantically that's correct, and it also will come with a bunch of free accessibility benefits as well. Go ahead and get started on this challenge. All right, let's come down and I'm going to create yet another section. We'll open that up. I'm going to give it a class name of, let's say, keyboard, and we'll come back to the styling in a minute. Kind of like we're doing up here, we'll render, what should we call it? Maybe keyboard elements? We haven't created that variable yet, so let's go ahead and do so right here. Keyboard elements is equal to the alphabet.split. The only reason we have to split it is because I wrote it up there as a string just so I didn't have to type as many characters trying to put each letter as its own string in an array. Okay, so this gives us an array, and then we can map over that array, and for each letter in that array, we will return a button element. It's going to have the letter inside, and actually, I forgot to mention this, but I wanted to uppercase it, so that's what we'll do. We're mapping, so we need to make sure that we include a key, and because we are only rendering one button for each letter of the alphabet, I can use that letter as a unique key. We're not worrying about the functionality for it quite yet, so I don't know. Let's see where it is. So we'll hit save, and whoops, I did that wrong. That's supposed to be the actual variable of the letter. That's why I got my key warning. Okay, there we go. You could have chosen either Flexbox or Grid to style it. Honestly, because of the design, Grid seems to make more sense, but because of my stronger familiarity with Flexbox, I'm actually going to lean on Flexbox to handle this one. So let me access the section with the class of keyboard. We'll give it a display of flex. We need to make sure that it can wrap, so I'll say flex wrap wrap. We'll give a gap of 8 pixels. And let me space it away from the word a little bit, maybe right up here. We'll give a margin bottom of like 20 pixels. Yeah, that looks better. We'll justify the content to the center. And I believe it's going to, yeah, it's just going to keep spreading out. So again, I'll give this a max width of, I think the design shows it's around 450 pixels. Now things aren't lining up super well, but I suspect that has to do with our actual keys. So let's access section.keyboard and then the spans inside. No, the buttons inside. All right, the design shows that it is 35 pixels high and wide. Oh yeah, look at that. That lines up much nicer. I'm going to copy the background color from the design. Let's change the default border for these buttons to a 1 pixel solid, and then I'll paste in this color from the design as well. I usually like to make my buttons have a cursor of pointer. And oh, we need a little bit of a border radius as well. I think it shows that it's 3 pixels. All right, I don't know what you think, but that seems like it is working and looking pretty good to me. Now, the last piece of our app is to have this new game button at the bottom. But because I love you guys and you've done such a great job on the challenges so far, I have a little surprise. I can snap my magic fingers. And just like that, we now have a new game button in our app. Yay! I figured this was an easy enough element, we didn't really need a whole separate challenge for it. We're in our second capstone here. You don't need a challenge on how to add a single button. Okay, well, it sure is looking good, but of course it's not doing anything. So let's jump into the next challenge where we will start adding some functionality to this. All right, so we've added the keyboard. Let's start working on making the keyboard actually work. Of course, the user is going to click these letters in order to give their guesses as to what should be in the word. Right now we're displaying the word. It's going to be blank letters, of course. So our overall goal for the next few challenges is to allow the user to start guessing the letters by clicking the buttons. The specific challenge for this scrim is to be announced, but first I want you to think what's going to be the best way that we can store the user's guessed letters. I'm going to put in a pause here and give you a chance to think through that. Because we need to remember the user's guessed letters across every render of our component, and we know that when the user guesses a letter, we want to update the UI in a few different ways, right? We need to display the letter here. If it is a correct letter, we need to cross out one of the languages. If it's a wrong letter, we need to change the keyboard key color, if it's right or wrong, to either green or red. So because of all those things, we want to make sure that we save the user's guessed letters in state. So let me type out what your challenge will be. Your challenge is to create a new array in state to hold the user's guessed letters. And when the user chooses a letter or clicks one of these buttons, you need to add that letter to this state array. For now, we're not going to worry whether it was a right or wrong guess. There's a few other ramifications with that, so we're just going to focus on adding it to the state array. And you'll probably want to console log this array just here near the top of the component so that you can make sure that it's working correctly. Go ahead and get started on this challenge. Okay, we'll create some new state. Maybe we'll call it guessed letters and set guessed letters is equal to use state, and we'll initialize it with an empty array. Let's go ahead and console log our guessed letters. As a reminder, this console log is going to run every time our component gets re-rendered, and because we're about to make it so that clicking the button will set state, that will re-render it, and that will run our console log right here. Okay, maybe right below the alphabet here, I'll create a click handler. We'll call it maybe add guessed letter. We are going to need to know what letter was guessed, so we'll assume that we can pull that in as a parameter to the function. To update our state, of course, we will call set guessed letters. We do need to know what the previous letters were, so we'll access the previous letters in a callback function. And as a first iteration of this function, let's just say we're going to return a new array that has all of the previous letters and then adds the new letter at the end. Some of you might already notice what kind of issue we might face with this, but we will fix that in a second. Let's take add guessed letter, and where are our buttons? Right here's our keyboard buttons. And so I will add, maybe right here, I'll add an onClick that runs add guessed letter. But I need to do a little bit more than this because remember, when I have an event listener like onClick, if I just pass a function, I don't get to choose what parameter it receives. It's going to receive an event object from JavaScript. So what I can do is simply wrap this in its own anonymous inline function And then the only thing that function is going to perform is calling add guest letter, at which point I can pass in the letter while we're mapping over them to that function. This is getting a bit wide. Let me clean this up a little bit. Okay, let's hit save and open our console. A, B, C, D, E, F, G. Awesome. If you haven't yet discovered what bug I introduced in the way that I wrote my add guest letter function here, I'm going to refresh this page and give you a chance to see if you can figure it out. So I'll put in a pause here, see if you can figure out what kind of bug we have currently. If the user keeps guessing the same letter a bunch of times, we are going to be duplicating the guessed letters in our array. And that's not what we want to do. We want to make sure that we are only including letter into this array if it isn't already present. There's a few different ways that we can do this. And just for fun, I'll show you 2 different ways that you could choose. The first thing we could do is, let me put this on a separate line. Actually, let me just get rid of this. We're going to be doing it from scratch here. One way I can ensure that I'm not duplicating the letters here is I can check if the previous letters already includes the letter that I'm trying to add. And I can use a ternary that says if that returns true, in other words, the letter that I'm trying to add already exists in the previous letters, then I can just return the previous letters. I don't need to make any changes to it. But otherwise, I can do what we were doing before, where we just spread in the previous letters and then add the new letter to the end here. Let me put these on their own lines as well. Let me hit save and just make sure this is working. If I click A, I get A added. If I click A again, okay, it's not adding it. Perfect. Let's do B and C and then try to do A again. It looks like it's logging it to the console, but at least it's not adding the previously guessed letters to the array and duplicating them. Again, just for fun, I think it can be a good learning experience to see another way that we can do this, perhaps using an API in JavaScript that you're not yet familiar with. I'm going to get rid of what we had, and let me fix my brackets here. Open up the body of this, and what we can do is create something called a set in JavaScript. A set is very similar to an array in JavaScript, except it doesn't allow for duplicates. It's built into JavaScript to not allow duplicates. And so what I could do is create a new variable. Let's call it maybe letters set, and that's going to equal a new set, and we can pass in the array of previous letters to pre-populate this set. Then I can say letterset.add. Sets in JavaScript have a method called add, and you can add the new letter to the set, which will automatically remove duplicates from the set. Then I can turn the set back into an array and return it by using return array.from my letter set. Let's go ahead and see how this is working. I can click A. Yep, I'm clicking A a bunch of times. This does have an interesting side effect where it is re-rendering our component, even though we're not changing the state of this variable. So that's kind of interesting, but it is working. And oh, we're probably not seeing those lower ones. So I can click A, B, 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 C, 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 and the array just has A, B, and C in it. Well, I haven't taken the time to figure out why it is re-rendering the component every time I click it, whereas what we had before is not. And so I think I'm actually just going to back up to the other version right here, and we'll just leave it at this. Either solution is completely fine and valid. Okay, now that we have a way to store in state the letters that the user has guessed, we have the ability to start working on some of the other user interface pieces of the app where the game can give feedback to the user. So that's what we'll dive into next. All right, folks, this is one of those challenges that's going to require you to think critically. I'm being pretty vague in all the steps that will need to take place in order to complete this challenge. And as a bonus, you are going to get a chance to read about and use a fairly popular third-party React package. So first, let's talk about the challenge. I want you to update the keyboard keys to display whether the selected letter that the user just clicked is right or wrong. As you can see from the design, if the letter is a correct letter that's in the word, then it turns green. If it's wrong, then it turns red. For testing purposes, we're still keeping the current word as React and displaying it here. We're going to get to obscuring that and choosing a random word later, but this will really help with testing. Of course, if you hit R, E, A, C, or T, then the letters should turn green, and if you choose anything else, they should turn red. As a bonus, I am recommending that you use this CLSX package. It's going to require you to go learn about it, but as you can see, it receives about 21 million weekly downloads, so it is a pretty popular package, and its whole purpose is to give you a chance to construct the class name string. That's the string that you are passing into your elements like this right here. Class name, we have hard-coded it to be chip. Or in the case of the button, which we are going to be styling, we are not passing in any class names, and CLSX gives you a chance to construct those class names conditionally. So if you want to use CLSX, you're welcome to do so. Click on the screenshot here to go to NPM and read all about it. There's a chance that the documentation may prove a little bit confusing. If you find that's true, then don't be afraid to turn to Google or the AI assistant of your choice to ask how this package is used. So try to psych yourself up for this awesome challenge, and I'll turn it over to you to start working on it. When I first was building this app, I thought to myself, I wonder if I should save in state an array of all the correct letters and another array of all the incorrect letters. But then I realized that we can easily derive that value by simply looking at the array of guessed letters and by looking at the current word. As we are mapping over the alphabet and displaying the buttons for each letter of the alphabet, we can take the opportunity to check if the current letter that we're looking at is in the array of guessed letters, and if it is, then we can check to see if it's correct or not by seeing if that letter is also in the current word. If those two conditions are true, in other words, it's been guessed and it's in the current word, we can change it to the green background. And if it's in the guessed letters but it's not in the current word, then we can change it to the red background. No new state necessary at all. I can simply derive those values based on the state that we already have. So let's come down to our keyboard elements here. And I'm going to need to include some additional logic before I return this button. So I'm going to open up a set of curly braces and move my button inside just so I have some ability to write some additional logic here. I'll go ahead and put this in a parentheses. Wow, I have some serious formatting issues to figure out right here. Okay, but now that I'm doing an explicit return, I can start writing some additional logic up here. So let's think, what are some of the values that I need to know? Well, I need to know if the letter has been already guessed. Remember, I'm mapping over the alphabet, and this map operation is going to happen every time our component re-renders, which means I know that I can have an updated version of our currently guessed letters and the current word. So if I want to know if the letter has been guessed, I can simply check inside of the guessed letters to see if it includes the current letter that we're mapping over. Okay, well now let's check to see if the guessed letter is correct. Well, first of all, it's important that the letter has been guessed, otherwise it's neither correct or incorrect. So if it is guessed and the current word includes this letter, then yes, this is a correct letter guess. And it wouldn't be enough to have an is wrong variable that simply says it's not is correct, because every letter would be considered wrong because we're not comparing it to make sure that it's been guessed. So we would simply say const is wrong is, and I'm just going to take this logic and reverse the fact that it's included in the current word. Okay, how is this helpful? Well, at this point, I could now add a class name to my button and try to do a crazy nested ternary that says, first, let's check to see if it's guessed, and then if it is, let's check to see if it's correct, and if it isn't, let's check to see if it's wrong, and apply certain class names accordingly. But this is where the CLSX package comes into play. What CLSX allows me to do is create an object where the keys are the names of the classes that I might want to apply, and the values of those keys is a Boolean as to whether or not that class name should be applied. This will be much easier to just show. So let me go ahead and create a new variable called class name, and this will be the string that gets returned by calling the CLSX package, or function rather. There's a bunch of different ways to use CLSX, as I'm sure you discovered from the documentation, but the most common way that I find myself using it is to provide an object. And as I mentioned, the keys of this object will be a potential class name that will end up on the button in the end. So, for example, I might have a class name called correct, and I only want the correct class to be applied if isCorrect is true. And I could do another one for wrong or incorrect. Let's call it wrong and say this is if is wrong is true. I haven't created these class names yet, but let's finish up our work here. First of all, I need to apply this class name that results from calling CLSX, and I don't believe I've imported CLSX yet. So let's go ahead and do that before that becomes a problem. Import CLSX from CLSX is a pretty hard thing to say, actually, now that I'm saying it so many times. While we're still here, let me go ahead and console log class name. We'll get a better idea of what's going on here. Well, this console actually doesn't show anything, but the little pop-up down below shows that it was an empty string. Let me see what happens if I click A. Oh, whoops, we do have an error here. Current word.include is not a function. Yes, this needs to be includes. Sorry for anyone who was shouting at their screen because that was a mistake. Okay, let's try this again. We'll click A. Okay, look, it console logged correct. If we put B, it's going to console log both correct and wrong. And that's because what it's doing here, as it's looping through the entire keyboard, it's looking at each letter and it saw that A was guessed and it is in the final word or the current word, which is React. So we have an A there. Is correct became true. It applied the class name of correct and then it just console logged that class name for that specific letter, which was correct. Then it continued through its map and it got to the letter B. It said, yes, this is in the list of guessed letters. And so it is guessed, but it is not in the current word. So is wrong is true, which means that wrong is going to be applied and it console logged wrong. And then I think behind the scenes, there's actually a bunch of empty strings that are happening because every other letter in here is not guessed. Okay, let me close the console. I have some styles that I just have copied over. It just has the background colors from the design. So let's see, here's our keyboard and we'll just put these right there. Okay, button.correct and button.wrong. And I would have thought that would have applied. Let's go ahead and hit save. Let's try A. And oh, you know what is happening? We have a specificity battle going on. Up above, I am being more specific about this button than this button. So I guess let's just add the same level of specificity. Well, actually increasing the specificity. And okay, there we go. We get our letter A being colored as green because it's in the final answer. Let's go ahead and click B and awesome. So let's go back up to our challenge. And sure enough, we were able to update the keyboard when a letter is right or wrong. This should work all the way through. R should be in there. Let's see, T should be in there, and we've gotten all the letters, so everything else should be red. Feel free to continue playing around with CLSX. We are going to be using this in a couple different places in this project, mostly to help us avoid any crazy nested ternaries or having to write a bunch of conditional logic just to determine our class names. I guess another thing to note about this package is that although we are using it in a way where these are mutually exclusive classes, it doesn't have to be that way. You can provide an object that has a lot of different class names, and it will just apply all of them where the value at that key ends up being a truthy value. All right, we're making great progress. Let's keep it going. All right, there's really no hints that I'm giving you this time at all. I'm just asking you to add the next feature to our app. So your challenge is to only display the correctly guessed letters in the word. Right now we're displaying the entire word, which of course defeats the purpose of a game like this. So now that we have some UI feedback as to whether the letter that they guessed on the keyboard is correct or not, if the letter is correct, then we want to display it in the final word, but otherwise we just want it to display nothing, I guess an empty string. I'm going to let you find where in the code you would need to make that change. And that's it. I'll hand it over to you now to work on this challenge. Well, naturally, I think the first place we want to look is where we are displaying these letters. And so if we come down to the letter elements, this is where we are looking at the current word. We're splitting it so it's an array. We're mapping it. And then for every letter in that array of letters, so R, E, A, C, and T, we're creating a span. And inside that span, we are just automatically putting in the letter. So this is where our logic is going to live. Instead of always putting the letter in, we could put in a ternary here that says If the guessed letters, remember the array that we are keeping track of as the user is clicking the buttons, if the guessed letters includes the current letter that we're mapping over in the current word, that means that the user has guessed this letter and it was correct, because at this point we are only mapping over the letters in the actual word. And so I can use this ternary that says if the guessed letters array includes the letter that we're looking at, and I'm actually going to pop this onto its own line here. Then I want to display the uppercase version of that letter, but otherwise I'll just put in an empty string. So when I hit save, all of the letters should disappear. Perfect. Oh, it looks like I still have a console log hanging out for this class name. Let's get rid of that. So the letters disappear, and then let's start guessing the letters. We know that it's React, so R, E, A, C, and let's do a non-letter like W, and okay, perfect. Nothing else updated, and we'll do T. Awesome. Although the final code ended up being pretty straightforward, hopefully this was a good challenge because remember, I only gave you the feature that we wanted to add, and it was up to you to figure out how to do that. If you were able to do that, that is a great sign that you are following along, you're understanding this code, and ultimately, hopefully, you're not getting stuck in tutorial hell by just watching me do all of this without actually getting your hands on the keyboard and practicing. We're making great progress. Let's keep it going. We're on to the next goal. So far, there's basically no consequences to getting wrong letters, and so we need to add a little bit of tension to the game by adding in the mechanism that will count the number of incorrect guesses and actually have consequences that lead the user to potentially losing the game. In this game, we only have 8 wrong guesses that we're allowed to get before assembly is the only language that we're left with in the world. And so we need to be able to count how many wrong guesses the user has had. We talked earlier about how we could have chosen to track in state an array of correct letters and then another piece of state for the wrong letters. And honestly, that could have worked just fine. However, the way that we currently have this set up, where we have the current word and the array of guessed letters, both of which are being held in state, we can actually figure out how many wrong guesses the user has had based on just these 2 values. So your challenge is to do exactly that. I want you to derive a variable which you can call wrong guess count for the number of incorrect guesses by using these other state values, current word and guessed letters, that we're already holding in this component. We're starting to add a bunch of extra values here, either for state or this static value, or we're about to create a derived value. So I'm actually going to create a little bit of separation with some comments. I'll say that these are the state values. Let's say this is a static value. And we'll just say values in case we have to put something else there. And right here, we will add a section for derived values. For now, once you have created this variable, just to test it, we'll say that you can just console log the variable, or let's say the wrong guess count. We'll make better use for it in the upcoming challenges. All right, the time is yours. Go ahead and get started on this challenge. Well, we have an array of all of the guessed letters, both correct and incorrect ones. So if we could filter out the correct letters from this guessed letters array, all that would be left is the incorrect letters, and then we could simply take the length of that array to get the exact count for the number of wrong guesses the user has had. This certainly is not the only way to do it, but it is the way that I will be proceeding. So we'll say const wrong guess count. And actually, just for now, so that I don't have to try and chain too many things together, I'm going to maybe have a wrong guesses array, and we'll just take care of this in 2 steps. I will probably end up combining them once we understand what's going on here. Okay, so let's look through the guessed letters array, and we're going to create a new array by filtering out the correct letters. And so my filter is going to look at every letter in the guessed letters array. And we only want to include in the resulting array, this wrong guesses array, the letters that are not in the current word. So I can say current word dot includes, and I'll go ahead and put my negative there because I want to make sure that the current word does not include the current letter that we're looking at from the guessed letters array. Let's do a little bit of an intermediary step. We'll console log the wrong guesses array. Okay, starts out as an empty array as we'd expect. If I add A, okay, we're still an empty array because that was a correct letter. Let's go B. Okay, look at that. We've got a B in there, D, F, Perfect. Just for good measure, let's put in a correct letter. Okay, we're console logging the array again, but it does not, of course, include the correct letter. Great. Well, then obviously the only last thing we need to do is take the length of the wrong guesses array, and that's going to give us our wrong guess count. At this point, instead of creating a separate variable, I'm just going to have the wrong guess count like this and chain on a dot length at the end of everything else that we have. Let's just go ahead and make sure, oh, whoops, I put this in the wrong place. This is where I put the dot length, and I want to console log the wrong guess count. Okay, let's try it out. 0. A is correct, so we're still at 0. E is correct, still at 0. D, okay, we're at 1, 2, 3, 4, and 5. Cool. This wrong guess count is going to be pretty crucial for us to be able to do a couple of the other things involved in adding this incorrect guesses mechanism to the game, like starting to cross off different programming languages, or knowing if the game has been lost. That's also going to help us fix our status section up here, which currently is just hard-coded to you win. And so this was a pretty important feature that we just added. And something that I think is kind of nice is that we were able to just derive it from the state that we're already maintaining. Generally speaking, if you don't need something to be in state, it's usually better for it not to be in state. Let me go ahead and clean up some of these extra spaces here. And awesome, great job on this challenge. On to the next one. Now that we have access to the number of incorrect guesses from the user, one of the first things we can do is to mark off the languages that have been lost based on how many incorrect guesses there have been. To me, the CSS for adding this little gray overlay and the skull felt a little bit outside the scope of the course, and so I just went ahead and added these rules here. It's just a pseudo element where if you add the lost class name to our language chip, it's the span with the chip class, then it will gray it out with an overlay that's opacity of 70%, and it has this little skull emoji and everything else here. Feel free to look through these CSS rules if you want, but as I said, it just felt a little bit like a distraction to worry too much about this. The only thing you really need to know is written up here in the challenge text. When you're mapping over the languages, you should determine how many of those languages have been lost and then add the lost class if it is a language that's been lost. I give a hint here where you can combine the wrong guessed count that we figured out in the last scrim right here and combine it with the current index of the item in the array as you're mapping over the languages array. You're welcome to use CLSX if you want. If you do decide to use CLSX, you'll need to refer back to the documentation on how you can always include a class name, because right now we are including this hard-coded chip class name and we want to make sure we don't lose that. This one, however, is a relatively easy one to do manually, just right here inside of this class name prop if you'd like. All right, time to get your hands on the keyboard. All right, so let's come down to where we are mapping over our language elements. And let's try to reason through how we can determine if the current language that we're looking at while we're mapping over them is a lost language. Well, if we can get access to the index of the current item in the array, since our array will always be in this same order that we see here, we can know that if we have a wrong guess count of 1, then any index that's less than 1, or in other words, any index that's less than the number of wrong guesses, should be considered a lost language and needs to get the lost class name added to it. Inside the callback function of my .map, I can add a second parameter called index, which gives me access to the current index of whichever item we're mapping over. And with that current index, I can create a new variable that says something like is language lost, and set that equal to the Boolean that results from saying the index is less than the wrong guess count. So if our wrong guess count is 0, then even the item at the 0 index is not going to be considered lost because 0 is not less than 0. If our wrong guess count is 1, then this will evaluate to true for the very first item, and we'll mark it as lost. If the wrong guess count is 2, again, this will evaluate to true for the items with the index of both 0 and 1, and so forth. With this isLanguageLost variable, I now can update my class name to include the lost class name if that's true. And I'll just show this in two different ways. I can do this manually by updating my class name here to use a template string and simply say is language lost and use a ternary. And if it is lost, then we'll add the lost keyword. Otherwise, we'll just maybe use an empty string so we don't add any additional classes. And let's try this out. We'll hit save, we'll choose a wrong letter, and awesome. Well, not awesome, we lost HTML. Let's do a correct letter or maybe a few correct letters and then another wrong one. Oh no, okay, bye CSS. Okay, look at this, we are doing this correctly. Okay, well, since we do have the CLSX package, I guess it doesn't hurt to use it. So right here, I'm going to create a class name variable, and I'll give CLSX a call. We want to make sure that unconditionally, we always include the chip class. And so if one of the parameters that I pass to this function is just a string, then it will just always include that in the final resulting class name. I also don't have to use an object like we did with the keyboard letters. Instead, I can just pass in a ternary here that says, is language lost? If so, then include the string lost. Otherwise, well, actually, you know what? I could even do the short circuit double ampersand method, and this should work just fine too. In CLSX, if this evaluates to false, then it just will ignore this parameter to the function anyway. Then I can come down here and just update all this with the class name that we determined above. Let's hit save, and we should get the same results. We're getting closer and closer to the end. Great job on this challenge. And since I don't think I've said it recently, take some time to look through our code again. If any of this has been confusing for you, it's time to put in the effort to become familiar with this code before just plowing ahead. There's absolutely nothing wrong with doing that. In fact, just plowing ahead will put you in a worse spot in the end. Once you're ready, we'll keep moving forward. Currently, we are rendering our new game button even at the beginning of the game. Your challenge is to create a new derived variable called isGameOver, which evaluates to true if the user has guessed incorrectly 8 times. 8 times because we have 9 items in our languages array, but we want to leave assembly as the only remaining language at the end. That said, I do want you to consider how we might make this value, or this isGameOver value, a bit more dynamic if we were to ever add or remove languages from the languages array over here in this languages.js file. Once you've completed challenge number 1, your second challenge is then to conditionally render this new game button only if the game is over. And at this point, it doesn't matter if they've won or lost, it's just if the game is over. For this first part, try to think critically as to what conditions in which the game should be considered over. And in this case, I don't mean game over like in the old Mario game over where you lost. It really just means game over whether you won or lost. All right, your turn to take the reins and work on this challenge. I didn't type this down, but I did mention it as I was speaking, but this isGameOver value is something that we can derive based on the existing state. And because we know that the game should be considered over whether the game was won or lost, maybe the first thing we should do is try to derive some state about whether the game is lost, and then we could say, well, the game is over if either the game is won or the game is lost. So let's go ahead and first create isGame1. And again, you may have chosen a completely different way to approach this. That's okay. I didn't say anything in the challenges about creating these extra variables. I'm just going to use them to separate my logic out a little bit more. Okay, well, how can I know if the game is won? Let's think about this one. Well, I've got my current word. This, of course, has all the correct letters in it. What if I were to check to see if every single one of the letters in our current word was also in our array of guessed letters? That should mean that the user has guessed every one of the letters in the current word, which should indicate that the game has been won. I could do a for loop to loop over every letter in the current word. I could use a .map, but there is a built-in method called .every, which allows me to pass in a function that should return a Boolean for every item in the array on which I'm calling .every. The callback function returns true, then the entire expression evaluates to true. That's going to make a lot more sense if we actually see it written down. So first I need to take my current word, which is a string, and turn it into an array so that I can even call the .every method on it. So we'll say current word .split, and that will give me the array of letters in the current word on which I can call .every. And we'll look at each individual letter, and if the guessed letters array includes this letter, this will evaluate to true. And if every single letter that we map over in this current word returns true, as in every one of those letters is included in the guessed letters array, then .every will return true, and this entire expression will return true. And so isGame1 will be the Boolean value true. Okay, cool. I think that should work just fine. Well, maybe let's go ahead and console log it. So we'll console log isGame1. We'll hit save and then just type out the correct answer. So false, that's good. We haven't yet won the game. REAC, that's a bunch of falses, and then T, and we evaluate to true. Perfect. Let's close the console, get rid of our console log. Now let's work on isGameLost. This one's a little different. Intuitively, it might seem that we should just say it's the opposite of isGame1, but the state of the game isn't either won or lost. There's also a currently in play state of the game. Instead, we'll need separate logic to determine if the game has ended and is lost. Well, we know that the game is lost if the user has a wrong guess count that is equal to 8, or I guess greater than or equal to 8, just to cover our bases. And actually, let's type it out that way first. We'll say wrong guess count is greater than or equal to 8. But now, as I mentioned in the challenge text, it would probably be helpful for us to consider how we can make this more dynamic if the length of the array were ever to change. So maybe instead of 8 hard-coded, we'll just say languages.length -1. Because again, we need to leave assembly here so that at least if all the other programming languages disappear, we can still program something. Well, somebody can program something. I certainly couldn't. Okay, so that finally leads us to the isGameOver variable. The game is over if either the game is won or the game is lost. So now that we've put that work in, we should be able to easily say isGameOver is equal to isGame1 or isGameLost. This is kind of just an intermediary convenience variable. Anywhere that we are relying on it, we could have theoretically just said isGame1 or isGameLost, but this way is a little bit fewer characters. All right, so that was challenge number 1. Number 2, we need to conditionally render the new game button only if the game is over. So we'll come all the way down to our button right here, add some curly braces, and we'll go ahead and say, is the game over? And if that evaluates to true, then we will render this button. Okay, let's test it out. We'll hit save, and let's see, should we win or lose first? Let's go ahead and win first, REACT. Okay, cool. Our new game button has shown up. Let's refresh this and just do a bunch of lost letters here. Oh, I guess T is in there. Okay, one more and we should be up. Not going to do R. Let's do Q. All right, the new game button showed up there too. Perfect. With our new derived values, we have a new improvement that we can make to our app. So that's what we'll jump onto next. Now that we know whether the game is over and whether the person has won or lost, we can come back down to this game status section and update it so that it's not a hard-coded you win, but instead we'll only display this you win, well done message if, of course, the user has won the game, or alternatively, we'll display this game over, you better start learning assembly if the user has lost the game. There's actually a third status that we're going to include here, which is a sort of farewell message to each one of these programming languages whenever the user gets a wrong guess, but we'll be worrying about that in a little bit. So for now, your challenge is written up here. I want you to conditionally render the won or lost statuses from the design, both in the text and the styles, based on the new derived variables that we created, isGame1, isGameLost, or isGameOver. As a quick note, we want to make sure that we're always rendering the surrounding section. So you can see in the design here, even when there is no message being displayed, we want that space to be open. And if we were to remove that section from the DOM with conditional rendering, then I think everything else would kind of bump up. And then when a message popped up, everything would bump back down. We just want to leave that like an open slot. All right, the time is yours. Get started on this challenge. Let's come down to this section, and we're going to be dealing with this section right here. And as I mentioned, we don't want to conditionally render this whole section because things would start to jump around on the page. Instead, we can conditionally render what's inside that section. So we will open this space up a little bit. One point of trouble that you may have run into is that we get an error if we surround two of these elements in curly braces like this. Just like how components need to return a single parent element, if we're going to be evaluating an expression that has some JSX inside, it needs to be surrounded with a single parent element. We could use something like a div, or because we don't necessarily want to add any additional elements to the page, we can just put in a fragment, just like this. Now, there's a lot of different ways that we could handle the conditional rendering here. And there's certainly not one correct way, just like in most of the stuff that we do when we're building these apps. So the different approaches that I'll show you now are just different options that you might choose. On the top level, we can think of it as having two different states. One where the game is not yet over and we want to display either a blank space, or if we go into this design, the little farewell message while we're in the middle of playing the game when the user chooses a wrong letter. Or the other state is that the game is over, and then it kind of branches again from there. Either they've won or they've lost. Currently, we are only really dealing with this second scenario where the game is over, and we can use a ternary to help us determine on the top level which of those two major states, whether the game is over or the game is not yet over, is true. So let's say if the game is over, then we will render this section. And for now, I'm just going to put an else in here that maybe just says null. Let me format this because my spacing is looking a little funny. At this point, we could decide whether we want to nest another ternary inside here to check if the game is won. And if the game is won, we render this one that says you win, and otherwise we render the one that says that you lost, or game over. Alternatively, we could just change the text because we want the H2 and the paragraph to stay there whether they've won or lost. But for some reason, I think I would prefer to nest a ternary here. In this case, it wouldn't be terribly confusing. I think I'd be able to read it kind of like an if-else statement, which is a little bit of foreshadowing as to the next way we're going to see to do this. So rather than putting a ternary here to determine the text and then another ternary here to determine this text as well, let's go ahead and just give this a shot. We'll say if the game is won, and we're just nesting a ternary here, we'll move this fragment with the H2 and paragraph inside. And if the game is not won, in this instance, we can know that the game is lost because we're not reaching this code unless the game is over. And then there's only two options from then. The game is won or the game is not won, which means the game is lost. So maybe then we'll just copy this and we'll indent it, and then we'll change our text. It says game over. And then this one says, you lose, better start learning assembly. And I just copied that from the design. This is something we'll be coming back to later, but I guess this isn't so terrible. If we have our indentation correct, then we can kind of read this like an if-else statement. Before we refactor anything here, let's go ahead and get our styles working, because our styles are still going to make it look like they have won, even if they've lost. Let me just guess a bunch of wrong letters here. Okay, so it says game over, you lose, which is great. That's a good first step, but the green box sure makes it look like we won the game. Just like how there's different ways that we could have done this conditional rendering, there's a few different ways that we could handle changing the styles as well. Because we're kind of on a kick using CLSX here, I think I'm going to use CLSX. So above my return, just right here, I'm going to create a new variable called GameStatusClass. And I'll set that equal to CLSX, or a call to that function CLSX. We have a class name that's already being used here of GameStatus. So let me copy this and put that as my first argument, which just means that I want you to always include the GameStatus class. And I guess I'll go ahead and set this equal to the GameStatus class. This is the string that's being returned from CLSX. And then I can provide maybe another object where I have different properties, like a won class that is determined based on a condition and a lost class that is based on another condition. Well, we have variables that I think help us know when we're won or lost. So I will apply the won class if is won or is game won is true, and I'll apply the lost class if is game lost is true. And we'll keep a close eye on these to make sure that this logic is correct. Let's go ahead and refresh this app. We haven't changed it since we added our little nested ternary in there. And okay, because the game is neither won nor lost, we have a blank message there. But the space is still being taken up, so that's good. The green box is not good. So let's go over to our CSS and add some rules for won and lost. So let's go over to the CSS, and here's our section with the game status. And I think right here, I'm going to add section.gameStatus. dot one, and I'll do the same thing for dot lost. Both of these will just be changing the background color, and the winning color is this one. Actually, I guess I can just take this line out of there and put it right here. And the losing color from the design is this one right here. All right, let's go intentionally lose the game to see if that's working. Actually, let's win the game first. We owe ourselves that. Okay, React. Awesome. Okay, the space got taken up. It has the green background. It's got the new message. Perfect. Let's refresh and we'll intentionally lose the game. Okay, perfect. As you can tell, a successful completion of this challenge did require a bit more than what I had led on in the beginning. I just gave you the feature and expected that you would be able to think critically and do some of these tasks by yourself. This was a hard challenge. So if you didn't quite complete it, then like I've said before, don't feel bad. This is all part of the learning process. If you were able to complete it, then do your little happy dance because that's pretty impressive. I had mentioned that we might look at a different way to do this conditional rendering, and so I think in the next lesson, I'm just going to quickly show you another way that we can handle the logic that we're currently doing right here. Before we jump into a quick side lesson, I wanted to apologize for anyone who is following along locally. I had a design flaw that I didn't realize I had introduced here, because as I'm recording here in Scrimba, our mini browser here is quite narrow, and the flaw was something that I kind of overlooked. Those of you who have been using a wider screen have probably noticed that things are not aligning quite right. And it turns out it's any of the elements that I have added a max width to. You see, when I have the justify content center on my body, it's taking the center point of the element as it would be if it weren't constrained with a max width. So this paragraph, for example, which we can clearly see is off center from the entire page, if I take the max width off, then it expands to its full width and the center point of it aligns correctly with the center of the page. I can come down here to, let's see, this is my language chips. I also have a max width. If I take that off, then it aligns correctly to the center. I do still want those to have a max width, just so that they wrap in the way that I want. So there's a few different fixes that I can provide. I can either on every one of these put a margin inline of auto, but another fix that I found is we can provide another flexbox to the parent of all of these sections. So that would be the main element. I can say the display is going to be flex, and we're getting a crazy layout right now, but we will adjust the flex direction so that it points downward in a column, kind of like block elements. And then I can use align items to the center. And just like that, we get everything nice and aligned to the center. Because of this, I actually no longer need my display flex or justify content on my body, so I can get rid of those styles, and everything's in harmony. Making the main element its own flex container does introduce a new problem. If I win the game, we can see that our status message is really tiny now. It's being compressed to only fit the space that it has. And so something we might want to add to our section with a game status right here is, and I'll group these with the other sizing properties, we'll say the width should be 100%, but we will also set a max width, and just need to spell that right, of 350 pixels. That is looking much better, and everything seems to be in harmony now. Again, I apologize for anyone who was just wringing their hands at the misalignment. I know that would have bugged me if I were in your shoes. All right, let's jump back in and learn about another way that we can handle conditional rendering. Sure, correct indentation can make our nested ternary look at least a little bit manageable, but come on, these crazy frowny faces are just really pretty awful. I personally don't love nesting ternaries, and I thought it could be helpful for us to see another way that we could handle all of this conditional rendering. It might be tempting to think, well, I can just simplify all of this crazy ternary logic by putting an if-else statement directly inside. However, as it turns out, we can't use if-else statements inside of our JSX expressions like this. And that's because if-else statements don't implicitly return anything. An expression, on the other hand, like a ternary, does automatically return these values. And since they get returned as a JavaScript expression automatically does, then it can get rendered to the page. However, that doesn't stop us from using an if-else statement inside of a helper function. So I'm going to just come up here right let's see, maybe right below our game status, I'll create a function that we call render game status. And because I'm inside of a function, I can return something from these functions, and I can use JavaScript statements like an if-else block. At this point, it's more of an algorithmic challenge to figure out exactly how to equate what we have down here with what's going to be in the function. I don't think that's an important part of the scope of this course. So one way I could do this is to quickly do an early return and say if the game is not over, so is game over, then for now, we're going to be changing this later, but for now we're returning null. So I can say let's return null. Because this is an early return, from this point on in the code, I can assume that is game over is true. And so I can just separately check, is the game won? If so, let's return, and let's grab this guy right here and put that there. And otherwise, we will return this one down here. Later in this series of challenges, we are going to be finding some of the things that we can offload to a separate file. And because of how tall this function is, it feels like a good candidate for that. For now, we're not going to do that. And I can just simplify all of this by calling render game status. Maybe I should hit save and test this out first. Okay, let's win the game first. Okay, awesome. That's applying the way we'd think, and then we'll go ahead and lose the game. Well, I guess I can't keep choosing correct letters if I want to lose the game. Okay, awesome. Again, this is not a right or wrong way to do it. When I do find that my rendering logic is getting a little bit complex, I'll sometimes prefer to offload that to a function that lives inside the body of my component. We've really been jumping from one challenge to the next. I think it might be helpful at this point for us to step back again and take a quick inventory as to what we might still be missing in our game. Just to reorient ourselves after this whirlwind of challenges that we've done so far, I think it could be helpful for us to take an inventory of the features that we still have in our backlog. If you've gone over to the Figma design, you have already seen that we are planning to do these farewell messages every time the user gets something wrong. And I don't remember if I've mentioned it, but these are going to be randomly chosen from a list of different farewell messages. So we do still need to handle this use case. So we'll say that we need some farewell messages in the status section. We also have a few pretty glaring accessibility issues that we need to make sure we fix. So I'll say we're going to fix the accessibility issues. And maybe just in case you didn't already know this, because it took me an embarrassingly long time to figure this out, but the reason accessibility is shortened like this is because it starts with an A, it has 11 letters in the middle, and then it ends with a Y. You'll also see abbreviations like internationalization, which is I18N, because there's 18 letters in the middle of these two letters. Okay, so we have some accessibility issues we need to fix. We also currently have a new game button that doesn't work, so we need to make the new game button work. We're currently hard coding the word that we need to guess as React, so we need to actually choose a random word from a list of words. And then last but not least, we definitely want to make sure we drop some confetti when the user wins. We'll certainly be making other improvements and little tweaks to the app along the way, but I think this represents a full picture of the backlog that we still have to work on. Maybe this would also be a good opportunity to remind you that if you've been sitting down for a while, maybe it's time to get up, stretch, take a few deep breaths, go for a walk, do whatever it is you need to do to recenter and refocus yourself. I also won't be offended at all if you decide it's time to shut down the computer and pick this up at another time. As they say, we need to sharpen the saw. Once you're feeling refreshed and renewed, let's jump into this backlog and continue making progress to finishing this app. This is a fun game, but let's not forget what's at stake here. Every time the user gets a wrong letter, we have to bid farewell to one of the languages that gets erased from existence. Including this farewell message up in the status bar is your challenge for this lesson. As a help, what I've done is created a getFarewellText function inside of this new utils.js file. All it does is it takes a language as a parameter, it has an array of farewell options, and then it just randomly returns one of them. Now, I'm not going to click on it, but I do have a hint.md file that I have created. If you give this your best shot and you find yourself getting stuck for maybe more than 15 or 20 minutes, at that point you would have my permission to go over to hint.md to see if that hint helps you out. But I do want you to do your best to solve the challenge without using that hint if you can. The time is yours. Go ahead and get started on this challenge. All right, since I assume you have done that challenge now, I'll go over to the hint. And this instructs us that we need to know if the most recently guessed letter was a correct guess or not. If we think in terms of the render cycle for our game, when the user clicks one of the buttons to choose a letter, what's actually re-rendering our app is that we are placing that letter in an array of guessed letters. Guessed letters doesn't indicate if it was a correct guess or not. We are deriving that information elsewhere, but simply by adding it to the array of guessed letters, our app is re-rendering, and then based on that information is updating the display. If the guessed letter was in the word, then it puts it in its correct spot in the word. If it wasn't in the word, then it's killing off one of our programming languages and marking the letter as red as the keyboard gets re-rendered. However, we need a way to know if the last item in that array of guessed letters was a correct guess or not. And by the way, this probably isn't the only way to do it. It's simply the way that I came up with, but I'm super open to feedback. If somebody comes up with a more logical or easier to reason about way, then I would love to hear it. Come over to the Discord. You can @mention me. You can even send me a DM on X if you'd like. Okay, so let's come back to our app. And maybe just to get started, I'll go ahead and import this function. We'll import the get farewell text from /utils. And maybe what we can do is derive whether or not the last guessed letter was a correct letter. Or maybe since I'm going to display this only if the last guessed letter was incorrect, we'll go ahead and say const is last guessed letter, or let's just say last guess, incorrect. Okay, well, I can get access to the last guessed letter by finding the last item in our guessed letters array. So maybe I'll do that separately just so that I can kind of separate my logic here a little bit. Let's say last guessed letter. That is going to be equal to the array of guessed letters at the index of the array of guessed letters.length. But then we have to do -1 just because of the 0 indexing. So this will get me the last guessed letter. It doesn't indicate whether it is correct or not. But now what I can do is I can check to see if the current word includes the last guessed letter. And because this is a Boolean as to whether it's incorrect, I'm going to say it does not include the last guessed letter. Let's console log this. Is last guess incorrect? We'll hit save. Oh, interesting. We did show true when the app was first rendered, even though we haven't made a guess yet. And that would be because guessed letters is an empty array. Guessed letters.length is 0. And so we are trying to index into guessed letters at the index of -1, which is going to be undefined. So maybe we can just protect against this by making sure that the last guessed letter is a real value. And only then will we check if the current word includes the last guessed letter. Okay, let's try this again. Okay, undefined, that's going to work for us because it's a falsy value, and we'll pass any of the conditional checks that we have later. Well, actually, before we continue on, let me try this. Okay, so we get yes, it was an incorrect guess as the most recent one. It should be another true, and then let's do a letter we know is in there. False. Okay, good. That is correctly telling us if the most recent guess was incorrect. Okay, so what do we do now? Whenever the most recent guess was an incorrect guess, then we want to display the farewell message. We wrote a helper function to help us determine what should get rendered in that status section right here in render game status. And we were just returning null if the game is not yet over. But what we can do now is to also check if the last guess was incorrect. So we can say if the game is not over and the is last guess incorrect is true, then we can see we just have a single line here. Maybe we'll just render this as a paragraph. So I'll return, I need my return here, return a paragraph. And for now, let's just get the styling correct. I'm going to just say bye. We'll add a class name, and maybe we'll say this is a farewell message. And over in our CSS, we can select the farewell message. Let's see, game status. Here's one lost. Let's go ahead and, oh, look, this is probably going to select the paragraph we already have. That's okay. Actually, yeah, let's duplicate this one and then make sure that the paragraph has a class of farewell message. And I'm just going to paste in some of the styles that you can find in the design, which gives it a dashed border, a purplish background color. It makes it italics, bumps up the font weight a little bit. And well, let's just see what this looks like. I haven't yet saved over here. Let's make sure, yep, we're returning this. It's just going to say bye for now. Let's hit save. And oh shoot, I've made a mistake in my logic here. And let's think about it. Okay, so the game is not over. The last guess is not incorrect, so we're not considering it correct, but it's not incorrect. So then it skips this. It comes to if the is game 1 is true, that's not going to be true. So then it's just hitting the else and it's telling us that the game is over. You know what, let's, instead of having this else here, let's explicitly check if the is game lost is true. Then we'll do that, and then otherwise, at the very end, after all these returns, if none of them hit, then we will return null. Okay, let's try again. Oh, awesome. Okay, our game over is gone. Let's go ahead and hit Z. And oh, look at that. I just realized I don't want to put my styles on the paragraph. I want to put those styles on the game status. This is a mistake on my part. I think I'm just going to leave it here in the recording because it's a very common thing. So we can go back and fix this. Let's see, we have some styles that are already being applied dynamically with CLSX. Let's go ahead and just duplicate this. We'll change this to be maybe a class called farewell. And let's take the section specific styles, which are the background color and the border here, and we'll just replace that one. Clean this up a little bit. The font style and font weight, I believe I still want to be sitting there on the text itself. And so now we will go over to where we have our CLSX call right here, and let's add another one called farewell. And let's think, this is going to apply if the is last guess incorrect, but I think we might also want to make sure that we're not conflicting with the is game lost styles. And so let's just make sure that the is game over is not true and the last guess is incorrect. Let's try this out. We'll get an incorrect guess. And okay, well, our styles are applying. It's floating up there at the top a little bit. Let's go check that out. And right here, yes, it looks like we're doing a display of flex direction column. We're doing align items, which in the column direction makes it centered horizontally. But in this case, we will also need to do justify content center. And okay, great. Just for kicks, let's refresh again and see if the other message is still working, even though we changed the justify content. And so I'll need to win the game real quick. Okay, good. That's looking great. Let's get rid of that console log that's running every time. We'll clean up our challenge text. And just like the message says, well done. There's a lot of moving parts to this challenge. We had to create a couple more derived values so that we could more easily check to see if the last letter was incorrect, and therefore displaying that message. The last thing we need to do is call our getFarewellText function. Maybe I prematurely deleted the challenge text, but that's the last thing we need to do. Instead of it just saying bye, we want to randomly choose one of those farewell messages. So let's see, right here it's saying bye. Instead, let's go ahead and call getFarewellText. And let's see, we need to call this function, but it's expecting the language to be passed in. So how can we get access to the language that was just removed? Well, let's see. One language is going to get removed for every incorrect guess. And I believe we derived some state, for the wrong guess count. So what if we index into the array of languages at the index of wrong guess count, and then I think it would have to be -1 because languages is 0 indexed. Let's go ahead and give that a try. So right here, get farewell text. This is getting really long. Let me put these on its own lines, and I'll put the class name there. We'll just kind of format this a little bit. Okay, so I can call getFarewellText. I need to index into languages to try and find the correct language in this array. I want to index by the wrong guess count, and then that's going to be -1. And then we have to remember too that languages is an array of objects, and so if we want the name of the language, we're going to have to call .name. Oh boy, okay, let's see if that works. Let's get it wrong, and RIP HTML, sad day, but also happy day, it's working. That's quite a roller coaster of emotions we're on. Great work on this challenge. I know that there were a lot of moving parts to this, and something that seemed as simple as just display a simple message here ended up being quite a bit of logic. Hopefully that went well for you, that we're really building something that has a lot of moving parts. I think I don't need this on its own line, actually. That's good enough. And we can check one more item off of our backlog. We're getting closer to completing this app. Before we jump into fixing some accessibility issues, I added another item to our backlog, which is to disable the keyboard when the game is over. Right now, when the user completes the game, let's go ahead and win here, they can continue to guess letters and lose the game, which, wow, gives us some pretty strange results here. In order to stop the user from continuing to guess, we can simply disable every one of these buttons whenever the game is over. This is just going to be a super quick challenge. It's your task here to do exactly that. So go ahead and disable the keyboard when the game is over. Let's see, let's come down to our keyboard elements, and inside of the code for our button, we can simply say disabled is equal to is game over. So let's hit save. Buttons are still working, which is good because the game is not over. And okay, just like that, we can no longer click these buttons. Maybe let's just add a little bit of styling here. So let's go ahead and say inside of the keyboard, the button when it's disabled, let's give it a cursor of not allowed. And then we can actually set some opacity on it just to make it a little more obvious that the keyboard is disabled. Okay, well, doing this brings us into the next part of our backlog, which is to fix some accessibility issues. I was planning on starting that in this same lesson, but I think just to keep everything organized, we are going to do this in the next lesson. One thing that's really important to do as you're building your app is to try and keep accessibility in mind, specifically when you're choosing what elements to put on the page. For example, we made sure to make every one of the keys in the keyboard a button element because we get quite a bit of accessibility benefits for free by using a semantically correct button element instead of, for example, just making this a div that is clickable. Buttons automatically come with their own focused state, the ability to tab through them, and you can make divs accessible, but you just have to do a lot more work to get that done. However, when we're working in React and we're dynamically rendering or removing things from the page, it's still really important for us to keep in mind what is changing and what might be difficult for assistive technologies to keep up with if we don't specifically cater our code to those needs. The thing that got me thinking about how we need to disable the keyboard when the game is over is that we want to also tell assistive technologies that those keys are disabled. There are some screen readers that will announce when a button is disabled, but some of them don't. And so we can add a dedicated ARIA disabled property. If we can find our buttons here, okay, right here. We have disabled it, but we can add an ARIA disabled. And we could decide to set this equal to is game over in the same way that we did with the disabled property. However, when we're thinking about someone who is using the tab key to tab through all of these letters, maybe a better user experience would be to disable the ones that have already been chosen. To do that, I could simply say something like the array of guessed letters includes this current letter that we're looking at. And I guess at that point, it might be a choice to decide if that's also when we want to disable the keys in general. We've already included some logic that doesn't allow the user to keep trying to add the same letter to the array of guessed letters. So I think I'll probably just leave it the way that it is. Thinking about the user experience from the point of view of someone using a screen reader as well, when they're tabbing through these, the screen reader will say the letter that is currently being focused in the button, but it might be just a slightly better experience for us to label it with maybe the word letter beforehand. So it actually says letter A, letter B, letter C. I guess at that point it might just be a preference. I'm not really sure, but let's go ahead just for the sake of it and add an ARIA label. And this will simply say the word letter followed by the actual letter. Okay, so that should make the user interactive part of it a lot more usable for those using assistive technologies. We also need to take some time to look at any portions of our site that are being dynamically rendered. Well, one of those is the status message that pops up here. Screen readers are not just going to automatically announce things that get added to the DOM by React, but fortunately there's a way that we can mark certain portions of our app as sections that will be live updated. So we chose to render this with a function, which is right here in render game status. But the parent of these elements is just down here in the markup right here. This section with the game status, what we can do is add an aria live region to it and say that it is polite. Polite just means that it's not going to interrupt the rest of whatever it's currently reading to announce changes to the section. It will kind of queue it to the end of any changes that the screen reader is currently reading. There's also a role property, and we can essentially say this section's role is to be a status. Let me put these on their own lines, and doing this will give us some additional accessibility benefits. Okay, well, let's think about another part of this app that kind of acts like a status and is definitely something we would want to have read to our users if they're using a screen reader. Well, I think it's going to be pretty important that they have some idea of what the current revealed status of our word is. And while we could just surround let's see, this one, this is our actual word. We could surround this in an aria live region, just like we did up here above with the game status. However, because this is such an important part of the game, I think we could put a little bit of extra effort into what gets read out by a screen reader when this is being updated. Now, because this isn't a dedicated course to accessibility, I am just going to kind of explain the code that I'm writing as we go, and hopefully it will give you some ideas of how to improve your own apps in the future. Something that we can do is we can create an entirely separate section whose sole purpose is not to display anything visually, but to be read out loud by a screen reader. And then with CSS, we can just completely hide it from the DOM. So maybe right below our word here, I'm going to add another section, and I'm going to add some CSS that will essentially just completely hide it from the DOM. We'll give it a class name of SR only for screen reader only. Then in our CSS, I'm going to just paste in a screen reader only class that I have defined in another project. It essentially is removing it from the visible area and doing everything it can to make sure it never shows up. Then, just like we did in our status section, we can also put an aria live of polite and a role of status. Okay, let me put these on their own lines too. And oh, I said dash instead of equals. Okay, so now anything that I put inside of this section is just going to be read out by the screen reader, and that will happen anytime there's an update to this section. So maybe the first thing I'll do is to put a paragraph that will just read out what the current word is. And because this will never be there visually, I can actually type in the text that I want the screen reader to read. So I can say something like the current word, colon, and then I can just have it read out each individual letter of the current word. So let's see, we have our current word. We'll add a dot split to turn it into an array, and then we can map over it. And for each letter in that array, if the letter is currently revealed, or in other words, if the array of guessed letters includes the current letter, then we'll just have it read out the letter out loud, and not the literal string letter, but the letter itself. And otherwise, well, it won't read anything out. Although I have found that if you have an empty string, it's just going to ignore it. So what we can do is actually just have it read the word blank. So it'll say something like R blank 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 blank. Another thing that I have found as I've played around with screen readers is that if you add a period like this, it will add a little bit of an extra pause. So if there were multiple letters, instead of saying REACT just super fast, I think this might give it just a little bit of a pause between them. I guess don't quote me on that. I'm not 100% sure. It's been a little bit since I've played with it. Okay, well, let's see. I'm still mapping over this, but I'm not actually turning it into a string that it can read out. And let me put a period here too, just in case that works the same way as I was describing before. But now we can join things back together, and we'll put a little bit of a space in there just to make it a little more readable for the screen reader. Okay, I know this looks a little bit crazy. We could probably offload some of this to a helper function if we want, but I think this is going to get the job done for now. There's actually a little bit more that I want to add to this section, but since we've bitten off quite a bit in this lesson, I want to give you a chance to review what we've done, maybe think about other apps that you have created, see if there's any of these accessibility rules that we've talked about that you could apply over there. And then there's one other thing I want to add to this section, which we're kind of treating like a generic screen reader status update section. And so we'll do that in the next lesson. Another accessibility user experience improvement that we can make is not just to reread out the current state of the word and the status that we have up above, but we could simply announce whenever a letter was guessed correctly or incorrectly every time the letter is guessed. So after the user selects a letter, we could have the screen reader read something out like, correct, the letter R is in the word, or sorry, the letter Q is not in the word. We could even add something that says you have 6 attempts left. Now, we could choose to do that in a completely different section, but I think just before this paragraph, I'm going to add another paragraph that will announce whether or not the previously guessed letter was correct. So let's go ahead and add a paragraph. And what we'll do is check to see if the most recently guessed letter is in the current word. We'll have it read out correct the letter whatever is in the word. Otherwise, we'll have it read the negative side of that statement. And I think we are saving the last guessed letter. Yeah, we actually created a separate variable up here so we can get access to that. Awesome. So let's see, right down here, we're going to check to see if the current word includes the last guessed letter. And if it does, this is where we can have the text of the paragraph just read out what we want it to say. So correct, the letter, and then this will be the last guessed letter, is in the word. Otherwise, we can put our message that says, sorry, the letter, last guessed letter, is not in the word. And then whether it was right or not, we could say something like, you have, we need to know how many attempts they're going to have left. Let me just hardcode this. We'll say you have 4 attempts left. And let's see, the number of attempts that they have left is going to be, we had figured something out up above. And yeah, we were using languages.length -1 as our number of incorrect guesses that we're allowed to have. So I guess we could just use this again, although I kind of want to just derive that value so we can use it elsewhere. Maybe just right here at the top, I'll say something like number of guesses remaining left. Number of guesses left is equal to languages.length and then -1 because we need to leave assembly as the last item. Okay, so then number of guesses left. Let's see, we can just say this. And then with that new derived value, we can come down to our screen reader only section again. And then instead of putting in the hard-coded 4, we'll say num guesses left. And with just those few updates, maybe a dozen or 2 lines of code, we have now made this app much, much more accessible for those using any kind of assistive technology. Of course, it's also important to make sure you go through and make sure that your contrast ratios are good enough and everything like that. But what we've done here marks a huge step forward in the accessibility friendliness of this app. Right now, another developer coming to this section might pretty easily miss the class name of SR only. And so I think it can be helpful to include a little comment here that can say that this is a kind of combined, visually hidden ARIA live region for status updates. Okay, let's come up to our list here, and we're just going to mark this one off. There likely are other improvements we could make. There's always more that you can do. But we just have 3 more really small features to add to our game, 2 of which are crucial for the functionality of the game, and 1 of which is just going to be a really fun way to wrap things up. So next, let's jump on to the next item in our backlog. And actually, now that I'm looking at this, I'm going to swap these 2. I want us first to choose a random word from a list of words. So that's what we'll be working on next. This should be a pretty short and sweet challenge. We are going to make it so that a random word is chosen when the game starts. Right now we're just hard coding React, but we're going to make it so that a random word will get chosen. I've created a new file called words.js that has close to 500 words in it. I tried to weed out anything that was fewer than 5 letters and greater than something like 9 letters, I think. And so your task is to come over here to utils.js and write a new function that will randomly choose one of the words from that list of words. I've already imported the words right here, so you can use it in your function. This part is just sort of an algorithmic challenge, nothing very React specific to it, but then I want you to import that function into this file, the app.jsx file, and figure out where to use that function. Go ahead and get started on this challenge. All right, let's come over to utils.js, and we will export a new function that we'll call get random word. And simply enough, all we need to do is get a random number that's in the index of the array of words. So let's create a random index and set that equal to math.floor, math.random, and then we can make sure that it's limited to the length of the array by multiplying this by words.length. Then all we have to do is return words at the index of our random index. Easy peasy. Okay, let's come over here to our app file, and from utils, we're already importing the get farewell text. Let's go ahead and also import get random word. And we're really flying through this challenge. We've already finished 1 and 2. Let's figure out where to use that function. Well, we were hard coding React as the initial word that we were using, and instead of using React, we're basically going to be turning on the game now. We're going to call get random word, and let's try playing our game. We'll hit save. And look at that, we no longer have a 5-letter word here. Ooh, this is a long one. This is 8 letters. Let's see. Usually longer words in Hangman are a little bit easier, but I'm not doing very well here. Ah, that's why there's 2 I's. Sorry, HTML, CSS, and JavaScript, we have already lost you. Let's see, what could this be? Ah, I think this is military. Sure enough. All right, well, we're still left with TypeScript, Node, Python, and Ruby, so we did pretty good. Military, yay, we won. Now, some of you might have remembered that if we are initializing state by calling a function like this, technically every time we cause a re-render in our app, React will rerun this function. Even though it's not going to use its returned value to change the state again, it is calling this function again every time. This getRandomWord function is not a very expensive function, but it doesn't hurt us to use lazy state initialization, which we learned in the last section, by simply wrapping this in a callback function. This way, on the very first render, React will call this function and it will get our random word and set the initial state. But on subsequent re-renders, it's just going to simply ignore this function. That way we're not running any extra operations that we don't need to be. Awesome. Let's clean up this challenge text and mark this next one as completed. The next thing we'll be working on is giving the new game button some love so that clicking it actually resets the game. This is going to be another short and sweet one. That's how you know we're really tying off the loose ends of our game here. Your challenge is to make the new game button reset the game. Go ahead and get started on this challenge. All right, well, let's hook up our button first, and then we'll write the logic for it. So maybe just right here, I'll add a new function that says start new game. And I'll just console log start a new game. That'll do for now. We'll go ahead and hook up our button, which is way down here at the bottom for new game. We'll say on click, it's going to simply call start new game. Okay, let's hit save. And I guess we need to actually play this game now in order to display the new game button. Oh no, this is not a good start. Oh, I don't need to win this game for this to show up. I can just lose the game. Okay, let's go ahead and click new game, start a new game. Perfect, okay. Oh, I just thought of another feature we need to add. We need to display the word after the game has been lost. Otherwise it's so anticlimactic we never get to figure out what it was. Anyway, let's stay focused. Up here where we are resetting the game, okay, we don't need to console log start a new game. There are 2 things that we need to update. First of all, we need to get a new random word because this one's been used now. And secondly, we are maintaining a list of guessed letters and we need to empty that back out because we want our keyboard to refresh. We don't want to display any of those letters to the new word and so forth. So we can use our state setter functions to set the current word. And of course, once again, we will call getRandomWord. And then we will say set guessed letters to an empty array. Once again, short and sweet, this should be working. Let's go ahead and just lose the game right now. These last letters tend to not be correct. And we'll click new game, and perfect, everything starts over. Okay, I'm actually going to add that item to our list here. We need to reveal what the word was if the user loses the game. In the meantime, we can mark this one off. We are so close to the finish line, I can practically taste it. So let's hurry on to the next challenge. This one will require a little bit extra thinking compared to the last 2 challenges. So what I want you to do is to reveal the missing letters of the word if the user loses the game. So for example, let's just lose the game real quick here. Oh geez, I'm not losing. Okay, here we go. We don't want this to be a mystery. We want to reveal what the word was to the user. So you'll have to think through the logic of how these letters get displayed, and if the game is lost, you'll want to reveal the missing letters. And as it mentions here, for now, let's go ahead and style them with the same red color that we use for the button keys when they're incorrect. Go ahead and get started on this challenge. All right, well, let's go down to where we are figuring this logic out of how we display the letters. And that's right here when we're mapping over the current word. I think the first thing I'll do is figure out the logic to display the missing letters only when the user has lost the game, and then we'll worry about styling them. The most concise way I could think to do this wouldn't be to conditionally render one span or another, depending on whether they missed that letter and lost the game or not, although that would have been a completely legitimate way to do it if that's how you decided to solve it. Currently, as I'm mapping over the current word, I am publicly displaying that secret letter if it is included in the guessed letters. What I could do is simply come up with another variable that will also display this letter if the game is lost, so that if the game is not lost, it will only display it if it's in the guessed letters, and if the game is lost, it will just display all the letters. So let's go ahead and do that. One thing I can do is just create a new variable that's called maybe something like should reveal letter. And I want the letter to be revealed if the game is lost, just automatically display the letter, or if the guessed letters includes the letter that we're currently mapping over. Oh, and I was using an implicit return before, so I'm going to have to fix some of my brackets here. Let's see, I'll move this down here. We'll return the span. Yeah, there we go. Okay, so instead of doing this, we'll say should reveal letter. And let's go ahead and lose the game and see if it shows all the letters. Oh, this is a long one. All right. Holy cow. 3 T's. Okay, statement. Yes, perfect. The word was revealed. Now, because CLSX is so powerful, we can use it to determine if the letter was not in the guessed letters array, and if the game is over, then we can dynamically add a class name. So let's see, right below here, let's go ahead and say maybe the letter class name is equal to CLSX. And the first thing we want to make sure is that the game is lost. We want to add a class name if this letter was not included in the guessed letters. So we'll say if not guessed letters dot includes the current letter. Then we can add the class, let's call it missed letter. I'll go ahead and make sure to add my class name of letter class name. I'll hit save and come to my CSS, and I guess we're already here. So this rule right here, the span, is what we're trying to attach to. Let's add a class for missed letter, and we will just change its color to be the red color from the design. Okay, let's go ahead and lose this game. Wow, that looks so good. That is a much better end of game user experience. All right, the last challenge, and arguably the most fun one, let's make it so that our confetti will drop when the user wins the game. This challenge kind of feels like in golf when you just barely missed a putt and all you have to do is just send it home. We've literally done this exact same challenge in the last project at the end of Tenzies, so this should feel right at home to you. I've already installed the React confetti package and imported the confetti component here. All you need to do is trigger the confetti drop when the user wins the game. I'll hand it over to you to send us home. I guess before I walk through this challenge, you may have noticed that I did have to downgrade my version of React back to React 18. That simply has to do with the fact that React 19 is not officially launched yet. It's still on the release candidate version, and it seems like the React confetti package is not yet working with React 19. All right, let's do it. We'll go down to our markup down here below, and it doesn't really matter where we do it. I think I'm just going to have it be rendered right here at the top. We'll call this a glass half full kind of decision, and we'll say if the game is won, then we'll go ahead and render confetti. Now I actually am going to add some of the options to confetti, the props that you can pass to it. Specifically, I'm actually going to turn off the infinite confetti by setting recycle equal to false. And you can specify the number of pieces. These are just things you can find from the documentation for React confetti. And I'm going to bump it up a little bit to 1,000. Let's do our best to win this game. This would be a little anticlimactic if I lose now. Oh, I'm on a roll. Look at that. I think we need another vowel in here. Oh, yeah. Ooh, I think it's distance. Here we go. Before I click the N, it's going to be anticlimactic for you as the viewer because you're not going to be able to see the canvas elements of the confetti dropping, but I can tell you that it is awesome. What a celebration. I guess you'll just have to hit refresh and play the game for yourself. Now, surely there are other improvements we can make to this game, but before we jump into a recap of everything that we did with this game, I want you to take a second and just look at this code base. This is a hefty code base. Let me go ahead and check this off too. Obviously, this doesn't compare to any enterprise-level apps that you're making, but this definitely represents the longest app that we have built in this course, and it looks and works amazing. Huge congratulations to you if you made it through the entire React course up until this point. That is an amazing accomplishment. We are going to celebrate that even more in the wrap-up that we'll do in the next scrim and recap everything that we've learned. Well, you've done it. You've saved humanity from having to suffer through writing assembly for everything. In all seriousness, this was a complex project, and you have done an amazing job working through all of the challenges along the way to building it. And just like the Tensies game, this is another one that will be super fun to share with your family and friends. If you want to keep the fun going, there are a few extra credit ideas that I came up with. First, you could simply display the remaining guesses count. We do have the visual of the remaining languages, but maybe just having the number of remaining guesses allowed could be a helpful UI addition. We do celebrate the win with the confetti component, but you could consider rendering some kind of, anti-confetti when the game is lost, or maybe another animation that really makes the user feel that loss. You could also implement something like a chess timer that starts when a new game starts and causes a loss if the time runs out, adding a little bit of extra pressure to the player. There are a couple things that you definitely should do. The first one is you should deploy this live online so you can share it with other people, including putting it in your portfolio. And secondly, you guessed it, you should head over to the Today I Did channel on the Scrimba Discord server. Even if you don't have it posted live online to share a link with other people, simply leaving a message there to celebrate your win is a great way to engage with the community. Amazing job completing this project. Hey, you did it! We're here at the end of the course! You should be so proud of yourself for finishing, because assuming you've done all the challenges and projects in this course, you are well on your way to becoming a proficient React developer. As I said in the very beginning of this course, my philosophy is that the easiest way to get good at something is to put in the work, to do it the hard way. And considering you are here at the end, having done all the projects, you have put in the hard work, and I can promise you that it will have been worth it. Let's take a look back on the projects that we worked on in the different sections of this course and do a quick recap of what we have learned. In section 1, we started with really basic static pages in React so that we could build a solid foundation to support the rest of our learning in React, and we began that section by first learning why we even care about React in the first place. We talked about how React is declarative, making it a much better developer experience, and how React is composable, allowing us to build reusable pieces that can be combined together to make a masterpiece of a web app. We touched on setting up a new React project, not only in terms of the code that you have to write, but also how to do it on your local machine. Then we learned about React elements and how JSX was created to make creating those React elements a very familiar experience, similar to writing HTML. Then we learned about the crux of composability in React by learning about custom components. Custom components allow us to co-locate logic, markup, and styling all in the same place to create a custom reusable piece of code. And then, of course, we needed to make sure that we added some styling so that we weren't just throwing around ugly components. With that knowledge, we were able to build our first static ReactFacts web page. From there, we moved on to our second section where we built a travel journal. What set this travel journal apart from the ReactFacts project is that it was data-driven. We really drove home the concept that reusability is extremely important, and learned how we can take our React components, pass props into them so that they could be reused in multiple different ways. Once we knew how to pass props into a component, similar to how you pass parameters into a function, we learned how we can use vanilla JavaScript array methods to create components from an array of data. Doing this allowed us to put the data for our travel journal in one place and simply map over it to create the ultimate view on the page. This meant that if we wanted to add new entries to our travel journal or change a detail of one of the items, all we had to do was change it in one place, the data. Then we really dialed it up to 11 and jumped into the Chef Claude project in section 3. This section was entirely dedicated to building interactive web apps, whereas before we were working with static, read-only pages. Now we're able to respond to the user's inputs by learning about event listeners and how we can update our app based on the interactions of our users. We learned about state, which allows us not only to save information between one render and the next, but also allowed us developers to focus on updating the state correctly and letting that flow to the UI, which is what React is intended to do. Changes to the state will automatically update what the user sees. We learned about conditional rendering, how we can display or not display certain parts of the web page based on conditions. Then we learned about forms and how React 19 enables an entirely new approach to forms, which is much more closely aligned with how the native web platform handles forms. And we took a chance to dabble just a little bit into different state management strategies, although state management is a rabbit hole that would probably require an entire course of its own. Then we had a lot of fun building our meme generator and learning about side effects in React. We began the section by talking about controlled components, which are essentially the way that React has approached dealing with forms all the way up until very recently at the time of this recording. But there are scenarios where controlled components can still be useful. In our case, we wanted to update our state so that the top text would reflect on every keystroke what the user was typing into the input box. Then we talked a little bit about how React has a philosophical basis in functional programming. We touched on the concepts of immutability in React and how our components shouldn't affect any outside systems from themselves. However, the purpose of the side effects section is to learn how we can use an escape hatch from that functional programming paradigm when we absolutely need to. And the way that we did this in our meme generator project was to fetch some data as soon as the component loaded. Having a so-called escape hatch, which gives us a chance to safely handle side effects whenever they're absolutely necessary, turns out not only to be a really important thing in React, but also one of the more misunderstood aspects of React. Then we got to the place where the rubber met the road, and that was in our capstone projects. We built 2 back-to-back games that were both really fun to build and legitimately are fun to play. Hopefully, looking back at all of these sections gives you a really strong sense of appreciation as to how much time and effort you put into this course. This would be a perfect opportunity for you to head to the Today I Did channel on the Scrimba Discord server and post a message, dare I say brag, about this tremendous accomplishment. Now, I don't want to just leave you hanging at the end of this course, so I wanted to give you some ideas of what you could be working on next. Naturally, I'd first like to put in a plug for my Advanced React course here on Scrimba. The Advanced React course is the natural progression from where we left off at the end of this course. In that course, we dive deep into reusability in React and learn a bunch of new ways that we can turn our reusable components into even more reusable components. We learn how to build single-page applications using the React router library, and we learn all about performance in React and how we can improve the performance of our React apps. Another really important topic you could move on to if you haven't already learned it is TypeScript. And good news, I also have a TypeScript course here on Scrimba, and it is completely free. I already mentioned React Router, but you could focus specifically on learning the React Router package. At the time of recording, React Router is about to release version 7, which is a completely new version of React Router. If you're looking to go more into a full-stack realm, Next.js and Remix are awesome frameworks that you can use to be building not only the front ends, like we've learned here in React, but also the back end, so you can handle server interactions, data, caching, cookies, and all of that. If you are interested in backend, you could go the direct backend route by learning Node.js with or without Express, all to help you build REST APIs that your front-end React apps can consume. And last but certainly not least, you could learn about deployment and how you can get your apps live on the web for your friends, family, and potential future employers to check out. My name is Bob Ziroll. It has been my absolute pleasure to teach this course and guide you through learning React. My username pretty much everywhere on the web is Bob Ziroll, although these days I do tend to be most active on X. If you click my username here, it will take you to my profile. I would certainly appreciate a follow. And folks, that's all I have left to say, except for congratulations on completing this Learn React course.
Hi, I'm Tom from Scrimba, and in this section, I'm going to take you through a couple of really useful VS Code and Chrome browser extensions, which are going to make your life as a React developer just a little bit easier. As we look at these extensions, we're going to be working on this layout. This is actually a screenshot right here. So the company is Urban Nest, and this is the dashboard. And on the dashboard, we've got 4 product cards and 4 user detail cards. These contain dashboard type activities like changing billing address or changing password. Now, if we have a close look at this, you can see that we've got the username right here in the header, also here in the dashboard title. We're using it again down here. And you might also notice that we've got the location here, and that is going to affect which currency symbol we use. And we've also got the user's email address in this card right here. So you're starting to get a feel, hopefully, for the way that props are used in this project. Now, at the moment, we're working inside Scrimba, and I've already written some of the code. Let's just open up the mini browser and see where we are. So we've got a header and we've got a footer, but we haven't got any of that content in the middle. And the reason for that is that we've got this dashboard component, but it's completely empty. So what we're going to work on is getting this dashboard component sorted out using some browser extensions. And to do that, I want to move everything over to VS Code. Really easy to do in Scrimba. I just click on Settings, download a zip. That's downloaded a file. And there we are, we've already unzipped the file, and I'm just going to change this name to something more useful, and I'll call it Urban Nest. And now let's head over to VS Code and open up this folder. So it was in Downloads, Urban Nest. Okay, we've got all of our code here, and we can just follow the instructions inside readme.md to start the server. So we just need to do npm install and npm start. Let's open up a new instance of the terminal. So first, npm install, and that will bring in all of our packages. And then npm start to start the server. And then we can just click on this link, and there we are open in the browser, and we can see we've got the header and the footer. Okay, let's just take a quick look at the code we've got so you understand how this layout works. We start off with app.js. That is bringing in the header and the footer. Also in here, we've got some state. This is just set up with me. So we've got my name, my email address, my location, and my age, which is honestly not entirely accurate. And then we're just rendering out the header and the footer components, passing in the props that they need. Now, there's nothing particularly strange going on. The header is basically what you'd expect. We've got this nav element, and then it's right here that we're using the username and the location. And if we flip back to the browser, that's what you can see right here. Now, down in the footer, it says follow us on Instagram. That's kind of important. If we go to the footer, we've got this cheeky little bit of ternary right here, and I might just make that a little bit clearer by bringing it down onto a couple of lines. So what's going on here is that we're checking the age, and if it's greater than 50, we're inviting them to follow us on Facebook. If it's greater than 12, we're inviting them to follow us on Instagram. And if not, so they're under 12, we're inviting them to follow us on TikTok. And if we just head back to app.jsx, I said that my age was 30, and that's why we're seeing Instagram down here, but we could change that. And now it says TikTok. Okay, let's put that back. Now I can still show you the screenshot that we've got. We should have it right here in images, and that's just going to show us what we're working towards. So we've got these 4 product cards. We've already got a component for that right here, productcard.jsx. We're reusing that 4 times. And then down here, we've got the user detail cards. Again, we've already got the React in there. So we've got all of that code available to us. We just need to put it to good use in dashboard.jsx. So the first thing we need in dashboard is a functional component, and that brings us to our first extension. Adding an extension in VS Code is really easy. We just come to this icon right here, or you can go to Views and Extensions, And then in here, you can just search for the extension you want. You could just use a keyword and see what comes up. I actually know the one I'm looking for, but if I put in React, it's this first one which comes up. It's ES7 plus React Redux React Native snippets. A really snappy name. All I need to do is click install. A couple of things to notice on this page. It's got nearly 13 million downloads, which is great. It's also well reviewed. And we could scroll down and see a bit of information about it and what features it's got. But I'm just going to give you a quick demonstration. So let's just close that. Come to dashboard.jsx. Now, I'm going to use a key binding, and in VS Code there are loads of key bindings. It just means key combinations that bring up some kind of shortcut. I'm going to use Command, Shift and R, but if you're on Windows, you would actually use Control, Alt and R. What that does is it brings up this pretty fiendish looking menu of all of these options, and these are all code snippets that this extension can give us. So we've got stuff here which is both for React, for Redux and for React Native. Some of it is legacy, so you'll likely never use it. Some of it is highly complex that you probably haven't come across as yet. So we've got, for example, HOC, which stands for higher order components. When we click that, it gives us the code we need. But hey, that's getting a little bit ahead of ourselves. So again, Command Shift R, and let's actually do something useful. What we want to create here is a functional component. And so we can use this search functionality. And I've put in functional comp, and then down here at the bottom creates a React functional component with ES7 module system. That sounds good. Now we could just click on this right here, but as we're going to be reusing this a bit, why don't we try and remember these four letters, RFCE, and that stands for React Functional Component, and then the E is for export. We use that just by typing it right here in the editor, React Functional Component Export, hit enter, and look, there we are. It's made a functional component for us, and it's actually taken the name dashboard from the name of the file, so we don't have to. So that is a nice, really quick way of setting up a functional component. Now, I should give you a warning here that if you rely too much on these automated code snippets, you might end up in a situation where you can't even write very basic React code like a functional component. You could end up looking pretty silly, for example, in an interview environment. So do make sure you actually know the code that you're generating automatically. That is the best way to use a tool like this. It should just be for saving time. Okay, let's quickly pop back to our screenshot. And we can see that we need a dashboard right here. That's going to be inside an H1. So let's return that here. We also had the name of the user, in this case, Tom's dashboard. So let's take that in as props. And I'm actually destructuring the props right here. So I'm using username inside the curly braces, and then we can use it right here. We don't have to say props.username. Now the dashboard is going to have these 4 product cards, and we've got the data for the product cards right here in this data folder, productdata.js. Now we also need to use productcard.jsx. So we've got some importing to do. And to be honest, importing can be a real pain because you can end up with some really long relative paths because you've got a heavily nested file structure. It can be quite confusing and really difficult to debug. So we're going to use a really useful VS Code extension, which is going to help us with importing. Now, the snippet that we used before gives us this import statement that we don't actually need. So let's delete that. And now let's investigate an extension which will help us with importing. And the extension I'm looking for is called auto import relative path. This is the one right here. So let's click install. And if we just clear the search box, that will take us back to our installed extensions. What you'll notice is that we got 2 for the price of 1. We've got auto import relative path and drag and drop import relative path. And it's this one that I'm really interested in, although they come together. So let's just go back to the files. And what I'm going to do is take this component that we want to import. I'm going to drag it over. Now, if I let it go now, it's just going to open the file. But if I put it in position, hold down the Shift key and then release the mouse button, there I get our full import statement, including the relative path. This is a really short relative path, so it wouldn't have been that much trouble to write it ourselves, but it's done it for us. All we need to do is update the name. And now we can use the product card component. But in order to use it effectively, we need to get access to this data. We're going to be mapping over that data. So let's import that next. And again, I'll just drag it and hold down Shift and drop it in. So we want to import product data from, and then we've got the relative path. This one a little bit more complicated because it is in a different folder. So that has saved us a little bit of cognitive load. Okay, let's map over this data. So I'll set up a const right here inside the component, and I'll call this const product cards. And then we'll take product data, call the map method, and that will take in an arrow function with a single parameter, which will be a product. And let's bring this down onto a new line because we've got quite a lot to do here. So for each product, we want to return to this array an instance of our product card component. And that is going to need some props. Let's just have a quick look at the product card components. So each one is an article, and inside we've got a card title, an item name, we've got a currency symbol, which we're sorting out right here based on the location. We've got the price, we've got the source for the image and the out text. So we need to bring in all of this. And let's actually just copy this list. And we need to remember when mapping over data and creating these components that each one needs to have a key prop. And the key prop, if we look at the data, is going to be this ID. So it will be available at product.id. And actually, most of these are going to come from product. Location is the exception. So let's just put product in these 5 props. And then location, we are taking in app.jsx, so we've got it set right here. When eventually we add in the dashboard component, we'll be passing it down. So let's bring it in right here, and we should be done. So let's just take our product cards, and we're going to render them down here in this return statement. And they're going to live inside a section, and that section needs to have the CSS class name of product cards container. We've got an error here, and that's because we're no longer rendering just one thing, so we can just wrap everything here in a fragment. And then we'll take the product cards and render them right there. Okay, let's save that, and we'll head over to app.js, and let's see if we can import our dashboard. And I'll do this one a different way. I'm just going to write import, and then when I put a D, we see dashboard. If I click on it, it does the rest for us. So you've got 2 options, the drag and drop we did before, or just writing import, the name of the component, and then let it do the rest. Okay, down between the header and the footer, we can render the dashboard. And we do need to pass in some props. We need the username, and we also need the location. And we will actually be adding to that list later. Okay, let's hit save. We can open up the mini browser. And there we are. We have got our 4 product cards. So that is looking pretty good. Now, we're not done because go back to the screenshots. Well, we need these user detail cards as well. We've already got a component for that right here. So all we need to do is bring those in. So back at the dashboard, let's import user detail cards. And as they are actually the main content on that page, they are going to go in an HTML main element. Now we know we want 4 of them. And things do get a little bit strange here because we've got the email address and we've got the username. So I haven't given us a data file like we've got here to map over. I don't think it's realistic that that information would be coming down from some API or something like that. So instead, we're just going to render this one out 4 times. Just to save you watching me do loads of typing, I've actually got a text file right here with everything that we need. So I'm just going to copy that over and I'll just pass those in as props. And if we just check that component, we can see that each one is expecting title and text. That should do the trick, and just notice how we've used curly braces on 2 of these where we are including props, the user email and the user name. Okay, let's hit save. And then when we open up the browser, we've got a bit of a problem. So something has gone wrong. Let's just investigate what's going on in this component. So we have got the user detail card. That should work just fine. But let's check the props that we've got coming in. We've got username and location. We haven't got user email. So let's add that to the list. And let's just make sure in app.js that we're passing that down to the dashboard. We're not at this moment. Let's save and try again. And there we are. Look, that is working just fine. Okay, now we've got that working, I want to show you a really cool Chrome extension. Let's come up here to our Chrome settings, go to extensions, visit Chrome Web Store, and again, we'll search on React, and this is the one we want, React Developer Tools. We're going to add it to Chrome. And now let's go back to our layout and we'll just open up the DevTools. And what we're going to get from this extension is a couple of options right in here. And actually we're not, because I need to do a refresh. And now when I click on these 2 arrows right here, we'll see 2 new options, Components and Profiler. Let's just click on Components. And we might just make ourselves a little bit more space so we can actually see our app. So what have we got here? We can actually see the entire React tree. We've got the app, we've got the header, and if we click on one, like I've just clicked on header, we can see the props we've got location UK, username Tom. If we move on down to the dashboard, we've got our individual product cards. Again, we can see all of our props in here. That is pretty cool. Let's just head up to app. Here we've got the hooks, so we've got all of our state. Let's just change one of these. So one of the benefits of this extension is that we can just make some changes and see re-rendering actually happen live. Right here, we've got the £sign because I've put my location as the UK. Let's change that to US. And when I hit enter, look what happens. We get the $sign instead. And if I scroll right to the bottom, it says here, follow us on Instagram. Let's change my age to 130. And now it says, follow us on Facebook. Take it down to age 1, follow us on TikTok. So you can really see how the state that you change is percolating down through the apps as it's passed down as props. So that can be really, really useful for understanding how an app works and of course for debugging. Now we had another option in here, which was this one, Profiler. And this is quite an advanced one, and you're probably not going to use this anytime soon, but I want to show you quickly and just explain a bit about what it does. What happens is that we can click the blue button to record, and now we can interact with the app. And so because this is basically a static site at the moment, I'm just going to flip back to the components, and then let's make some changes. Let's put the age back to 30 and the country back to UK. And now if we go back to Profiler, I'll stop the recording. And now we get some feedback on how fast our app responded and exactly what happened. So we can see what rendered and how long it took. And that can be really, really useful for seeing re-renders. You might find in a complex app where something's gone wrong that you're just re-rendering the same component thousands of times and it's causing performance issues. Well, this is the tool to help you debug that. As I say, it is quite an advanced topic, not one you're going to use anytime soon, but good to know that it's there. Okay, we're not quite done. I want to go back to VS Code, and I just want to show you two more extensions. Let's go to the Extensions tab, and here I'm going to search for React Tree. And we come across React Component Tree. Let's install that. And I'm just going to close down that tab now. Down here, we got a new option, Build Tree. Let's click it. And look what we get here. We get a similar view of the tree as we actually got in the DevTools. This one is also pretty useful. So imagine you've got a massive app and you're looking at a component. Well, right now, if we go to Dashboard, it's going to highlight it here and you can instantly see how it fits into the tree. Again, let's go back to the File Explorer. I'll take Product Card. And now when I go to the tree, and by the way, we've got a new icon for it right here, I can easily find it in this tree and just see what the parent or sibling elements are. Now, this one I think is quite useful, but there's actually a somewhat better one. I'm just going to put in here React Tree, all as one word. This is the one I want. Let's install that. Okay, we get another option down here, which is Start Tree. Let's click that, and I'm just going to close all of the open files. And it's inviting us to select a file. Let's click on that, and we will go to Downloads, Urban Nest. Let's just take the top of the funnel, so app.jsx. Let's open that. And look, here we get a really nice visualization of the app. And we might just zoom out a little bit so we can see it all. So we've got app.jsx, the 3 components it renders, and the 2 components we've just added to the dashboard. If we click this P icon, which is grayed out in here, that will actually open up all of the props so you can see what's going on. We've got the username here and here, for example. We can see that we passed title and text down to user detail card. You can also change the direction. It might be a bit easier to read left to right than top to bottom. And also you can play around with the layout, which again, in a big app might be useful just to be able to sort of spread things around and see what is where, and perhaps consider some changes, consider making things a little bit more economical. Okay, so we are done. Those are some pretty useful extensions that you can use with VS Code or with Chrome to make your life as a React developer just a little bit easier.